Python is more than just a programming language. It is also a great place to begin if you're just starting to code. With the popularity and versatility that Python bags, no wonder it is a great time to learn Python programming. Hi, I welcome you all to this full course session on Python programming, and what follows is hopefully a crash course of everything that you need to know to start out with Python. But before we begin, let's talk about our agenda for today. So we're going to start out by introducing you to Python. Here we are also going to talk about the market trends and overview of Python. Also, we're going to give you a guided way of becoming a Python developer. Now next, we are going to talk about the step-by-step installation of a Python IDE, and we are going to also help you run your first Python program across various IDEs. Now next, we are going to talk about Python basics. Here, we are going to talk about comments, variables, data types, and operators in Python. Now followed by which, we are going to talk about a few popular Python libraries like NumPy and SciPy. Now, next, we're going to get a little deeper. Here, we're going to talk about file handling and functions in Python. We're also going to discuss concepts such as object-oriented programming, classes, and inheritance in Python. Now, followed by that, we have our final topic, which is web development and web scraping in Python. Here, we are also going to talk about frameworks associated with Python like Django, Flask, and Web2Py. With that, I come to the end of the agenda. Also, kindly take up this time to subscribe to us, and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, check out our Python programming certification course, the link to which is in our description box below. So without much ado, let's get started.
Python is the fastest growing language in terms of developers, libraries, and applications that it can be used for. It could be machine learning, artificial intelligence, web development, anything that you can think of, Python has always got you covered. Now, before we get started, please subscribe to the channel and turn on notifications for all of our future videos. With that, let's go ahead with the agenda for today's session. We shall understand what Python exactly is and why it is so popular, thereafter the features that Python has and where it is used in the industries. Finally, we can take a look at how to get started off with the Python basics and end our session with the career opportunities that Python holds for us. Let's move ahead with the first topic for today. What is Python? Well, Python is a general purpose programming language which is high level, easy to learn, and dynamically initialized. The development of Python started out as a hobby for its creator, Guido van Rossum, because he wanted to make a language that was beautiful to look at and easy for everybody to read. To do this, he used indentations instead of curly braces to basically describe the blocks of code that came inside the language. The language went on but did not receive love as it was slow compared to the other languages. Now, with the rise of machine learning and artificial intelligence, Python has come into the spotlight because it makes the work much more productive and much more easy. Why is that? Well, it is because of the amazing computing power that we have. We just want work to be much more productive, even if it takes a lot of time. So that basically wraps up this topic of what is Python. Having that understood, let us move ahead and understand why Python is popular comparing it to the other languages. Python is the best language to get started off with. Its easy syntax and high-level features make it one of the best languages for anybody to get started off with programming. May it be kids or veterans, it is the language for everybody. The next reason is that Python is an open source language, meaning that it is free for anybody to use. Every day, there are thousands of programmers who come together online in making Python better and efficient. You modify the code, you break the code, and you make the code. You're allowed to do it without any problems. Moving ahead, Python can be used to make almost anything. GUI applications, web applications, mobile app server-side coding, artificial intelligence, machine learning algorithms, anything that you want to make, Python will always have the way to do it. Lastly, there is a huge community of people who come together to make the libraries or modules that can be used to obtain your solutions. Just for an example, machine learning algorithms are already available and you can use them to obtain your solutions better. Your productivity right up there. Your code is much more lesser. You can see why people around the world prefer Python so much. Features make a language attractive, and that is what Python is made up of. Features that make anybody want to start coding with it. Let us now see the different features that Python has in store for us. The most well-known feature of Python is its simplicity. Python has made programming fun because it is simple. It makes you think more for your solution rather than the syntax. The next important feature is that Python is an open source language, which means that it is free for anybody to use. Modifications to Python are also allowed without any problems. Which brings us to its next feature, portability. Python supports portability, which means that you can write your code and share it with anybody that you want to, and it would work the same way as it does for you when you run the code. This makes movements of projects and systems much more easier. Our next feature are the embedding properties. Chances are that certain languages may perform certain functions better than Python, but that does not stop you, as Python supports adding code of other languages into itself to run those functions, which makes Python all the more powerful. With that, let us move over to the next feature, interpretation. Python is interpreted line by line, which makes the management of memory and CPU and debugging of the code much more simple. If you wonder by now whether Python is the language to get started off with, let me tell you that it is. Python has a huge library support which would help you to obtain solutions to your problems easier. You can get started off with data science, web development on the go with Python. You may have had questions like how do developers make applications that are so well related to a domain? That is because of object-oriented concepts. Python supports OOPS, meaning that you can model a real-world problem into your code and have security for it such that access to them is restricted, which helps you replicate real-world scenarios. Now that we know all the amazing features that Python has for us, why don't we look at a few of the most well-known companies who use Python? Google is the most known tech giant who uses Python to provide better search features to its users. Dropbox is a cloud platform to save data online. Its client and server applications have been coded using Python. Netflix uses machine learning with Python to learn the taste of its users, cluster them into groups, and then recommend them shows to retain them for longer. The National Security Agency uses Python for cybersecurity analysis and for the encryption and decryption purposes. The BitTorrent application, which is used for peer-to-peer communication, started out as a simple Python file. NASA scientists use Python to perform calculations, which helps them reduce time and makes their work easier. So these are the major companies who use Python. As you may know, Python is a very important language and it would definitely be beneficial if you start learning it. Now you would wonder, how do we get started off with learning Python? Let me help you with that. So to get started off with learning this amazing programming language, you would firstly need the basics, which are variables, data types, and operators, which helps you to understand data and the different data types that you can use, such as numeric, lists, tuples, and so many more. Naming data and performing operations, which can help you to obtain logic or simple addition or subtractions and so forth. Once you understand that, you can move ahead to understand arrays, which can be used to store data in a structured manner. Nextly, understand the flow control working and how you can manipulate it using loops, such as the for loop and the while loop, and conditions, which are the if-else statements. You can then study about how to make methods which are basically used to perform certain functions, which can be as simple as adding numbers to performing the most complex of work that you can think of. Later, learn how files are handled, where you can read data from files and write data to the files. You can then learn about OOPS by understanding classes and objects and what their importance is. And finally, to master it all, you need to practice Python as much as you can, because practice is what makes you better at it. Once you are done understanding the basics, what do? You master it. There are a variety of careers that are at your disposal. Stick to the one that you feel is your goal and start mastering it. Which brings us to the career opportunities that Python holds for us. Web app development is an option that you can choose. You have frameworks such as Django and Flask that can be used to create web applications. Game development is also a career option that is available, where you can create AI enemies and bosses and graphic textures accordingly. Big data analysis is a booming field which can be used to obtain data helpful to make decisions and help take risks for better profits. Web app testing is also an option where you can report bugs and make sure that a website works as needed. Data scientist, machine learning engineer, artificial intelligence are some of the fields that everybody wants to get into, and it is clearly one of the jobs that looks like it would have a long life cycle. Smart IoT devices are another place where you can use Python and build better infrastructure for connecting the world. So those are some of the most well-known career opportunities that Python has for you. There are many more, such as a software developer, automation engineer, and much more. So now, I hope all of you know what Python is and why everybody loves it so much. I hope all of you would consider learning Python because it is just fun to learn and easy to program with.
Netflix is the leader of its clan for video streaming, and for all tech savvies, this market giant has revealed that Python is the secret to its success. Before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards this session, let's first begin with a small introduction to Netflix, and then we shall move on to see how Netflix uses Python in various sectors such as for its CDN, which is OpenConnect, for demand engineering and machine learning, big data analytics and scientific experimentations, video encoding, animations, security, and finally for monitoring and auto remediation. So without any further delays, let's get started. Netflix, as we all know, is an American company which renders video on demand services. It has about 148 million subscribers throughout the world, and the number, however, keeps growing each day. In a period of approximately 2 decades, Netflix has emerged as the king of its clan for the biggest TV series and movies throughout the world. Being the fastest growing brand of America and having a revenue of $20.5 billion till June 2019, it's enough for it to be an eye-catcher, thereby interesting all into its technical spheres. Let's move on to see how Netflix uses Python in its various domains. Engineers at Netflix admit that they use Python for the full content lifecycle, from deciding which content to fund all the way to operating the CDN that serves the final video to 148 million subscribers. Now that we've taken the name of CDN over here, let's move on to see what this is and how it makes use of Python. The CDN or Content Delivery Network that Netflix makes use of is OpenConnect. This basically comes into picture when you hit the play button. All the content delivered to the end user is looked after by this CDN. OpenConnect basically requires various other softwares to design, build, and operate it, which are in turn written in Python. Not just this, the network devices underlying this CDN are Python applications, since Python is prominent in solving network issues. Now that we are aware of the first component, OpenConnect, let's move on to see how Netflix uses Python for its demand engineering. The demand engineering team is responsible for handling Netflix Cloud's regional failovers, traffic administration, capacity operations management, which is looking after the limit up to which the content can be made serviceable, and fleet efficiency. The libraries used by this team are the NumPy and the SciPy library, which is used for performing numerical analysis, Boto3, which is the software development kit of the Amazon Web Services for Python. This helps Python developers integrate Python into AWS, thereby allowing development in the infrastructure. RedisQ or RQ, which is a Python library which helps to keep track of the tasks that are present in the queue and allows their execution, thereby allowing the management of asynchronous workloads. Flask. Netflix uses Flask for Python web development. Netflix uses Flask APIs to bind all of the previous segments together. Not just this, Netflix also makes use of Jupyter Notebooks along with Interact, which is an extension for Jupyter on a large scale. Jupyter is known to be popular for data analysis. It serves very well in operation data analysis and visualization, which in turn help in detecting capacity regressions. Now let's move on to see how Python is used for machine learning. Machine learning ranges from creating personalization algorithms to figuring out the use cases. Personalization algorithms help to train the machine learning models as per the Netflix standard. It also provides personalized recommendations, outlines on a day-to-day basis, label generations, etc. The libraries required to learn deep neural networks are TensorFlow, Keras, and PyTorch, whereas XGBoost and LightGBM for gradient-boosted decision trees. Netflix has also developed quite a few higher-level libraries that help in combining with the work areas such as fact logging, feature extraction, publishing, etc. Apart from all this, Netflix also makes use of Metaflow to create machine learning projects. The big data team is responsible to execute the ETL or the extract, transform, load, and ad hoc pipelines. A major part of this orchestration is written in Python. This team uses a scheduler which runs on Jupyter notebooks with Papermill to produce job types with templates, for example, Spark, Presto, etc. In addition to this, the team has also created an event-driven platform which is built completely on Python. They've created a number of events and combined it into a single one, allowing Netflix to filter, react, and route events. Okay, so now let's move on to see how Python is used for scientific experimentations. This platform is basically created for experimentations and to allow A/B testing. Guys, A/B testing is also called as split testing, and it deals with comparing two versions and figuring out the better performing variation among them. The scientific experimentation team can also present new innovations in data, statistics, and visualization. The Python framework that is implemented here is Metrics Repo, which is based on PyPika and allows writing of reusable parameterized queries. For the statistics sector, PyArrow and RPy2 are used to calculate the statistics in either Python or R. Plotly helps in visualizations. Video encoding or media cloud engineering. This team is responsible for encoding and re-encoding tasks for the Netflix catalog. Python is used approximately for 50 projects such as the VMAF, which is Video Multi-Method Assessment Fusion, and Mezzanine File System, Computer Vision Solution, which deals with imagery using Archer, etc. Netflix Animation and NVFX. Python forms the base for all animations and visual effects at Netflix. Maya and Nuke, which are 3D and 2D computer graphic applications, are united using Python. Now let's move on to see how Netflix uses Python for its information security. Netflix uses Python-powered information systems for auto-remediation, security automation, risk classifications, etc. The most active open source project of this team is SecurityMonkey. Netflix also uses BLES, which stands for Bastion's Lambda mFerel SSH service to protect secure shell resources. RepoKit is used to grant IAM permissions, and TLS certificates are allotted through Lemma. Both of these tasks rely mainly on Python. Finally, let's move on to see how Python is used for monitoring and auto-remediation. The monitoring and auto-remediation team is also known as Insight Engineering Team. They build and execute tools for operational insight, diagnostics, auto-remediation, and altering. For most of its services, this team makes use of Python. For example, the Spectator Python client library. This library is used for recording dimensional time series. Along with these libraries, products like Winston and Bolt are also built on Python frameworks which are Flask, Unicorn, and Flask REST Plus. Summing it all up, one can easily claim that Python is the driving force for Netflix. Python has swallowed all its rivals in popularity, and this popularity is directly proportional to money making. So before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards this session, we shall first take a look at who are Python developers and what are their job trends. Then, we shall take a look at the average salaries drawn by these developers based on three factors, which are experience, location, and skill set. So without any further delays, let's get started. A Python developer, just like any other developer, is someone who designs, programs, and delivers software applications, but using Python. Some of the most important responsibilities include writing effective code for backend components, testing and debugging programs, creating applications that can be integrated with the present ones, etc. The current salary trend of these developers has also remarkably increased. But before taking a look at that, here is a survey that reasons out why Python developers are heavily paid. Python's popularity in 2019 is record-breaking. According to Stack Overflow, Python has emerged as the most questioned language, leaving behind its fierce competitor JavaScript. GitHub grants Python top slot in the race for popularity. So as you can see on the screen, Python stands first, Java is second, followed by JavaScript, etc. This popularity is also a reason for the growth in job trends for Python developers. These developers are in great demand all over the world. In August 2019, Indeed shows about 69,000 openings for a Python developer. Most of these jobs are in sectors like web development, big data, machine learning, data science, etc. New York City has the most number of job postings for Python developers, followed by Chicago and San Francisco. So given this, I know you all will be eager to know what is the average salary drawn by these developers. The average salary depends on many factors. The three most important factors are experience, location, and skill set. So talking about a Python developer's experience, an entry-level Python developer earns a minimum of 2.4 lakhs per annum. The upper limit, however, depends on the organizations and the skill set possessed by the developer. On an average, the Python developer's salary at an entry level is about 5 lakhs per annum in India and about $88,000 in the US. The next level of these developers is becoming a senior Python developer, and at this level, the average salary comes about 8 lakhs per annum. The biggest leap in salaries is seen after the senior level for developers. So now let's move on towards the next factor, which is location. Salaries of Python developers also vary geographically. In the US, the best location for a Python developer seems to be California. Having an average of $122,000 per year, California stands at the top of the list for best work locations for Python developer. When it comes to India, the best location for a software developer with Python skills is Gurgaon, having an average pay scale of 7,31,000 per year. Okay, so now moving on towards the next very important factor, which is skill set. Having the knowledge of Python along with other skills proves to be a very crucial factor influencing Python developer salaries. According to CV Compiler, the most in-demand skills preferred along with Python are AWS and Django. The average salary for a Python developer having knowledge of Django is about 6 lakhs per annum, which is much higher compared to the average seen earlier in this session.
How to become a Python developer. So guys, I'll be discussing everything related to a Python developer. Who is a Python developer? What are the various job roles available in the market? Who can become a Python developer? And then prerequisites and everything around, if you're looking to, make a career in Python. Let's move forward and have a look at the agenda for today. So this is what we'll be discussing today. We'll begin by understanding who is a Python developer and why one should even consider Python as a preferred programming language. Then the question is, how should I start? How should I go about becoming a Python developer? Then we'll focus on various job roles for a Python developer, and let me tell you that there are a lot of job roles out there, right? So if you think about Python, you have a lot of fields, a lot of domains that you can go in, right? Then a few projects for practice. You can just find it on the internet and it's available. And I believe the best way to learn anything is to start working on it. And you should start working on the project. So I'm going to give you a small introduction to a few of the projects that you can start with. Now, the question is, who is a Python developer? So let me tell you that, first of all, a Python developer does not, is a very subjective term, I would say. Why? Because, there are a lot of domains, there are a lot of different types of job roles available in Python, right? So when I say Python developer, does not necessarily mean I'm talking about a software engineer. Does not necessarily mean I'm talking about a web developer or a mobile app developer, right? So a Python developer is a very vast field. Something which doesn't exist, right? Because there are certain fields or subdomains in Python that you can, come up with a job role around that. That's what I mean, right? So, he can be a software developer, a software engineer. He can be developing web apps, mobile apps. He might be even into testing, right? Because you can use Python with Selenium. Then he can become a data analyst as well, or he can be a data scientist, machine learning engineer, artificial intelligence engineer. So there are different types of job roles available in the market. Next up, we are going to focus on, why become a Python developer, because everything exists for a reason, right? And let's try to figure out why one should even consider Python as a programming language when you have Java, JavaScript, and other different programming languages. And the best answer given to this question is by Stack Overflow. So have a look at the graph, guys, right? I don't have to explain anything here because the red line, the red curve that you're seeing is of Python, right? So from 2012 till 2018, you can see that it's an exponential growth, right? It's a straight line, right? So yeah, it's growing pretty fast. And I would also tell you one thing, guys, it always makes sense to learn something when, there's a demand. You cannot, surf when there are no tides, right? So just to explain you that. Now, Python comes with really, really cool features. So let me just talk about those features. First of all, it is very, very easy to learn. So all the people who are actually scared of coding, uh, don't have to be scared of Python. I'm being really honest because it is very, very easy to write code in Python. The syntax is very easy, right? Then tons of libraries, guys. If you are talking about machine learning, web development, numeric computation, scientific computation, whatever comes to your mind, any type of application, Python gives you a very good library around that, whether it's computer vision, anything you can think of, right? So there are a lot of libraries available with Python that you can use for multiple purposes, right? Next is it is free and open source, that I think a lot of you might already know, right? And the best part is it has a very active community, guys, right? High demand, as I've just proved with the Stack Overflow graph. Apart from that, since Python is not only used for one particular domain or one particular purpose, so if you learn Python, you can go into any field, right? It's like, a typical Indian household, parents who tell their kids to go ahead and study engineering and then he can decide what he wants to do. Well, something similar, but this makes more sense, right? So these are the various features, guys, right? And few companies, few giants who are using Python, and let me tell you guys, each and every company out there in the market nowadays use Python, right? I've written down few big names so that you can actually relate: Google, NASA, Firefox, YouTube, Netflix, Facebook, Dropbox, Raspberry Pi, IBM, Walt Disney. All of them are using Python and are very happy about the services and basically whatever Python comes with, right? Next up, we are going to talk about salary trends. This is something that you can see it on your screen, but I would definitely tell you guys it is an average number, and generally a data scientist is not gonna earn 8 lakh per annum, 8 lakh rupees per annum. It will be definitely more than that. It's just an average. We have taken it from a pay scale. It is definitely more than that. I'm telling you that through my experience, right? And DevOps engineer also earns a lot more than what it is here. Apart from that, there is also a stat around the Python developer salary in popular cities, right? So we have San Francisco, which is paying somewhere around $137,389 US dollars to Python developers, which is pretty great if you ask me. And I'm definitely sure it is way above than $150,000 in US as well, right? But for now, let's focus on how should I start, how to go about becoming a Python developer. Obviously, everything starts from basics, right? You have to understand the fundamentals to reach to a certain level. So first of all, install Python. Go ahead, type on Google, install Python, right? You'll go to their official website. You'll find a lot of things out there. I can actually show you that. Let me just open it. So if you click on install Python, you'll be directed to this website. Download Python. Here, just select the version, select the OS that you're using, and you are good to go, right? Choosing an IDE is, it varies from person to person. I prefer PyCharm. You can also download PyCharm. Let me just take you to one more link. Download PyCharm. You'll be directed to a JetBrains website. And here we go. So just go ahead, click on the community version because the professional version is, you have to pay some amount for that, right? So go ahead, click on the community version, download it, and it's very cool, guys, because it gives you autocomplete features and a lot of other benefits as well. You don't have to manually go and install the libraries using CMD. You can just go ahead, use PyCharm and do it, right? Choosing an IDE is done. A simple hello world program, right? So I've already installed Python. I have PyCharm. I'm just gonna show you how easy it is to write code in Python, right? So let me just quickly open my PyCharm, and all I'll do here is print hello world. Alright, I just have to click and select the interpreter as well. Let me just go to the settings. I'll just go to the interpreter. Just have to select the interpreter and we are good to go. Now let's go ahead and try executing again. It is again saying that you haven't selected an interpreter. I just did. That's weird. Let's see. Yep, I can see there is an interpreter. So just waiting 2 minutes to process. Let's just wait for that and we'll go back to our slides till then and we'll continue. So I'll tell you how to execute a simple Hello World program. Just give me like 5 minutes. After that, let's see what we have next. So we're going to talk about a little bit about the basics. So obviously, as I've told you earlier as well, to become a Python developer, to become a data scientist, or you know, to go to a level in your career, you have to start everything from basics, right? So we have we already talked about how you can install Python, how you can install Python IDE, which is PyCharm, right? And now let's talk about what are the basics that you actually need to learn. Now, people who are from a programming background can easily understand this, but people who are not, let's just focus on them. So variables and data types, you need to understand how to declare variables, how to, what are the different types of variables that we can declare. So there are numeric variables, there can be list, tuples, sets, dictionaries, all those data types you need to study. There is a separate tutorial on all of these. You can go ahead and check out that in the Python playlist. But for now, let's focus here what I'm talking about. Then we have functions, exceptions, and input-output operations. So how you input-output operations basically mean how you can open a file, how you can delete a file, how you can give an input to the programming language, right? If you want to input something, the user wants to input some variable value, right? So input-output operations, plus how to open, close files, delete files, add certain things, append certain things in a file. So all those things. Apart from that, exception handling, right? What about 1 by 0? Some term like that comes which has no answer, right? So how will you handle those exceptions? That'll be covered in exception handling. There are functions which are nothing but useful code blocks, right? So that you don't have to again and again write the same thing, right? If you have, for example, if you want to calculate factorial 10 times in a program, you don't have to write the logic 10 times. You can write a function and execute it 10 times. Just an example, guys. Then loops, control statements, and conditional statements, which are very important, right? I am pretty sure you guys know what are loops, right? If you have a set of, if there's a logic that you want to repeat again and again and you have a condition defined, then you can go ahead and use loops for that, right? So there are different types of loop. There is a while loop, right? There's a for loop. So there are nested loops as well, where inside one loop you can define one more loop. Conditional statement, if, elif, if statement. So if a particular condition is true, execute this. If it is not, then execute the next statement. So those kind of things are called conditional statements. Data structures, then you have OOPS concepts. What OOPS concepts basically, your polymorphism, encapsulation, classes, objects, how to declare them, what are global variables, all those things. It's basically a very vast field, OOPS, and it is very, very important. And Python is one of those programming languages which have object-oriented as well as procedural concepts, right? And file handling, I've just told you in the beginning itself how to open, close, delete, add, append, all those operations with a file, right? How you can do that with the help of Python, right? So now let me just go ahead, open my PyCharm and I'll execute that Hello World program. So I think we can execute it now. Just a second, guys. It is just indexing right now. Or how about I go ahead and create one more Python file. Let us name it as test. And I'll type here print hello world. And here we go. Yep. So with one line of code, I can do this. Try doing that in Java. So guys, that was a very simple Hello World program that I've written. There are separate tutorials I'm again and again telling you guys. All right, so now let's talk about the job roles, which I'm pretty sure everyone is waiting for it. Next, we have job roles, as I was mentioning. So there are software engineers and developers, right? So these people might be writing APIs for your web app, right? These people might be, helping with mobile applications. These might be mobile application developer, web application developers, right? So basically, who are or desktop GUI developers or game developers, all those people, right? So what sort of skills industries look for in such a profile, right? So core Python basics, right, which I've just mentioned at the beginning, where I was talking about data types, variables, functions, OOPS concepts, file handling, conditional statements, loops, control statements, all those things, right? Apart from that, you need to have basic knowledge about the web frameworks, right? Object relational mappers, RESTful APIs. You need to understand all these terms, guys. I cannot go into detail of all of these terms, but just to give you a knowledge, basically you need to understand how the web works. You should know the basics of web, front end, back end, and you should be aware of libraries such as Django and Flask, which are very famous Python libraries for web application development, right? Database knowledge is a must, because where is your data anyway going after somebody does any sort of activity on a website? It will go to a database, right? So that database knowledge is very important for any developer out there in the market. When I talk about script writing, so scripting is a little bit different than programming, right? So scripting basically is, suppose I want to execute 7 programs sequentially, right? So what I can do is I can write a script that can execute those 7 programs in an order that I have defined, right? So it basically automates a lot of tasks, right? In this case, I can write a script that will automatically take my data and create a schema and store it in the database. So there are a lot of other things that you can do with a particular script, right? So just wanted to tell you the difference between scripting and programming, and I hope you have understood what you need to understand, what you need to learn, what are the skills required in order to become a developer, whether you are a web application developer or any sort of developer, right? Let's move forward, guys, and let's see what is the job role we are going to focus on next. So we're going to talk about a Python web developer, right? We just spoke about a web developer in the previous slide as well. So here it's all about understanding the web, HTML, CSS, Django, Flask, MVC, MVT architecture, model view controller, template. So these are all things that you need to understand, right? These are few things which you will know once you start going and researching in that particular field, right? Database knowledge, as I've told you, it is a must for any sort of developer, right? Script writing is also very important, because without scripting, guys, there's no automation, right? Any automation tool that you use now also uses script, right? So just to clear that doubt, scripting is also very, very important, right? Now let's see which job role we are going to focus on next. All right. So a data scientist, sexiest job of the 21st century, right? Now, what do you need to learn to become a data scientist? What skills are industries looking for in a data scientist? So you definitely require core skills, right? Core Python skills, which I've just discussed. Mathematics and statistics is the core, or you can say the foundation of a person who wants to become data scientist. That is very, very important. These fundamental topics are very, very important, guys, and people generally ignore them, right? So basics of programming, core Python skills, mathematics and statistics. Apart from that, you also require skills like, data visualization, data wrangling. You might have to clean the data before processing it, right? Then there's a skill called EDA, exploratory data analysis, where you just look at the data, understand the data, what it is talking about, what should I predict, what I can't predict, which rows are useful for me, which columns are useless for me. Can I subtract a couple of columns and come up with a new column that might be more useful for me? So these are the things that, you should have that. It only comes with experience, and that's how it works. Apart from that, a very important skill is machine learning and artificial intelligence. So you need to be very, you need to understand all the machine learning algorithms. You need to understand where I can use which sort of a machine learning algorithm. And if you want, you might come up with a different algorithm as well. So how you can achieve that with Python? So with Python, there are a lot of libraries that you can work on. So there's a library called Pandas, which is, for creating data frames. So you can import any sort of data with the help of Pandas, whether it's a TSV file, CSV file, Excel file, doesn't matter. You can import that data. You can perform basic operations, joining, concatenation, merging, any sort of operation. Then you have NumPy, because Python does not support any thing called arrays. There's nothing called arrays, right? So there are NumPy arrays that you need to create with the help of NumPy package, right? So any sort of matrix operation you can perform with the help of NumPy. Scikit-learn is a library used for machine learning. So it has predefined methods for different algorithms, whether it is KNN, K-means, all those algorithms. There are predefined functions or methods in this particular library that you can use. And very cool feature about this library is that it comes with sample data sets. So you can practice those data sets. You can practice those data sets the way you want. You're getting data sets, guys. You don't have to download it. What else do you want? So I've just received a very good comment. The explanation is very good and helpful. Thank you, Mumtaz. Is it easy to learn Shravya Reddy? Well, let me tell you, this is the easiest programming language that I have ever come across. Okay, so Shravya Reddy has one more question. I am fresher to learn Python. Is it useful in future? Please tell me. Well, Python is growing at a very, it's at a very good rate. I just showed you the graph of Stack Overflow. Python is it's in demand right now, and whether it is any domain, Python is useful, and definitely it will take over all the other languages in another 5 years, right? Because of the kind of community that they have and the kind of packages that they come with. Right, so let's move forward, guys. So now we're going to talk about data analyst, right? So data analyst is someone who understands data and who understand a lot of things, who understand the entire data lifecycle, who can take care of data wrangling, who can take care of data exploratory analysis, right? All those things, but they have only implemented simple linear regression models, right? They are not aware of those complex algorithms or some neural networks or some complex machine learning algorithm which can be unsupervised, for example, k-means. So they build prediction models, simple regression models, sales forecasting and things like that. They are very good with data manipulation, and they have this skill which is very important, and it is called as data-driven problem-solving approach. So you need to understand, what sort of approach should I take for this particular data, and that only comes with experience, right? So that's how things work, because you cannot just apply one algorithm to all the data sets that are there in the market, right? You need to figure out what sort of a problem is it. Is it a clustering problem? Is it all those things. So basically, I don't want to go into too much detail here, but that's what a data analyst is, right? So let's see emerging job roles. So AI and ML engineer, artificial intelligence, or popularly also called as machine learning engineers. So these people are not bothered about data pre-processing. They get the good data. They get the data where they have to predict something. It might be a regression problem where they're predicting something. It might be a clustering problem where they might be clustering different people, right? It might be a classification problem where they are classifying whether the given input is X or Y, right? So that's what the major job role of machine learning engineer or an AI engineer is. So they require programming skills, data science skills, and machine learning, right? So that is what basically an AI ML engineer should have, right? Apart from that, neural networks is what people are talking about right now. It is a buzzword in the industry, and it takes machine learning to the next step, and it is called deep learning. I cannot go into detail here. I hope you guys can understand. But deep learning is very, very interesting, guys. And there are a lot of libraries that Python has for deep learning. One is TensorFlow, right? And it is given to us by Google. So I hope you guys trust Google, right? So, it's a very good library, and I find it pretty interesting. I have separate tutorials on TensorFlow as well, right? I have worked on TensorFlow, so you can go ahead and check out my videos. Next is Python automation testing. So what is Python automation testing? Is basically, you're using, okay, let's talk about Selenium, because I can see only Selenium in the slide. So Selenium, you can write scripts in Python using Selenium, right? You can perform functional testing, basically, testing login of any website, testing any feature, whether it's login, whether it's search engine, or any sort of feature, whether the link is clickable, the button is working. All sort of functional testing, or you can say user acceptance testing, can be done with the help of Python in a very automated fashion. Next is a deep learning engineer. So deep learning engineer focuses mainly on neural networks. So he'll need to understand different types of neural networks. Whether it's a recurrent neural network, it can be a convolutional neural network, it can be RBM, autoencoders, fully connected networks, or single layer, multi-layer perceptrons. So they should have that thing where they can understand all of these different types of networks and have good experience in working on applications such as video processing, image processing, computer vision, speech to text, text to speech, image recognition. So how do you think that the Facebook auto tag feature works, right? So it works with the help of deep learning only, right? And right, so that's how it is. Now comes the roadmap, guys. Okay, so I have I'll talk about each and every job role one by one. So how you can master core Python. So what you need to understand, you need to learn variables and data types, file handling, exception handling, oops concept, data structures, iterators, generators, right? So these type of things where basics of programming you need to understand, right? Then, well, let's talk about master web frameworks. So Django or Flask, whatever you prefer, right? Tkinter is basically for GUI based web apps, right? Then we have MVC MVT architecture, that is basically model view controller and template that you need to understand. HTML CSS is a must for any web developer, guys, right? It's and there's no rocket science here. I think people should be aware about it, that web developers have to learn HTML CSS. Okay, just a second. Towards data science, if you want to go, statistics, applied math, data visualization, analysis, basically any sort of data manipulation, you need to understand that. On top of it, you need to understand machine learning. And you have, Python libraries to make your life easy. Machine learning and artificial intelligence, you need to be very good with the machine learning algorithms, understand, libraries like scikit-learn, TensorFlow, probability and statistics, you should be very good with. Apart from that, neural networks and deep learning, if you're looking to become a neural network deep learning engineer, right? So deep learning, again, there is a neural network architecture that you need to understand. So machine learning and deep learning, there's a very thin line here, but deep learning is nothing but an advanced machine learning, right? So don't get confused here. Both are the subsets of artificial intelligence, right? Artificial intelligence is an umbrella term which encompasses machine learning and deep learning together. So this is I don't want you guys to be confused about it. I mean, it's very easy to understand machine learning. The next step after machine learning is deep learning, which uses neural networks. So it's nothing but advanced machine learning. And OpenCV for computer vision, web scraping with BS4 predictions, models, etc. is what you should be knowing. So OpenCV is basically a library which is used for computer vision. Again, I have a separate tutorial on OpenCV as well, so you guys can check that out. Apart from that, web scraping is nothing but scraping data or collecting data from different websites, web pages that you can easily do, right? And prediction models is I think you guys are already aware of.
Let's take a quick look at why you should consider learning Python. Well guys, Python is a general purpose language, but it has a wide range of applications ranging from web development, scientific and mathematical computing, and even designing your own graphical user interfaces. So you can make use of Django and Bottle for web development, you can make use of NumPy and SymPy for mathematical computations, and you can design your own games using Pygame as well, and so much more guys. And also the syntax of the language is really clean, and the length of the code is relatively short. It's fun to work in Python because it allows you to think about the problem rather than focusing on the syntax itself guys. And every Fortune 500 company that exists today uses Python in one way or the other guys. You don't even have to do any digging to know this fact. And again, as I said, Python is extremely popular among both the startups and established industry giants. And programming in Python is definitely fun guys. It's easier to understand and write Python code. Again, why? Because the syntax feels natural guys. And on that note, let us come to the main agenda of the session, which is to help you all to install and set up Python. Let us begin. So guys, to begin with and install Python, the easiest way is to come to the official documentation page and go about from there. So here I have opened up the official python.org page and we are in the download section of the page. As you can check the URL, we are at python.org/downloads/Windows guys. Since this tutorial is mainly focused on installing Python for Windows, we are here guys. Just in case if you had to install on Linux or something, the steps are quite different from what we do for Windows. However, coming back, the latest Python 3 version release is Python 3.7.2 and the latest Python 2 release is 2.7.15. Well, based on your requirement and your needs, at this point of time, you should already know which version of Python that you should use. And just in case if you don't, you can actually install both of these versions, Python 2 and Python 3, into your machine and go about from there as well, guys. Well, as you can check out, 3.7.2 is the latest version of Python at the time that this session was curated, guys. So basically, we need to go and download this from the official site. Well, all you need to do is click on the latest release version there and it'll take you to the download section, guys. However, the first section is actually all of the changes and the new features added in Python 3.7, and there are multiple documentations here as well. So basically, this is all the changelog of this particular version of Python, guys.
Well, all you need to do at this point of time is to scroll down to the files section and then search for Windows out here. Well, as you can see, there are multiple versions to install, right? So you actually get an embeddable zip file, which is actually a zip file where you have to unzip it and then install it manually, or you actually have an executable installer, guys. And if you can notice, there are two versions here as well. One is the 32-bit version and the other one is 64-bit version, guys. Well, basically, you need to know if your machine is either running a 32-bit version of Windows or a 64-bit version of Windows, guys. But however, do know that the 32-bit version is actually backwards compatible with 64-bit as well. So what I mean by that is, in case if you have a 64-bit machine, you can still go ahead and install Python 32-bit and it would work absolutely fine. But if you have a 32-bit Windows, then you will not be allowed to install the 64-bit version, guys. I hope I'm clear with that. And now that you would be familiar with your particular version of Windows, both are actually of the same installer as well. Well, as soon as you go ahead and download it, and basically all you need to do is open it later, guys. Giving it administrative privileges is a choice, but then it is always recommended. So as soon as you run it as an admin, you'll be greeted with the following screen, guys. So basically it is telling you the Python version right now, and it has automatically selected 64-bit version for my machine, guys. So basically you can actually customize the installation at this point. You can choose the location and the features you need as well, and all of that. One main thing that I want you guys to do is that make sure that this particular option is checked. It says add Python 3.7 to the path. I will let you know why this is really important, but just make sure to check this at this point, guys. And all you need to do is hit install now, and Python is ready in your machine, guys. Well, basically, as you can already see there, it says that a program called idle is also installed with it, right? So idle is nothing but a graphical user interface which is used to work with Python, guys. So let me quickly open up idle to show you what it actually is. Well, as you can check out, it is basically a Python 3.7 shell, guys. So here you can actually type out anything that you want. So let us say print hello Edureka. As soon as I hit enter, that is executed, right? So basically you can run any of the Python programs here as well. So let me go ahead and do another x equal to 10, print x into 2. So x into 2 is basically 10 into 2, 20, and that is good, right? So it basically provides a GUI for Python, guys, as simple as that. But do note that if you actually have a Windows machine, there is a very good chance that Python might already come installed in your machine, guys. However, there is one more thing that you need to do. Well, that is to actually check out your environment variable, guys. So basically, you need to right click on my computer and go to properties, guys. And in properties, you need to go to advanced system settings and environment variables. And here you need to check if the path of the user variable actually points to your Python installation location, guys. So this is basically why we had to have the checkbox during the installation. Well, if this is not the case, then you have to manually come here and add the path in the system variable, guys. So why is this required? I'm pretty sure you guys could have already guessed it at this point, but let me quickly go ahead and show you a demo. Let me open up my command prompt, and if Python is in my path, as soon as I hit Python, it is supposed to open up the interpreter and be ready for me to execute commands, guys. And since I already have the path established, it is actually done. So it is as simple as this, guys. Well, installing Python is actually pretty straightforward and simple, but let me quickly push you on another concept, right? Well, so next up on this session, we'll actually check out the different development environments available for Python, guys. Well, Python has a large supporting community and there are numerous active forums online which can be handy if you're stuck anywhere, guys. Well, at Edureka, we have a vast community for Python, lots of blogs, and these amazing videos created by our subject matter experts as well. So make sure to check them out, alright? So we have multiple development environments for Python, guys. So we have PyDev for Eclipse, we have PyCharm, we have Notepad++, and Bluefish for you all Mac users as well. We have Komodo and Vim too. Guys, these are some of the many IDEs that's out there that you can develop code in. Well, I suggest you use something that you're comfortable with and then go from there, guys. Well, choosing an IDE is like choosing an ice cream flavor. You need to first try it out practically and see if it suits your need perfectly. If it does, then go ahead and make use of it, guys. Well, personally, in my case, it has been a long journey with Python, guys. I have tried multiple IDEs and I have a personal liking towards PyCharm. It is really simple and amazing to work with. And I'm sure a majority of the entire community agrees with me when I say that PyCharm is the #1 IDE for Python, guys.
Let's talk about how you can write a simple Hello World program in Python. Before talking about a simple Hello World program, let me talk about the Python interpreter. Or Python is also a piece of software called an interpreter. The interpreter is the program you'll need to run the Python code and scripts. Technically, the interpreter is a layer of software that works between your program and your computer hardware to get your code running. Now, depending upon the Python implementation that you're using, the interpreter can be, when you're writing a program in C, it's going to be CPython. And if you're writing the program in Java, it's going to be JPython or Jython. And then we have a program written in Python itself. Then we have PyPy. And for the program implemented in .NET, there is going to be IronPython as the interpreter. So whatever form the interpreter takes, the code you write will always be run by this program. So therefore, the first condition to be able to run Python scripts or Python program is to have the interpreter correctly installed on your system. Now, the interpreter is able to run Python code in two different ways, which is basically as a script or a module. And the next one is as a piece of code, which is typed into an interactive session. So talking about the Hello World program, guys, in Python, if you want to write a simple Hello World program, it's very easy. You just have to write a print statement. And inside the print statement, you just have to specify the string, which is hello world inside the inverted commas. So let's take it up to the command prompt, guys, which I have opened the interactive session already. So to print the hello world program, what I'll do is I'll just mention hello world over here as a string inside the commas. And when I press enter, it is going to show me the output as hello world. So this is as easy as it looks, guys. So this is how you run a simple hello world program in Python. The syntax is pretty easy since it is Python programming, and one of the salient features of Python is the easy syntax. So what you have to do is just write a print statement, and inside the print statement we have written a string which is hello world inside the inverted commas. So now that we are done with how we can write a hello world program in Python, let's see how we will run it using a .py file and other different approaches as well, guys. So I'll exit from here now. Okay, let me open idle, guys, which is what you get when you install Python, guys. So I'll make a file, which is a new file, of course. So I'll just write print hello world over here. Now I'll save it, guys. So I'll save it on desktop and I'll just write it as hello.py. So this is going to be my .py file, guys. So now when I run this, I'm getting the output as hello world. So this is how you run a .py file in idle, guys. So this is a Python shell, guys. So to print the same thing, I'll just write hello Edureka learner. Let's see what is going to happen now. Okay, now when I print this, it's going to show me that the string that I have provided over here. Now one more thing I want to show you guys. When I open my desktop over here, I have a file which is demo and hello as well. So these are my .py file extension, guys. So to run it in using the command prompt, what I have to do is I'll just write Python over here and mention the file that I have saved using the .py file extension. And you will see that, okay, we are not in the same directory, guys. So you have to make sure you should be in the directory where your file is actually saved. So now when I run Python and mention the file name, I'm getting the output as hello world. Now I'm checking the file. I'll check the file over here. As you can see, I'm getting the output over here. So this is how you actually execute a .py file, guys. And a .py file is nothing but a simple file which has a Python code and it is saved with an extension .py which contains the code or the script, guys.
We always like to have options in everything, but choosing the best among them, especially in case of IDEs, gets confusing. So if you have any issues regarding this, here is the top 10 best IDEs for Python to help you narrow down on the most suitable one for you. So before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Moving on towards the session, we shall first begin with understanding what exactly is an IDE and the basic features of it. Following that, we shall take a look at the top 10 best IDEs for Python and the factors that need to be in mind before selecting one of these. So without any further ado, let's move ahead straight away to learn what exactly is an IDE. Guys, IDE stands for Integrated Development Environment. It's a graphical user interface where programmers write their code and produce their final products. An IDE basically unifies all essential tools required for software development and testing. This in turn helps the programmer to maximize his output. Now that you know what is an IDE, let's move on to see what are the basic features of an IDE. Many of us do not know the difference between code editors and IDEs. Code editors are applications that are able to write and manipulate source code. They can either be standalone applications or can be integrated into IDEs. The only feature a code editor should support is being able to edit text. On the other hand, an IDE is a complete environment where you can create software applications. In addition to code editors, IDEs also have other features such as syntax highlighting, which is used to mark the syntax of the base language in different colors and fonts. The autocompletion feature is designed to minimize the time consumption. A debugger is available which is required to test and debug the source code. IDEs also consist of compilers. Now these are tools that translate source code from one language to another. Finally, IDEs can either be language specific or may have support for multiple languages. The choice relies on the user to single out and embrace the IDEs of his choice. Now that you know basic features of an IDE, let's move on to see what are the top 10 best IDEs for Python. At our position 10 is IDLE. It's a cross-platform open source IDE which comes as a default implementation along with Python, and it's written completely in Python as well. Its name is presumed to be in honor of Eric Idle, who's one of the founding members of Monty Python. This IDE is considered to be extremely suitable for the education industry due to its simplicity. It also provides special features such as availability of a Python shell with syntax highlighting, a multi-window text editor, program animation or stepping, which refers to executing one line of code at a time. Breakpoints are available to ease the debugging, and the call stack is clearly visible. At position 9 is Thonny. This is an IDE that was developed for beginners. It provides step-by-step assistance to the programmer. It has separate windows that are provided to execute function calls. Line numbers are available to the user to keep track of each line. Log of the user actions is available so as to assist the user in future. Statement stepping without breakpoints is also possible. Moving on towards the next IDE, which takes the 8th slot, is Atom. Atom is an open source cross-platform IDE built using web technologies. Atom is based on the Electron framework, which is built by GitHub. It also provides some remarkable features such as support for third-party packages and themes so as to format the editor. Atom's APM allows installation and management of packages. It also provides support for a number of languages other than Python such as C, C++, Java, etc. Atom also consists of an exception reporting package. At the 7th place is EricPython. EricPython is an open source cross-platform IDE which is written completely in Python. Its source code is available freely and can be studied and recreated by anybody. Some of the quality features provided by EricPython are formattable window layout, formattable syntax highlighting, code folding, which is selectively showing or hiding some part of your code. It is also furnished with a class browser and has built-in support for unit testing and Django. At the 6th position is Wing. This cross-platform IDE was created by Wingware. It is a lightweight IDE and designed to allow quick programming. It comes in 3 variants, namely Wing Pro, Wing Personal, and Wing 101. Wing Pro is a professional version which is priced somewhere between $95 to $179. Wing Personal and Wing 101, on the other hand, are simplified free versions that are available for students and beginners. Wing provides special features such as automatic multi-process and child process debugging. Remote debug process is possible. It also has a module browser and allows refactoring, which is a process of structuring existing computer code. It also provides auto-completion feature for non-Python files as well. Now let's move on towards Sublime Text, which stands at the 5th position. Guys, Sublime Text is a cross-platform IDE priced at $80. It is developed in C++ and Python. In addition to Python, it provides support for other languages as well. The features of this IDE can be enhanced using plugins. The GoToAnything feature allows quick access to files, symbols, or lines. Its command palette provides robust matching for keyboard invocations. Python-based plugin APIs are supported. This IDE also allows simultaneous editing, and the preferences can be made project-specific. At position 4 is Rodeo. Rodeo is an open source cross-platform IDE built in particular for machine learning and data science. Rodeo makes it very convenient to load and compare data. It also allows data experimentation and is furnished with Python tutorials to guide the users. It also provides cheat sheets for material reference. Files and package search is made very easy. Rodeo is a simple and a lightweight IDE. At the third slot is PyDev. This is an open source cross-platform third-party package which serves as a plugin for Eclipse, which in turn enables it for Python development. PyDev provides a remote debugger wherein the files which are not launched in Eclipse can be debugged. It also provides the code folding feature so as to selectively hide or display sections of code. It provides support for Python 2x and 3x syntax. The auto-edit feature can automatically edit the parentheses, add self-parameter to the class methods, and can also add import keyword in the import lines. Standing at number 2, Spyder is an open source cross-platform IDE designed mainly for data analysis and scientists. It's considered to be a powerful scientific development IDE written in Python. Spyder is integrated with many scientific Python libraries such as SciPy, NumPy, Matplotlib, Pandas, etc. Pertaining to its scientific use, Spyder provides advanced support for editing, analysis, and data exploration. It also allows static code analysis, wherein the analysis is performed without actually executing the code. The features of this IDE can be expanded further through plugin system and API. The IDE that takes the top slot and is at position number 1 is my personal favorite, PyCharm. It was developed by the Zek company JetBrains, and it's a cross-platform IDE. It comes in 2 versions, wherein the community version is free and the professional version is priced at $199 per user. PyCharm is considered to be one of the best IDEs and also the most widely used because of its remarkable features such as specialized project views allowing quick switching between files. It also facilitates web development along with Django, Flask, and Web2Py. PyCharm is equipped with more than 1,000 plugins, so programmers can write their own plugins to extend its features. 81 of the top 100 companies make use of PyCharm. Before ending the session, let me just help you guys to narrow down on the best IDE that's suitable for you. Before choosing an IDE, keep the following points in mind: the level of expertise of the programmer, the type of industry or sector where Python is being used, ability to buy commercial versions or stick to the free ones, the kind of software being developed, and the need to integrate with other languages. Once these points are decided upon, the programmer can easily select among the IDEs which we have discussed earlier based on the given features.
So now exactly on that note, let us start checking out PyCharm. So guys, many programmers nowadays opt for Python to build software application, right? So they need the code to be concise, clean, and readable as well. They can even accelerate custom software application development by actually taking advantage of the number of IDEs supported for Python. Well, a company called JetBrains has actually developed PyCharm as a cross-platform IDE for Python. In addition to supporting versions 2.x and 3.x of Python, PyCharm is also compatible with Windows, Linux, and even Mac OS. And at the same time, the tools and the features provided by PyCharm helps programmers to write a variety of software applications in Python very quickly and efficiently, guys. So the developers can even customize the PyCharm UI according to their specific needs and preferences. Also, they can extend the IDE by choosing over, I think, say around 50 plugins as well to meet their complex project requirements. So again, it is a win-win for everyone, starting from the beginner to the advanced user as well. So PyCharm is one of the most widely used IDEs for Python programming, as I mentioned. At present, Python IDE is being used by all of the large enterprises like Twitter, we have Pinterest, we have HP, we have Symantec, and even Groupon, guys. So this is really a good thing in terms of industry traction. So now that that's done, we need to check out why PyCharm is so popular. I'm sure you guys were thinking about this, right? So let me quickly walk you through all of the features and the tools provided by PyCharm, guys. So first we'll look at the features and later we'll move to the tools. So the first important tool we have is the code editor, guys. So what is the code editor feature? So basically, the intelligent code editor provided by PyCharm enables all of us programmers to write, say, high quality Python code directly, guys. So the editor enables programs to read code easily through their different color schemes, insert indents on new lines automatically, pick the appropriate coding style, and avail context-aware code completion as well. And at the same time, the programmers can also use the editor to expand a code block to an expression or a logical block. They can also avail code snippets, format the code, identify the errors and misspellings as well. They can even detect duplicate code and auto-generate code too. Also, the editor makes it easier for developers to basically analyze the code on the whole and identify the errors while writing the code, guys. Now, that was an important feature, right? So next one I want to talk about is code navigation, guys. So the smart code navigation options provided by PyCharm basically help the programmers to edit and improve the code without putting any extra effort or time. The IDE basically makes it easier for the programmers to go to a class or a file, a symbol, and go along to the declarations invoked from a particular reference as well. And the user can even find an item in the source code or the code snippet, UI element, or a user action almost immediately. So basically, they can further locate usage of various symbols and set benchmarks in the code. And also, at the same time, the developers can even take advantage of the code navigation feature to scrutinize the code throughoutly in this mode called as the lens mode, guys. So next up, we have refactoring. Well, PyCharm definitely makes it easier for the developers to implement both local and global changes really quickly and efficiently, guys. So the developers can even take advantage of the refactoring options provided by the IDE while writing plain Python code and working with Python frameworks. They can avail the rename and move factoring for files, classes, functions, methods, even properties, parameters, and local and global variables as well. Also, likewise, they can improve the code quality by extracting variables, fields, constants, and even parameters. Also, PyCharm allows programmers to break up longer classes and methods through the extract method. So next up is support for web technologies. Guys, PyCharm makes it easier for programmers to write various web applications in Python. So Python basically supports technologies like HTML, CSS, JavaScript, TypeScript, and even CoffeeScript, right? So the web developers can basically use the live editing preview options provided by the IDE to view a single web page simultaneously in the editor as well as the browser. So at the same time, the live edit feature provided by the IDE enables programmers to see the changes made to the code instantaneously on a web browser. PyCharm further allows developers to avail a JavaScript debugger as well as CoffeeScript and TypeScript editors as well. Do note that it even simplifies isomorphic web application development as well. And this is done because it supports both AngularJS and Node.js, guys. So the last feature is support for Python scientific libraries. So guys, PyCharm further helps programmers to use Python more efficiently in big data and data science projects as well. So it supports some of the widely used scientific libraries for Python, starting from NumPy, Anaconda, and Matplotlib as well. So the developers can work efficiently with all of these scientific libraries by availing the interactive graphs, deep code insight, even array viewers provided by the IDE. They can even run the REPL Python console provided by PyCharm to avail robust features like on-the-fly syntax check and code inspection as well. And at the same time, programmers can also integrate the IDE seamlessly with the IPython notebook to create innovative solutions without putting extra time and effort as well. So that is a really good added advantage as well, right? So now that we're done with the features, let me quickly walk you through the important tools. Well, all these tools definitely give PyCharm the upper hand, so let's check it out. So the first one we'll be checking out is database tools. In addition to supporting various Python libraries and frameworks, PyCharm allows developers to work with a number of relational databases including Oracle, SQL Server, MySQL, and even PostgreSQL as well. So the developers can further use the IDE to run the queries, edit the SQL code, browse data, alter table data, and even analyze the schemas as well. Well guys, PyCharm further supports SQL Alchemy library and inject SQL code into code which is written in various programming languages as well. The professional edition of the IDE further makes it easier for the developers to handle large volumes of data efficiently through the data grids. And next we have Visual Debugger. So guys, the Visual Debugger provided by the IDE basically helps the programmers to debug Python, JavaScript, and Django code directly. The developers can use the inline debugger to see live debugging data directly on the editor. Likewise, they can build multiple Python processes simultaneously and step through the code bypass libraries as well. PyCharm further creates reusable and customizable configuration for each test script or debugger execution. The user can have an option to facilitate remote debugging by integrating the visual debugger with the remote interpreters directly. And the next feature we have is built-in terminal. Well guys, PyCharm comes with a local terminal for Windows, Linux and Mac as well. So the built-in terminal basically enables the programmers to continue the code and test without ever leaving the IDE. Also, the programmers can use the IDE to basically run the Python files and configure custom Python environments. Well, this is done according to the precise project requirements as well, so that's good. And at the same time, they can run interactive Python or Django console directly into the IDE. And the console provides useful features like code completion, automatic braces management, and dynamic syntax change. The programmers even have an option to integrate the console with both local and remote interpreters. So the terminal is a really big advantage, guys. And next up, we have software testing. So like any other IDEs, PyCharm also comes with features and tools to simplify Python application testing. It allows developers to perform unit testing through popular Python testing framework like Nose, Attests, and Doctests as well. So the testers even have an option to run individual or multiple test files and test classes, guys. They can further integrate the IDE with coverage.py to measure the code coverage while testing the applications as well. And while testing multi-threaded applications, the testers can use the thread concurrency visualization option provided by the IDE to control the application fully and efficiently. At the same time, PyCharm enables users to deliver high-quality software by implementing behavior-driven development, guys. In short, we actually call this as BDD. And lastly, we have remote development capabilities. Guys, PyCharm allows developers to connect with various machines and build software applications remotely. The programmers can avail the built-in SSH console provided by the IDE to basically connect to machines and perform various development tasks remotely through SSH. So they can even run, debug, and profile the Python applications in a remote environment by replacing the local interpreter with that of the remote interpreter. And also, PyCharm enables programmers to create reproducible development environments through a robust tool called as Vagrant, guys. And this basically simplifies distributed application development, and this is done using Docker. The users even have the option to integrate PyCharm seamlessly with issue tracking systems as well. So in my opinion, that is enough of knowing what it offers. So let us dive right into PyCharm now, and I'll walk you through the interface. Let me open up my PyCharm. So guys, this is probably the first screen that PyCharm greets you with. So on the left here, you will basically have all of the codes that you have actually worked with or any of the recent projects that you've opened. I have a handful of projects right here. So basically this might be blank for you if you're installing PyCharm for the first time. And guys, installing PyCharm is very simple. So it is free and the installation is extremely straightforward as well. So all you need to do is go to the official website and it's a single step download procedure. I already have it installed on my machine, as you can see. So first, let's go ahead and create a new project in PyCharm, guys. So all you need to do is hit create new project on the right side and give a name for the project. So let me just type it out as PyCharm test. And then for now, you might not have the Python interpreter. I'll just come back to this. So for now, let me just hit create and let PyCharm take us to the UI. So basically it has created the project folder for us, as you can check out on the left, and it is blank, right? And this part actually queries all the skeleton procedure. And this is the time where it actually sort of scrolls through and checks all of the installed packages and all. So it probably will take a while and you could actually catch it rotating somewhere here, guys. So this is good. So let us quickly go ahead and create a new Python file that we can write into. So click new scratch file. What type of file are we trying to do here? So the file we're trying to do is Python here, right? So that, and you can write in different languages as well. So basically you can use XHTML, XML, HTML, DTD, command line as well. So right now, since we're doing Python, let me quickly go ahead and type in Python. So as you can see, we have a scratch file, which says scratch.py, guys. So you can basically right click, refactor and rename this to whatever you want. But since this is just a demo, I'll leave it at scratch. So then there are multiple options to go with as well. But if you want to get started really simple, just follow all the procedure until now to create your scratch file. And later you need to add the configuration to actually use Python to run this, guys. So we click on add configuration, click on the tiny plus icon, Python, and then we don't have any configurations, right? So let me name this test config, and then the script path. The script path basically is providing the path to the particular script. So it's PyCharm test. And then as soon as we come into the environment, here is where we'll be actually checking out our interpreter, guys. So I have multiple versions of Python installed. As you can see, I have 3.7 and I have 3.6 as well. So there is a very good chance that this might not show for you because you have not installed Python, and it is very simple to install Python, guys. So I'll just show you that in a second. So this is the part where we actually select our interpreter 3.7, and all we need to do is okay. So this is actually ready to execute with our test configuration, guys. So now coming back to on how you can install Python, guys. So basically we open File, Settings, and in Settings we actually come to Project PyCharm Test, guys. So click on the project interpreter, and on the right side you can actually check out the interpreter. So basically we have multiple interpreters here, and for this case I'm going to use Miniconda 3, and that is what I've used. So for your case, if you have not installed it, so go to the gear icon on the right and click add. Here you can actually use the system interpreter which has Python in it, guys. So in my case I've installed it using Anaconda, so it says Anaconda. So make sure you click this and hit OK, and you're done, guys. So apply. So now that all that is done, right? So how can we add all the packages to Python? Not everything comes inbuilt, right? So again, go to File, Settings. This is pretty much almost same, guys. So we go to the interpreter, and then we have the packages tab under this. So basically we use the gear icon to actually check out our interpreter. Now check out all the list we have, guys. So basically these are all of the packages that is installed for my particular case. So these are all of the libraries that are installed, guys. So in case if you need to add a library, hit on the plus icon on the right side. So just type in any of the libraries that you require, right? So there are multiple installed as well. As you can see, whatever is in blue is actually installed. If I just type in TensorFlow, it says already installed, but then it won't be in blue for you because you might have not installed this, right? So click on that install package on the left side and you're good to go. How simple is it, guys? So now that we're actually all set up and we're waiting in our Scratch file, so let me quickly walk you through a tiny code snippet and we can check out the advantages here as well. So guys, let me try to quickly import a package here. I'm not even going to type the entire thing, right? So I just basically typed out the first three letters, IMP, and it is actually prompting me to pick up the entire thing, right? So this is basically how IntelliSense works in Visual Studio, and this is all the intelligence of PyCharm, guys. So it is at this point of time you can actually choose to type in the entire thing like ORT, or you can just again come back IMP, and then you realize that you want to use import. So all you need to do is either hit enter, or you can hit tab as well, and it takes the entire thing. So this definitely helps reduce a lot of time by providing good predictions, right? So this was just basically one line of code. So imagine if you have to write hundreds and thousands of lines of code, then this is definitely a lifesaver in my opinion. So next I'm going to actually try importing a package, let's say Pygame. So import Pygame, come to the new line. So as you can check out, everything is grayed out here, right? So we can actually change the color by making sure we actually use something, right? So let me quickly go ahead, pygame.init, for example. As you can see, the color changed, right? So this is basically telling us that Pygame is being used now. Simple as that. And next, this is another actually good tip for you guys. So let me quickly take an example. I equal to 10. I'm going to print I. So as you can already guess, this is not a very complex code, right? So it is going to print I. So as soon as I run this piece of code, I'm supposed to get I printed to be like 5 times, right? So check this out. This was only 5 times. So let's say you have a piece of code where you have to change something, right? So let me change this I to P quickly. And now that this has been changed to P, since this is a small program, I can probably go ahead and change this manually, right? So I can go ahead and change this to be P. Again, P. One more. See, again, it took like almost 20 seconds to do this for 5 times, right? So imagine if someone has to do this for thousands of lines of code. So it becomes really annoying, right? And this is where another useful feature of PyCharm helps us. So let me quickly select this P. As you can see, if this is selected, every P here is highlighted, right? So let me quickly right click on it, go to refactor, and then hit rename. So let's say instead of P, we want it to be test. And as soon as I hit refactor, boom, as you can check out, right? So once this got changed, everything else got changed in just one click. And this is also a lifesaver in my opinion, guys. So next up, there are multiple keyboard shortcuts you can use as well. So basically, it's the same. We can use Control F to actually find something and then use it, right? So this actually works even in scope as well. So let's say you're in the scope of a function or a user-defined function or something, and then you want to find something in that particular scope. So this particular search option actually works there as well. So basically with coding, you would have done multiple changes, right? So you would have done multiple changes with your program. And in case you just want to check out what are all the changes that you have done, so we actually press Alt, Shift and C to actually give us a list of changes that we have actually done. Check this out. So these are all of the changes that we have actually done, right? So we deleted something or created a new scratch file. So this basically goes in the reverse order, guys. So this is definitely useful in case you actually want to step back or check out what are the changes that got done. And then in case if you just want to print the same thing over and over again, you can do it as well. So let me quickly go ahead and type out print, say Edureka or something like this. Guys, these are all examples, right? So do not bother about the exact syntax right now. I'm just trying to show you how PyCharm works here. So basically, in case I have to just hit this print again, so instead of typing it out or copying it, pasting it to something, there is actually a shortcut, guys. I'm going to place the cursor here and I'm going to hit Control D. So Control D basically duplicates this entire line for us. And how cool is that, guys? So guys, the next feature I want to show you guys is basically to select a current column. So let me just quickly select print here, and then I'm going to use Alt and actually scroll, guys. I am not sure how you might actually use this, but you can select the columnar output of it, and maybe this might help for your particular requirement as right. So basically you can use it for indentation of the code as well, and then this basically depends on your requirement, but this is a very good feature provided by PyCharm, guys. So basically to run this, all you need to do is select it or right click, run scratch, or say you can even click the play icon here as well. To debug it, there is a tiny bug icon on the right. So basically you just place the debugger wherever you want, and you can actually stop execution at this particular point of time and later move on from there as well. So guys, there are n number of features that PyCharm offers, and to keep this session simple, so I basically just showed you all of the tips and tricks that you can actually use with it. So guys, on the whole, PyCharm is one of the most popular IDEs for Python. So the Python programmers can make use of PyCharm as licensed software as well. However, JetBrains allows developers to choose between 3 distinct editions of the IDE, guys: community, professional, and educational. The developers can always curtail software development cost by opting for the community edition of PyCharm. However, the community edition is free, but it still lacks some of the advanced features provided by the professional editions, guys. So JetBrains have been updating both editions of the Python IDE to make programmers more productive and simplify custom software development as well. Let's say, for instance, the professional edition of PyCharm 2017.3 actually makes it easier for developers to test functionalities of the API by providing a built-in REST client. Likewise, it accelerates web application development by allowing programmers to avail new features provided by Django 2.0. And also, it allows developers to visualize and analyze the data more efficiently through a data science model as well, guys. So now that we checked out PyCharm in a really good amount of detail, let me quickly conclude the session for you guys. So we started out by checking out what an IDE is. Later, we looked at why we need to make use of an IDE. Followed by that, we actually looked at the different IDEs you can make use of to code with Python. And lastly, we checked out Python in a small amount of detail, guys. So it is at this point of time I'd like to tell you that we have in-depth tutorials and blogs on Python, and even a complete master's program which will help you become a certified Python expert, guys. So I highly suggest you guys check it out.
Have you ever asked any programmer to explain the code he wrote a year ago? Or have you ever tried reading your own previously written code? It would become a very time-consuming and tiring task, guys, if you had to reanalyze every block of code from scratch. Well, the best thing to do is add a comment. So let's just quickly move ahead and look at what's in store under this topic. Firstly, we shall understand what exactly comments mean and when to use them. Then, I'll be showing y'all how to write comments in Python and how they're going to be interpreted. Following that, we will be looking at the types of comments, that is single line and multi-line comments, and a few shortcuts related to them. And finally, we will be looking at docstring comments, or to be more precise, docstrings as comments. So I hope you're clear with this. Moving on towards the first topic of this session. What are comments? No, they are not something there just to increase the size of your code. But guys, they are indeed very meaningful. Comments are programmer coherent statements that describe what a block of code means, and they get very useful especially when you're writing large blocks of code. Say for example, you've developed some software previously, and now you're working on something that's new and completely different. At this point of time, you find that your previous software is throwing some error. You would have completely forgotten what you did and how. So this is where comments come into picture. A good code actually consists of relevant comments. These comments actually increase the readability of the program, not just to the programmer, but to the others as well. Now that you know what are comments, let's move on and see when to use them. The best practice is to write comments as and how you proceed with your code. Comments are very useful, but only if they are implemented wisely. Just keep the following points in mind when you're commenting your code. Make sure your comments are very precise and clear, and preferably short as well. They need to be as specific as possible to the block of code they are included with. Please make sure you use decent language, guys, and do not repeat your comments as they become redundant. Now that you know what are comments and their importance, let's see how to write them in Python. Comments in Python are preceded by a hash character. As you can see on the screen over here, I have a small example with some 2 lines of code. My first line is a comment and my second line is a print statement. Now let's move on towards a Jupyter notebook and see how this works. Now let's move on towards a Jupyter notebook and write some comments. All I'm going to do over here is I'll open a new Python notebook and I will rename this notebook. To rename your notebook, guys, all you have to do is click on the title, give whatever title you want, and use rename. Like I've told you before, comments start with a hash character in Python. So here I'm going to write a comment preceded by a hash. As you can see my output, there is nothing related to the comment line, and whatever I have printed in the print statement has been returned as my output. Now this is how comments work. They do not show up in your output. Now let's get back to our presentation and see how they are interpreted, which is exactly what is our next topic. Whenever the interpreter encounters a hash symbol, it omits whatever is present after that. The hash character actually tells the interpreter to stop reading whatever is present after that until the end of that line. So when you're writing comments, whatever is present after your hash character is going to be omitted by your interpreter. Now what if the hash character was present inside a string? Let's go to our Jupyter notebook and see what happens. I'm including a hash character within a string and I will run this. As you can see, when I run this, the string is returned, which means a hash inside a string means a hash itself and nothing else. So you cannot write comments within a string. Okay, so I hope you've understood how to write comments. Now let us move ahead and see what are the types of comments. Comments can either be single line or multi-line. Single line comments can either appear individually or in line with some other code. Multi-line comments have to be preceded by a hash character in every line they appear. Now let's see a small example of single line comments. Like I've told you before, single line comments can appear either in an individual line or in line with some other code. Now let's move on towards a Jupyter notebook and write some single line comments. I'll just create a heading over here. To create a heading, all you have to do is go to code, select heading, give whatever heading you want as your heading and prefix it by a hash. A single hash tells that it's H1 level heading. 2 hashes tell that it's H2 and so on. You can use the heading level of your choice. Here I prefixed my heading by a single hash, which means it's of level H1. Now let's write some single line comments. As you can see over here, my first line of code is a comment line. I've prefixed this line by a hash character. And in my last line, I have an inline comment. This inline comment is present with some part of the code. As you can see in the output, none of the comments have been returned. Now let's get back to our presentation and see how multi-line comments work. Like I've already told you, multi-line comments can appear anywhere in your code, but each line needs to be prefixed by a hash character. For example, as you can see on your screens, I have a hash character present in the first 2 lines of my code. After that, I have some code followed by it. You can see in the output that none of these lines have been returned. Now let's go to our Jupyter notebook and write some multi-line comments. As you can see over here, I have 3 initial comment lines and all 3 have been prefixed by a hash. After that, I have some code. And you can see in the output that none of the comment lines have been returned, and whatever code is present after that, an output is returned based on this code. Now, typing a hash everywhere might be a problem, and many of us would not like to do so. Let's look at some shortcut methods of how to comment multiple lines at once. All you have to do is type your multi-line comments first. Hold the control key and left click wherever you want to insert a hash character, just like how I'm showing you all. And then type it once and it appears wherever I have inserted the cursor, as you can see on the screens. Now, in case you want to remove multiple hash characters all at once, do the same thing, hold the control key, click on wherever you want to remove the hash character from and press the backspace key. As you can see, from 2 lines I removed a hash character in a single go. So these are some shortcut methods to comment multiple lines. Many of us think that comments and docstrings are same. Now let's move ahead and see what are docstrings and whether they are actually comments or not. Docstrings are not actually comments, but they are documentation strings. These strings are written within triple quotes. They are not assigned to any variable, and many a times they are used as comments as well. Now you'd be thinking, what is the difference between docstrings and comments? Docstrings are not omitted by the interpreter. Unlike comments, comments are omitted by your interpreter and nothing present after the hash character is going to be read by it. On the other hand, docstrings are strings that describe something about the code. Docstrings actually tell what some function is going to do, whereas the comments will tell how it is going to do. So this is the difference between docstrings and comments. Now let's go to our Jupyter Notebook and see their functionality. Like I've told you before, docstrings are written within triple quotes. As you can see in the output, when I execute this, it returns the string itself. Whereas in case of a comment, when I execute a comment, it does not return anything. Which means the interpreter does not omit docstrings, whereas it omits the comment. Now these docstrings are efficiently used when you want to describe something about a class or a function or something else. Now these docstrings can either appear in your output or they can be omitted based on where you're going to place them. Let's try to place a docstring initially before the code starts. As you can see in my output, the docstring has not been returned. Whereas when I use the docstring individually without any code and I executed it, you could see that it had returned the string itself. But when I include the docstring before the code and after that I've included some code lines and I run this, you can see that only the output for my code is present and nothing related to the docstring has been returned as my output. Now let's try to include a docstring after some code. As you can see over here, when I included the docstring after the code, it has returned the output for the code as well as the string itself. So when you're making use of docstrings, just be specific of whether you want it to be returned in your output or not. Many a times these strings are called rather than writing it again and again. So I hope you've understood what are comments and docstrings as well.
First of all, we have to understand what a variable is. A variable is like a memory location where you store a value. Now this value you have stored, you may or may not change in the future. Now coming back to Python, to declare a variable, we just have to assign a value to it. You don't have to give any additional commands unlike any other programming languages like C, C++, Java, where you have to give additional commands for declaration and assignment purposes. Let's take a look at an example here. We have two variables x and y, and we have assigned values to each of them. We have given 100 to x and Edureka to y. So this is actually how you create a variable in Python. Now when I print these variables, I am going to get the output as 100 and Edureka. You can also perform operations on these variables using the arithmetic operators. You can perform addition, multiplication, subtraction, or division as well. Now let's try to understand this in the Jupyter Notebook as well. First of all, what I'm going to do is I'm going to declare a variable without assigning a value to it. Let's see what happens. It is going to show an error. The error says name x is not defined. So let's try again after giving it a value. Let's say x is equal to 10. It does not give any errors now. So we have successfully declared a variable here. Let me declare one more variable. Okay, I'll give it a value 12. Now let's try to perform a few operations on these variables. First of all, let's just perform addition between x and y. Now let's try to do multiplication. There's one more thing I want to tell you about variable declaration. That is, variables in Python are case sensitive. Meaning, an uppercase letter here is not going to be the same as a lowercase letter. They are going to be two different variables. Let me show you. It is showing another error which is saying name y is not defined because we have not assigned a value to a uppercase letter y. Let me give this another value here. Let me give it 20. So we have declared two variables here, a lowercase value y and an uppercase value y, which are going to be two different variables. So we have understood here the variable declaration, how we declare a variable. Now let's quickly move on to various variable data types that we have in Python. Depending upon the properties they possess, there are mainly 6 data types in Python. First one is the numbers or numerical data type. The next one is the string. Then we have a list. After that we have a dictionary followed by a tuple, and in the last we have a set. There is one more variable data type, that is range. We will talk about that in the end because it is mainly used when we are iterating through values or when we are using the for loop. So let's try to understand all these in detail. Numbers or numerical data types mainly have numerical values. And in numbers also we have 4 different data types. That is integer, float, complex and boolean. So integer mainly takes the whole number values without any decimal point values. But if I add a decimal point value to a number, it is going to become float. And for complex, we just use j as an imaginary part and add it to the number. For boolean, it only returns a true or a false. So we use boolean for only categorical output. Now let's try to understand this in Jupyter Notebook. First of all, let me declare a variable x and give it an integer value, let's say 10. Now to check the type of a variable, I am going to use the type function. So it is going to show me the type of this variable, let's say x, that is int. Now if I add a decimal point value to x, let's say 10.25, and let's check the type of this variable now, we should get float. As you can see, we are getting float here. Now to make a number complex, I'm just going to add an imaginary part, that is j here. Let's check the type of this variable. It is going to show complex number. To understand the boolean variable, let me take another variable. Now I'm going to check if 10 is greater than 9 or not. So when I check the type of this variable here, it is going to show me that it is a boolean. And when I print this value, it is either going to show me true or false. Since 10 is greater than 9, it is showing true as output. So this was all about numerical data types. Now let's quickly move on to string data type. String data type in Python is written in single or double quotes. As you can see here in the example that I have shown you, I have two variables x and y, and I have given them the string values hello and world. Now to access the string values, we use the square brackets with the index number. Now you must be wondering what an index number is. So let's take a look at an example here. I'll show you what index numbers are in the Jupyter Notebook. Now let me declare a variable and give it a string value, let's say Edureka. Now let me check the length of this string, let's say. So it has a length of 7. Now what are index numbers? So index numbers basically start from 0. So at the letter E here, index number is going to be 0 and it is going to go until the end of the string. So here at the end is the letter A. So index number at the letter A is going to be 6 since we have the length of the string as 7 and the index numbers start from 0. Now let's try to access some values from the string using the index number. So when I write the index number as 2, I am going to get the value at the index number, that is 2, which is letter U. Now we can also perform several operations on strings. For example, we can change the case of the string. We can replace the values in the string. We are going to see if we can actually replace values in the strings or not. So let's try to update a value here at the index number 2 here. So instead of U, let's say I want D here. It is going to show an error, which is a type error, which says string object does not support item assignment. which means strings are immutable. You cannot change them. Now to access a series of letters from a string, I can specify a starting index, and with the colon here, I can specify the ending index as well. Let's say I write 8. But we only have 7 indexes here. Let's see what is going to happen here. So it has actually started from the index 2, that is U here, and has gone to the end of the string. But what if I write ending index as 7? Since we have the length of the string as 7, let's see what it's going to do. It is going to show the same thing. But what if I write 6 over there? It is not going to include the last letter because the ending index there is not going to include when we are accessing the values from the string. Now let's try to do one more thing here. Let's try to make all the letters here to uppercase letters. As you can see, I've done that. Similarly, I can make all the letters to lowercase as well. So this was all about string data type. Okay, one more thing I want to tell you here is to access the values from the end of the string, I can specify the index number using the minus here. So what I'm going to get here is starting from the end of the string, I'm going to get the 2 letters there, that is at the index number 5, that is K. Similarly, if I write name, specify the index number 2 here, it is going to give me the same value. So we can also access the values in the string like that also. So this was all about string data type. Now let's quickly move on to list data type. A list is a collection of arrays which is changeable and ordered, which means they have indexes, just like strings. So we use the square brackets to declare a list. As you can see here, I have the list name fruits, and inside the square brackets, I have the list values. Now we have to understand that we can declare different data types in the list, not just strings or not just integers. We can merge integers and string as well, or we can also use other data types in the list as well. So I'm going to show you this in the Jupyter Notebook. So let's declare a list first. Give it some integer values first, some duplicate values as well. Let's just see what happens, and a string value as well. As you can see, we have successfully declared a list. Now when I print the list, let's see what all values I will get. So I'm getting all the values that I have declared here. Now let me try to access the values using the index number, just like we did in the string. As you can see, we can access the values in the list just like we did in the strings as well using the index number. Now we can also update the values in the list using the index number as well. So let's just try to update the value at index number 2. So instead of 30, I want 35 over there. So let's just see what it does. As you can see, we have successfully updated our value in the list. Now let's try to add a value using append. So what append does is it will add the value at the end of the list. Now let me show you. So there is a value at the end of the list that we have added using the append function. Now what if I want to add the value at the middle of the list using the index number? So what I'm going to do is I'm going to use the insert function, specify the index number and give it a value. Let's just say 100. Now when I print the list, as you can see at the index number 5, I have added 100 as our value. So the difference between the insert and append is that using the append you can only add the value at the end of the list. But when you're using insert, you can add the value specifying the index number. Now let me do a few operations here. Let me try to reverse the list here using the reverse function. Now when I print this, the list is reversed. So this was all about list here. Let's quickly move on to dictionary now. A dictionary is a collection just like a list, but it is unordered, changeable and indexed. So we have a key value pair in a dictionary and we can use the keys as indexes because they are unique, but the values in the keys can be duplicate. As you can see in the example here, I have the dictionary name as animals and in the curly brackets I have declared the key value pairs. So let's try this in the Jupyter Notebook as well. So I'll declare a dictionary here. Let's just say courses is my dictionary. Inside the curly brackets I will get key values. Let's just say 1 and give it a value, comma, key value that is 2. And then I'll give it another value. Let's just say data science. I can give string values in the key as well. So I'm going to write here machine learning. Now let's see if we have successfully declared our dictionary. Yes, we have. Let's try to print the dictionary now. As you can see, I am getting all these values with key value pairs. Now I can access the values in the dictionary using the keys as indexes. I'll just write third over here. As you can see, I'm getting the value at the key that is third. Now for the similar purpose, I can use the get function and specify the key value there. It is going to show me the same value. Now to update a value in the dictionary, I'm just going to write the index number, that is our key value here. So instead of machine learning, let's just say Hadoop, I'll write. So when I print the dictionary now, it is going to show me an updated value. Also, I can add the key value pairs using the square brackets. I'll just specify the key value. Let's just say 4 here. I'll add machine learning again. Okay, 1 second, we have made a mistake here. We wrote the wrong name. Now, as you can see, we have added another value to our dictionary. So this was all about dictionary, guys. Let's quickly move on to tuple. A tuple is an ordered and unchangeable. Now what it means is it is immutable just like a string. We cannot make any changes in the tuple, but we can have the duplicate values in the tuple as well. So let's try to understand this with an example. So I have a tuple here which has a name animals, and I have few values here. So let's just do this in Jupyter Notebook as well. So I'll have my tuple as a name animals. So I'll give it a value in round brackets, a few integer values first, just to check, of course. And then I'll add some values like tiger. I'll just say lion, and one more I'll give, let's say giraffe. Now let me give a duplicate value here to check if we can actually add a duplicate value or not. I'll say tiger once again. So I have successfully created a tuple here. Now let me access the values here using the index number. Let's see if we can do that. So this actually means the tuples are indexed as well. We can use the index values to access the values from the tuple. Now since it is immutable or we cannot change it, there are not many operations that you can perform on a tuple, but you can count the number of duplicate values using the count function. So you're just going to write the value. Let's say tiger, we have duplicate value over there. So we will check how many times tiger is there. So it's going to give us the count here. So this was all about tuple, guys. So let's quickly move on to set now. Now a set is a collection just like a list or a dictionary as well, but it is unordered and there are no duplicate entries present. Now let me show you this with an example in the Jupyter Notebook. So I'll give my set as the set name, and inside the curly brackets we can have values. Let's just say 10, 20, 30, 40. I'll also give a few duplicate values just to check if we can have duplicate values or not. String value, let's just say Edureka. Courses. As you can see, we have successfully declared a set here. Now let me try to print this. Now as you can see, there are no duplicate values, even though when we have declared the set, it was there. Now let me try to access the values using the index numbers. It has shown us an error which says set object does not support indexing, which means a set does not have any indexes, and every time we print a set, it is going to show us a random value. So this was all about set, guys. Briefly talk about range now. So range is used whenever we are iterating through values. Suppose we want to print numbers from 0 to 10. Let me put it in a list to get the values. So what I'm going to do is I'll just write 11 over here, and it is going to give me the values in the list, that is from 0 to 10. So this is all about range, guys. Now let me take a miscellaneous example. Now I'll have a dictionary with some values, again integer values. Now let me try to make a list and try to get the values from A and B as well. Let's see if we can do that. Now when I print C here, it is going to show me that our list C has the list A and a dictionary as well. So which shows you can actually make a list with other data types. For example, you can actually incorporate a dictionary over there. You can also do that with a tuple or a set. And if you want some value that you don't want to change in the future, you can actually make it a tuple and declare it in a list so that you cannot change that value in the future. For example, if you don't want to access any value using the indexes, you can make it with a set so that it does not have any indexes. So that is all about data types, guys. So there is one more topic that I want to talk about, which is type conversion. Now suppose we have an integer here that has 10 value, and we have a string as well which says, now when I try to add these two variables name and x, it is going to show me a type error which says unsupported operand types. Now for this error, I am going to do a type conversion here. So let's quickly talk about type conversion before moving on to the example. So type conversion is basically when you convert a type of a variable to another data type. So we have all these functions here which will convert the data type into their respective counterparts. Now let's try to look at the example now. So we are getting an error here. But what if I change the data type of integer into string? Am I going to get the same error again or not? Let's just see. We're not going to get any errors. So this is what is all about type conversion. Let me show you one more example. So we had a dictionary over there that is with the name B. What I'm going to do is I'm going to use the list function and specify B over there. So I have actually converted our dictionary into a list. So this is what is type conversion all about. collections in Python. Before moving on, let's take a look at the agenda for this session. So first of all, I will be talking about what are collections in Python, and then I will discuss what is the collections module in Python and how we can use it. And finally, I will sum up this session with various specialized data structures that are present in the collections module. I hope you guys are clear with the agenda. Also, I suggest you to subscribe to Edureka channel for more exciting tutorials, and also press the bell icon to get the latest updates from Edureka. Now, without wasting any more time, let's understand what are collections in Python. Collections in Python are basically container data types, namely list, sets, tuples, and dictionary. They have different characteristics based on the declaration type and the usage as well. So let's take a look at each of them. So talking about list, a list is declared in square brackets, guys. It is mutable, which means you can actually change the values once you have declared a list. And it also stores duplicate values, and the elements can be accessed using the indexes. Now talking about tuple, a tuple is ordered and immutable in nature, which means you cannot change a value inside a tuple once you have declared it. And a tuple can also have duplicate entries present inside it. Now talking about a set is unordered and declared in curly brackets. It is not indexed, which means you cannot access the elements inside a set using the indexes. Also, it does not have any duplicate entries present as well. Now talking about a dictionary has key value pairs and is mutable in nature, which means we can change the values inside a dictionary, and we use the curly brackets to declare a dictionary as well. So these are the Python's general purpose built-in container data types. But as we all know, Python always has a little something extra to offer. So it comes with a Python module named collections, which has specialized data structures. So let's take a look at the Python collections module, guys. What is it and how we can use it? So Python programming language has 4 collection data types that I have already told you, which is list, tuple, sets, and dictionary. But Python also comes with a built-in module known as collections, which has specialized data structures, which basically covers for the shortcomings of the 4 data types. Now, collections module in Python implements specialized data structures which provide alternative to Python's built-in container data types. So let's take a look at those specialized data structures in collections module. Also, you don't have to install collections like other Python modules, guys. It is already there inside Python. You can just import it by writing this name collections. So I'll show you while we are working on the use case, guys. So taking a look at the specialized collection data types, guys. So first of all, we have a name tuple. Then we have chain map, deck, there is counter, order dictionary, default dictionary, then we have user dictionary, user list, and user string. So we'll be taking a look at each of them one by one, guys. So let's take a look at name tuple, guys. So what exactly is name tuple? Name tuple returns a tuple with a named entry, which means there will be the name assigned to each value inside a tuple. Now if you look at the tuple as in general, it does not have any named entries, but with name tuple we can do that. So it actually overcomes the problem of accessing the elements using the index values. With name tuple, it becomes easier to access these values since you do not have to remember the index values to get the specific elements. Now here is an example, guys. So this is what a name tuple looks like, guys. So let me take up to PyCharm, guys. We'll try to implement a name tuple using the collections module. So we are inside the PyCharm, guys. I hope this is visible to you. So first of all, what we'll do is we'll import the collection module. And from collections, okay, as you can see, I have not installed it or anything. You can just write collections and it will appear there. So from collections, I want to import name tuple, guys. Done. Now what I'll do is I'll simply, okay, let me implement a name tuple first. So I'll just make it as A and use name tuple here. And over here, I will just provide some values. Let's say the name of my name tuple will be courses. I have to put it in commas, guys. Now I have to give some names, like I'll just write course name and then let's say technology. Now what I'll do is I'll make one more variable and I will pass this and provide some values over here. For my course name, I'll write data science, and for technology, let's say Python. Now when I print S over here, let's see what happens. So as you can see, I'm getting the output as this courses, which is the name of my tuple. And over here, I'm getting the named entries for these values that I've put inside this tuple, guys. So this is how you can implement a name tuple, guys. It's as easy as it looks. You just have to import it from collections, and after that you have to implement a name tuple, and inside that I have provided the name and the values that are going to be there for the tuple, guys. Now I'll show you one more thing, guys, how you can actually get the value or implement a tuple using a list, guys. So let's take a look at that. So what I'll do is I'll take one more variable, let's say s. Now what I'll do is I'll just specify using this variable over here, and I will use make, and over here I can just make a list and I will provide the values like, let's say, artificial intelligence, and the technology is going to be Python, guys. So if you're wondering why am I making these courses are available at our Edureka website, guys. You can check them out anytime you want. So now when I print this, let's see what is going to happen. So I've actually used a list to get a name tuple, guys, to get the values inside a name tuple. So this is all about name tuple, guys. It's actually pretty easy, and you can get named entries for your values inside the tuple. So let's take a look at the next one that we have, which is actually dec, guys. It is written as DQ, but we can pronounce it as dec. Now talking about dec, what actually it is used for. So dec, pronounced as dec, is an optimized list to perform insertion and deletion easily. So when I say optimized, what it actually means is there is a way where you can actually do it very precisely and very easily, guys. So let's take it up to PyCharm again, and we'll try to implement this. So from collections, instead of name tuple, what I'm going to do is I am going to import dec, guys. Now what I do is, so let me just specify a list over here. So I'll just write a few values here. Let's say Edureka, guys. Okay, let's see what's happening here. So now what I'm going to do is I'm going to use a variable, and inside this I will pass this list. Let's see what we get if I print this variable, guys. So I'm getting a DQ. I have made a dec using the list, guys. So let me show you the operations that we can perform in this. So first of all, let me append a value or add a value, guys. So what I'll do is I'll just append a value. So let's say append, and let's say Python. Yeah. So now when I print this, you will see the different, guys. So we have a dec over here, and after that I have appended a value or inserted a value using this append function, guys. So which means I have added the value at the end of the dec. Now if I want to add it like before the dec, guys, like in the beginning of the dec, what I have to do is I'll just have to use this method, which is append left. So now you'll see what is going to happen, guys. So this value Python is actually inserted in the beginning of the dec. Similarly, for removing a value, what I can do is, okay, I'll just, now we have added this value. Let's say I want to actually remove this value. So what I'll do is I'll just write d.pop, and let's see what happens. I'll print it again. So as you can see, from the value from the end of the dec is missing now. We have actually removed it from the dec using the pop function. But let's see if I want to actually remove this value. How am I going to do it? I'll just write pop left, guys, and as you can see, the value Python is also missing here. So this is an optimized version of insertion and deletion, guys, using the dec. So this is all about dec, guys. Now let's talk about the next one that we have, which is a specialized data structure, obviously, and that is chain map. So chain map is a dictionary-like class which is able to make single view of multiple mappings. So it basically returns a list of several other dictionaries. Suppose you have two dictionaries. Suppose we have two dictionaries with several key value pairs. So in this case, chain map will make a single list of both the dictionaries in it. So as you can see in this example, we have two dictionaries, A and B. And if I use the chain map, it will return me a single view of these two values or multiple mappings. So let's take it up to PyCharm, guys. We'll try to implement this again. So I'll remove this, and instead of dec, we are going to use, or we are going to import chain map, guys. So it's very simple. So let me declare two dictionaries, guys. So first of all, I'll give a value, let's say one Edureka. Then the second key value pair is going to be, let's say, Python. Now let's take one more, and inside this I'll give the value, let's say ML, and the fourth one is going to be, let's say, AI. Now using the chain map, I'm going to specify these two dictionaries in this. So let's print A1. Let's see what happens. So as you can see, I have made a chain map which has a single view for multiple mappings, which is A and B, guys. So this is what you can do using the chain map, guys. I hope you understand this. So this is a very basic example, guys, to let you actually understand what is happening over here. So we are using these two dictionaries, and we are able to get it inside a single view, guys. So let's take a look at the next one that we have, which is counter, guys. So counter is also like a dictionary subclass which is used to count hashable objects. Now, what are hashable objects? So let's take a look at this example. So let's say we have a list. Inside this we have different elements. So what counter is going to do is, okay, let's take it to PyCharm to understand this better, guys. So I'll remove this, and instead of chain map, let's say I have counter. So let's take a list, guys. So I'll specify some duplicate values because this is what it is used for, to count the hashable objects, guys. Now what I'll do is I'll make one variable and use the counter and pass A over here. So when I print C now, let's see what happens. So as you can see, I'm getting a dictionary inside which I have these values. So which is saying the number of times 2 has occurred is 5, number of times 4 has occurred is 3, and then again 1, 2 and all. So when I run this again, I'm getting the same value. So this is how you can actually use counter, guys, to count the hashable objects inside any iterable value. So we have a list, we can do it for any other iterable object, guys, like a tuple or set. So this is all about counter. I hope you understand this. Now in addition to the operation you can perform on a dictionary, counter has 3 more operations that we can perform. So which are basically an element function, a most common function, and a subtract function as well. So we'll talk about them in detail now. So talking about the element function, guys, so let's see what elements does. So we'll see elements now. So over here we want the list, so we will put it in the list constructor, guys, and let's print this. Okay, let's see what are we going to get. So it returns a list containing all the elements in the counter, guys. So as you can see, I'm getting all the values that I have inside the counter, and this is the counter that I have. So 2 comes 5 times, 1 comes 2 times, and then we have 3 2 times, 4 3 times, and so on. So this is the function of elements function, which is returning a list containing all the elements inside the counter. Now let's take a look at the next function that we have, which is the most common function. So let's get on to it. So we'll use the C, which is our counter, guys. So I'm going to use the most common here now. So let's see what I'll get here. So I'm actually getting a sorted list with the count of each element inside the counter. So we have 2 5 times, 4 3 times, and 1 2 times, 3 2 times, 5 2 times, and 6 1 time. So this is actually how you can use the most common function. And then we have one more function, which is subtract, guys. So for subtract, let me get one more variable. So I want to subtract, let's say, so I'm getting 2 5 times, so I'll just subtract 2 1 time, and I'll subtract 6 1 time. So what I'll do now here is I'll use the counter and let me use the subtract function, guys. Here it is, and I will pass sub over here. Let's see what happens. Okay, so now when I print my counter, okay, I'll get the values, the most common values again. So now as you can see, 2 is coming 4 times here and 6 is coming 0 times because I have subtracted using the subtract function. So this was all about counter, guys. Let's talk about the next data structure, which is ordered dictionary. So ordered dictionary is a dictionary subclass which remembers the order in which the entries were added. Basically, even if you change the value of the key, the position will not be changed because of the order in which it was inserted in the dictionary. So let's take it up to PyCharm, guys. We'll implement the ordered dictionary over there. So I'll remove all this, and instead of counter we will import ordered dictionary. Now what I'll do is I will implement an ordered dictionary, let's say D, and now I'll add a few values. Let's say, okay, the first one is going to be E, and then the second one is, let's say, D, Now let me print D over here, which is our ordered dictionary. Let's see what the output will be. So we have an ordered dictionary which is saying on the first value we have E, and then so on we have Edureka, all the letters from Edureka, guys. So this is how you can actually implement an ordered dictionary, guys. So let me take a look at what all functions do I have in this. So I have pop, update, pop item, get items, from keys, set default, values, clear, copy, keys. So let me get all the keys from this. So when I run this, okay, let me print this. Now as you can see, I'm getting the ordered dictionary keys, which is 1, 2, 3, 4, 5, and 7. And similarly, I can get, instead of keys, let's see what all we can get. We can update pop item. Okay, let's get items. So the functions are actually similar to what we have for dictionary, guys. So this is all about ordered dictionary, guys. It remembers the order in which the elements were put inside the dictionary, guys. Okay, let me do one thing, guys. I'll change the value. Okay, first let's print this so you'll understand it better. So now what I'll do is I will change the value at 1. So instead of E, let's say I want P over there. And now when I print it, let's say what happens. So as you can see, I have replaced the value over there. But since it was inserted in the beginning, like the first one was E, the value is not changing over there. So this is the main reason why we use ordered dictionary, because it remembers the order in which the elements are being added inside the dictionary. So now that we are done with ordered dictionary, let's talk about default dictionary, guys. So what basically default dictionary does is, it is a dictionary subclass which calls a factory function to supply missing values. So in general, it does not throw any errors when a missing key value is called in a dictionary. So you'll understand this better, guys. So let's take a look at this example. We have a default dictionary in which we have to specify our type as well. So let's say we have two values. On the first value we have Edureka and then we have Python. But instead we want to print Java over there, which is not actually inside the dictionary because there is no value present over there. But we will not get any key value errors, and it will instead give the output as 0. So let's take it up to PyCharm, guys. We'll try to understand over there. So let's remove all this. Now instead of ordered dictionary, we are going to import default dictionary, guys. So let's make a default dictionary. And inside this, let's specify the type as well. Now let's say we have the first value as Python, the second value, let's say Edureka. Now when I print this D over here, I'm getting the value as it's showing me that we have a default dictionary which has a class int that we have specified over here. And then we have a dictionary with the values 1, 2, which has Python and Edureka respectively. Now let's say I want to get the value at the number 3, which is not actually present there, but I'm getting the output as 0. So I'll show you the difference, guys. What actually happens if you do this in a normal ordinary dictionary, guys. So I'll make one more dictionary, let's say A, and I'll give it some value, let's say Python and Edureka. Now when I print this, which is not actually present inside the dictionary, let's see what we are going to get. We are going to get the key error, guys, because 3 is not actually present inside this ordinary dictionary. But if you put it inside a default dictionary, you're not going to get this error, guys. So this is what is the function of default dictionary, guys. It does not show you or throw you any key error, even if the value is missing inside the dictionary, guys. So now that we are done with default dictionary, let's take a look at the next one that we have, which is user dictionary, user list, and user string. So these three data structures are actually same but different. So let's talk about them one by one. So talking about user dictionary, this class acts as a wrapper around dictionary objects. Now the need for this class came from the necessity to subclass directly from the dictionary. It becomes easier to work with this class as the underlying dictionary becomes an attribute. Now talking about the user list, this class acts like a wrapper around the list objects, and it is useful base class for other list like classes which can inherit from them and override the existing methods or even add a few new ones as well. And the need for this class came from the necessity to subclass directly from list. It becomes easier to work with this class as the underlying list becomes an attribute as well. Now talking about user string, guys, It is also a wrapper around string objects for easier string subclassing. Now the need for this class has been partially supplanted by the ability to subclass directly from string. However, this class can be easier to work with because the underlying string is accessible as an attribute.
In this session today, guys, I'll be covering the following topics. First of all, I'll be explaining what exactly is an array, and then I'll be differentiating between Python lists and arrays. Now, this is a very common question that many of us ask. After that, I'll be showing y'all how to create arrays in Python, following which we will try to access array elements, and then we will try to perform some basic operations on arrays such as finding the length of an array, adding and removing elements from it, array concatenation, slicing, and looping through an array. Now let's move on towards the first topic. Our first topic for this session is what exactly is an array? An array is basically a data structure, guys, with ordered series of elements. Any variable that is declared as an array can hold more than one value at the same time. All values in an array have a particular address which is specified by its index number. Here, as you can see on the screen, I've declared a variable a as an array, and I've stored values from 1 to 100 in my array, which is a. Also make a note of the index values. Indexing always starts from 0 and not from 1. Therefore, a of 0 holds 1, a of 1 holds 2, a of 2 holds 3, and similarly, a of 99 holds 100. When the length of my array is n, the index value will be n minus 1. It is always 1 less than the length of the array. Now let's move on towards our next topic for this session, which is the difference between Python lists and arrays. Python lists and arrays have the same way of storing data, but there is a key difference that you all have to note. Arrays can store only single data type values, whereas lists can store any data type values. So for example, if I have an array of integer values, all values present in that array will be integers and nothing else. On the other hand, if I have a list, then it can store integers together with float and chars and strings, etc. Now when you try to perform some operations like slicing or looping, it will be similar for both. But when you try to perform different operations, like if you want to multiply your array values by 2 or you want to divide it by 2, you can do so easily when you have an array. But if you try to do the same with a list, it will throw an error because naturally you cannot multiply chars and strings or divide them. So I hope you're clear with the difference between these two. So now let's move on towards the next topic, how to create arrays in Python. Unlike other programming languages, if you want to create arrays in Python, you will have to import the array module. Now this module has all the functions that are necessary for creating and performing various kinds of operations on arrays. To import the array module, you can use 3 ways. First is to import the array module by its original name, which is array. The second method is to use an alias name. This is the most widely and commonly used method as well. In my demonstrations, I'm going to be using this method. The third way is using star. From array import star. What this does is, it's going to import all that is present in your array module. Now let's go to our Jupyter notebook and try to do this. Please do it along with me, guys. I'll open a new notebook and I will use the first method to import the array module. As you can see, when I hit run, no error has been returned, which means this is executed. Now let's try to create arrays using this method. As you can see over here, I've created an array A using the first method. So I have used array of integer values and I've specified some random integer values. Here the first array is the name of the module. The second array is the array constructor. And then I've given a type code. This type code specifies what type of elements my array will hold. As you can see, I've created an array. So I hope you're clear with how to create arrays using the first method. Now let me open a new notebook and try the second method. The reason to open a new notebook is because I've already imported array module in this notebook. I'll rename this notebook because I'm going to be using this method in further demonstrations as well. As you can see over here, when I use import array as ARR, ARR here is my alias name. When I use this and hit run, it does not throw any error. Now let me try to create arrays using this method. I'm using int as my data type. You can use any data type of your choice. As you can see that an array has been created with some random integer values. In place of the module name array, I've used ARR. Now let's try the third method. I'll open a new notebook again. As you can see over here, when I'm creating arrays using the third method, I've just specified the constructor name and then the type code and the value list. So now let's get back to our presentation. Our next topic for this session is accessing array elements. To access array elements, you'll have to make use of the index values. Each index value holds a unique element. Like I've told you before, indexing starts from 0 and not from 1. So therefore, A of 0 holds 1, A of 1 holds 2, and so on. This is the normal traversal order which starts from the left-hand side and moves towards the right-hand side. But here, I want you all to note this point as well, that negative indexing also exists. So negative indexing will start from the right-hand side and move towards the left-hand side. Therefore, 100 will be at A of -1, 99 will be at A of -2, and similarly 1 will be at A of -100. Now let's go to our Jupyter notebook and try to access some array elements. As you can see over here, I've created a heading. To create a heading, all you have to do is go to code, select heading, and prefix your text with the number of hashes based on the heading level you want. So if I want h1, I will use 1 hash. If I want h2, I will use 2, and so on. Here I've created a heading of h1, so I prefixed my text with 1 hash. Now let me try to access some array elements. As you can see over here, when I access A of 2, my output is 3. Let's see where 3 is present in my array. 1 is present at A of 0, 2 at A of 1, and 3 at A of 2. So therefore, when I access A of 2, 3 has been returned. Our next topic of this session is basic array operations. Here, I just want to tell you all something. Arrays are mutable, which means they are changeable. So in case you want to add or remove elements from it, you can do so easily. Now coming back to our presentation, our first operation under this section will be finding the length of an array. The second is adding or changing elements of an array. And then we will try to remove or delete elements of an array. And then guys, we will try to perform array concatenation, slicing, and finally we will be looping through an array. Now let's move on towards the first operation. To find the length of an array, you will have to make use of the len function. Now this function returns an integer value which is equal to the number of elements that are actually present in your array. The len function takes one parameter which is the name of your array. As you can see in the example over here, I've created some random array A and I've given some random values. As you can see, I have 3 values over here. And when I use the len function and I specify the name of my array, the output is 3, which is equal to the number of elements that are present in my array. Now let's move towards our Jupyter notebook and see how this works. As you can see over here, when I use the len function and I've given the array name which is A, an integer value is returned which is 6. 6 is the number of elements that are actually present in my array which is A. Okay, so I hope you're clear with this. So our next operation is adding elements to an array. In case you want to add elements to an array, you can do so using the append extend or the insert function. The append function is used when you want to add an element to the end of your array. The extend function is used when you want to add more than one element to the end of your array. The insert function specifically adds a new element to a particular position in the original array. Let's have a look at a small example of these three. As you can see on the screen, I've created some random array A, and then I've used the append function and I've given the value that I want to add to my array. As you can see in the output, 3.4, which is the value I've specified to the append function, has been added to the end of my array, which is A. And then I've used the extend function. Please make a note over here that when you use the extend function, you will have to specify the values between square brackets. If you don't use the square brackets, it will throw an error. I've given 3 new values and all 3 values have been added to the end of my array. And then I've tried to use the insert function. Over here, I've specified the index number as 2 and the value to be inserted at that position as 3.4. As you can see in the output, 3.4 has been inserted at C of 2. Now let's go to our Jupyter notebook and we'll do the same. I'll reprint my array, which is A, so that it's easy for us to refer to it. Since my array A holds integer values, I will give some new integer value to it. As you can see, I've given 8 as the value that I want to insert in my array, and 8 has been added to the end of my array. Now let me try to give some float value to this array and see what happens. As you can see, when I try to append some float value, it gives me a type error. Therefore, I can add only those values which is specific to the type of elements that are present in that array. Now let me try to use the extend function. Like I've told you all, when you're using the extend function, you will have to make use of the square brackets. As you can see in the output, all the values that I've specified within the extend function have been added to the end of my array. Now let me use the insert function. I've used the insert function and the first parameter I've specified is the index value and the second is the element to be inserted at this index position. So at index value A of 2, 6 will be inserted. As you can see in the output, 6 has been inserted at A of 2. So I hope you're clear with how to add elements to an array. Now let's move on towards the next operation. Our next operation is removing elements of an array. In case you want to remove elements from an array, you can make use of the pop or the remove function. The pop function removes the element and returns it, whereas the remove function will remove it but it will not return it. The pop function can either take no parameters or one parameter. The parameter it takes is the index value of the element to be removed. If you do not specify any parameter, it will remove the last element from the array. The remove function takes one parameter, which is the element to be removed itself. Now let's have a look at a small example of this. As you can see on the screen, I've created some random array A and then I've used the pop function without specifying any parameter. As you can see in the output, when I do not specify any parameter, the last value present in my array has been popped and returned as well. Second time, I've used the pop function and I've given some index value. Now this pop function will remove the element that is present at this index position. As you can see, it has removed 3.1 and returned it as well. After that, I've used the remove function. Like I've told you before, the remove function takes one parameter, which is the element to be removed. And you can see in the output that the remove function has not returned any value. After that, I've printed my array. And you can see all the values that are removed using these two functions are no more present in the array A. Now let's go to our Jupyter notebook and do the same. Let me reprint my array, which is A. First, I will use the pop function without specifying any parameter to it. As you can see over here, when I do not give any parameter, it removes the last element that is present in my array. Now let me give some index value to it. I'll reprint my array A because I've removed an element from it. Now let me give some index value to the pop function. As you can see, when I use a.pop of 2, it removes the element which is present at a of 2, which is 6, and it returns it as well. Let me try to use some negative index value for the pop function. A.pop of -1 removes the last element that is present in my array, which is 5. Now I'll use the remove function. Let me reprint my array, guys. As you can see, all the elements that have been removed using the pop function are no more present in my array A. Like I've told you before, when using the remove function, you will have to specify the element that is to be removed. Here, let me remove 8 because there are 2 occurrences of 8, and let's see what the remove function does. When I hit run, remove function does not return anything. Now let me print my array A and see what is present. As you can see, the first occurrence of 8 has been removed, but the remove function did not return the value. So I hope you're clear with the remove and the pop functions. Now let's get back to our presentation and perform the next operation. Our next operation is array concatenation. Concatenation means joining. So in case you want to join different arrays, you can make use of the plus symbol. As you can see on the screen, I've created some random array A and B, and then I've created some random array C which is empty. Also make a note that all 3 arrays have the same type code. And then I've concatenated A and B into my empty array which is C. As you can see in the output, all the elements present in A and B have been concatenated into my array C. Now let's go to our Jupyter notebook and perform array concatenation. I'm using int as my data type. You can use any data type of your choice. To create an empty array, all you have to do is specify the type code and leave the value list empty. Here I've created an empty array D and I've concatenated B and C into my array which is D. Now let me hit run. When I hit run, all elements present in B and C have been concatenated into my new array which is D. So I hope you're clear with array concatenations. Let me just show you what happens if I try to concatenate arrays of different data types. I'll just change one of my previously created arrays type code and I'll give it as float. Let's see what happens when I change the type code and I try to concatenate these 2 arrays. You can see that I've encountered an error and it says type error, which means it cannot concatenate 2 arrays of different data types. So just be careful when you're concatenating arrays. You cannot concatenate arrays which hold different data type elements. Okay, now let's move on towards our presentation and see what is the next operation. Our next operation is slicing an array. Slicing actually means fetching some particular values from your array. To do so, you can make use of the colon symbol. As you can see on the screen, I've created some random array A and I've sliced it from 0 to 3. 0 specifies from where fetching has to start and 3 specifies where it has to stop. So, it will start from 0, it will go on till 3, but it will not include the value which is present at 3. As you can see in the output, I have A of 0, A of 1 and A of 2 that is present in my output. Now let's go to our Jupyter notebook and we will try to slice our arrays. I'll reprint my array D over here, and then I will try to slice it. As you can see, I've sliced my array from 0 to 5. So it will start from index number 0, it will go to 5, but it will not include the value which is present at index number 5. You can also see the same in the output over here. Let me try to use some negative index value. My output when I use 0:-2 contains all the values between 0 and -2, but it will not include the value which is present at -2. Okay, so I hope you're clear with this topic. Just give me a quick confirmation before I move on. Okay, Anil says yes. Shashank has a question. He asks, what does ::(-1) mean? Shashank, unlike what many of us think, ::(-1) does not reverse my array, but it prints a reversed copy of my array. So let's try to do this over here. As you can see, all the elements present in array D have been reversed. Now let's print our array which is D. The original array D is the same, but ::(-1) has reprinted a reversed copy of my array which is D. This method is actually not preferred because it exhausts the memory. So I hope I've cleared your doubt, Shashank. Just give me a quick confirmation. Okay, Shashank says yes. Now let's get back to our presentation and perform the last operation of this session, which is looping through an array. You all might be familiar with these two loops, which is the for and the while loops. The for loop iterates over the items of an array specified number of times, whereas the while loop iterates until some condition is met or some condition is true. When you're using the while loop, you will have to keep three things in mind. One is initializing your iterator. Second is to specify a condition. Third is to increment your iterator. Remember that if you do not increment your iterator, your while loop will go on forever. Let's see a small example of this. As you can see on the screen, I've created some random array A, and then I've used the for loop to loop through my array A. I've used for x in A print x, which means go to every element that is present in A and print it. Let's try to do the same on our Jupyter notebook. Let me reprint my array D. Now let me use the for loop to loop through this array. For x in A, print x, which means go to every element in D and print it. As you can see, all elements present in D have been returned one after the other. Now let me try to slice this array and print specific elements. As you can see over here, I've sliced my array from index number 0 to -3 and I've printed only those specific values using the for loop. Now let's go to our presentation and have a look at the while loop. Like I've told you before, when you're using the while loop, you will have to do three things. One is initializing your iterator. Second is to specify the condition. And third is to increment your iterator. Let's try to perform looping on our Jupyter notebooks. Please do it along with me, guys. Let me reprint my array D. Here I'm using the iterator as temp. You can use any name of your choice. As you can see over here, I've initialized my iterator to 0 and then I've specified a condition wherein I have told whenever the value of my temporary variable is less than d of 2, then print that value. And then I have iterated the value of temp. I can also use temp plus equal to 1, which is same as temp equal to temp plus 1. Now let's try to use the while loop using the len function. Here I will use my array A. So let me reprint it over here. As you can see over here, when I use the len function, my temporary variable will go to all elements present in my array A and print them one after the other. So I hope you're clear with looping. Data requires a number of ways in which it can be stored and accessed, and one of its most important implementations includes hash tables and hash maps. So before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards this session, we shall first begin by understanding what exactly are hash tables or hash maps in Python. And for that, I'll be showing you guys how to create dictionaries, nested dictionaries, and perform various operations on hash tables such as accessing, updating, and deleting items from them. Finally, I'll be showing you guys how to convert a Python dictionary into a pandas data frame. So without any further delays, let's get started. So what exactly is a hash table or a hash map in Python? In the field of computer science, a hash table or a hash map is a type of data structure that maps keys to its value pairs. It implements the abstract array data type. So this basically makes use of a function that computes an index value that in turn holds the elements to be searched, inserted, removed, etc. This makes it easy and fast to access data. In general, hash tables store key value pairs and the key is generated using a hash function. Hash tables or hash maps in Python are implemented through the built-in dictionary data type. The keys of a dictionary in Python are generated by a hashing function. The elements of a dictionary are not ordered and they can be changed. So for example, a dictionary can be a mapping of employee names and their employee IDs or the names of students along with their student IDs. Okay, so moving ahead, let's go on and see how to create dictionaries in Python. Dictionaries in Python can be created in two ways. One is by using the curly braces and the second is to use the dict function. So now I'll jump onto my Jupyter notebook and over here I'll be showing you guys how to create dictionaries in both these methods. So the first method is by using the curly braces. For that, I'm just going to give some name to my dictionary. I'll say my dictionary. And I'll just give some random key value pairs to this. So I'll just give a name, say Dave. And I'll specify the value of this as 001. So just consider this to be an employee mapping with their ID numbers. So I'll give another key over here. I'll say Eva. And I'll specify the ID to be 002. I'll specify another one. I'll say Joe. And I'll give the value as 003. Okay. So after this, I'll print out my dictionary and also the type of my dictionary. And then I'll hit Shift Enter. So as you can see over here, my dictionary has been printed out and the type of it is dictionary itself. Okay, so now to show you guys how to make use of the dict function, all you can do is just specify some name. I'll say new dictionary and make use of the dict function. I'm not giving any parameters at first. I'll just print out new dict and the type of it as well. Okay, so as you can see over here, an empty dictionary is created since no key value pairs are supplied as a parameter to the dict function. In case you want to add the values, all you have to do is specify parameters into that function. So what I'm going to do is copy this from here and I'll just paste it. And within this function, I'll specify these values as a parameter to this. So over here, I'll just use the key value as Dave and I'll say this is equal to 001 and then Eva, which is equal to 002. Now I'll just print out new dict and I'll run this. So as you can see over here, I've specified the key value pairs as a parameter to this function and therefore my dictionary has been created with those parameters. So I hope you're clear with this. So now moving on towards our next topic, which is nested dictionaries. Nested dictionaries are basically dictionaries that lie within other dictionaries. So for example, consider a project within which there will be a number of teams such as the development team, the marketing team, sales team, etc. All these are basically other dictionaries that are contained within the project dictionary. This project dictionary itself can be a part of the organization that has a number of projects. So I hope that gives you a clear idea about what exactly is a nested dictionary. So now I'll jump onto my Jupyter notebook to show you guys how to create them. So all I'm going to do over here is create a dictionary which contains the employee details. A single team can have a number of employees, and these employees have different salaries, IDs, and designations. I'll just create a variable over here. I'll just say EMP details, and then I'll use the curly braces, within which I'll specify the main element to be employee. And this is going to contain various other dictionaries. So here, the first employee name will be Dave. And since each employee will have other details such as ID, salary, designations, etc., it is going to be another dictionary within this dictionary. So I'll just open another dictionary, and over here, I'll specify ID to be 001. The next detail that I'm going to specify for this employee is the salary. So I'll just specify the key as salary, and I'll give some random value to this, say 2000. And finally, I'll specify the designation. Okay, so this was all the details for Dave. Now I'll create another employee name. So I'll move out of this dictionary, and here I'll specify Ava. So just like Dave, Ava is also going to have ID, salaries, and designations. And for that, I'll create another dictionary within this, and I'll specify the same key value pairs. The ID is going to be 002, and salary, I'll give some random value, say 1000. The designation will be associate. Okay, so after this, I just print out this dictionary. So as you can see over here, I've created a nested dictionary. So I hope you guys are clear with this. So now let's move on towards our next topic, which is performing operations on hash tables. There are a number of operations that can be performed on hash tables in Python using dictionaries. In this session, I'll be showing you all how to access, update, and delete elements from dictionaries or hash tables in Python. So accessing values. The values of a dictionary can be accessed in many ways, such as using key value pairs, using functions, or implementing the for loop. Now to show all this to you, I'll jump onto my Jupyter Notebook. I'll just give a heading over here, say accessing values, or rather I'll say items. So the first method that I'm going to show you is using the key values. So for that, I'll just use the dictionary that I've created earlier, which is myDict, and I'm going to say my_dict, and the parameter that I'm going to specify is Dave. And then I'll hit run. So as you can see over here, the key Dave contains the value as 001. Python also provides a number of functions using which you can access the key value pairs that are present within dictionaries. Some of these functions are the keys function, the values function, or the get function. So what I'm going to do over here is first print out my dictionary. Now I'm doing this only because it's going to be easy for us to refer to it. So after this, I'll be showing you guys how to use the keys, the values, and the get functions. So what I'm going to do is print mydict.keys, and then I'll hit run. Okay, so as you can see over here, when I use the keys function, all the keys that are present in my dictionary have been returned. Now, in case I want to access all the values, all I have to do is change this from keys to values and then hit run. Okay, so as you can see, in contrast to the previous function, the values function has returned all the values that are present within my dictionary. Now, there's another function which I already told you, which is get. And to use that function, you'll have to specify some parameter whose value you want to retrieve. So what I'm going to do is print myDictionary.get, and I'll specify the value as Ava. So as you can see over here, the value that's present for Ava is not2. So I hope you guys are clear with this. So there's another way by which you can access the values that are present in a dictionary, and that is using the for loop. So in case I want to retrieve all the keys that are present in my dictionary, all I'm going to do is use for x in myDict. I'll say print x. So as you can see over here, my for loop is iterating over all the keys that are present in my dictionary, and it has returned all of them one after the other. Now in case I want to fetch only the values that are present in my dictionary, all I can do is use the same for loop, and within that I can specify myDict.values function. So as you can see, all the values that are present within my dictionary have been returned by the for loop. Now there's another function called as items that will retrieve all the key value pairs that are present in my dictionary. So to show you guys, I'll just type for x in my dictionary dot items, which is the name of the function. Sorry guys, this is supposed to be x comma y. Since I have to retrieve two values at a time, that is the key and the value. And then I'll just print x comma y. So as you can see over here, I have all the keys along with their value pairs. Okay, so I hope you're clear with this. So now let's move on and see how you can actually update the values of a dictionary. Dictionaries are mutable data types and therefore you can update them as and when required. So in case, if you want to change the ID of some employee or if you want to add some new key value pair to your dictionary, you can do it easily. So now to show that to you guys, I'll get back to my Jupyter Notebook. I'll give a new heading. I'll say updating. So I've already created a dictionary over here. And from that dictionary, I'll just change the value of Dave from 001 to 004. For that, I'll just specify my dict. And within this, I'll specify the parameter as Dave. And the value, I'll change it from 001 to 004. Now, I want to add some new value to my dictionary. So for that, all I'm going to do is specify my dict. And I'll specify a new parameter, say Chris. And the value I'll specify to this as 003. Finally, I'll just print out my dict. So as you can see over here, the value of Dave was initially 001 and now I updated it from 001 to 004. You can also see over here that I've added a new key value pair and the key is Chris and the value is 003. So I hope you guys are clear with this. Okay, so now let's get back to our presentation and see how you can actually delete items from a dictionary. There are a number of functions that allow you to delete items from a dictionary such as the del function, the pop function, the pop item function, clear, etc. So to implement this, I'll get back to my Jupyter Notebook and over here I'll create a new heading. So the first thing that I'm going to do is use the pop function. So I'll just copy the name of my dictionary from here and I'll use the pop function with this. So the pop function will take one parameter and it's going to remove that key value pair from my dictionary. So I'll just specify Ava and I'll hit run. So as you can see over here, the pop function has removed and returned the item from the dictionary. So there's another function called as the pop item function, which will remove the last inserted element from my dictionary. So for that, all I'm going to do is specify my dict dot pop item and then I hit run. Okay, so as you all know, the last item that I had added to my dictionary was Chris, having the value of 003. Pop item has removed that and returned it as well. So to use the delete function, all you have to do is specify del followed by the name of the dictionary. And to this, you'll have to specify the key whose value you want to remove from your dictionary. So here I'll just specify Dave and I'll hit run. Finally, I'll just print out my dictionary. So as you can see over here, all that is left in my dictionary is just one key value pair, which is Joe, having the value of 003. Okay, so now let's move on towards the last topic of this session, which is converting a dictionary into a data frame. So before showing you guys how to convert this, let's first see what exactly is a data frame. A data frame is a two-dimensional data structure that consists of columns of various types. It is very similar to Python dictionary, and you can even convert a dictionary into a pandas data frame. So now to convert this, I'll get back to my Jupyter Notebook. Okay, so as you all have seen previously, I had created a nested dictionary containing employee names and their details mapped to it. Now, to make a clear table out of that, I'll make use of the pandas library in order to put everything as a data frame. So what I have to do over here is import pandas. and I'll take a new variable, say df. I'm going to import the pandas library as pd, guys, sorry. It's just an alias name, so you don't have to worry about that. So I'll just use pd.dataframe. And over here, I'll specify employee underscore details, which was the nested dictionary which I've created earlier. Finally, I'll just print out the data frame. So if I would have imported the pandas library as pandas and not as pd, in place of pd over here, I should have written the complete name of the library, which is pandas. Okay, so now I'll just hit run. So as you all can see, a clear table has been created for the dictionary which I had created earlier.
So here is a list of all the operators that we have in Python. So first of all, we have arithmetic operators, then we have assignment operators, comparison operators, logical operators, then we have membership operators, identity operators, and bitwise operators. So we will be discussing all of these operators in detail. So let's talk about arithmetic operators. Arithmetic operators are nothing but the operators that are used to perform arithmetic operations between variables or two values. So these are the arithmetic operator symbols that we use in Python. So we have addition, subtraction, multiplication, division, modulus, exponentiation, and floor division. So let's take it up to Jupyter Notebook to understand the concept of arithmetic operators. So let's say I have two variables, x, I'm going to give this value as 10, and then I have one more variable, let's say y, I'll give it a value, let's say 20. Now to understand the concept of arithmetic operators, what I'm going to do is, first of all, I'll try to perform addition between these two variables. So I'll just write plus over here, and when I execute this, I'm going to get the addition as my output. Now to perform subtraction, I'm going to use the subtraction operator, and it is going to give me the value as the subtraction over here. Similarly, I can perform multiplication, then I can also perform exponentiation. So I'll use two asterisks instead of one for exponentiation. It is that easy in Python, guys. Now we will perform division over here. So it is going to give me the value of the division. Now when I do the floor division, I'm going to get the value over here as well. One more operator is left, that is the modulus. So I'll try to perform modulus as well. So it is going to give me the value, that is the remainder. So this was all about arithmetic operators, guys. So these are all the symbols that we can use for various purposes like addition, subtraction, multiplication, division, etc. I hope you are clear with the concept of arithmetic operators. Now let's try to understand the next operator that we have, which is assignment operator. So you can imagine what an assignment operator is by the name itself, that is assignment. So we use the assignment operators to assign values to a variable or any value that we have in Python, right? So we have assignment operators like is equal to, then we have plus is equal to. So all these symbols we have, let's try to understand what all these are used for. For example, let's say we have a variable x which has a value 100. Now when I write this x plus is equal to 10, it is going to mean the same as x is equal to x plus 10. Similarly, we can write x minus is equal to, multiplication is equal to, division is equal to, or exponentiation is equal to. Now let's try to understand these operators or the assignment operators in Jupyter Notebook. So first of all, we have is equal to as our first assignment operator. So I'll have 1, let's say I have x. So I have not assigned any value to this. Let's say what happens. Okay, let's try one more variable. I'll write this. So it is showing me a name error, which is saying name A is not defined because I have not assigned a value to it. So in Python, until you assign a value to a variable, it is not going to be declared in Python. So now when I give the value to this variable, let's say I'll write 5 over here, it is not showing any error, which means I have assigned a value to this variable. Now let's try to understand other assignment operators. Let's see. So what does plus is equal to mean in Python? So when I write this, what should be the output, guys? So let's try to understand this. So when I print A, I get the value as 10. So why I'm getting this value? Because I have assigned the value 5 over here. Then I write one more assignment operator, that is plus is equal to 5. So what is going to happen over here is it is going to be same as A is equal to A plus 5. So we have 5 over here and we have added 5 more to this statement, which means we are getting the result as 10 over here. Now let's try to understand other assignment operators as well. So let's say exponentiation is equal to 5. So let's see what the output will be. So when I print this, I'm getting the exponentiation to the value of 5. Since a is equal to 10 and we are doing the exponentiation until 5 digits, so we are getting the output as 100,000. So this was all about assignment operators. Similarly, we can do the division is equal to, then we have minus is equal to. So these are all the assignment operators that we have in Python. Now let's talk about the next operator that we have, which is comparison operator. So comparison operators are nothing but the operators that we are using to compare two values or objects, right? So we have comparison operators like equal, not equal, greater than, less than, greater than or equal to, and then we have less than or equal to as well. So let's try to take an example over here. So when I use the equal operator, I'm going to write the statement as just I have written over here, x is equal to y. So when I'm using the comparison operator, I'm actually using double equal to. So this is the basic difference between assignment operator and comparison operator. So let's take it up to Jupyter Notebook to understand these comparison operators, guys. So let's say I have two variables, value is equal to 10 and number is equal to 20. So to understand the comparison operators, let me take one more variable. I'll say this will be our Boolean variable. So what I'm going to do is I'll write val is equal to number 1. What I'm checking is or comparing these two values. So what exactly I'm doing is comparing these two variables or values that we have, that is val and number 1. So when I print this compare variable, what I'm going to get is either true or false. So it is going to be false because value is not equal to number. So I can do the similar thing. I can check whether it is greater than, or I can check if it is less than. So when I write 10 over here, so I can similarly check if it is greater than or equal to. I can check if it is less than or equal to. So these are the comparison operators that we have in Python, which we can use to compare two values or two objects. Now let's try to understand the next operator that we have, which is the logical operators. So logical operators are used to combine conditional statements. So what are the conditional statements that we have in Python? So let's briefly talk about conditional statement, guys. So mainly we have three conditional statements in Python. We have an if statement, then we have an else if statement, and we have an else statement. So I'll give you an example for better understanding. So for these two variables only, I'll write if val is equal to number 1, print equal. Else if val is greater than number 1, print greater, else print smaller. So what happened here is, guys, first of all, the execution will go to the if statement. It will check this condition. If this statement is true, it is going to print this value. If this is false, it is going to move to the next statement. That is the else if statement that we have over here. It is going to check this condition. If it is true, it is going to print this statement. Or if this condition is false, it is going to jump to the next statement, that is the else statement. And I'll give one more condition. So if all of these conditions are false, it is going to jump to this statement and it is going to print not there over here. If all of these conditions are false, it is going to jump to the next statement that we are going to have in the program. But I have not written any other statements, so it is going to end the execution over here only. So this is a basic example using the conditional statements. Now that we are done discussing conditional statements, let's talk about logical operators. So I have told you logical operators are used to combine conditional statements. So what exactly are the logical operators? So we have a logical and, we have logical or we have a logical not as well. By looking at the example, let's say we have two conditions over here. We have x is greater than 5 and then we have x is greater than 10. So let's try to understand these logical operators in Jupyter Notebook. Now let's say I have two statements. I'll write x is equal to 10, and what I'm going to do is I'm going to check if x is greater than 10. I'll write and, which is my logical and operator, and I'll write x is greater than 5. So what is going to happen if I use the logical and operator? If both of these statements are true, it is going to give the result as true. But if one of these statements is false, it is going to give me the value or the output as false. So let's see what happens if I execute this statement. I'm getting false because one of these statements is false. Now when I write, instead of 10, if I write 8 over here, let's see what happens. Since both of these statements are true, it is going to give me the output as true. Now instead of AND operator, if I use the logical OR operator, let's see what is going to happen. It is showing me that it is true, because when we are using the logical OR operator, only one of these statements has to be true, the output will be true. But what happens if both of these statements are false? It is showing me the value that is false. But let's see what happens if both of these statements are true. I'm getting true as well. So one of the statements has to be true when we are using the OR operator. Now talking about logical NOT operator, what I'm going to do is I'll write NOT in the beginning. Now I'll specify the condition. Let's say x is greater than 10 and x is greater than 5. This is the same statement that we have used before, and for this we have got the output as false. So let's see when we use the logical NOT operator, what is going to be the output. I'm getting true as the output here because this statement is negated over here using the NOT operator, and we are getting the opposite value that we should be getting for this statement. So this is the purpose which fulfills by using the NOT operator or the logical NOT operator that we have in Python. So now that we are done with logical operators as well, let's try to understand what are identity operators. So identity operators are used to compare objects. Now you must be wondering, what are objects here? So everything in Python is actually an object. So we can use the data types as objects as well. So let's try to understand what are the identity operators in Python. So we have is and we have is not. So these are the identity operators. So what is does is it returns true if both the variables are same object. For example, let's try to do this in Jupyter Notebook. So what I'll do is I'll take, let's say, a list. I'll give it some values, let's say 10, 20 and 30. I'll take one more list, give it the same values, let's say 10, 20 and 30. And I'll write x is equal to list 1. So when I use the identity operators, let's say if I write x is list 1, let's see what is the output that I'm going to get. I'm getting true because x is actually the same object as list 1. Now let's try to write list 1 is list 2. Even though when we have used the same values in list 1 and list 2, let's see what the output will be. It is false because these are not the same objects, right? Similarly, I can use list 1 is not list 2. So here I'm going to get the output as true because list 1 is not exactly list 2. Even though we have the same values, it is not going to be the same object. So this is the concept about the identity operators. Now let's talk about the next one that we have is membership operators in Python. So membership operators are used to check if a sequence is present in an object or not. Now to understand the difference between an identity and a membership operator, okay, let's first understand what are the operators in membership operator. We have in and then we have not in. So it is going to return true if a sequence with the specified value is present in the object, and it will return true if the sequence is not present. So let's do this in Jupyter Notebook. We have already specified these objects. So let's try to do if x in list 1. Let's see what happens. It is going to show me that it is false because we have no values in x. So when I do the same thing with list 1 in list 2, now you see we have the same values over here. Let's see what the output will be. It is false again. Okay, let me do one thing. Now to check a particular value or a particular sequence, what I'm going to write is I'll check if 10 in list 1. So it is going to check if this is going to be present over here or not. It is showing me that it is true. So what if I write like this, 10, 20, 30 in list 2? It is false. So this is the basic difference between is, that is an identity operator, and membership operators. So when I write, let's say, it is going to check if this is present in the sequence or not. It is showing false because it is not there. But what if I add this value over here? Let's say, now when I execute the same statement, I'm getting true because this sequence is actually present in the object. Now to understand the difference between is equal to and the identity operator, let's see what is going to happen. What if I write list 1 is equal to list 2? It is showing false. I have made a change over here. So I'll do this once again. So when I print this, it is showing that it is true. But instead of is equal to, if I write is over here, it is going to show me false because these are two different objects. So this is the basic concept of identity and membership operators, guys. Now let's understand bitwise operators. So bitwise operators are used to compare binary values or binary numbers. So this is a rather difficult concept, guys. So I'll be telling you about what are binary numbers first, and then we'll be moving on to the bitwise operators that we have in Python. So these are the bitwise operators like bitwise AND, bitwise OR. So these are the symbols used for these operators, guys. So this is actually what happens when we are using these operators. So let's try to understand bitwise AND operator first in Jupyter Notebook. So what I'm going to do is I'll just write 10 and 12. So what is going to happen over here? Let's say it is showing me the output as 8, but it is not clear why we are getting this output, right? So let's understand what 10 is in binary numbers. So when I write 10 in binary numbers, it is going to be 1010, and similarly for 12 it is going to be 1100. Now when I use the logical AND operator, what it's going to do is if both the bits are 1, it is going to be 1. So in this case only first bit is 1 over here, so the output will be 1000, and if we convert this to decimal it is going to be the number 8. So this is the concept between the binary numbers, guys. Similarly I can use 10 or 12. So what is happening here is I have these values, let's say 1010 for 10 and 1100 for 12. Now looking at first bits here, that is 00, it is going to be 1. So all of these bits in the output will be 1111, which is exactly is equal to 14. So this is the concept of using the bitwise operators, where we are using the values as binary numbers. We are comparing the binary numbers. Now let's talk about left shift and right shift, guys. So this is what I write for doing the right shift. So 10 in binary numbers is 1010. So when I right shift these two bits, I'm going to be left with 10. And when I convert this to binary, I'm going to get the value as 2. So this is the concept of right shift, guys. Now let's try to understand left shift. So when I write this, I'm going to get the value as 40. Now let's try to understand how I am getting this value. So 10, if I write it in binary, is going to be 1010. So when I do the left shift, what is going to happen is it is going to shift two values, and I'm going to get the value as 101000. So what is happening here? If I convert this binary number to decimal, I'm going to get the value as 40. So this is why I'm getting the value 40 over here. So this is the concept of bitwise operators, guys. I hope you are clear with the concept of bitwise operators. It is a bit complicated because we are using the binary numbers. Even though I'm telling you these binary numbers, you need not mention them while using the operators. For example, for these bitwise operators, all these are written over here. Let's say if you're using the bitwise AND operator, it will set each bit to 1 if both bits are 1, as I've shown you. And then for bitwise OR operator, it is going to be 1 if one of the bits is 1. So similarly for XOR, it will set each bit to 1 if only one of the bits is 1. And then we have bitwise NOT operator, which is going to invert all bits. Let's say if we have all bits that is 1, it is going to convert all those bits to 0. And then I've told you about left shift and right shift as well. So this is about operators in Python, guys.
Today's session will be focusing on various loops that are available in Python. So without any further ado, let us move forward and have a look at the agenda for today. So first we'll see why to use loops. What is the reason of introducing loops in the programming world? Then we'll see what exactly are loops, and then we'll focus on various types of loops that are there in Python, namely while, for, and nested. I'll be explaining you all these three loops with examples. After that, I'll give you a brief summary of what all things that we have discussed in today's session. So let us move forward and see why we need loops. Now, let us understand this with an example that is there in front of your screen. Suppose you are a software developer and you are required to create a software module for payroll processing of all the employees in your office. Now, what are things you need? You need the salary of those employees, the bonus, and the total amount that they'll get after the end of the month, right? So all these things for each employee you need to print. So for each of the employees you need to print all these three details. Now there are two ways of executing this task. So let us see what are those two ways. So the one way is you can actually write a logic to calculate the total salary of each of the employees. That includes all the fields like salary, bonus, and total. And you are going to write that logic for all the employees that are there in your office. There might be hundreds of employees that are there in your office. So you need to write the logic or you need to write the code for all of those employees. So this process is actually pretty hectic. You need to repeat the same logic for total amount of employees that are there in the office. I'm just giving you an example of 3 employees, but what if you have like hundreds of employees? So at that time, this particular process will not work. This will not only increase the size of the code, it'll make it more complex and less efficient. Now another way of approaching this task would be, you write the logic to calculate the salary. You keep on iterating that logic for the total number of employees that are there. So when this loop runs once, it'll print the salary of first employee. When the loop runs for the second time, it'll print the salary of the second employee. Similarly, it'll keep on repeating. So if you have 100 employees, it'll repeat for 100 times. Now what advantage we get here? The major advantage that we get here is we don't need to write the logic for each employee in order to calculate the salary. We can write one logic and keep on repeating it for all the employees. So this way the size of the code gets reduced. The length of the code is reduced. At the same time, it reduces the complexity, makes it more efficient, and even increases the speed of execution. So this is just one example in order to show you why we need loops. So there are hundreds and thousands of examples that you can think of why we need loops, right? So this is just one simple example that I've shown you in order to make you understand why we need loops. So let us move forward and see what exactly are loops. Let me explain you this with the help of the flowchart that is there in front of your screen. Now what are loops? Loops basically allows us to execute a statement or a group of statement multiple times. Let me explain you this with the help of an example that is present in front of your screen. Now over here what happens, the control comes here and checks the condition. So if this condition is true, it will go on and execute the conditional code that is here. This is nothing but the statements that are present inside the loop. So it will execute that and again it will go back and check the condition. So if the condition is still true, then again it will execute the conditional code of the statements present inside the loop. And it will keep on repeating until this condition becomes false. And the moment this condition becomes false, the control will move out of the loop and it will execute the statements that are present after that loop. Now one thing to notice here guys is that there can be two kinds of loops. One is finite. This is actually the flowchart for the finite loops, and another can be infinite. Now in infinite loops what happens, the condition will never be false. So at that time the control will never come out of the loop. So it will keep on repeating and it will never stop. That is what infinite loops are. So basically the condition will never be false and due to that the loop will be executed infinite number of times. Now there's one more way in order to categorize loops. That is called post-test and pre-test. In post-test loops what happens, the control will first enter the loop and then in the end it will actually check the condition. But in pre-test loops, the control will enter the loop only when the condition is true. So the condition is checked in the beginning of the loop in pre-test loops, but in post-test loop, the condition is checked at the end of the loop. Now in Python, there are no post-test loops present. There are only pre-test loops. So we'll focus on pre-test loops in today's session. So we'll move forward and we'll see various types of loops that are present in Python. So Python basically supports 3 kinds of loops. One is while, for, and nested. We'll look at all these loops one by one and I'll explain you with examples as well. So first we'll have a look at while loop. So while loop is basically used when you don't know how many iterations are required. So let me explain you this with the help of the flowchart that is there in front of your screen. Now over here what happens, the control will move inside the loop only when this while condition is true. And when it is true, it will execute the body of the loop. And then again it will go back and see whether the condition is still true or not. If it is still true, then again it will execute the body of the loop and it will keep on doing that until the condition becomes false. And the moment the condition becomes false, it will come out of the loop and execute the statements that are present after the loop. Now this is the syntax for while loop. First you need to write while, then you write the expression or the condition, then you give a colon and the statements or the body of the loop. Now why we use while loop? Basically, I've told you earlier as well, while loop is used when you don't know how many iterations are required. So you don't know how many times you need to execute the statements that are present inside your loop. So that is the reason why we use while loops. Now let me show you that with the help of an example. I'll open my PyCharm and I'll give you a very basic example of using while loop. And after that, I'm going to increase the complexity of the code. So first we'll see a very small introductory example of while loop, in which I'm going to print the integer values between 0 to 9. That won't include 9, So it will print 0, 1, 2, 3 till 9, but it won't include 9. So let me open my PyCharm and show you how to do that. Now this is my PyCharm, guys. So over here, as I've told you earlier as well, I'm going to print the integer values between 0 to 9, but that won't include 9. So for that, what I need to do is I need to first define a variable. Let me name it as count, and I'm going to initialize a value to it that is 0. Now after that, I'm going to use a while loop, and I'll write while, and then I'm going to give a condition which says that when count becomes greater than 9, it should come out of the loop. Alright. So now what I'm going to do is I'm going to just type in print, let it be number, colon, comma, print count, right? Now I'm going to increment the value of count equal to count plus 1. Yep. Now when I come out of the loop, I want to print, say, goodbye. Yeah, looks fine. Now let me tell you what I've done here. I've defined a variable and I've initialized the value 0 to it. After that, I have used a while loop in which I've given a condition that says that count should always be less than 9, because I want to print values between 0 till 9, which won't include 9. Let me tell you that. So my condition says that the loop should be executed only when the count value is less than 9. The moment it becomes greater than 9, then the control should come out of the loop. After that, it's just a general syntax. I have given a colon, and then I have written a print statement that will print the count value. And after that, I have increased the value of my count by 1. And finally, when the control comes out of the loop, I want to print goodbye. So let us see whether it works or not. I'm going to run it, and as you can see that it works. So we have 0, 1, 2, 3, 4, 5, 6, 7, and 8. And finally, when the control went out of the loop, it has printed goodbye. This is just a very small example, guys. Now let me go back to my slides. Now the example that we just saw was a very simple example. So I'll increase the complexity a bit and I'll give you one more example. So let us move forward with that. So over here, what I'm trying to do is I'm trying to code a little guessing game. Alright, so what happens in this guessing game? So there will be a random number that will be generated between say 0 to 20, and you need to guess that number. So the number that you have guessed is less than that random number, then it will print number is too small. If you have guessed the number that is greater than the random number, then it will print that number is too large. And the moment you guess the right answer, you'll exit the while loop and you have won the game basically. So it's just a pretty simple example, but this is a perfect example in order to show you why we use while loop. Because if you notice here, I don't know how many iterations are required in order to guess the correct answer. So at that time, while loop is a perfect solution to this problem. So without wasting any time, I'll actually open my PyCharm and show you how to execute this. So this is the code here, guys. Let me explain you each and every line that is present here. Now what happens, first I need to import a module that is called random in order to generate a random number. Now over here I've defined a variable n and I've given a value to it that is 20. Because I want the random number that is to be generated should be between the range 0 to 20. Now I've taken one more variable and I've named it as to be guessed. And over here, it should be an integer type, so I've written int. And this logic will generate the random number that I'm talking about. And this will be generated between the range 0 to 20. So how it will be generated? It will be generated with the help of random module that we have imported. So it will be n random.random plus 1. This will actually generate a random number between 0 to 20. So after that, what happens, I've defined one more variable guess and I have assigned a value to it or initialized a value to it 0. Alright, so now comes the while loop. Now in while loop, I have given a condition which says that the number that I have guessed, if it is not equal to the random number, then enter the loop. Now once you enter the loop, you need to input the new number, the number that you want to guess again. Now if that guessed number or the number that you are guessing is greater than 0, then again there will be one more if condition which says that the number that you have guessed is greater than the number that has been generated or the random number that has been generated, then print number is too large. And if the number that you have guessed is actually smaller than the random number generated, then print number is too small. Now there's one more condition, that is else, which means that when the number that you have guessed is less than or equal to 0, then that means you are giving up. So it'll break, it'll come out of the loop and it'll print, sorry that you are giving up. That's when your game gets over and you have lost it. Finally, if you have guessed the correct number, then it will print, congratulations, you have made it. So let us go ahead and execute this and see what happens. Alright, so it asks me for a new number. So it has to be between 0 to 20. So yep, I'll type 10 and let's see what happens. So it says number is too small. That means it is between 10 to 20. How about 13? Alright, so I've guessed the correct number and it says congratulations, you have made it. Now over here, as you can see, that it took only 2 iterations for me in order to guess the correct number. But what if it would have taken more iterations? I mean, I'm pretty unclear how many iterations it will take for me. So that is the reason why we use while loop, because we don't know how many iterations are required. Now we can run this program again and I can show it to you once more. Ask a new number, so I'll just type in, say, 14. It says number is too large, so I'll type in 11. Again the number is too large, that means it is between 0 to 11. So how about 8, guys? Number is too small. So now as you can see that already 3 iterations have occurred, and for the 4th iteration definitely the random number will be somewhere between 8 and 11. So how about 10? So congratulations, you have made it, and the control came out of the while loop and it has printed congratulations, you made it. So we'll move forward and see for loops in Python. So for loop is basically used when you know the number of iterations that are required. Unlike while loop where you are not sure about the number of iterations that are required, in for loop you know how many times the statements that are present inside the loops need to be executed. So for loop provides you with a syntax that will include 3 fields basically, or you can say 3 informations. So first will be the Boolean condition, then comes the initial value of the counting variable, and then the incrementation of the counting variable. So as you can see it from the syntax as well, first you write for, name of the variable, in the range. Then you specify the range in which that variable should be. And then you specify the range. That means from which point till which point it should be executed. So you know the number of iterations required, then only you use for loop. Now over here, as you can see from the flow diagram itself, the control comes to this and it'll see the item from the sequence. It'll execute the statement, go back again, and then from the range it'll pick up the next item. Again it'll execute the statement, again go back, and then from the range it'll pick up the third item, and it'll keep on executing until the range becomes over, or that is the last item from the sequence. So when there are no items in the sequence, it'll go on and execute the statements that are present after the for loop. So this is how for loop works, guys. Now let me just give you a very small example of how for loop works. I'll open my PyCharm again and I'll start with a very small example, and then I'm going to increase the complexity of our code like I've done that in while loop. Now over here what I'm going to do is I'm going to first define a list and I'm going to name it as fruits. So what all fruits you like, guys? I'll first type in mango, then I like grapes, and finally I'm going to write and say apple. Yep. So this is my list which contains 3 fruits, mango, grapes and apple. Now I'm going to define a for loop, and over here what I'll write, I'll define a variable, say fruit. For fruit in fruits, give a colon, print current fruit, and type in fruit. Now when you come out of the loop, just print again goodbye. So I have declared a list and the name of that list is fruits. Now that fruits list contains elements which are mango, grapes and apple. Now after that I have defined a for loop which says that for a variable named fruit in fruits. So this will give me the range. Fruits will give me the range. As you know that in the fruits list there are only 3 fruits. So I know it will iterate only thrice. First for mango, then for grapes, then for apple. So this is the difference between the while and for loop. In for loop I know that it will take only 3 iterations. After that print the current fruit. That's all. And when the control moves out of the loop, print goodbye. It's pretty easy, guys. So go on, execute this and see what happens. So yep, the current fruit first is mango, then comes grapes, then comes apple, and then finally print goodbye. So what I'm going to do is I'm going to increase the complexity now, as I've done that in while loop as well. So I'll show you an example. First, let me go back to my slides. So what I'm going to do in this example, I'm going to calculate the factorial. Now one thing to notice here, guys, again in factorial also I know how many iterations are required. Because if you see, if I'm calculating the factorial of 5 and I know that I need multiplication 5 times. First I need to multiply 5 with 4, then 4 with 3, then 3 with 2, and then 2 with 1. So this way I require only 4 iterations. So I know the number of iterations required. So it's a very good example in order to show you where we should use while loop and where we should use for loop. So let me go back to my PyCharm and execute this practically. So this is the code in order to find the factorial of a number. So over here what happens, first I need to input the number that I want to calculate the factorial of. After that I've defined a variable factorial and I've initialized a value to it, which is 1. Now I have defined a condition. If the number that I've entered is less than 0, then print the number must be positive, because I can't calculate the factorial for negative numbers, right? And again I have given one more condition which says that if number is equal to 0, then factorial is equal to 1. And then else condition says that when number is greater than 0, then I've used a for loop which says that for I've defined a variable I in range 1 to num plus 1. When I write num plus 1, the range will be between 1 to num plus 1, but it won't include num plus 1, so it will only be including 1 till num. Alright, so after that what I've written, factorial is equal to factorial into I. So factorial was 1 earlier, then it will multiply by I will also be 1 in the beginning, and then again it will go back and it will become 2. Similarly, it will keep on increasing until it becomes num. So till that time it will keep on executing the loop, and the moment it becomes equal to num, it will come out of the loop and it will print the factorial value. So let me go ahead and execute this and show you if it works or not. So I need to enter the number. So let's say I want to calculate the factorial of 3, which is 6. So if I want to enter one more number, so what I can do is I can start it once more. So what I'll type, I can type again 4. So it prints 24, which is absolutely correct. So we'll move forward and we'll see what are nested loops in Python. So Python basically allows us to use a loop inside another loop. For example, you can use a for loop inside a for loop, or you can use a while loop inside a while loop. And at the same time, you can use a while loop inside a for loop as well, and a for loop inside a while loop as well. So that is basically what is called nested loops. Now we'll have a look at the example of nested loops as well, don't worry. So let us move forward and see one example of nested loops. Now over here what I'm going to do is I'm going to write a code in order to simulate a bank ATM. Alright, so for that I'm going to use nested while loop. And what will happen, first you need to enter the 4-digit PIN, and then you can perform the following functions. You can check the balance, you can make a withdrawal, you can deposit some money, and you can even, if you don't want to do anything, you can tell the machine to return your card as well. So let me show you how it is done. I'll open my PyCharm once more. So this is the code that I've written in order to simulate a bank ATM. I'll explain you each and every line, so don't worry about that. So the first line is nothing but a print statement that says welcome to Iron Bank of Bravo's ATM. Alright. And then I have defined a variable restart and I've assigned a value to it, that is y. Similarly, chances, I've assigned a value that is 3, and this is the balance that I'm going to initialize, that is 67.14. Notice you over here you won't get more than 3 chances in order to write the correct password. Now comes the while loop, which says that when chances are greater than or equal to 0, at that time what it'll do, you need to enter the PIN. So you need to input the 4-digit PIN that you have. And if that PIN is 1234, then it will print that you have entered the correct PIN. Now comes one more while loop, which says that while restart should not be in this particular tuple. That is, the value of restart should not be n, capital N-O, small n-o, or capital N. So it should not lie within this particular sequence, that is n, capital N-O, no, and n. But we know that the restart value is y, so it will enter the while loop. Now over here what will happen, it'll give you 4 options. First option is in order to check your balance. For that you need to press 1. To make a withdrawal you need to press 2. In order to pay in some cash or you need to deposit something, you need to press 3, or you want your card back, you need to press 4. So these are the 4 options that will be given to you. So when you choose option 1, it will print the account balance. So over here, as you can see, that your account balance is and the balance that is there in your account. After that, it will ask you for restart. So you need to input that value. So that will say, would you like to go back? And if your restart value lies in this particular tuple, then it will break and it will print a thank you statement. But if you want to continue or you want to go back, then you can press anything else apart from small n, no, or this no, or capital N. So if you press any other button apart from these, it will actually go back, and in the while statement, as you can see, it says that it is not present here. So it will give you all these 4 options once more. Now after that, what if you choose the another option in which you need to make a withdrawal? So for that, what will happen? You need to enter the amount that you would like to withdraw, which can be a float number. It cannot be an integer number. So that's why I've used float here. So you need to enter that value. And once you enter that value, it will check whether it is in this particular list or not. That is 10, 20, 40, 60, 80 or 100. Now by default, it will give restart Y because you need to enter the amount once more. So again, it will go back and it will give you all 4 options. So you can choose that withdrawal option again, and you can choose a number which is present in this particular list. Now when you choose withdrawal equal to 1, at that time, it will again ask you, please enter the desired amount. So this is for option 2. Now when we talk about option 3, it is pretty much similar to the couple of options that we have discussed before. So it is pretty much similar to that. Over here again, whatever the amount that you want to pay in, how much amount that you would like to pay, and balance plus the amount that you are depositing. So it will print the balance that will be equal to balance plus the amount that you are depositing. Again, it will ask you for restart. If you press anything apart from this particular tuple, then it will go back to the while statement and it will give you all these 4 options. Similarly for option 4 as well. Now what happens when you enter the incorrect pin? So there's one more condition in the end which says that if the pin that you have entered is not equal to 1234, then it will print that incorrect password and it will decrease the chances by 1. So earlier you had 3 chances. If you press the incorrect pin once, it will decrease your chance and it will make it as 2. Again, if you write the incorrect password, then again it will make it as chances equals to chances minus 1, which will become 1. And if the third time also you do the same thing, then the chances will become 0. And the moment it becomes 0, then it will print no more tries, break, it will come out of the loop. That's all, guys. So let us go ahead and execute this and see what happens. So please enter your 4-digit pin. So I'll just write 1, 2, 3, 4 and it'll give me 4 options, which is 1 for balance, 2 for withdrawal, 3 for pay in, 4 to return a card. So if I want to check my balance, I'll put in 1. So it has printed my balance, which is 67.14. And then the restart value that I was talking about, it is asking for that. Let me just make it big for you. Yeah. Would you like to go back? So if I press N here, it will come out of the loop and it will break. And if I press anything apart from small n, capital No, small no, or capital N, it will actually go back and give me all the 4 options that were there. So if I press Y, it will again give me all the 4 options that are there. You can see that press 1. So again, if I want to make a withdrawal, I'll press 2. How much amount that I would like to withdraw? Say I want to withdraw 10. So my balance has reduced from 67.14 to 57.14. So would you like to go back? So I'll again press Y and it will give me all 4 options. If I want to pay in something, that is I want to deposit something, I'll press 3. How much amount that I would like to deposit? I'll say 10. So my balance became again 67.14. Again, it is asking me, would you like to go back? No, I don't want to go back. So I can type in N. So yep. So it says thank you. And again asking me for 4-digit pin. So let me show you what happens if I write the incorrect pin. Say if I write 111, incorrect pin. If I write that pin again incorrect, again incorrect. So we have no more tries. It will come out since I've exceeded the chances that I was given. So I was given 3 chances. I couldn't write the correct pin in those 3 chances. So it will come out of the loop and it will stop. So this is an example of nested while. Now let me go back to my presentation and I'll show you an example of for loop as well. So this is an example of nested for loop.
So over here what I'm going to do is I'm going to write a code in order to print the Pythagorean number between a particular range. So what happens is, suppose if I want to enter the number 20, that means I want the Pythagorean numbers between 1 to 20. So Pythagorean numbers are nothing but the integers which satisfy a square plus b square is equals to c square. So at that time it will print all the Pythagorean numbers that are possible between 1 to 20. 3, 4, 5. You can see that 3 square, 4 square is equals to 5 square. 9 plus 16 is equals to 25. Similarly, it goes for 5, 12, 13, 6, 8, 10, 8, 15, 17, 9, 12, 15. Similarly for 12, 16 and 20. Don't worry guys, I'll go back to my PyCharm and I'll explain you how you can do that. So this is the example of nested for. So first over here I need to import certain modules in order to use the square root function. So from math module I'm going to import the square root function. After that it'll ask me for the number. In the example, if you can remember in the slides where I've written 20, so it has printed the Pythagorean numbers between 1 to 20. That same number it will ask me, and it will print the Pythagorean numbers between 1 to n. So whatever the number n that I'm going to put in or give an input. After that it will run a for loop and it will say that for a, which is a variable, in range 1 to n plus 1. That means 1 to n. That means 1 to n plus 1, but don't include n plus 1. After that there's one more variable b, which is in the range a comma n. That will not include n, it will only include till n minus 1. So the square root c square, I've defined one more variable c square, is equal to a exponent 2 or a to the power of 2. Similarly b raised to the power of 2. Alright, and then what I'm going to do is I'm going to calculate the square root, and then what I'm going to do is I'm going to define one more variable c, and it'll be an integer that will be the square root of c square. So if that c square is minus c square is equal to 0, then print ABC. It's pretty simple logic, guys. Okay, I'll explain it once more, Neil. So this is an example of nested for. So over here what I'm going to do is I'm going to first import the square root function from the math module. After that I'm going to input a number. So if you can remember in the slides I've given it as 20. So it will print the Pythagorean numbers between 1 to 20. Over here also it will print the Pythagorean numbers between 1 to n. So whatever the value of n you input, that will be depending upon it. So the Pythagorean numbers will be depending upon the values that you input. So it will be printing the Pythagorean numbers present between 1 to n. After that I'll run a for loop which says that for a should be in the range 1 to n plus 1. That will not include n plus 1, guys. It will only include n. So 1 till n plus 1, but don't include n plus 1. After that I've defined one more for loop which says that for b in range a comma n. It won't include n, it will be till only n minus 1. I've defined one more variable here which is equal to c underscore square. That is equal to a square plus b square. Now after that I've defined one more variable c, and this will be actually the integer of the square root of the c underscore square. Alright, so whatever value that you will get here, the square root of that value will be converted to an integer value and will be assigned to c. Now one if condition I'll be using here which says that if c underscore square minus c square is equal to 0, then print ABC. That means that will be a Pythagorean number. So this is a pretty simple logic, guys. Alright, so I hope you have understood the code that I've explained to you here. Now let us go ahead and execute this and see what happens. Yeah, so the first number that I'm going to type in, say 5, and it'll give me all the Pythagorean numbers present between 1 to 5. So we have only one Pythagorean number, that is 3, 4, 5 in that range. Now I'll execute this once more and I'll type in 10 here. So we have two Pythagorean numbers that are 3, 4, 5 and 6, 8, 10. Similarly, if I execute it once more and I type in a big number, say 25. Yeah. So we have these many Pythagorean numbers present between 1 to 25. We'll again go back to our slides and we'll have a look at one more example. Now in this example, I'll actually be using a for loop inside a while loop. So what is this example? I want the bulk reservation of train tickets. So I have like group of people who are traveling somewhere and I want to give their details such as name, age and sex. I want that to happen in bulk. I don't want to give it one by one. I just want it to happen in bulk. So for that what I'm going to use is I'm going to use a for loop inside a while loop. As I've told you earlier as well, you can even use a while loop inside a for loop. But for now, I'll use a for loop inside a while loop and see what happens. So let me go back to my PyCharm. So this is the code in which I'll be using a for loop inside a while loop. So first I have defined a variable traveling, so in which you need to input whether yes or no. So if you're traveling, you'll say yes, obviously, and then we'll have a while loop which says that while the condition is traveling equal to yes, that means if you're willing to travel, enter the number of people who are traveling. So you need to enter the number of passengers that are traveling, and that will be assigned to a variable num. Now there'll be a for loop which says that for num in range 1 to num plus 1, but it won't include num plus 1, enter the name, enter age, and finally whether the person is male or a female, and then print all those values. Now one more thing here is, again it'll ask you whether you have missed someone or not. So you need to input that. Oops, forgot someone. So at that time you can write in yes if you have forgotten someone. Then again it'll execute the loop. Again it'll ask you the number of people traveling and all these details. If you type in anything apart from yes, that means you have not forgotten anyone, and it'll come out of the loop. So it is a very small example, but a very good example to understand how for loop can be used inside a while loop. So let me go ahead and execute this. Whether you're traveling, I would say yes, I am traveling. Number of people traveling, I would say 3. Name is Saurabh. Age is 78. Male. Alright, so again it has asked me for one more name, so I'll say Neil. Age is 90. Male or female? Male. Yep. So one more name I need to type in. Say I would type in Jagriti. Age is 98. Male or female? Female. And yep, it'll print all those details for me. So now it is asking, have you forgotten someone? So if I type in and say yes, then it'll again ask me the number of people traveling. That means it is again executing the while loop. So if I would say the number of people traveling is 1, and I would type in the name of the person that was traveling, so I would just say Siddharth, whose age is 77 and he's a male. Yep. Again it has asked me, so if I type in anything apart from yes, say if I type N, so yep, it'll come out of the loop, and this is how you can actually use a for loop inside a while loop. So let me just open my slides, and yep. So this was an example of a for loop inside a while loop. So let us move forward, and I'll give you a brief summary of what all things we have discussed till now. First, we saw why we need loops. We actually used the example of software module for payroll processing, in which I showed you 2 methods. The one is manual and the another one in which you are using loops. After that, I told you what exactly are loops, and we saw various types of loops in Python, namely while, for, and nested. Then we focused on each of these loops. We started with while loop, and I explained you where to use while loop. I gave you 2 examples of while loop. Similarly, for for loop, I explained what exactly is for loop, how it works, its syntax, and 2 examples again for loop. When we talk about nested loops, again I've explained you the syntax, how to use it, and I've given you 3 examples for nested loop as well.
Let's take a look at the agenda for this session. First of all, I will start with star pattern programs, and the patterns include pyramid, half pyramid, hourglass, diamond shape patterns, etc. Moving further, I will discuss pattern program with numbers. So instead of asterisk, we'll be using the numerical values in the patterns. And finally, I will explain a few pattern programs with characters or alphabets in them. I hope you are clear with the agenda. Also, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates from Edureka. Now, without wasting any more time, let's take a look at the star pattern programs that I will explain in this session. So I'm going to start with star pattern programs, in which I'm going to show you how you can play with the concept and make other patterns like half pyramid, triangle, hourglass pattern, diamond pattern, and inverted pyramid patterns as well. So let's take it up to Jupyter Notebook, and I'll show you how you can make star pattern programs, and we are going to start with the simple pyramid program first. So now we are in the Jupyter Notebook, guys. I'm going to start with the simple pyramid program. So I'll write pyramid over here. And in this, I'm going to take one function and I'll name it as pattern, and inside this I'm going to pass n, because this is going to be our number of lines which I want in the pattern. And for blank spaces I'm going to take one variable, that is k. I'll show you what it does. And we're going to use a lot of for loops inside this. So if you're not familiar with loops in Python, I suggest you to check out other tutorials on Edureka for loops in Python so that you'll be able to understand this better. And I'm going to take one for loop here for I in. This is going to be the loop for our outer rows. So I'm going to take this as range 0 to n. And I'm going to take one more loop which is for j in range, and this is going to be our loop for columns, and I'm going to take this as k over here. Now I'm going to print some blank spaces over here. So for this I'm going to write this n is equal to, and after this I have to decrement the value of k, and I'm going to take one more for loop. Inside this I'm going to specify the range 0 to I plus 1, because we are going to move in the forward direction while printing the pattern that we have. So inside this I'm going to print the asterisk pattern, which is the star pattern also, and n is equal to this. Now one more important point, you have to print \r or \n in order to get the pattern right. I'll show you what happens if you don't do that. Now we're done with the pattern function over here. I'll just call pattern, and inside this I'll specify 5, and when I run this I'm getting a pattern which is a pyramid pattern. So instead of \n, if I write \r, the pattern will look something like this. And if I just comment this statement, let's look at the output that varies. So we're getting the output somewhat like this. If you want to get your pattern right, you're gonna have to write it like this, and this is how you can make a simple pyramid pattern program in Python. So you can see this is the variable that I was talking about to specify the spaces. So what if I write it as, let's say, n minus 2, the output will move to the left side, and if I write it as n, look at this. So this is what happens when you play with the spaces over here. So I'll just write it as 2 into n minus 2. So we are getting the pattern somewhat like this. So instead of 5, if I write 10 over here, I'll be getting a much more bigger pattern with a pyramid shape. And this is how we can write a simple pyramid pattern. So let's take a look at the next program that we have, which is the inverse pyramid. So by now I think you have got the idea of how we are doing this. So for printing the inverse pyramid, we are going to go from back to the starting. So we'll start with this one first, and we'll go in the backward direction so that we'll get 1 in the end. So we'll get the inverse pyramid then. So let's take a look at how we're going to do that. I'll just take a function like I have done before, and inside this I'm going to specify the space as well, which is 2 into n minus 2. And now I'm going to take a for loop. So for I in range, this is where the magic happens, guys. You have to specify n over here because we're going to the backward direction, and minus 1, and okay, we'll take this step as minus 1 as well. And if you're not familiar with range functions, please do check out the other tutorials on Edureka for better understanding, guys. We have a full video on range function as well, and I'll take another for loop for columns as well. So in this I'm going to go with the backward direction as well. Step is going to be minus 1, and now I have to print n is equal to this. Now I have to specify a increment in the k variable because we're going in the backward direction. I'm going to take one more for loop, and for j in range, this time we are going to go with the normal flow, which is I plus 1. And in this I'm going to print my asterisk, and after this I have to just print the \r so that my output will not be distorted and it will print a perfect pattern. So when I call my function pattern over here, and let's just say I write it as 10, okay, I have an invalid syntax over here, sorry guys. We're getting an inverse pattern right here. So in this you can see the output is towards right. So what I'll do is I'll just remove this, and you'll see the output is just like the other one, the pyramid, and we are getting the inverse pyramid right now. So the approach that I followed was I was starting from the end, which I got over here, and I got back to the backward direction, and in the end I'm getting the 1 star. So this is how you write a simple program for inverse pyramid. Let's take a look at the next pattern that we have, which is a right start pattern program. So we are going to follow the same approach right here. Let me just write right start pattern. So in this, I'm going to follow the same approach. I will specify a function pattern. Inside this, I'll specify n. And now what I'll do is I'll just write for I in range 0 to n, for j in range 0 and I plus 1 that we have written before as well. Now what I'll do is I'll print my asterisk. Can any of you guess right now which pattern I'm going to make? Because I'm not sure if everybody's familiar with the pattern right start pattern. It's going to be looking like a triangle, but mention in the comments if you had guessed right. I'll specify one more outer rows function because we're going to get fairly unique pattern in there. So we need two outer loops for rows and two outer loops for columns as well. So I in the range, I'm going to specify the range as n, 0 and -1. The step is going to be -1. And inside this, I'm going to specify for j in range 0, and we're going to follow the same approach, that is I plus 1. After this, I'm going to print asterisk again, and is equal to this. Print \r. Don't forget the \r, guys. So if you have any problems in your pattern, just look at the print statement where you have specified \r. Now when I call my function pattern over here, I'll specify 10 again. Okay, I'm getting the pattern somewhat like this. Okay, we're not getting the output as I had expected, so I'll just do one thing. Instead of 0 over here, I'll specify -1. So when I run it again, I'm getting the perfect right start pattern. So this is how you write a program for a right start pattern in Python. And let's take a look at the next program that we have, which is a left start pattern. So for this, I'm going to take pattern again, specify n, and after this, I'm going to take one variable for spaces because we're going towards the left side. So what I'll do is I'll just write k is equal to 2 into n minus 2. And again, I'll take a loop for outer rows. And inside this, I'll specify the range as 0 and n minus 1. For the columns, I will take for j in range 0 to k. Print end is equal to this because we want some blank spaces over there, and I will decrement the value of k by k minus 2. You can modify these values for k and all these range functions as well according to your pattern. Whichever pattern you're making, do experiment with these values so that you will understand how it's working. So I'll take one more for loop for columns again. So j in range, this time the range is going to be 0 and I plus 1. And can any of you guess right now? I'm going to print the asterisk over here, which is going to be in my pattern. Again, this is going to be n is equal to this. And over here, I need to print \r so that my output will not look distorted. And again, I have to get the value of k right. So I'll write k is equal to k minus 1. Now I have to take one more outer loop for outer rows. So for I in range, just like we did in the other program, okay, I'll show you why we are taking two different outer rows. So I'm printing a half pyramid until here, and after this I'm going in the backward direction like this. So instead of doing this, I'm going to print some blank spaces as well. So I'll be printing backspaces until here, and then my actual program will start. So this is why I'm taking two loops over here. So I'll just specify n minus 1, and -1 for the step as well. And after this, I'm going to take one more loop for columns. And inside this, I'll specify -1 and step as -1 as well. I'm going to print n is equal to spaces, decrement the value or increment the value because we're going to go in the backward direction in this loop. And again, for j in range 0, I plus 1. And after this, I'm going to print asterisk n is equal to this and print \r. Now when I call my pattern again, say 10. Okay, I have invalid syntax for j in range. Okay, I think I have made a mistake over here. So I'll just check my code again. Okay, I'll make this as -1 and move it a little further. So I'm getting my pattern right there, which is a left start pattern. So this is how you can write a program for left start pattern in Python. And now let's take a look at the next program that we have, which is a hourglass pattern program. So for hourglass pattern, I'm going to print a pyramid pattern, and on top of that, I'm going to print a inverse pyramid so that it will look like an hourglass. So let's take a look at how I'm going to write that. So I'll take one pattern function again, specify n, and I'll just go with the variables for spaces, and then for outer rows I have a loop in which I am taking the range as n minus 1 and step is minus 1 as well. Okay, I made a syntax error. And now for columns, for j in range, I'm going to take the range as k, 0 and minus 1. Okay, we'll do one thing, guys. I know for sure that we need an inverse pyramid, so I'll just take this code, copy this, and over here I'll just print this code. So when I call pattern now, say 5, I'm getting an inverse pyramid. So now I'm going to take the code for pyramid pattern over here, and I'm going to paste this after this. This goes here. So this is my hourglass pattern, guys. Okay, we have a little distorted hourglass. So in our inverse pyramid, we're getting the 6 rows, and in this pyramid we are getting only 5 rows. So what I'm going to do is I'll just specify this as 0 and n minus 1. Let's see what happens. So I'm going to take it as n plus 1. So now we're getting a perfect hourglass pattern, and this is how you can write hourglass pattern in Python, guys. All you have to do is understand how it works, and after that you can just play with the numbers and the spaces, and you can make any pattern that you want. So now that we are done with the hourglass pattern, let's take a look at a half pyramid pattern that we have in Python. So it's very easy, guys. I'll just take one pattern function, specify n over here, and in this I'm going to just write for I in range whatever number that you want. So I'll just write 0 to n, and for j in range, the range is going to be 0 and I plus 1, and I'm just going to print my number over here, and inside this my asterisk and is equal to this, and again I have to specify a backslash r. Now when I call my pattern function, specify, let's say 10. Okay, we have a syntax error again, I'm sorry, guys. And this is my half pyramid pattern, or we can call it a right triangle pattern as well. So this is how you can make a half pyramid pattern in Python, guys. So let me show you how you can make a left pyramid pattern. For that you have to just add a simple code in which you have to specify the spaces like we have done in the other programs also. So I'll just copy the whole code, paste it over here, and for spaces, okay, I'll have to take a variable k for spaces, and inside this I'm just going to specify 2n minus 2. And after this I have to take one more outer rows loop, and inside this I'm going to take the range as, it's going to go in the direction 0 to n. And for j in range, now this is where k comes into picture, and I'm just going to print the spaces that I want. So I think we're done. I have to decrement the value of k as well. So when I call my pattern now, just say 5. Okay, we are getting a different value here. I think I made a mistake, guys. Let me check the code again. Okay, I think I've got the error, guys. So let me just comment this line and see if our output changes at all. It doesn't. And this one as well. So now we are getting the left half pyramid pattern, guys. So I had made a silly mistake. So I was taking 2 loops for outer rows. Instead I just have to take 1. So let me just make it as 10 so that it will be better looking. So this is how you can make a left half pyramid pattern in Python, guys. Now let's take a look at the next program, which is a downward half pyramid. So we are going to go from this line to that line in a reverse order, so that we'll get a downward half pyramid. So we'll follow the same thing. We'll take a function, specify n over here, and now what I'll do is I'll write for I in range. Range is going to be downward direction, so it's going to be minus 1 and minus 1 again. And for j in range, this is going to be the same, I plus 1, Since we are not getting any left pattern, we're just going to print the asterisk over here and is equal to this. Print \r. Now when I call my pattern function, let's see what pattern I'm getting over here. I'm getting a downward half pyramid pattern like this. And if you want to make it a left downward pyramid pattern, you just have to follow this approach, in which you have to specify range and get this variable k and decrement the value, and you will get the same output as you're getting over here. Now let's take a look at the next topic or the next program, which is diamond pattern. Diamond pattern in Python. So for this, I'm just going to take pattern again, and after this I'll specify the spaces 2 into n minus 2 again. For I in range, I'm going to take the range as 0 to n, and again I'm going to take the columns, which is going to be in the range 0 to k. I'm going to print the spaces, and after this decrement the value of k. Now again I'll take one more loop for columns, which is going to be in the range 0 and I plus 1, and I'm going to print asterisk again for my pattern, and is equal to this, and after this I'm just going to print the \r. Now let me just call my pattern function and see what happens over here. I'm getting the pattern like this. To make it a diamond shaped pattern, I'll have to make an inverse pyramid on the downward direction so that it will look like a diamond. So I'll take one more for loop. For that I have to specify the k value again. So for this I'm going to take n minus 2, because if I take 2n minus 2, it will look a little distorted. I'll show you that as well. So I'll take the for loop for I in range. Now we're going in the downward direction, so it will be n minus 1, and step is going to be minus 1 as well. And for j in range, it's going to be k 0, and step is going to be minus 1. Now in this I'm going to print n is equal to this, print the \r for j in range. Now it's going to be 0 and I plus 1. Again I'll print my asterisk value over here, and is equal to this, print the \r. So now that we are done with the function, I'll just print this. Okay, we are getting a very distorted image. I'll take a look at what we are doing wrong over here. Okay, we have this one. So for this I have to specify k is equal to k plus 1, and as you can see we are getting the diamond shaped pattern over here. And let me show you, if I take the value of k as 2 into n minus 1 or n minus 2, the pattern looks somewhat like this. To make it better, I have to make it as 2n, and minus 2 should be gone. Or I'll have to make a few changes over here to make it align to the downward pattern. So what I'll do is I'll just remove 2 over here, and it will look like a diamond shaped pattern right now. So now that we are done with this one also, I'll show you a diamond star pattern. So there is a different approach to this, a diamond pattern, that I'm going to show you right now. So first I'll write the code, and then I'll explain how I've made this. So for I in range, I'm going to specify the range as 5, and for j in range, it's going to be 5 as well. Now what I'll do is, if I plus j or I minus j is equal to 2, or I plus j is equal to 6, or j minus I is equal to 2. So this is my condition, guys. I have put it all in the if statement. I'm going to print my asterisk, and n is equal to this, else print n is equal to this. I think I made a mistake over here. Let me just take a look at the code again. So when I print this, I'm going to get the value as this. So this is a star, diamond star pattern. So what I've done here is, you have to look at the picture over here. So if you take a look at the rows and columns, there's going to be 0, 1, 2 and 3, and you have to identify the pattern in which you can make a statement like this. So for all these values, I'm printing this one. So wherever we have a asterisk over here, it's going to satisfy this statement over here. Only then it's going to print this value. So this is how you can make a diamond star pattern in Python, guys. So now that we are done with the star pattern programs, let's take a look at the number pattern program. So instead of asterisk, we will have a numerical value in the patterns, and we will start with a simple numbers program. I'm just going to take one function, that is pattern, and again I'll just write for I in range. The range is going to be 0 to n, and after this I'll have a variable, but before that I have to specify it over here. So let's say x is equal to 0, and inside this I'm going to increment this x by 1. Now comes my program, guys. So for columns, for j in range, I'm going to get the value as 0 and I plus 1, just like before. And inside this, instead of asterisk, I'm going to print x and is equal to this. Or because we don't have spaces over here, I'll just write space. Now I'll have to specify a \r statement and take, okay, we'll just call our function over here. So we're getting a pattern somewhat like this. I'll just make it as, let's say, 7. So we're getting the pattern with numbers, which is 1, then there is 2, 2, then there's 3, 4, 5, 6, and until 7. This is a very simple pattern for numbers. Let's take a look at a Pascal's triangle pattern, guys. So I'm sure most of you are familiar with Pascal's triangle. So I'll just write the code for Pascal's triangle, and inside this specify n. Again, I'll have to take for I in range 0 to n. For j in range 0, I plus 1, and inside this I'm going to print my function, which is I and j, comma this, and end is equal to this. And after this I'll just print. Now I have to take one more function, guys. So my function is function, and inside this I have n and k. So my result is equal to 1. This is the logic for Pascal's triangle, guys. So I have made the function for my pattern. Now I'm just writing the code for Pascal's triangle logic. So if k is greater than n minus k, k is equal to n minus k. For I in range 0 to k, result is equal to result into n minus I, and result is equal to result floor division I plus 1, return result. So now when I call my pattern function, specify not 10, let's say 7. So this is my Pascal's triangle, guys. So basically what happens in a Pascal's triangle, if you take a look at this one, so sum of these two numbers is going to be over here, and similarly for later purposes, sum of these two numbers is going to be here, and these two numbers here. So this is how the Pascal's triangle will go on. And for, let's say, 10, it will look something like this, and for, let's say, 20, it will look something like this. So this is how you can make a Pascal's triangle pattern in Python, guys. It's a very simple pattern. I have given you the logic also to get the third summation over here in this position. So this is how you can make a pattern for Pascal's triangle in Python. Let's take a look at a half pyramid pattern with numbers, guys. So I just showed you a half pyramid pattern, guys. It's right here. So I'll just copy this code again, paste it over here. So we're getting, when I call my pattern function, let's say 10, I'm getting a half pyramid. So what I'll do is I'll just write x is equal to, let's say, 0, and after this I'll just mention x is equal to x plus 1, and instead of asterisk I'll print x, give a space over here, and we're getting the values as 1 2 2 3 3 3 4 4 4, like that. But instead of that, we can also make a diamond pattern with numbers as well. So we'll just copy the code again with this one. Okay, I'll just show you over here only. So instead of asterisk, I'm going to print x, and I'll specify x over here. X is equal to 0, and over here x is equal to x plus 1. Same here, I'll have to do x is equal to 0, x is equal to x plus 1. Okay, we have made a mistake, guys, and we have to change x over here as well. Give it a space. We'll not do this for 10, let's say do it for 7. And this is how you get a diamond pattern with numbers, guys. So you just have to change the values inside all these patterns that I've shown you, and you can play around with numbers and make different patterns as well. Now let me show you one more program with numbers. So I'm going to show you how you can make a descending order pattern. So it's very easy, guys. I'll just make one function with the same approach, and for I in range, I'm going to take the range as n, 0 and -1, and again for j in range 1, and I'm going to take I plus 1 again. I'm going to print j and end it with space, print \r, call my pattern function, specify 5 over here, and you can look at this. We're getting the descending order pattern. So first of all, we have 5 numbers, then we have 4, then we have 3, 2 and 1. Similarly, we can do this for 10 as well. For any amount of numbers, you can make this as a descending order pattern, which is also a downward half pyramid pattern as well. So now that we are done with this one, let's take a look at a binary number pattern program, guys. Out of all these numbers, we are just going to use 0 and 1. So what I'll do is I'll take one function pattern, and inside this I'll take the range as for I in range 0 to n. Okay, I forgot to take that variable. K is equal to 2 into n minus 2. After this, for j in range, it's going to be 0 to k, and after this I'll print the blank spaces, and it's equal to this. K is equal to k minus 1. For j in range 0 and I plus 1, I'm going to print 1 and 0. So instead of asterisk, I've just written 1 and 0. So it's going to print a binary number program. So basically what happens over here is we're just getting the output as 0 and 1. So you can use any characters. Instead of 0 and 1, you can use 2 and 3, and you can use just 2 or 4 or 5 or any number that you want. And we're getting the value somewhat like this. So this is a pyramid pattern with just binary number, that is 0, 1, and this is how you can make number patterns in Python. And now that we are done with number pattern programs, let's take a look at character pattern programs. Instead of numerical values, we will have a character value inside the program, and there is a little more change. You cannot just mention x, some variable or just like that. You have to make sure that you're changing it to a integer value, the character number. So first of all, let me show you the pattern for right alphabetical triangle. So what I'll do is I'll take function, name in that pattern, take n over here. So I'll take the variable x as 65 now, because 65 is the ASCII value for a. So for I in range 0 to n, and I'm going to take one more variable ch, and I'm going to change this x into the character variable. Now x is equal to x plus 1. It's easy for me now. For j in range 0, I plus 1, I can just print ch, call pattern program. Okay, let's just name it as 10. Okay, we have an invalid syntax over here. So this is how I'm getting my pattern. So it's starting from a and going until j, because I have specified 10 over here. Let's say I want it as 25. So we're going until y, and if I do it like 26, we're getting the whole alphabetical pattern with a to z in a triangle pattern. So this is a very simple example, guys. So I'm going to show you a character pyramid program as well. So I'll take this same approach, specify a function pattern n over here, and inside this I'll take the value of 2 n minus 1 or n minus 2 for I in range 0 to n. Okay, I forgot to take the x. Now over here for j in range 0 to k, print the blank space, decrement the value for k, and for j in range 0 and I plus 1. Now comes the ch or character variable in which I'm going to change the x into character. Now I'm going to print ch and is equal to this, and x plus is equal to 1 because we have not done that. Now after this I'll just print my \r again. Now when I call my pattern function, let's see what I'm getting. So we're getting somewhat like this. Okay, so instead of 10, let's just take 7. So we're getting A, B, C, D, E, F, and this is how we are getting the values over here. So I have changed a little over here. So I was incrementing the value of X on the outer rows, but now I have incremented the value in the columns as well. So we're getting A, B, C, D, E, F like that. Otherwise we'll be getting like A, B, B, C, 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 D, and so on. So this is a simple change that I've done in this program so that you will be understanding better. So let's take a look at the next pattern that we have, which is a K-shape character program. So I'm going to print the pattern in the shape of a K using the asterisk again. So I've shown you that diamond star pattern in which I have taken a if statement. So if that statement is satisfied, it's going to print a K-shape pattern, which is going to look like a K shape with asterisks in them. So I'll just write the code for this. So for I in range, let's see 7, and for j in range 7 again. So this is where the code begins, and I'm going to specify if j is equal to 0 or I minus j is equal to 3 or I plus j is equal to 3 again. I'm going to print asterisk, or instead of asterisk I'm just going to print a over here, and end is equal to this, else I'm going to print n is equal to this, and now print. So we're getting the value somewhat like this. So this character actually looks like K-shaped character. So instead of A, I'll just write asterisk again so that you'll be understanding better. So this looks like a K-shaped character program using Python, and this is how you can make a K-shaped character program in Python. So let's take a look at one more pattern here, which is a triangle pattern program. So I'll just specify a function again, specify n over here, take k is equal to 2 into n minus 2 again, x is equal to 65 for I in range 0 to n, and ch is equal to character x, x plus 0 is equal to 1. Now for j in range 0 to k, I am going to print blank spaces, and for j in range 0 to I plus 1, I am going to print ch and n is equal to this, print \r, and when I call my pattern function, I'm getting the value like this. So this is how I make a simple triangle pattern. So let's take a look at the last pattern that I have in this session, which is a diamond shape pattern with characters. So we'll just copy this code again. Okay, this is my diamond pattern, so I'll just copy this whole code, and over here I'll just paste this. When I run this, I'm getting the pattern somewhat like this. So instead of numbers, I want characters. So what I'll do is, I already have x over here, so I'll mention x as 65, and over here I'll take ch is equal to character x, and instead of x we'll write ch. Let's see how the pattern unfolds. So we're going to follow the same approach over here as well. So x is going to be 65, and we have ch is equal to character x, and instead of x we'll write ch. Now when I print my pattern, so I'm going to take this to another level, so I'll just write 15, So this is my diamond shade pattern using characters, guys.
Let me quickly walk you through the agenda for this session. We'll begin by quickly understanding why we need file handling. Later, we'll move on to understanding the types of files. And guys, this is very interesting. Next, I'll walk you through all of the concepts of how files are handled using Python. We'll be making use of the code first approach to ensure that we understand code at every point of time. We'll end the session by checking out how Edureka is helping learners across the globe so we can make sure you can get started as soon as possible and make your learning fun. So let's begin by quickly walking you guys through why we require file handling. Well guys, think about this situation. You have a server running and you need to give access to someone who needs to access it remotely, right? Or basically you need to work with these files in general and say you need to have some import into your program where you're actually configuring an input for it. Well, if I had to answer this personally, how would I go about it? I would be using files for a lot of my deep learning models to import my datasets into the program at all the time. So basically by doing this, I'll be making use of files a lot. So coming back to the basics again. How can we input something into Python? The standard input? The usual keyboard input, right? So you can key in anything you want. Well, there's another case as well. Maybe even command line arguments to input some parameters into the code, correct? But what if you had to read lots and lots of data which is not practical to type in at every point of time, or even that it doesn't make sense at all to type it all the time? The easiest way out of this here is to actually store whatever input you want in one place and keep using it as long as your requirement is met. So what's the answer? The answer is files, guys. So guys, this concept is actually very easy. I'm sure everyone who's joined will take away some really interesting stuff about Python that you can practically use. Working with files basically opens another door among thousands, and each door with Python opens up to n number of opportunities again. So now that we're good with this and we started off on a really high roll, let's keep it going. Next, we'll be taking a look at some of the types of files available in Python. So we have images, we have audio, we have video, we have text, we have script, and so much more, right? There is a key difference here I want you guys to note. Check this out. Windows supports all of these files that I told and more. Well, virtually unlimited to be honest. But again, I won't get ahead of myself here because there are limitations here as well. Now check out Python. There are two types of files, binary and text. So whatever is not text is binary, as simple as that. So either a file gets to be a binary which contains obviously zeros and ones, or it can have some literal text. Well, text as in strings or anything valid for that matter. Text files are structured as a sequence of lines where each line includes a sequence of characters, and this is what we call as code or syntax, right? And every line is terminated with a special character, what we call as the EOL. What is the EOL? Guys, it's the end of line character. A binary file is any type of file which is not a text file, as I mentioned. And because of their nature, binary files can only be processed by an application that knows and understands this file system structure. In other words, they must be applications that can read and interpret binary, right? And now that we know what are the types of files are, so we can start looking into more of this. Guys, formally speaking, I think it can be consolidated as the operations performed on a file, right? So what all can we do? Check this out. It's called as the CRUD operations. What is CRUD? Well, create, read, update, and delete, guys. These are the operations which can be done with files. Well, again, there are many other operations as well, such as copying a file, changing the properties of a file, or anything. But for simplicity's sake, I have planned to keep this session really easy for all of the audience. So let us dive into Python now. So let us quickly see how we can go about understanding the file handling capabilities of Python. Check out this flow diagram to give you a quick picture of what needs to be done. First, we create a file and later we open that file. We work on the file. Well, working on it is basically reading or writing or anything for that matter. And lastly, we close the file when we are done using it. Coming to Python now. Creation of a file can be done manually by the user or through Python. For now, let us consider that we will do it manually by going into the location and creating a file, say like a text file. Later in this session, I'll show you how easy it is to make Python create the file for us. So make sure you stay tuned till the end. So now we concentrate on how we can open a file with Python. Guys, it is very simple. So we have an inbuilt function called as the open function, which is used for this exact purpose. The open function takes in two parameters as seen here. One is the file name and other is the mode. And this on your screen is the syntax for the open function. So what do the two parameters mean? One is the file name that you want to open. It can be anything at this point of time, right? So it has to contain the extension of the file type as well. So this is compulsory and important. So make sure you keep this in your mind. And second, we have the mode. We know this means something that has to do with opening the file, right? So check the screen. So basically, these are various modes available to open a file. We can open it in the read mode, the write mode, the append mode, and even the create mode as well. Pretty straightforward. But do note that the default mode is always the read mode. And guys, note that you can open a file in read mode only if it exists as well. If you try to read a file or something that doesn't exist, then Python will greet you with a beautiful error message. And in addition, if you want to specify if the file should be handled as a binary or a text mode, then along with the mode as well, we can actually push in two categories for it. Check this out. So we have T for text and B for binary. T is the default value and B is for binary modes. So we can have something as WT. So what does it mean? So it basically says that the file needs to be opened in the write mode and the file that the Python opening is a text file. So we're basically making the job of Python to be really easy in this case. So check out the example code I have here for you guys. Even if we do not give a mode, as I said, the default is the read mode. So these two tiny snippets I have for you are one and the same. And yet, make sure something exists before reading that, guys, or else you're sure to hit that error. So check this out, right? So I have f equal to open and the file name is demofile.txt. I don't have a mode here. This is exactly equal to having the read mode in the next example. And it is as simple and straightforward as that. So now we know how we can actually create a file and open it, right? So let's begin working on it. Let us start with creating on how we can actually do a read operation using Python. So the read operation is very easy, guys. So basically, just like all the other functions and handling files in Python, we make use of the read function for this very purpose. But then again, there are so many ways to read a file too. So let me break it down for you, all right? So we can do many things here. We can read an entire file or read a few characters or read a few lines or any number of characters and lines together and so on. Check out this example code here. So we have a variable, right? We call it file. And then we are opening the file. It's called textfile.txt and opening it in the read mode. Later, we are actually going to make use of the print function to read the contents of the file and print the same on the Python console. Now, similar to the previous code that I just showed you, we have something slightly different here. Can you notice that 5 on your screen? What do you think the 5 indicates here, guys? Let me help you out. So it basically tells the Python interpreter to read the first 5 characters from the file and nothing else. Now check the old syntax. So here we don't have the 5. So we are basically telling the interpreter to read every single valid character present in our file and print it out for us. So you got a good picture of what is happening with the file now? Well, let's quickly take a tour into seeing this practically. So I'll open up my PyCharm now, which I use as the IDE to work with Python, where I'll show you the code for all of these. Guys, you can basically make use of any IDEs that you're comfortable with and even the console as well. It is your call. I am comfortable working with PyCharm, so I'll go ahead with that. So let me quickly open up the IDE and we can see the basic code to read the file. So as you can check out, I'm here in my PyCharm right now. Importing the OS module is the first line. This is currently being unused right now, but I'm going to talk about this in the future session. So basically, we're opening a file, right? So we have a variable file. We're going to open it and we're providing the entire path to the file present. So here, the file is demofile.txt. This is the name of the file. W is the write mode that I already told you about. Let me quickly go ahead and run this. That ran fine. But you cannot see anything on the output, right? That is because we just opened it, overwrote everything that is present in the file and we just closed it. So we're not seeing absolutely anything here. Check out example 2. Importing the OS module, file equal to open. Again, we are providing the same file. Here we had write mode and now we are having the read mode. And here we are actually printing it using the file.read. Again, I'll be walking you through file.read in a second, but right now all you need to know is this will print the output on the screen for us. If I go ahead and actually run it, nothing is going to be printed. Why do you think this happened? This happened because we actually used the write mode and we actually blanked out the entire file. Quick fix is to actually open the file. As you can see, nothing is present there. So let me type in something. So we love Edureka. Let me save that, quickly minimize it, go back to my PyCharm. Now as soon as I run this, it is supposed to give me that exact output which says we love Edureka. Perfect, right? So with absolutely 3 to 2 lines of code, you can actually print something on your screen. How simple is this, guys? Well, check out the next case. So again, it's the same thing, opening the file, using the read mode, and then you're printing file.read of 5. Guys, file.read of 5, right? So I actually explained this to you. So let me just go ahead and run it. We'll check the output. We got the first 5 character, right? So W, E, a blank space, L and O. Let us try to make it more nice to look at. Let me just quickly open up the file. Hello world. This is a perfect candidate for our example. Yep, the quick typo. Save it. Exit, back into the code. Now I'm going to run this old code, right? So you're going to get the entire output here. Check it out. Hello world. Perfect. Because we have read of blank. Now we're going to actually run this. Because we're telling the interpreter to read only the first 5 characters of the first line for us, it is just printing hello. How simple is this, guys? So now that we are actually done with this, let's quickly jump back to the presentation to see what's next. Well guys, next I want you guys to check out this syntax, right? So this is what I love about Python. Amazing readability, and you can almost guess what it means, and you can be certain of it, say 90% of the time. So we saw how to read characters. Now let us look at how we can read lines. Well, readLine will actually read each of the lines and give us a line by line output. ReadLine of 3 will tell the Python interpreter to read only the third line and absolutely nothing else. But what if we wanted to return every line in a file which is properly separated and nice to look at? Well, you can actually use the same function only in a new form. This is called as file.readLines function. Again, let's take a quick jump back into the code so we can see this in action. So check out example 4 on your screen. I have the same file demofile.txt. I'm opening it in the read mode and I'm using readLine. As soon as I go ahead and run this, I will have the same output as hello world. Okay, let us step it up a little. Let me just change this. Hello world. We love Python. And we love Edureka. So I have 3 lines here. All good, right? So I'm going to save it. I'm going to close it. I'm going to come back here. I'm going to run the read line. Again, we're reading only the first line. Cool. Check out example 5 now. This is where things get interesting. Import again, it's all the same, guys. So basically, instead of the read line, I have read lines over here. So the S is extra and it's going to read all of these lines and it is going to put it in a really beautiful way for us to see. Check this out. Hello world is an entity. We love Python as an entity. We love Edureka as another entity. And that's nice to look at, right? So instead of just getting a gibberish output of everything in the line, separating it actually makes a lot of sense. So now that we're done with this, another quick hop back to our presentation. So guys, next we need to check out a tiny concept on how we can actually loop over a file object. Well, this is another simple concept, so let me teach you this. We're using the for loop for this very purpose as shown. But why would we want to do this? When you want to read or return all the lines from a file in a more memory efficient way and in a faster manner, you need to use the loop over method. So the advantage of using this method is that the related code is both really simple and easy to understand, right? So let me take another quick jump into PyCharm and check the single snippet out. So we are back into PyCharm and check out this for loop example I have for you. So again, we're sitting on the same file, demofile.txt, reading it in the mode. So for every line in our file object, print read lines. So it is going to print the output for us containing all of the documents of our file. As you can see, we love Python and we love Edureka. That's really simple, right? And with this, we are actually done understanding how to open the files and read them in multiple ways. Next, we need to actually take a look at the write operation, which is again very simple and almost similar to the read method. Let's start. Writing to a file is as simple as using the write function, guys, similar to the read again. So to write to an existing file, we make use of two modes. One is the append and the other is write, which we already checked out earlier. By append, we actually add the contents of the write to a new existing content. And with write, we just add it to the blank file. Now, I am sure there is a question in your mind right now. So what if the file that I'm trying to work on is not blank? What if it contains some previous data and we make use of W instead of append? Guys, this will basically delete everything in the file and overwrite it with what we have just put. And this is exactly the first example case that I actually showed you. So make sure that you use the mode very wisely in every situation, right? So here's a quick example before we dive right back into code. As you can see, we open a file in the write mode and we write 2 lines into it and we close it. It is as simple as that, right? Now again, taking you back to PyCharm and let me walk you through the code. So guys, we are back into PyCharm right now, so check out the first example I have for you. Import OS, I already explained. Opening it in the mode of write. So since we already have some content, all of that content will be overridden with hello world and hello world again. So we're opening it, we're using file.write to write 2 content into it, and then we're going to close it. Let me run this. Again, no output because we are not printing it to our console. How do we check if everything is working? Open the demo file. Hello world and hello world again, right? So this is exactly what we wanted. But then again, this looks a bit gibberish as I told you, right? So we use read lines to actually make it look nice for us. Heading back to PyCharm again. Check out the next example I have for you. So now this is to prove that we are actually overwriting it again, which I've already told you and it is simple, but still let me walk you through this. So we're working on the same file, we're using the W mode and then we're writing it to it saying, oops, we have overwritten it. Run it, it ran, no output, but in the sense the file is changed. So it says oops overwritten instead of hello world and that old message that we printed. Let me head back to the PyCharm again. And this is for creation and we'll be coming back to this in just a second. So let's quickly go back to our presentation and then we're going to be coming back to PyCharm again. So we're down to the last 2 concepts that we will check out in this session. The first one among that is for us to create a new file using Python. Well guys, even for the creation of the file, we need to make use of the open method. We already know that A is used for append and W is used for write. And now we have X, which is used to create a file. But do note that you cannot create two files of the same name, guys. So basically it means that you cannot create a file which already exists. Check out the example on your screen and you will definitely get a better picture of it right there. So you cannot have two files with the same name, testfile.txt. This is not right. So again, Python will give you a beautiful error message and it won't be so beautiful at the end of it. Let me dive back to PyCharm and we can check out the example over here. Let me change this. We have something else, right? So let me type edureka.txt. I'm going to print new file into edureka. Opening it, we are opening it in the X mode, so we are actually creating this file physically. Write mode to write something into it and close it. So as a result, no output. Check out the file. Where is the file called edureka? It is here. New file of edureka. So it's perfect, right? Let me quickly head back to the presentation and we can check out what's next. And then the next simple concept I have for you guys is showing you on how deletion operation works with respect to files using Python. Guys, deleting a file is very simple and straightforward. We'll require the os.remove function just for this purpose. So yes, importing the OS module is a compulsion here. I've been using it all along because it is just a good programming habit to use the OS module when you're playing around with the file system. The biggest mistake I have seen people do is that they usually go on to delete a file which doesn't exist. Again, Python pushes in an error message and that is not good at the end of the day, right? So it is very vital to know for sure that the file exists. To do this, we just check if the path exists and if it does, cool, remove the file. Else, print that the file doesn't exist so you cannot remove it. What does this say? Guys, this is a very simple case of an exception handled by the user and this is a really good programming habit too. So all good, but can we delete a folder? Yes, we definitely can. A folder with all the content inside it can be deleted using the rmdir command. What does rmdir stand for? It basically stands for removing directory and the parameter here is basically the path. And by the path it includes the name of the folder which needs to be removed. And this is all of the operations you can do with Python by making use of files. Let me quickly conclude the session for you guys. So we started by checking out the different types of files and why we need to use files, right? So we also saw the different types of files again and how we can work with each of these types of files and all of the operations involved with this as well.
Let's take a look at the agenda for this session. So first of all, I will start with the prerequisites that are Python functions, and then I will talk about Python decorators with a few examples. And finally, I will discuss a rather complex concept that is fancy decorators with a few examples as well. I hope you guys are clear with the agenda. Also, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates from Edureka. So without wasting any more time, let's start our session. I'm sure most of you are familiar with functions in Python. So let's recall some of the important concepts that are going to be useful while working with the decorators. So the concepts that I want to discuss are first class objects and inner functions. So in Python, literally everything is treated as an object, including all the data types and even functions. So the functions can be passed around as arguments as well. So that is why it is called a first class object. Coming on to the inner functions, a function can be also declared in another function which is known as an inner function. It also resonates around the decorator, so we'll get to that later on in the session. So let's take it up to PyCharm and understand how inner functions work, and we will also try to return a function from a function, which is actually passing a function as an argument. So let's take it up to PyCharm, guys. So now that we are in the PyCharm, let me go to the presentation mode so that the clarity will be better. So first of all, let me talk about the first class object. So I'll just take a function, name it as, let's say, function1. And inside this I'm going to pass a variable name. So now I just want to return, let's say, hello. So for this, I'm going to use the string interpolation. If you're not sure about that, please do check out the tutorial on strings on Edureka, so that you will be familiar with what I'm doing here. That is the string interpolation. You'll see what it does. Now let me define one more function. Let's say define function number 2, and inside this I'm going to pass the same argument, that is name. And now I'm going to return using the string interpolation again. So after this, I actually want to ask how you doing. I have to give 2 lines over here. This should do. And now I want to take one more function, guys. So I'll name it as function number 3. And inside this, I'm going to pass function as an argument. So here I just want to return function number 4. And inside this, let's say I want to write dear learner. Now when I print this, I'm going to print function number 3. And inside this, I'm going to pass function, that is function number 1. Now again, I'm going to pass function number, let's say 3. And inside this, I'm going to pass the function number 2 again. Let's see what the output is. Okay, we have an error, guys. Function 2 is missing one required positional argument, name. So we have made a mistake over here. So when I print this now, I'm getting the output as hello dear learner and dear learner, how you doing? So I'm actually able to pass the functions as arguments. So that is actually how we use the first class object. We can use anything as an object in Python. Now moving on to the next example that I'm going to show you is for inner functions. So how exactly do you use inner functions? So I'm going to take one function, let's say func, and inside this I'm going to define one more function. So first of all, let me give it a statement. I'll say first function. And after this, I'm going to define one more function, and this is going to be function number 2, or I'll just write it as function number 1. And after this, I'm going to give one more statement over here. Let's say first child function. Now I'm going to go define one more function. Let's say function number 2. And inside this, I am going to print, let's say second child function. And let me take one more statement. So function 2 and function 1. Now when I print our function over here, let's see what the output is. So first of all, we are getting first function, that is the base function, and then we are getting the child function and the first child function. So this is how you can use inner functions in Python. Basically, it's a nested function. We are using multiple functions inside a function. So we have one function over here, and inside this we have 2 more child functions. So this is a basic example of inner functions, and Python decorators is going to revolve around this concept a lot, the first class objects and inner functions. That is why I was telling you about this. I'm going to show you one more example. So I'm going to return a function from a function. So basically what it means is I am taking a function as an argument for another function. So what I'll do is I'll just write function and define one function. Over here I'll just write n, and now I'm going to define one more function. Let's say function number 1. So I'm going to return, let's say Edureka, yes. And now I'm going to take one more function, let's say function number 2. And inside this function, I am going to return, let's say Python. And now let me take a statement, guys. So if n is equal to, let's say 1. So I'm going to return function number 1. I'll not use this. I'll tell you about this later. Else, I am going to return function 2. So this is my function, guys. Inside this, I have 2 more functions. I'll show you what it does. So I have a is equal to function, and inside this I'll write 1. And now again, inside this I'll write, let's say 2. So now when I print a, and let's say I am going to print b as well, you'll see what the output is. Okay, we have name b is not defined, so actually I had to take b over here. So the output is Edureka and Python. So I'm successfully able to return a function from a function, guys. So I've taken these 2 functions as arguments, and this is how we can return a function from a function. So now that we are through with the Python prerequisites, we'll talk about decorators in Python. A decorator is a design pattern in Python that allows a user to add new functionality to an existing object without modifying its structure. So decorators are usually called before the definition of a function you want to decorate. Let's take a simple example to understand how it works. So we'll go to PyCharm again. I'll clear this off. And okay, let me just put it right here. Now I'm going to take a simple decorator example. So I'll just define a function. Yes. And inside this, let's say I want to pass a function as an argument. I'll name it as function1. Now again, I'm going to define a wrapper function. This is my inner function, guys, and this is basically the decorator that I'm going to use here. I'm going to pass function again, so you'll see what it does, and I'm going to print one more statement after this. So let's just say welcome to Python Edureka tutorial. Now I'm going to return wrapper over here, and I'm going to define one more function, and inside this function number 2 I am going to use a print statement. Let's say Pythonista, and let's just call a function now. Function number, let's say 2 is equal to function1 function 2. So this is a very important statement, guys. Now I'm just going to call the function number 2. Let's see what the output is. So my output is hello Pythonista, welcome to Python Edureka tutorial. So as you can see inside the wrapper function over here, first of all we are getting hello. After that, the function which we have right here, this one, function number 2, which we have passed in function number 1. So this is my wrapper statement, guys. There is another approach to this using a Py syntax, or we can call it a syntactic sugar as well. So it basically makes it easier to use decorators in Python, guys. What I'm going to do is I'm going to make a few changes in this code and you will understand what I have done. So after this statement, that is return wrapper. Okay, let me clear all this. I can just write @ function number 1, and now I'll just define my next function, that is function number 2. And over here I'll just print Pythonista. And now when I call my function number 2, the output is going to be same. So as you can see, the output is same, which is hello Pythonista, welcome to Python Edureka tutorial. So what I have changed here is I have changed this over here. So I've used this Py syntax, or you can call it a syntactic sugar as well. It makes your job easier. So this is how you can use a simple decorator in your functions, guys. So now let's try to understand the concept of decorators in Python with a few more examples. So I'm going to take a program inside which I'm going to specify a decorator with arguments. So I'll just take function number 1, and inside this I'm going to pass function again. Now I'm going to define my wrapper function inside which I will have arguments. So earlier I didn't have arguments over here, but now I'm going to have arguments inside this decorator. So I'm going to print hello again like I did in the last program, and I'm going to call the function again. So inside this I'm going to use the arguments as well. And after this I'm going to print the same statement, that was welcome to Edureka Python tutorial. And I will return wrapper. After this I will use the syntactic sugar. Function number 1 I'll write, and after this I'll define my function number 2. And over here I'll write the print statement. Let's say, alright, we can use our argument over here as well, and we'll use the string interpolation again. Yeah, when I print function number 2, I'm going to specify a name as well. Let's say Wasim. Now my output is, okay, we have a error which is function 1 is not defined. So basically this, we have made a mistake over here. Now it should work fine. So we have hello Wasim, welcome to Edureka Python tutorial. So this is a very simple example, guys. So we have actually used arguments in our decorator. Let's take a look at the next function that we have. So I'm going to use a function in which I'm going to return values from a decorated function. So I'll just define a function number 1, and inside this I'll pass function again. And now I'll define a wrapper function with a few arguments, let's say. And after this, it's going to work the same way like we did. So I'm going to write print, let's say it worked. So it will show us that it worked. I'll return wrapper. And after this, I will have that same syntactic sugar, function 1. And I'll define my function number 2 here. Pass name over here. And I'll write print, string interpolation, get name. And now when I print, let's say function number 2 with name, let's say Python. So what is the output that we are getting? It's showing it worked. So now that we are through with the decorator examples, let's talk about fancy decorators in Python. They're nothing but the complex features of decorators in Python. And to explain this, I'm going to take a few examples like class decorator, and let's talk about them one by one. So we are making a reference here so that we can use it for various purposes in the future as well. So we are not using the parenthesis over here because we're making a reference to this function. So I'll clear this up and we'll talk about the class decorators now. So there are two ways to decorate a class in Python. The first one is where you can decorate the methods inside a class, and there are built-in decorators like class method, static method, and property in Python. So class method and static method define methods inside a class that is not connected to any other instance of a class. And property is normally used to customize the getters and setters of a class attribute. So let's take an example to understand this. So I'll take a class. I'll make it a more relatable. So I'll not use functions. Instead, I'll use, let's say, square. And for my class over here, I'm going to define few functions. So first of all, I'm going to define an init function. And inside of self, I'm using one more variable, that is side. Now self dot side is equal to side. And I'm going to add a property over here. So this is going to be my decorator, guys. So this is going to be my decorator. It's a built-in operator, guys. I'll show you what it does. So I'm going to define one more function named as, let's say, side. And inside this, I'm going to pass self. And now again, I'm going to return self side. And I'm going to use one more. So this is my setter function, guys. And now inside this, I'm going to use the side function. And after this, I'm going to use the value. So if value is greater than equal to 0, I am going to get the side is equal to value. Else, I'm going to print that there is one error over here. And now again, I'm going to use property. And over here, I'm going to define area, self again. And inside this, I'm going to return the area. So I'm going to use self dot side. And I'm sure everyone must be familiar with what is the area of a square, that is side square. So I'm using a double exponentiation operator over there, which is used to calculate the square. So if I make it as 3, it's going to be a cube, but we don't need that. So I'm just going to leave it at 2. Now I'm going to define a class method, and it is going to have one more function. Let's say unit square. And inside this, let's have one more variable, CLS. And now I'm going to return 1. We are done with the class, which has all these functions and built-in class decorators like property, class method, and setter and getter, all those. So I'm going to have square over here. I'm going to specify the side as 5. Now let's say what my side is. Yes, and I'm going to print the area as well. So when I do this, my output is 5 and 25. Now, sometimes it's useful to have a decorator that can keep a track of state. So let's take a few more examples to explain decorators in Python in detail. So I'm going to make a singleton class using class decorators. So first of all, I'll import func tools. And after this, I'm going to define a singleton class. So name is as singleton. Now after that, I am going to use the function tools dot wraps inside this CLS. Now comes the wrapper function, and inside this I'm going to have a few arguments as well. And after this, I'm going to get the instance is equal to CLS args and chaos. I'm going to return wrapper again, making a reference to the function and not calling it, but I'm going to use this to make an wrapper dot instance. Okay, we're making a small error over here. Now I'll just write wrapper dot instance is equal to none. And now I'm going to return wrapper again. After this I have a singleton, and after this I'll have class 1. I'm going to pass, and let's say first is equal to 1, and let's say second is equal to 1 as well, and I'm going to print first is second. So let's see if we get true or false. I'm getting a error, guys. Alright, I have made a mistake over here. I had to add a if statement. That's why we're getting this error, guys. And after this it should work fine now. So it is actually true, and we know that a singleton class only has one instance, and there are plenty of singletons in Python including true, none, etc. So now that we are done with making a singleton class, I want to talk about nesting decorators. So in a function you can actually use nested decorators as well. So I'll show you the syntax for that. So basically what you can do is you'll just write function 1 and you can write function 2, but you have to define all those before that you use. After that you can just define a function name and print whatever you want. You can use multiple decorators by stacking them on top of each other. And now let's take an example in which I'm going to take arguments in a decorator. So for that I am going to import function tools, and after this I will define a function, let's say repeat, and inside this I'll write number. Now again I'll write one more function, let's say decorator repeat, and after this I will pass a function inside this, and now I will make one decorator, let's say func tools dot wraps. Inside this I will pass function, and I'll define one more wrap function over here, and inside this I will pass a few arguments. Now for in range number value is equal to I'm going to return value after this, and return wrapper, making not using the parenthesis again, and after this I'm going to return decorator repeat, and again not using the parenthesis. Now we make our decorator, let's say repeat. Inside this I'll specify the number itself, let's say 5. After this I'll define a function, and inside this I'll pass name. Using the string interpolation we will have a name again. So let's just say I want to print my name again, or I can use Python as well. So I'll just write Python over here. Now when I run this, there should not be any errors. So I'm getting it as Python as 4 times. So instead I can use 4 over here. I'll get it 4 times. So this is my repeat function. So I'm using it as an argument 2 times also. We can use it for 20 times as well. So it is always useful to pass an argument in a decorator.
Everything in the world of programming requires a name, but still there are a few anonymous mysteries. Lambda functions or lambda expressions are one of these kind of entities that are in fact nameless. So before we begin, just make sure guys that you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards the session, we shall first begin with understanding what are lambda functions or lambda expressions and why they're used. Following that, I'll be showing you all how to write these lambda functions along with some user-defined functions as well as some predefined functions such as filter, map, and reduce. Finally, we'll be using these lambda functions to solve some algebraic expressions. Okay, so without any further ado, let's move on towards the first topic of this session, which is understanding what exactly are lambda functions. Python lambda functions are functions that do not have any name. They are also known as anonymous or nameless functions. The word lambda is a keyword that specifies what follows is anonymous. Now that you're aware of what these lambda functions are, let's move on further to see why they are actually used. The main purpose of anonymous functions comes into picture when you need some function just once. They are created wherever they are needed. Due to this reason, Python lambda functions are known as throwaway functions. They are also used within higher order functions which take a function as an input or return it as an output. Another very good advantage of using these lambda functions is reducing the size of code. And I'm going to be showing y'all in this session how to do this. So now let's move on towards our next topic, which is to see how to write anonymous functions. Lambda functions are created using the lambda operator, and its syntax is as follows. The first thing that you'll need to specify is the lambda keyword, and following that you'll have to specify the arguments or the inputs. And finally, after the colon symbol, you'll have to specify the expression that needs to be solved. Lambda expressions can take any number of arguments. So as you can see over here, my first example is a lambda expression without any arguments. In the second example, I've taken a lambda expression which just has one argument a1. Finally, I'm demonstrating a lambda expression which has inputs from a1 to an. Just remember that all your arguments or inputs need to be separated by a comma. So now let's move on towards our Jupyter Notebook and see how we can actually write these lambda functions. I'll just create a new notebook over here, guys. I'll just open a new notebook over here, guys, and I'll rename it as lambda functions. So guys, now just let me write the syntax as a comment over here. This is going to be good for a referral purpose. So first is the lambda keyword, like I already told y'all. Sorry guys for the spelling mistake. Lambda and the arguments, followed by the expression. Okay, so the first thing I'll have to write down is the lambda keyword. Following that, I'll have to specify the arguments. So let me just give one argument to this. And after that, I'll just say I want to multiply this a with itself. So this is my lambda function. But before executing this, I'll require some variable that can hold the value of this. So I'll just specify that x is equal to this lambda function. And after this, I'll say x of 3. And I'll hit run. So as you can see over here, when I used x of 3, it's returned the output to be 9. So guys, if I had to solve the same expression using a normal function, then I would have had to write a larger piece of code than this. Let me just demonstrate this to you guys over here. So I'll just define a function, say new, and I'll pass the parameter as a. Now I'll be using return to return the value of a star a. To call this function, I'll have to use the name of the function and specify some value to the argument that I've already passed. So in place of a, I'll pass the value as 4, or let me take it as 3 itself, like the previous function, and I'll hit run. As you can see over here, using lambda functions, I just required 2 lines of code. Whereas, while using the normal function, I had to make use of 3 lines of code along with this return statement over here. Okay, so guys, I hope you all have understood how to write these lambda functions. So guys, as you all have just seen, I've used lambda expressions in the example along with some other variable x. Now I did this because these functions are nameless and require some name to be called. But doesn't it seem confusing as to why assign a name to a nameless function and what is the need of it? It's a legitimate question, guys, but the point is this is not the right way of using anonymous functions. Anonymous functions, like I've already told y'all, are best used within higher order functions. These functions either take a function as an input or return it as an output. To demonstrate this, let me just move on towards our next topic of this session. The first thing that we're going to study is anonymous functions within user-defined functions. So as you all can see on the screen, I have a user-defined function that takes the lambda function as an input. In this example over here, The normal Python function, which in my case is new func, takes one argument x. This argument is then added to some unknown argument which is supplied through the lambda function. Let me just jump onto my Jupyter notebook to explain this in detail. Let me just first create a heading over here, guys. Just remember the number of prefixed hashes tells which heading it is. So if it is h1, it will have one hash prefixed to it. If it has 2, then it's h2 and so on. So I'll just create a heading over here of h1 level and I'll give the name as user-defined functions or lambda within user-defined functions. Lambda within user-defined. So I hope you guys know what are user-defined functions. Okay, so as you all know, when you have to create a function in Python, you'll have to use the def keyword followed by the name of the function. I'll just name the function as a and I'll pass one parameter to it, say x. After that, I'll be using the return statement. And within this, I'll specify a lambda function. I'll pass y as the argument to this lambda function and I'll use x plus y as my expression. Now let me just give some value to the variable x and store it in another variable t. So a of 4 and I'll print the value of t of 8 and I'll hit run. So as you all can see on the screen, the lambda function that is used within the function a is called whenever I call this higher order function. And the first thing that I'm doing over here is passing a value to the variable x and then I'm printing the value of x plus y. So I hope everyone's understood this part. Okay, now let me just copy this function and pass a few other values to this as well. I'll just store a new value in the variable u and I'll pass the value for x as say 7 and I'll print 2 of 5 and I'll hit run. Okay, so I hope everyone's clear with this. If you have any doubts, please do let me know in the chat box and my team is here to help you. Now let's move on towards the next topic, which is using lambda functions within filter, map, and reduce functions. The filter method is used to filter the given iterables, which can either be lists, sets, etc. Now this is done with the help of another function, which is passed as an argument to test all the elements to be either true or false. After applying the function to the set of iterables, if the value is true, then that value is returned in the output. Now let me just jump onto my Jupyter notebook and use the lambda function within the filter method. I'll just give a new heading over here again. Just for your reference, guys, I'll create a heading of h2 level by prefixing it by 2 hash characters. So I'll just use lambda within filter. And since it's a method, like I already told y'all, the filter function needs iterables. Now here I'll just create a list. I'll say my list and I'll specify some elements to this. The filter method is going to check for all the elements to either be true or false in accordance to the expression that is passed within the lambda function. Like I already told y'all, the filter method is going to check if the expression that is specified within the lambda function is either true or false for all the elements that are present within my list. And it returns all the elements that satisfies the expression. So as a result, I'll have a new list. So I'll just name it as a new list. And I'll use the filter function. And within this, I'll be using the lambda function like I already told y'all. Let me just specify the input as a. And I'll give an expression over here, say a. I just want to check if any of these values when divided by 3 will equate to 2. And I'll pass my list. And I'll pass my list as an argument to this. And since the output is going to be a list, I'll just use the list method over here. And one more point I want you guys to note is the syntax of the filter function. And since I forgot to specify this before beginning the demonstration, let me just specify the syntax of this function over here. I'll say syntax. You'll have to use the filter keyword along with some function followed by the iterables. Okay, so as you can see over here, I have the filter keyword, I have the function which is lambda, and then I've passed my list as the iterables to this function. Now let me just print the new list. And I'll hit run. Uh-oh, sorry guys, I've made a spelling mistake over here. So it's Filter. So as you can see over here, I've passed the elements 1, 2, 3, 4, 5 and 6 to this filter method. And after checking if this expression is true for all the iterables, it has returned 6 as the output. Now let me just cross check over here. So if I divide 1 by 3, I will not get a result which is equal to 2. Similarly, if I divide 2 by 3, I'm not going to get the result as 2 again. Finally, as we all know, if I divide all these elements by 3, only for 6 I'll get the output as 2. So I hope everyone's clear with how to use the lambda function within the filter function. So now let's get back to our presentation and see how we can use the lambda function within the map function. Guys, the map function in Python is a function that applies a given function to all the iterables and returns a new list. So I hope you're understanding what exactly it does. It takes a function as the input and some iterables as well. And then it applies this function to the set of iterables that are passed and it returns a new list. So now let's get back to Jupyter and do the same. I'll create a new heading, of course. And it's going to be lambda within map. And I hit run. So before moving on towards the demonstration, I'll just write the syntax for the map function. So it has to have the map keyword, of course. And the parameters that are passed to it is a function and the iterables. Now let me just make use of the same list which I was using previously. And I'll copy that over here. And then I'll just store the output in a new list P. And I'll use the list function since I want the output to be a list. Within this, I'll use the map function, and to that map function, I'll pass a lambda function as the input. I'll just pass one argument to this as A, and the condition I'm going to specify is to check if any element present within my list divided by 3 is not equal to 2. And I'll pass my list as the set of iterables. And then finally, I'll be printing this. Now let me hit run. So as you all can see over here, it has returned a list with some Boolean values. The expression that I wanted to check is A by 3 not equal to 2. Now let me just move on to my list and see what happens when I divide 1 by 3. Of course, I'm not going to get 2, so I have true as the output. Now when I divide 2 by 3, again, I'm not going to have the output as 2, and therefore I have true as the Boolean value for this. Similarly, all the elements present in my list are divided by 3 and it's going to check if the condition is true. Therefore, only for 6 it's going to be false and I have the output as false. Okay, so I hope you guys have understood how to use the lambda function within the map function. If you have any doubts, please do let me know in the chat box, guys, and my team will revert to you. Okay, now let me just jump on towards our next topic, which is using lambda function within the reduce function. So guys, the reduce function is used to apply some other function that is passed as a parameter to it to a list of iterables, and finally it returns a single value. And to demonstrate this, I'll just jump on to my Jupyter notebook again and I'll create a heading. This is going to be lambda within reduce and I'll hit run. So first let me just write the syntax of this function. It is the reduce keyword and it takes a function as a parameter. The first parameter is a function and second is a sequence. Now to make use of the reduce function, you'll have to import the functools library, or from that library you'll have to import the reduce function. To do this, I'll be using from functools import reduce. You can also directly import the functools library as import functools, or you can also use from functools import star. These are just the alternate ways that you can also use over here. Okay, so now I'll be using the reduce function, and within this I'll specify a lambda function. And I'll pass two parameters, say A and B. And let me just print the sum of A and B. And finally, it has to have a sequence as its input. So I'll just specify a list over here. I'll say the list of values to be 23, 56, 43, 98, and 1. Okay, so now let me hit run and see what it returns. So as you can see over here, guys, I have 221 as my output. So what this reduce function is actually doing is, it first adds 23 to 56. So guys, the first thing that the reduce function does is add 23 and 56. And the output of this is going to be 79. Now after adding these two values to this output, it will add 43. So to 79, it's going to add 43 and it will produce a new output. After finding the output of 79 and 48, it's going to add the result to 98. And finally, it's going to add that result with 1 and returns the final output, which is 221. So I hope you guys have understood how this function is recursively adding each value to the next value that's present in the sequence. Guys, if you have any doubts, please do let me know in the chat box. Okay, now let's move on to see how you can actually use these lambda expressions or lambda functions to solve some algebraic expressions. For this, I'll just go back to my Jupyter notebook and I'll create a heading over here. Sorry guys. I'll just delete these two kernels. And I'll create a heading. I'll just say lambda for algebra. So guys, first we'll be taking some linear equations. So I'll just create a heading as linear equations. So as we all know, algebraic linear equations consists of variables of degree 1, which means they'll have the power as 1. So now let's just use the lambda function to solve some linear equations. I'll just say S is equal to lambda. And I'll pass the argument or the input as A. And the expression I'll specify as A star A. And I'll use S of 4 and I'll hit run. So as you all can see over here, 4 cross 4 is 16. Now let me take a different linear equation. So let me just write the linear equation over here as a comment. So I just want, say, 3x plus 4y. Okay, so if I want 3x plus 4y, so I'll have to specify some name to this. Say d is equal to lambda and x and y as the inputs. And since I want 3 star x plus 4 star y. Okay, I have 3 into x plus 4 into y. Okay, and then I'll pass the values as 4, 7 and I'll hit run. As you all can see, 40 has been returned as the output when I pass the value of x as 4 and the value of y as 7. Now let me take some quadratic equation. So I hope you all know what is a quadratic equation. It's an algebraic equation with the degree 2. Let me just give the heading as quadratic equation. Okay, so now let me just try to solve the very famous a plus b the whole square. A plus b the whole square. So I'll just say part 2, okay? Now let me write a lambda function that's going to return the value of a plus b the whole square. I'll just save it within a new variable x and I'll use the lambda function. And the arguments or the inputs are a and b. The expression that I'm going to use is a plus b. And like we all know, we'll have to use double star when we use powers. And then I'll print this x. I'll pass the values of a and b as 3, 4 and I'll hit run. Okay, so as you all can see, I found the value of a plus b the whole square using the lambda expressions. We love shortcuts in everything, and with Python's built-in functions, it just gets more exciting. And in this session, you'll be learning about three very important built-in functions, namely map, filter, and reduce. So before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards this session, we shall first begin with a small introduction to map, filter, and reduce functions, after which we shall take a deep look at each of these and see how you can actually use these functions along with user-defined as well as Lambda functions. Finally, we shall try to put these functions within each other and see how it works. So I hope everyone's ready to start with this. So let's move on towards the first topic of this session, which will be a small introduction to map, filter, and reduce functions. Okay, so let's move on. The map, filter, and reduce functions are inbuilt functions of Python. These functions enable the functional programming aspect of Python. In functional programming, the arguments passed are the only factors that decide upon the output. These functions can take any other function as a parameter and can be supplied to other functions as parameter as well. The map function takes another function as a parameter along with a sequence of iterables and returns an output after applying the function to each of the iterable that's present in the sequence. The filter function, as the name says, is used to create an output list consisting of values for which the function returns true. The reduce function, on the other hand, applies a given function to the iterables and returns a single value. Okay, so now let's move on and take a deeper look at each of these functions and how you can actually write them in Python. Like I've already mentioned before, the map function will take a function and a sequence as a parameter, and it applies that function to the iterables that are supplied to it. As you all can see on the screen, I have a map function to which I've supplied a lambda function as a parameter and a list of iterables. All I want to do over here is add 3 to each of the iterables that are present in this list. As you all can see, I'll have an output list with 3 added to each iterable that's present in the original list. So now let's move on towards our Jupyter notebook and see how this works. Okay, so I'll just create a heading over here. Okay, so before I begin writing this function, let me just write the syntax first. I'll just write it as a comment. So basically, the map function takes a function and a set of iterables as a parameter. Now these iterables can be either a set, tuple, or anything. Here, the function defines an expression that is in turn applied to the iterables. The map function can take user-defined as well as lambda functions as a parameter. Let us first take a user-defined function as a parameter to the map function. So I'll just create a function over here. So I'll use the keyword def. Okay, so I'll just name my function as new, and I'll pass a parameter as a to this, and I just want to return a star a. Now I'll take a variable as x, and then I'll use the map function. I'll take a variable x, which will be my map object, and then I'll write the map function, to which I'll pass the new function as a parameter and a list of iterables. All I'm going to do after this is print x, just to show you all that this is a map object, and then I'll print the list of x. So as you all can see on the screen, x is basically the map object, and the list of x consists of all values multiplied to itself. So I hope everyone's clear with this. Instead of using the list function, you can also use other functions such as tuple, sets, etc. Let me just show you what happens when I use tuple as the function over here. So as you can see, previously I had an output list, and now I have an output tuple. Similarly, for the input iterables, you can supply anything such as lists, tuples, sets, etc. Okay, now let's try to take a lambda function along with the map function. Map function can take more than one list of parameters as well. Let's see what happens when we try to do that. So I'll just copy this over here, and I'll paste it, and I'll pass another list as a parameter. And I'll make a small change to the function over here. So I'll pass 2 parameters, so I'll say a comma b, and I'll say a star b. Now I'll hit run. Okay, so as you all can see on the screen, these values present in the iterables have been multiplied, and I have a resultant tuple. So I hope everyone's clear till here. If you have any doubts, please do let me know in the chat box, and my team is here to help you. So now let's see how to use lambda functions along with the map function. Lambda functions, as we all know, are functions that do not have any name. They are also known as anonymous or nameless functions. These functions are generally provided as an input to other functions. So now let's move on and see how to use lambda functions along with the map function. Okay, so I'll just take a list over here, say lst, and then I'll pass some random values to it. I'll take a new variable, say y, and then I just want to print the list of, and then I'll use the map function along with the lambda function. Lambda functions are single line functions, so we have to provide the expression along with the function itself. So I'll just say x plus 3, and then I'll pass the parameter as lst, which is my list. And then I'll just print this. Okay, so as you all can see on the screen, 3 has been added to all the elements that are present within this list over here. Now let's get back to our presentation and see how the filter function works. Like I've already mentioned before, the filter function is used to create an output list consisting of values for which the function returns true. So as you all can see on the screen, I have a small example with a condition where I want to print the values which are greater than or equal to 3. Where I want to print the values which are greater than or equal to 3 within this list present over here. So now let's jump onto our Jupyter Notebook and see how the filter function works. I'll just create a new heading over here. The syntax of this function is similar to the map function. So basically it takes a function and a set of iterables as a parameter. Okay, just like the map function, filter function can be used along with user-defined as well as lambda functions. So first, let us take a user-defined function as a parameter to this. So I'll just define a function over here. So I'll say new 1 and I'll pass a parameter, say I. Now, if I is greater than or equal to 3, I want to print the value. Now I'll take another variable j, which is going to be my filter object. And then I'll use the filter function and I'll pass new 1 as the parameter and I'll supply a tuple of random iterables to this. And then I'll just print out what is j. Okay, so as you all can see over here, I just printed j, to which the output says that this is a filter object. Now if I want to return the values that are present within j, I'll just have to use print tuple of j. Okay, as you all can see, all the values that return true for this condition has been returned as the output of this function. So now let's try to use the filter function along with lambda functions. I'll take a new variable, say z, and then I'll use the filter function, to which I'll supply a lambda function as a parameter. So I'll say lambda x, where x is greater than or equal to 3. Sorry, I have to put this within brackets. And then I'll pass the same tuple as a parameter. I'll just copy this. This time I'll print out the list of C. Okay, as you all can see, the output has been returned. Just make a note over here, guys, that last time I wanted my output to be a tuple, and this time I just said print list of C, so I have a list as the output over here. Okay, so I hope everyone's clear till this. Now let's get back to our presentation and take a look at the reduce function. The reduce function, as the name describes, applies a given function to the iterables and returns a single value. So here I have a small example wherein I want to add all the values of these iterables and return one single final value. So in the first iteration, I'll have 1 as x and 2 as y. And then I'm going to add x plus y, which is 1 plus 2, and it gives me 3. After the first step, this output 3 becomes x and this input 3 over here becomes y, and then I get an output as 6. This process will go on till all the values present in the iterables have been reduced to a single value. Now let's jump onto our Jupyter Notebook and see how this works. So I'll just create a heading. Just like before, I'll write the syntax first. So reduce, it takes the function as a parameter and a set of iterables. Now one thing you'll have to note over here is to import the reduce function from the functools module. So all I'm going to do is say from functools import reduce. Sorry, I've just made a spelling mistake over here. Just like filter and map, you can use reduce functions also with user-defined as well as lambda functions. So first, we'll take a user-defined function, say a, to which I'll pass the parameters as x and y. Within this, I'll just say return x plus y. Now I'll just take a new variable, say s, and I'll use the reduce function, to which I'll pass a as the parameter, and I'll pass a list of values. and then I'll just print S. Oh, sorry guys, I've added an extra comma over here, and now I'll hit run. As you all can see, all the values have been added to each other, and I have the output as 49. Now let's try to use the reduce function with lambda functions. I'll use the reduce function directly over here, and then I'll use the lambda function within this. I'll pass parameters and x and y, or this time I'll change the names. I'll say q and p, and then I'll just use q star p. And I'll pass a list of values to this. And then I'll hit run. Okay, so as you all can see, all the values that are present in this list have been multiplied to each other, and I have the corresponding output. Okay, I hope everyone's clear till here. If you have any doubts, please do let me know in the chat box, and my team is here to help you. Now let's get back to our presentation and see how you can use these functions along with each other. So first, we'll be using the filter function within the map function. When I use the filter function along with the map function, it filters out the values that satisfy the condition which is present within the filter function, and it supplies that output list as a parameter to the map function. So as you all can see on the screen, I have a filter function which says I want to filter out the values that are greater than or equal to 3 from the tuple of values that are supplied as a parameter to this. I'll have 3 and 4 as the output of this function, which will be supplied as the input to the map function. Okay, so now let's move on to our Jupyter Notebook and see how this actually works. So I'll just take a variable, say C, and then I'll use the map function, to which I'll supply a lambda function first as a parameter. So I'll say lambda x. I'll just say x plus x. You can specify any expression of your choice, and then I'll use the filter function, to which I'll supply another lambda function as a parameter. And as a condition, I'll just say x greater than or equal to 4. I'll pass a list of values to this, say 2, 3, 4, 5. And then I'll just print the tuple of C. So as you all can see, the first thing that happened was filtering out the values that are greater than or equal to 4 present within this list. After that, 4 and 5, which is the output of the filter function, will be supplied as an input to the map function. And then using the map function, I'll add 4 plus 4 and 5 plus 5, which is 8 and 10 respectively. Okay, now we've used the filter function within the map function. So now let's move on and see how you can actually use the map function within the filter function. So when we use the map function within the filter function, the set of iterables that are supplied as an input will be operated upon first by the map function, and the output of this map function will be supplied as the input list to this filter function. So now let's get back to our Jupyter Notebook and see how this works. So I'll just take a new variable, say D, and then I'll use the filter function. I'll use the same condition again. So I'll just copy this. And then I'll use the map function within the filter function, and I'll use lambda within this map function. So I'll just say x plus x, and I'll pass a list of values. Then I'll just print the tuple of D, or this time I'll just say set of D. So as you all can see on the screen, I have an output set, which is a resultant of applying map function to the given set of iterables, and then applying this condition within the filter function to the output of the map function. So now let's move on towards the final topic of this session, wherein we'll be using map and filter within the reduce function. Okay, so as you all can see on the screen, I have a small example wherein I have a reduce function to which I've supplied map and filter as the input functions. Now, the innermost function is the filter function, which says I want all the values that are greater than or equal to 3 from the list of iterables that are supplied to it. So as an output of the filter function, I'll have 3 and 4. To this output list of the filter function, the map function produces a new list of iterables, which is 6 and 8, which are obtained after adding each of these values to itself. And finally, 6 and 8 will be supplied to the reduce function as a parameter. So now let's get back to our Jupyter Notebook and do the same. So I'll just say map and filter within reduce. Okay, so I'll just take a new variable, say r, and then I'll use the reduce function, to which I'm going to supply a lambda function as a parameter. So I'll just say lambda x comma y, and then I'll just say x plus y. Now I'll take the map function, to which I'll supply another lambda function as a parameter, and then I'll just say x plus x. After this, I'll be using the filter function, and again I'll use a lambda function within this filter function. I'll say x. I want to return all the values that are less than or equal to 4. To this, I'll pass a list of iterables, say 1, 2, 3, 4, 5, 6, 7. And then I'll just print out r. Oh, sorry guys, I've made a smaller mistake over here. Okay, so now let me hit run. Okay, as you all can see on the screen, first, my filter function will filter out all the values that are less than or equal to 4. The output of this is supplied to the map function, and all the values are added to each other. Finally, the output list of the map function will be supplied as an input to the reduce function, and all the integers will be added to each other, and I'll have one output, which is 20. Generating iterables is considered to be a painful task, but with generators in Python, this task becomes very simple. Before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards this session, we shall first begin with understanding what are generators and their advantages. Then we shall be differentiating between normal functions and the generator functions, following which I'll be showing you all how to create generators in Python. Then we shall take a look at generator expressions, and finally a few use cases, which will be generating the Fibonacci series, generating a stream of numbers, and generating the sine wave using Seaborn along with generators in Python. So let's move on towards the first topic, which is what are generators? Generators are basically functions that return traversable objects or items. These functions do not produce all the items at once. Rather, they produce one at a time and only when required. Also, whenever a for statement is included to iterate over a set of items, a generator function is run. Generators have a number of advantages as well. Without generators in Python, producing iterables is extremely difficult and lengthy. Generators make our task very simple. This is because they implement the iter, next, and stop iteration methods automatically. Generators also help save memory, as the items are produced only when required, unlike normal Python functions. This fact becomes very important when you need to create a huge number of iterators. This is also considered as the biggest advantage of generators. Along with this, generators can be used to produce infinite number of items and to pipeline a number of operations. So I hope everyone's understood what are generators and their advantages. Okay, so now let's move on to see the difference between normal functions and generators. Generators in Python are created just like how you create normal functions using the def keyword. But generator functions make use of the yield keyword instead of return. This is done to notify the interpreter that this is an iterator. Not just this, generator functions are run when the next function is called and not by the name as in case of the normal functions. And like I've already mentioned before, generator functions produce items one at a time and only when required, whereas the normal functions produce all the items in a single go. Now that you have a brief idea about generator functions, let's move on to see how to write generators in Python. So as you can see on the screen, I have a small example wherein I've defined the function and then I've used the yield keyword instead of return. So now let me jump onto my Jupyter notebook and show you all how to write generators in Python. I've already opened a new notebook over here. I'll just rename the notebook as generators in Python. And then, like I've already told you all before, I'll have to use the def keyword to define a generator function. So I'll just name the function as new, and I'll pass the parameter as a dictionary. After this, I'll use the for statement, and I'll use for x comma y in my dictionary, and I want the items as well. Yield x comma y. Okay, after this, I'll have to specify a dictionary. So I'll say A, is my dictionary, and I'll specify 1 as hi and 2 as welcome. You can give any values of your choice. Now after this, I'll have to create a generator object for my function. So I'll name that object as B, and I'll specify B is equal to new of A. Just to show you all what is B, I'll print B. And like I've already told you all before, instead of the name of the function, you'll have to use the next keyword to return values from generators. So I'll say next of B, and I'll hit run. So as you can see over here, the first output over here specifies that B is a generator object, and the second output is generated by this next function. Now let me just copy this function again, and I'll paste it over here, and I'll hit run. So as you can see over here, the first time I used the next function, it returned the first key value pair of my dictionary. And when I used it again, it has returned the second key value pair of my dictionary. If I try to use the next method again, it says that stop iteration has been called. Okay, now let me take another example wherein I'll specify some condition. I want to return iterables that satisfy that particular condition. Okay, so here I'll just define another function. So I'll say define my func, and I'll pass the parameter as A, or I'll use some other name. Since I've used A last time, I'll use I. Now, while the value of I is less than or equal to 3, yield I. Sorry, I've made a spelling mistake over here. It's Y-I-E-L-D. Okay, so yield I. Now for this, I'll have to create a generator object again. I'll say the generator object is J, which is equal to the name of my function. And I'll have to specify a value for I. So I'll just specify the value as 2. After this, I'll just print next of J. Since you all know that J is the generator object, I'm not going to print it again. Okay, so as you can see over here, the first time I use next of J, it has returned 2 as the value. Now I'll just copy this, and I'll rerun it. Sorry guys, I've forgotten to increment the value of I. Please keep in mind that when you're using while loops, you'll have to increment the value of the variable that you're using as an iterator. So now let me hit run. So as you can see over here, without incrementing the value of I, when I use the next method, it has returned 2. Now that I've incremented the value of I, I'll hit next of J again. And as you can see over here, I've got 3 as my output. Now if I use next of J again, it has called the stop iteration method. So I hope everyone's clear with this. Now let me take another example wherein I'll have 2 parts in my function. So I'll just define a new function. I'll name the function as EX. And within this, I'll just specify some variable n equal to 3. And then I'll yield the value of this. After this, I'll make some changes to the value of n. I'll say n is equal to n star n. And then I'll yield n again. I'll have to create a generator object. So I'll just say v is equal to. And then I'll use the next method. So as you can see over here, when I use next of v, it has returned only the first value of my function. Now in case I use the next function again, it will return the second value which is present in my function. And after this, if I do it again, it has to call stop iteration. In case you want to execute the same function at once, you can make use of the for loop. This loop helps iterate over the objects, and after all implementations, it executes stop iteration. Let me just jump onto my Jupyter notebook and show you all how to do this. Okay, so I'll use the same function which I've used previously. And after this, I'll use the for loop. So for x in v, print x. So as you can see over here, after using the for loop, I have both the values that are returned one after the other. The for loop has not returned them simultaneously, but using the for loop, I'm getting into the function, printing the first value first, and after that, I'm printing the second value. So I hope everyone's clear till here. In case you have any doubts, please do let me know in the chat box, and my team is here to help you. Now let's move on and see how to use generator expressions. Generator expressions can be used along with for loops to produce iterators. This usually makes the generation of iterables much easier. Generator expressions resemble list comprehensions, and like lambda functions, generator expressions create anonymous generator functions. Let me just jump onto my Jupyter notebook and explain this in detail. I'll use some variable f, and I'll specify the values of this to be in the range of 6. After this, I'll just print list comprehension, and I'll end this with a colon. I'll use another variable q, wherein I'm going to store the values of list comprehensions. So to specify the list comprehension, I'll be using the square brackets. So I'll say x plus 2 for x in f, and then I'll print q. After this, I'll just copy these two lines and create a generator expression. So I'll just change the name over here. I'll say generator expression, and make a note, you'll have to change the braces to regular braces, and then I'll print q again. I'll change the name to r, and then I'll print r. As you can see over here, when I used list comprehension, it has returned a list of values corresponding to the values of f. And when I used a generator expression, and after that when I said print r, it has just returned that r is a generator object. To print the values using the generator expressions, I'll be using the for loop. So for x in r, print x. So as you can see over here, using the for loop, I've generated the values one after the other, whereas using the list comprehension, all the values were generated at once. Generator functions like lambda functions can be used within other functions as well. So in case you want to find the minimum value of r, I'll just copy this and I'll paste it over here. And then I'll say print minimum of r. So as you can see over here, it has returned the minimum value which is present in r, and that is 2. So I hope everyone's clear till here. Okay, so now let's move on and look at the use cases that we'll be discussing in this session today. Like I mentioned before, I'll be taking 3 use case examples, which is generating the Fibonacci series, generating a number stream, and generating the sine wave using generators in Python. Okay, so let's move on towards the first one, which is the Fibonacci series. Fibonacci series, as we all know, is a series of numbers wherein each number is the sum of preceding 2 numbers. The first 2 numbers of this series are assumed to be as 0 and 1. So for example, as you can see on the screen, I have values 0, 1, 1, 3, etc. Okay, so now let's get back to our Jupyter notebook and see how you can use generator functions to produce Fibonacci numbers. Okay, so I'll just give a heading over here, guys. I'll just give the heading as fib. Okay, and I'll define a function. I'll name the function as fib. And within this, I'll just specify the first variable and the second variable as 0 and 1. After this, while true, I want to yield the value of f, which is the first number of my series. After this, I'll have to increment the values. The second number becomes the first number, and the third number is the sum of the first and second number. So I'll just use f comma s will become s and f plus s. In case you have any doubts, please do let me know in the chat box, guys. Okay, so after this, I'll use the for loop. So for x in fib, now I'll specify some condition over here so that the iterators that I'm producing satisfy some limit. So I'll just use if the value of x is greater than 50, then I want it to stop. So I'll say break. After this, I'll just print x, and I'll end this with a space. Now let me hit run. So as you can see over here, I have all the values of the Fibonacci series that are less than 50. So I hope everyone's clear with this. Okay, so now let's move on and see how you can generate a stream of numbers. The stream of numbers can be anything from 0 to any number, or even numbers or odd numbers. Okay, so let me jump onto my Jupyter Notebook and see how you can actually generate a stream of numbers. So I'll just create a new heading over here. I'll name it as number stream and I'll hit run. Okay, I'll just take a variable a and I'll specify the range of this to be 100. After this, I'll use a generator expression. So I'll say b is equal to x for x in a. I want to print all the values of a within the range of 100. So after this, I'll just print b. And I'll have to use the for loop. So for y in b, print y. So as you can see over here, I have all the 100 values of a. Now, in case you want to generate only odd or even values, you just have to make a change to the range function. So I'll just copy this and I'll paste it over here. And to print even numbers, I'll just say start from 2, go on till 100, and in the range of 2. So as you can see over here, I've generated a stream of even numbers. In case you want to generate odd numbers, all you have to do is change the values over here. I'll just say 1. So as you can see over here, by just changing the first value from 2 to 1, I've generated a stream of odd numbers. So what this range function actually does is, it starts from 1, it will go on till 100, excluding 100 in the intervals of 2. So I hope everyone's understood this. Okay, now let's move on towards our third use case example, which is generating the sine wave using Seaborn and generators in Python. So as you can see on the screen, using the normal function, my sine wave is going to produce all the waves at once. But using the generator function, I can produce one wave at a time. Okay, I'll just move on to my Jupyter Notebook. I've already written a function for that, so I'll just paste it over here and I hit run. It's going to take a few minutes since I've imported the NumPy, Matplotlib and the Seaborn library. As you can see over here, using the normal function, I've generated all the sine waves at once. Now let me show you what happens when I use the generator function. Since I already have my function, I'll just copy paste it over here. And then I'll hit run. So as you can see over here, I've produced just one wave among all the waves that are present in my output. Now, if I want to print another wave, I'll just copy this next function again. So I'll say Control C and I'll copy it and I'll hit run. So as you can see over here, when I use the print statement with the next function again, it has returned another sine wave. Okay, so I hope you're clear with this. Let me just print the sine wave again. As you can see on the screen, the third sine wave has been returned. And then when I print it again, it will return the fourth sine wave.
OOPS, which basically stands for Object-Oriented Programming System, or Object-Oriented Programming as it's most popularly known, is one of the most popular programming paradigm. Now, although Python is not completely an object-oriented programming language, but still it uses major concepts of object-oriented programming style as part of this. Now, in this session, what we'll majorly be talking about are classes and objects, classes in Python, and object-oriented concepts in Python as well. Now, let's first start about classes and objects. Now, to those of you who are not familiar with the different programming paradigm, two of the most programming paradigm is object-oriented programming and procedure-oriented programming. Now, when you look at older programming languages like C, or you can see Visual Basic as well, these followed procedural-oriented programming language style, wherein what used to happen was that the entire program was divided into smaller parts known as functions, and the importance was not given to the data but the sequence of actions which were performed. Also, what used to happen there was that the entire process took a top-down approach as such. But what happened is, when newer programming languages came up, they realized the value of the data and they came up with the opportunity of creating something known as objects. Now, objects are quite similar to what you can relate to in real-world entity as well. Now, anything that we see around, anything that has different properties can be called as an object. And here how it differs from the older style, that is the procedure oriented programming style, is that it goes from a bottom up approach, as well as there's more data security as well, and you can use various operations like data accessing, data overloading, data expansion, and so forth. Now, some of the examples of object-oriented programming languages is C#, Java, Visual Basic.NET, and so forth. Now, let's first address the question of what exactly is a class and object. Now, to help you understand this better, let's actually look at an example here. Now, to give you a simple one-line definition, a class basically is a logical grouping which helps us reuse and rebuild our data as part of the code. Now, to put it quite simply, it basically is similar to a template or a blueprint that we use. Once I have defined a specific requirement of mine, then what I can do is that I can go on variating with respect to that. Now, let's look at the example here. Now, if you look here, I have created a class called employees, wherein I have defined some of the most common parameter each of my employees will be having. There would be his name, there would be their age, and there would be their salary. Now, I have defined a blueprint, but there comes a time where I need to implement this. So an instance, which is basically a entity of the class, is referred to as an object here. Now, if you look here, there are basically three different objects. I have object 1, which is referring to Sarah, whose age is 37, as well as salary is 10,000. My object 2 is John, whose age is 43 and salary is 21,000. Similarly is Jessica as well, whose age is 26 and the salary is 24,000. Now, how does Python implement classes? Now, again, to go back to the definition, a class basically is a blueprint for which objects are created. Now, coming to the basic syntax for how to write a class in Python, it's quite easy because you just need to define the keyword class, following which you need to specify the name of the class. Now, let's go, if you take the previous example, the name of that class would be employees, and each of the objects would be created from that same class. Now, what I'm going to be writing inside the class would be three major aspects. I would have my class variables, I would have instance variables, and I would have data members. Okay, now these are the three major aspects to any class as such. Now, if I need a variable which is going to be shared by all the instances of the class. Now, do not get confused when I say instance. It basically is referring to a object itself. So here we refer to an object as instance. Now, if I want each of the instance to share a common variable, then I would make it a class variable. But let's say I want each of the instances to have a specific variable. Okay, then I would be using an instance variable as such. Then comes the third part, which basically is your data member. This basically is a class variable or an instance variable as such that actually holds the data associated with respect to the class and objects. Now, without confusing you any further, let me actually switch to my PyCharm, okay, and let me show you this by defining a class here itself. So let's start by creating a simple class here. Now, let me use the first keyword for defining any class, that is class. Then comes name of the class. Now, for today's example, what I'll do is I'll create a class called cars. Okay, so I've created a class called cars. Okay, can you guys see this? Okay, and here what I'm going to do is that right now I'm not going to write anything. So I'm just going to use the keyword pass. Then comes the time for me to create objects for this class. So what I'll do is let me call an object, let's take Honda for it. Okay, so this is the name of my object, and then I'm going to specify to which class it belongs to. So it belongs to the class car, and this is how you create an object in Python. Quite easy, right? Similarly, let me create another one. Let me call it Tata. Okay, Tata is also going to be of car. Okay, so basically what I've done here is that I've created two objects that belong to a specific class. Now, now comes the time when you actually assign values to these instances or objects as such. Now let's say I want to add the name or the model number for the Honda car. So I'm going to say Honda, which is my object, following which use a dot operator and then specify what instance variable you want to use. Now let's say I want to specify model name. Okay, model name is equal to, I'd say, city, because I like Honda City. Okay, now I'll also add another variable which is year of manufacture. So I'll say year M, okay, and this basically is going to be equal to, let's say, 2017. Now I'll also add price. Okay, I'd say about 10 lakhs. Does that sound fine? Now let me just copy the same and let me create an object for Tata car as well. Now here let me just change it to Tata. And let's say this is bold. Okay, so let's keep the year the same, or let me reduce it to 2016, and let's say the price is, let me reduce it, I'll make it 6. Okay, does that sound fine? Now what I have done here is that I've created instances of the class or objects to that class, and each of these instances themselves have a specific variable assigned to them as well. So in this case, what you see here is the model name, what you see is the year, and what you see is the price. So these are basically variables associated to each of these instances as well. Now if I say just print and I say Honda dot model name. Okay, let me take the price itself. Let's try running this. Okay, it's with respect to the definition of the class. Now if we go back to our slides here, can you see there's a small semicolon here that we have missed out? So this is how it is. A single semicolon can make a lot of difference. Okay, now let's just save this, let's run it. Okay, I can see the price of my Honda car here. Now this is a lot of pain for me when I'm working with multiple instances which have unique variables to them. But let's say if I have common values that needs to be created for all of these. If I was using other programming languages, we had a concept known as constructors. But don't worry, that same is present here as well with Python. So to create a constructor, use the following command, which is def, which is basically defining a function, and use init. Now init is basically a constructor here, and what it is representing is that it is going to initialize the value of the variables. Now if you notice here, there's a keyword that is already added here, that is self. Self basically is a reference to the object which is going to be calling this function. Now those of you who are not familiar with functions can check out our video on Python tutorials where we have talked about functions, and also check out our Python function video as well. Okay, now what happens is, to this let me pass a model name. I'll also pass the year manufacture, and let's say the price as well. Okay, now I need to assign the values for these variables for all the object. Now if I need to do that, then what I need to do is that I need to first reference the object. So that's self dot model name equal to the model name that it's getting. So then self dot year of manufacturing, and finally self dot price. Okay, now what I'm basically doing is that for my constructor, I would be passing these three parameters. So for the object or the instance which is going to be created, please add these values for that. Okay, now let me show you how to change this as well. Now I don't need this, so I'll remove all this. Okay, so here what I'll do is I'll pass Honda, I'll pass city. Okay, I'll also pass the year of manufacturing is 2017, and let me pass the price again. Same for Tata. So what I've basically done is that I have generalized the requirement that I want. Now again, if I run the same, what you can see here is I'm getting the same output that I had gotten earlier as well. So this basically is a constructor that is going to be used when I have to assign specific values to my objects or instances at the time that they are creating. Apart from this, if you want to create or you want to add any specific value, you're free to do that. Now let's say I want to add a new value. Let's say I want to create Honda dot, let's say I want to add the CC as well, the CC of Honda City, which is equal to 1500. Okay, so this is also very simple. Now what happens here is that I've created an instance variable for the Honda object. Okay, now same thing, let me just say, if I want to see the complete values that are associated to an object, then what do I do is that I check the namespace for it. Now how do I check the namespace for it is that I use the dictionary option. Sorry, I use the dictionary function. Okay, so if I use dict function and if I run this, then what you see here is that I have a model name which is city, I have a year of manufacturing 2017, I have a price, and I have the CC associated to it as well. Okay, now what basically it tells me is if I use this object and request any of these values, then this is the output that I would be getting. Same if I change for Tata and I run this, then what you see here is that CC is not present. So I hope you understand the difference between both. Can I have a quick confirmation in the chat box? Okay, that's great. Good to see that all of you are following it. Now, if I have a class, then if I don't perform any operations in it, then I'm basically not optimizing or using the complete capability of that class as well. Now, what I'll be doing is that I'll be creating a function here. So this function, what it basically does is that it's going to increase the price of my car. So what I'm going to do is that for defining any function, use the keyword def, okay, following which the name of the function. So let's say price underscore increase. Okay, now this is a function, but it's going to be performing on itself as well. So use self here. Okay, and I'm going to start defining this function. What do I need to do is that I basically just need to update the value of price. Okay, so what I'm going to do is that I'm going to use self dot price equal to, then I'm going to do a simple computation. Let's say the present self dot price, sorry about the typo, into, okay, how much do you think the annual price range would be? Let's take a guess. Let's maybe a 15% rise. In that case, I'll go with 1.15. Okay, now I have defined a function here, but what you need to understand is that it's not exactly in the scope of the class. So oh, sorry about that. Now, how do you identify if it's in scope or not? It's basically one of the eases with respect to PyCharm. If I expand it, then I know what is part of the class and what is not. So this is one of the major reasons that we recommend you use PyCharm as an IDE as such. Okay, now I need to increase the price. So what I'll do is, let me go back. Let's say I want to check the price of the Honda first. Okay, then what I'm going to do is that I'm going to call the function with respect to the class. Now it's defined to that class. So what I'll do is that I'll send this function. I'll use the Honda object to call that function. Now to use any of the functions associated to a class, make sure you're using the instance or object of that class. So Honda dot. Now you can already see here the different suggestions that comes to it. Now price increase is the function that I want. Okay, and again let me copy this and paste it. Okay, so again see, the major issue here is it's considering this. So if you just double indent it, it's going to set back. Okay, just save this and let me rerun this. Okay, now it's giving me the output. So it's converting it. Let me just add int here just to convert it to integer type. Okay, so the output should be converted to integer type for me. So it's incremented the value to 1.15 times. Okay, so these are basic function operations that you can perform with respect to Python. Now let me go back to my presentation, and here let's talk about the various object-oriented concepts in Python. Now in this session, what we'll be talking about are the three major concepts, which is inheritance, encapsulation, and abstraction. Now when we come down to inheritance, inheritance basically is the ability or the opportunity for any class to inherit the attributes and behaviors from the parent class. Now when I talk about a parent class, it refers to a superclass as such. Okay, so let's take cars itself for an example, but before that let's look at the example here. Now your parent becomes a base class and son becomes the derived class as such. This is same that we'll be implementing in our program as well. So in our PyCharm, what I'll do is that I'm going to create a new class, and let me call it supercar. But if it has to inherit the properties that are present in the car class, then what I need to do is that I need to specify car here. Okay, that means it becomes the parent for the supercars. Okay, so here I'm not going to define anything. I'm just going to say pass, and let me remove this from here and let me add it here. Okay, now rather than making Honda as an instance of car class, let me make it of the supercar class. Okay, now I have not defined an init operation, or nor have I initiated the values for these variables as well. Okay, so what I'm going to do is that let me just try running this. Okay, let me remove this. Okay, and let me just print the namespace for Honda, which is Honda dot wait, before that let me just show you, let me just print one of the values itself first before I show you the namespace completely. Let's say Honda dot year. Okay, so year of manufacturing is defined here. I have not explicitly defined in the child class, but let me make sure. Let me just run this and let's see the output. Okay, so here basically it's just passing it. Spelling mistake. Let's rerun this. Now here what is happening is that it is referencing to its parent. Okay, now to get a better understanding of what exactly is happening here, okay, we're going to use something interesting. What we're basically going to do is that we're going to use the help function. Print help, and here what I'm going to do is that I'm going to pass Honda. Let me just comment this. Now this is something that I really want to show you guys. Okay, now if you see here, what is happening is that it's showing me the method resolution order. So basically it's showing me how it is going to follow the sequence of operations. First it is going to check in supercar for init method, but I have not defined it here. So what it's going to do is that it's going to refer the car class. If it is not defined there as well, then it will go back to the parent class for all objects, which is built-in dot objects. This is the parent class that is going to be inherited by all the classes used in this language as such. So it's found the init method present in cars, okay, and it's shown methods inherited from class is the init method, and it has initialized itself. Okay, now this is basically the sequence of operations that happen as well. Now when I define any function with respect to the child class, it's going to check the child class. If it is not present, then it's going to check the parent class as such. Now it can be anything as such. It can also be the price increase as well. And okay, okay, let me just comment this section out. So here again it has inherited this method as well. Now let's say if you do want to define an init method as part of the class, then what you basically do is that you follow the same sequence. You write define, okay, following which you use init, then you specify the parameters it has to take, okay, and then what you basically do is that you shouldn't actually copy this entire code and replace it here. What you can do is that you can use the keyword super dot init. Okay, so what I'm referring to is that it should call the init function present in the super class. Okay, in that case what I'm going to do is that I need to pass the parameters here as well. So I'm going to pass the model name, I'm going to pass the year of manufacturing, as well as I'm going to pass the price as well. Now this is basically to reduce the code that you're going to be writing as such. Now apart from this, let's say there are a few other variables that you're going to be taking. Let's say I'm going to include CC as part of my superclass. Then what I can do is that I can write here self dot cc is equal to cc. So I'm basically building on what is already present, and this is one of the major aspects that you can use inheritance for. This in turn reduces a lot of code dependency as well, and is one of the most popular and major factor for any programming language that uses object-oriented programming systems. Okay, now coming back to the next concept that is associated to Python, okay, you have encapsulation. Now encapsulation basically is the method through which you bind your data and your code together. Now it also helps you in hiding your data from people whom you don't want to don't want to give visibility to. So this is one of the major key factors for any programming language as such. Now there are two major ways through which you can access or achieve encapsulation. One is by using the getter and setter method, and the next is by using at project. Okay, now we'll be talking more about that in our next session, but let me give you a simple understanding. What happens is that you want to change a specific value as on when in the Go itself. Let's say my year of development or my model year just keeps changing continuously. In that case, what I need to should do is that I need to update these values on regular interval. But let's say if there's a specific dependency on these variables ahead as well, then it becomes an issue. Same can be said with respect to price. Now price is going to be increased continuously. Through getter setter method, I can ensure that this is going to be implemented every time there's going to be a change as well. Apart from that, one of the major concepts with respect to object-oriented programming is abstraction. Now, with respect to abstraction, what basically it means is that it hides the implementation details and only provides the functionalities to the user. Now, if you look at the image here, now a mechanical engineer or an automobile engineer who works with your car is aware of the inside and out of your car as well. Now, if I need to drive a car, I don't need to know that. I just need to know how to turn on my car, how to change the gears, and how to move forward as well. So that is what abstraction helps me achieve. I don't need to understand what exactly happens when a gear shifts from second to third, but I just need to know that a gear shift from second to third is going to make it easier for me to move ahead as well. Okay, so this can be achieved by using abstract classes, and an abstract class is quite similar to an actual class itself. But how is it different from an actual class is that an abstract class cannot have an object of itself. You need to inherit the abstract class and you need to create an object of that abstract class as well. Now let me go back to the same example. Let's change it here. Okay, now what I'll do is that I'm going to add a few additional lines of code. Okay, let me just copy the here. Let's say I'm going to say from ABC and create abstract method. Okay, now what I'm going to say is that my car class ABC is also inheriting this abstract. Now I'm going to remove all this, and okay, here I'm going to make this an abstract method wherein I'm not going to define the logic here. Okay, for now what I'll just do is that I'll call it okay. And in my superclass, what I'll do is that I'm going to create the same function but here I'm not going to define any logic. Okay, so what I'm basically doing is that in my abstract class, I'm defining the method to increase the price, but based on my requirement. Now, let's say I don't want my supercars to have an increase of just 1.15. So what I'm going to do is that I'm going to increase this. Let's say the annual increase is going to be 2%. So this is one of the major uses through which I can perform or I can use abstract classes. I can just define the basic logic which is needed to be implemented in all the classes going ahead, and then what I can do is that I can implement or variate these functions as per my requirement. Okay, now with this, let me go back to our slide and let me just summarize. So we started with classes and objects. We talked about classes in Python, and then we talked about the various object-oriented programming concepts in Python.
Let's talk about the init function in Python. So what exactly is an init function? Init function automatically gets called each time an object is created for a class. Now when we add an init function to a parent class, a child class will not be able to access the parent class method. So to overcome this, the child class init function overrides the parent class init function. So now let's take a look at an example to understand this. Now to show how init function works, let me first clear this. We'll write a init function over here. Yes. And instead of self, I will add one more variable, let's say fname and fage. Now what I'll do is I'll just write self dot name is equal to fname and self dot age is equal to fage. Now I'll take one more function, guys. So I'll just name it as, let's say, view. And for view, I want to print the value of fname, self dot name and self dot age. So this is my parent function, guys. And for the definition in the child class, I will also make one init function. So I'll just write it as init self. And again, I have to add fname and fage. And let's say self dot name is equal to fname and self dot age is equal to fage. Now this init function is going to override the parent init function, guys. So let's make one more function. So this is going to be view as well. And in this, let's say I want to print. Okay, before we move on, we have to specify the parent function with the init function as well. And we don't have to mention these variables. Instead, I'm going to add one more. Let's say I want to add last name as well. And I'm going to add it as, let's say, Edureka. Now I'm going to print over here self dot age, self dot last name and self dot, let's say, name. All right, I have to remove these. Let's make one more object and give it the value. Let's say I want the age to be 23 and last name is going to be Python in the inverted commas. Name we have already specified, so we don't have to give it again. And I'm going to just call the function. Let's see what happens, what is the output will be. So as you can see, I'm getting the output as Python, Edureka and 23. So this is how you can override the parent class init method using the child class, guys. So this is all about the init function. Now let's talk about the next topic that we have, which is the types of inheritance. So depending upon how many types of parent class and child class are going to be there inside the program, following are the types of inheritance in Python, guys. So there is single inheritance, there is multiple inheritance, then there is multi-level inheritance, hierarchical inheritance, and there is hybrid inheritance as well. So we are going to talk about each of them in detail, guys. So first of all, let's talk about what is single inheritance. So when the inheritance involves one child class and one parent class only, it's going to be a single inheritance. The example that I showed you before is the example of single inheritance, guys. And talking about multiple inheritance, it is going to involve more than one parent class, which means we are going to have at least two parent classes and the child class is going to derive properties from both of them. And this is called multiple inheritance. Now talking about multi-level inheritance, let's say we have a single inheritance going on. We have a parent class and we have a child class. But the child class also act as a parent class for another child class. That is going to be a multi-level inheritance, guys. And talking about hierarchical inheritance actually involves multiple inheritance from the same parent class. And talking about hybrid inheritance, if a program has more than one types of inheritance, let's say we have a single and multiple inheritance going on simultaneously, it's going to be a hybrid inheritance, guys. So let's take a look at examples for each of them. So let's go to PyCharm, guys, and I'll remove all this. So I'll start with single inheritance, guys. So I'll just take a parent class and give it a function. Let's say function1 and give it a statement. Let's say this is function1. Now let's take another class, guys, class child, and give it the value of the parent class. And after that we can move for another function, let's say function number 2, and give it a statement. Let's say print this is function 2. Now make a child class object and call the function. So we can call both of these functions. So I'll just call function1 give it the output, and we are getting the output as this is function1. So this is a basic example of single inheritance, guys. Now talking about multiple inheritance, what I'm going to do is I'm going to make one more class over here. Let's say class parent2. Now what happens is, let's say give it a function number 3, let's say, and print statement, this is function 3. And in the declaration over here, I'm going to just specify two classes, and when I call the functions, I can call function number 1 and I can call function number 3 as well, guys. So let's see what is happening here in the output. I'm able to call the function number 1 and function number 3 as well from the child class object. So this is the example of multiple inheritance, guys. Now talking about multi-level inheritance, so what I'm going to do is I'm just going to specify parent over here, and from this, let's say it doesn't have any declaration of parent1, which is this class, so it is not able to inherit any properties from that. But what I'm going to do is I'll just specify parent2 over here, and I can still call these functions because there is an inheritance going on between them, which is multi-level inheritance, which basically means this class, the parent1 class, is actually giving properties to parent2 class, and parent2 class is giving properties to the child class. So this is example of multi-level inheritance, guys. Now talking about hierarchical inheritance, guys, what I'm going to do is instead of parent2 over here, I'll just specify parent. So for these two child classes, I have the same parent class. And now let's see if I can have the same output or not. I'm not going to get the properties from the parent2 because I have not specified it in the inheritance. So I'll just remove this and let's see what happens. I'm getting the output as this is function 1. Okay, let's make the object for parent2 as well. Alright, give it 1 and ob1 dot. Let's say what functions we can have. I can have the function number 3 and I can have the function number 1 as well. So I'll just print function number 1, and from both the child classes I'm able to print the function number 1. So this is the example of hierarchical inheritance, guys. I'm using the same parent class to give the properties to both parent2 and child class as well. And now talking about hybrid inheritance. Hybrid inheritance actually involves more than one inheritance going on in the single program. So we have a single inheritance over here. So let's say I want to have multiple inheritance as well. So I'll just specify parent2 now. And this is the example of hybrid inheritance, guys, because we have a single inheritance going on over here. And in the child class, I'm inheriting both the parent1 and parent2. And this is the example of multiple inheritance. So this is a hybrid inheritance example, guys. Okay, we are getting a type error which is saying cannot create a consistent method resolution order for base parents, parent1 and parent2. Okay, let's say instead of this, I'll make one more class over here. Give it a value, let's say parent number 3. Give it a function, let's say 4, and print statement. This is function 4. Now instead of parent number 2, what I'm going to do is I'll just take parent number 3, guys, and with the child class operator, let's see if I can actually get the function number 1, and let's say I want function 4 as well. I'm able to do that. So in the output, let's say what I get, I'm getting the function 1 and function 4. So this is a simple example of hybrid inheritance, guys. Now that we are done with the type of inheritances, let's take a look at what all we have now. So we're going to talk about the super function, guys. Super function actually calls the parent class method directly. So let's take a look at a simple example, guys, how it works. So I'll just remove all this. Now what I'll do is I'll make a, let's say, parent class and give it a function 1. Again, the print statement. Now what I can do is instead of calling the parent function from the object, I can just use the super function, and over here I can just call the function 1. Now I'll just print this is function 2. Let's make a child class object. Now let me see if I can call the function 2 or function 1. I can do that. So I'm going to call the function 2, guys. Let's see what the output will be. So I'm actually able to call the function 1 directly from the super function over here. So this is the function of super function, guys. It can directly call the parent method. And now that we are done with the super function, let's take a look at the next topic that we have, which is method overriding in Python. So method hiding can also be achieved to change the functionality of the parent class function. So let's take a look at an example to understand how we can actually achieve method overriding in Python, guys. So instead of naming them separately, I'll just name them as same. So when I create the child class constructor, and if I call the function now, okay, function 1, which is, so when I'm calling this function, technically it should call the parent function, but what happens is it overrides the parent method. Okay, to specify this, run it again. Now I'm getting the output as this is function 2, even though I'm calling this function 1, which should be ideally calling the parent function, but it is printing out the function which I have specified in the child class. So this is how I have overridden this parent class method, and this is how we can perform method overriding in Python, guys.
In this session, let me walk you through on how you can learn and make use of exceptions in Python. Guys, this session is intended to be useful for anyone considering to kickstart their learning about Python and need some insight on how you can go about making use of exceptions to make coding very easy for you. So the focus is basically on approaching the language in the easiest way possible and to find out what it has to offer to the community and all of the learning enthusiasts out here. So let's begin by checking out the agenda for the session. We'll start by checking out why we need exception handling first. Later, we'll check out what an exception actually means. Followed by that, we'll be walking through the entire process of how we can handle an exception. And lastly, we'll look at how easy it is to code with Python, where we'll take a programming approach and learn the concepts through code. Now that we're done with the agenda, without further ado, let's begin by checking out why we need exception handling. Well, to understand the concept, let me quickly walk you through a very simple scenario. Consider the case where you're dividing any number by 0. What will happen? Can you divide a number by 0? You cannot, correct? But how would a kid approach this problem? The kid would think that you can actually use regular division to divide something by 0. So you're dividing something by nothing, so it stays the same. Something like this, right? Little does the kid know that this is wrong. Now check out how a programmer would approach the same concept. Well, it is established that dividing by 0 is not possible mathematically. So as programmers, we know it is not correct. So this basically leads to two cases, either an exception or an error. So a Python program terminates as soon as it encounters an error. Well, in Python, an error can be either a syntax error or an exception. And it is as simple as that. Well, let us actually divide by 0 for fun, guys. So this is what happens in Python. Python presents us with this beautiful error message saying that it cannot divide something by 0. Well, in fact, let us head to PyCharm, which is my IDE for coding in Python, so we can actually walk through this practically. So guys, here I am in my PyCharm. So let me quickly go ahead and type out some simple code for you guys. So let us start with y equal to 10. We can actually print y by 0 now. So let me quickly go ahead and run this in the console. So as you can check out, it says 0 division error, division by 0 is not possible. So you cannot divide anything by 0. So let's establish that at this point, guys. That was good enough, right? So let's get started then. Let us quickly check out what exception handling actually is. Well guys, to get a clear picture of what that is, we need to start with understanding the definition for both exception and exception handling. Well, what is an exception? Guys, an exception is an event which occurs normally during the execution of a program that disrupts the normal flow of the program's instruction. So instead of the program actually executing evenly and nicely, there is actually a disruption in between the code. So this we basically call as an exception. So next, what is exception handling? Guys, this is the process of actually responding to an occurrence of an exception. As simple as that. So basically the process of responding to the occurrence during compilation of exceptional statements which require special processing is actually what is exception handling, guys. So this is basically done because of the change in the normal flow of the program execution. Well, it is a very simple concept and I'm sure at the end of this session you guys will agree. Well, at this point, what do you think of exception handling in Python, guys? Head to the comment section and let me know what you think so we can interact there. And now that we know what exception handling is, we need to understand how the entire process of exception handling works. So let us check it out. First, let us walk through what happens in Python. So let us say the user makes an error. What happens next? Guys, when you think about it, it is either the user that finds out the error or Python will actually tell you what the error is, correct? So once you know what the error is and you know where it is, you can basically start analyzing it to know if it is fixable or not. Well, if it is fixable, how can you go about doing that? Well, if it isn't, nothing to worry. Guys, Python is so good that no matter on what level you mess up, there is always a way out of it, guys. So now if it's fixable, how can we handle the exception? Check out the image on the right side. So we need to first find the error. If we cannot do it, Python will find out for us. Well, next is to make sure you take caution while coding if you think that there is going to be an error in that particular piece of code. Well, remember the word try at this point, alright? And later we'll actually fix the error and we call this as catch. Just remember the keywords for now and we'll be walking through these in detail in the following slides. In fact, let us begin by checking it out right now. So guys, these are some of the important terms that you need to take a note of before starting to code and understanding exceptions. So first we have try. Well, try is basically the keyword which is used to keep the code segment under check. So whatever code you put under try is actually the code under scrutiny, guys. And next we have except. Well, except is the segment which is actually used to handle the exception, guys. So how do we know that the exception has occurred? If our piece of code in the try block has actually caused an exception, then we can handle it in the except block. And how do we use else? Well, else is basically run when no exceptions exist, guys. And lastly, we have finally. Finally will run even if there is an exception. Finally will run if there is not an exception as well. So I want you guys to note this at this point of time, and this will help you a lot on the coming slides, guys. So now coming back to Python, this is what it visually looks like. We first have the try block where we run a piece of code. And next we have the except where the code actually runs only when there is an exception in the try block. And if there are no exceptions, then we run the else block, guys. And lastly, no matter what, exception or no exception, we run the finally block always, guys. Sounds simple, right? Well, it actually is. And now that we're familiar with the process of exception handling, let us check out how we can go about understanding this using Python practically, guys. Well, syntax errors occur when the parser detects an incorrect statement. Well, check out the tiny arrow on the left side here. Well, this is basically to indicate where the parser ran into the syntax error. Well, in this particular example, there were too many brackets, right? So there was an extra closing bracket. Well, if you actually remove it and run it, you will actually get a different error this time. Well, check on the right side part of the code. Well, this time you actually ran into an exception error. Well, this type of code occurs whenever syntactically correct Python code results in an error, guys. So the last line of the message indicated is what type of an exception error that you actually ran into. Well, in this particular case, it is zero division error, and it says that the integer division or modulo by zero is not possible. So this is basically the same case that I showed you in PyCharm a while ago. But instead of showing the message exception error, Python details what type of exception error was encountered. Well, as I mentioned, in this case, it was a zero division error, right? Well, Python comes with various built-in exceptions as well as the possibility to create self-defined exceptions as well. And now that we are clear with that, let us check out how we can go about raising an exception on our own. So we can basically make use of raise to throw an exception if a condition occurs. The statement can be complemented with a custom exception. Well, if you want to throw an error when a certain condition occurs using raise, you can actually go about it like the following piece of code you actually see on the screen. And when you run this piece of code, you'll be greeted with the following output, guys. So it says exception x should not exceed 5 and the value of x was 10. So let me quickly jump back to PyCharm and we can execute this there. So guys, I'm in my PyCharm right now, so I've quickly typed out the code for you guys. So let me quickly go ahead and run it and we can check out the error. As you can see, it says exception x should not exceed 5 and the value of x was 10. Perfect, right? So let's quickly jump back to the presentation to check what's next. So the program basically comes to a halt and displays our exception to screen, right? So this basically offers clues about what went wrong. And now that we're clear with that, we can actually proceed to checking out the assertion error, guys. So instead of waiting for a program to crash midway, you can actually start by making an assertion in Python. Well, we assert that a certain statement is actually met. And if this condition turns out to be true, then excellent, the program can continue. But if the condition turns out to be false, you can have the program to throw an assertion error exception for you guys. Well, have a look at the following example on your screen. Well, this is basically where it is asserted that the code can be executed in a Linux system, guys. So if you run this code on a Linux machine, the assertion passes. If you were to run this code on a Windows machine, the outcome of the assertion would be false. And what would happen? Well, definitely the result would be something like this, right? So it would basically present us with an assertion error and says that this code runs only on Linux, right? So I'm using a Windows desktop in this particular case. So let me quickly open up my PyCharm and then we can actually run this piece of code to check out our exception, guys. So I'm back in my PyCharm and I've typed out the code, guys. So let me quickly go ahead and run this. As you can check out, since this is a Windows machine, it says this code can run on Linux only. But this particular case, this assertion would be true if you are actually running this on a Linux machine, guys. So if any of you guys are using Linux machine, make sure to try it out. And on that note, let's quickly come back to the presentation, guys. Well, in this particular example, throwing an assertion error is the last thing that the program will do. The program will definitely come to a halt and it will not continue, guys. But what if that is not what you want? What if you want something different from this, or that you want the program to continue while displaying an exception for you guys? Well, now that we actually have a fair idea about how we can go about understanding exceptions, let us dive right into the heart of exceptions now. Yes, I'm talking about the try and except block, guys. So basically, the try and except block in Python is used to catch and handle exceptions. Well, Python basically executes code following the try statement as a normal part of the program. The code that follows the except statement is the program's response to any exception in the preceding try clause, guys. Well, as you saw in the earlier example that I actually showed you, when syntactically correct code runs into an error, Python will throw an exception error. And this exception error will actually crash the program if it is unhandled, guys. So the except clause determines how your program responds to these exceptions, guys. So instead of actually crashing our program, we can actually tell Python what to do when this particular exception occurs. Well, check out the following function, guys. So this function can basically help us understand the try and the except block. Well, the Linux interaction function can only run on a Linux system. The assert in this function will actually throw an assertion error exception if you're using it on any other operation system apart from Linux. Well, we can actually give this a try in PyCharm, so let me quickly open up that. So guys, I'm quickly here in my PyCharm, so let me quickly go ahead and select this and run it. Well, this won't say anything right now because, well, if it was actually a Linux platform, the message would have been printed, right? So let's quickly jump back to the presentation. So basically, if we run the tiny piece of code you see on the bottom, the way we actually handle the error in this particular case is because we gave out a pass, right? Well, if you were to actually run this code on a Windows machine, you would get the following output, which is already on your screen, right? So it is a blank output. You get nothing. Well, the good thing here is that the program actually did not crash, but it would be nice to see if some sort of exception occurred when you actually ran your code. Well, to this end, you can actually change the pass into something that would generate an informative message like this. Check it out. So let me quickly go ahead and run this in PyCharm. Well, as you can check it out, it says the Linux function was not executed, right? So basically this happened because I am on a Windows machine, guys. So let's quickly go back to the presentation. And guys, when an exception occurs in a program running this particular function, the program will continue as well as inform you about the fact that the function call was not successful. Well, what you did not get to see was the type of error that was actually thrown as a result of this function call, guys. So in order to see what exactly went wrong, you would need to catch the error that the function threw. Well, check out this particular piece of code I have for you guys. So here is basically where we actually capture the assertion error and we print the output message to the screen. So we have a try block, we have the same function, and we have except as error, right? So we're going to print what type of an error it is, followed by a message for us, right? So running this particular case on a Windows machine will actually give us this following output, guys. So it says function can only run on Linux system, and whatever you have chosen in the print block is actually being printed for us. So let me run this in PyCharm. So as you can check it out, we have the message printed, right? So it was the same as I told you. So it was the same message as I told you before. So heading back to the presentation. Well, in the previous example, we actually called a function that we wrote ourselves, right? And after that, when we actually executed the function, we caught the particular assertion error exception and then we printed it on the screen. Well, I have for you another example where you actually open a file and use a built-in exception, guys. In fact, let us dive into PyCharm and we can actually run this and we can come back and take a look at the output. So guys, I actually came into PyCharm and I actually ran that particular piece of code. Why does it say could not open file log? Well guys, basically if the file.log does not exist, the block will give you this output, right? So it says the file could not be opened. Well, this is an informative message and our Python program is actually still able to continue to run. It has not crashed, right? Well, actually in the Python documentation, you can see that there are a lot of built-in exceptions that you can make use of. And here is one exception that I have for you guys that you can check it out. So it says exception file not found error, right? So basically this is raised when a file or directory is requested, but that doesn't actually exist. And this is just one among many that Python offers to us, guys. Well, to catch this type of an exception and to print it on the screen, we would actually use this following piece of code, guys. So in the try block, we're actually going to open it as file and we're going to read something present in it, guys. We're going to accept it by pushing a file not found error as an object, and later we actually end up printing that object, right? So let me quickly go into PyCharm and we can check it out. Well, as you can check it out, we have error number 2, which says no file or directory, right? So it's perfect. Well, you can have more than one function call in your try clause actually, guys, and anticipate catching various exceptions as well. Well, a thing to note here is that the code in the try clause will actually stop as soon as an exception is encountered. But there is one important thing that I want you guys to note down is that while catching an exception, it basically hides all of the errors, guys. Well, definitely there are some unexpected errors in your program, right? When you're catching an exception, and even these are completely hidden from you. Well, this is why basically you should avoid using bare except statement clauses in your Python programs, guys. So instead, basically what you can do is you can refer to the specific exception class that you want to catch and then handle those particular exceptions, guys. So look at this following piece of code I have for you. So here basically you first call the Linux interaction function and then later actually try to open a file, guys. So let us quickly jump into PyCharm and we can actually check it out. So as you can see, I actually executed the program, guys. Again, if the file doesn't exist, running this code on a Windows machine will give you that output, right? So it basically says that the function can run only on a Linux machine, and then we have actually printed something, guys. Well, what we actually did here is inside the try clause, we directly ran into an exception immediately, and we did not get to the part where we'll actually try to open our file.log, right? Now, basically, when you actually run it on a Linux machine, it's going to say no file or directory found. Check it out here, guys. So this is the Windows output that you get, and this is the Linux output, guys. Well, at this point, let us take a quick break and check out what are the key takeaways of this particular module, guys. So basically, a try clause is executed up until the point where the first exception is encountered. And inside the except clause or the exception handler, what we basically call it, we can actually determine how the program actually should respond to that particular exception. And we can actually manipulate multiple exceptions and differentiate how the program should respond to each of them, right? And lastly, we actually learned why we should avoid using bare except clauses, guys. And now that you're clear with this, next up I have for you is the else clause, guys. So basically in Python, using the else statement, you can instruct a program to execute a certain set of code only in the absence of exceptions, guys. Well, check out this following diagram on your screen. So basically in the try part, we have the code except when we actually want to handle the exception, or else in case there is no exception, we're going to run the piece of code that comes in under else, guys. So let me quickly walk you through the code, guys. So here is basically the same Linux interaction function, and we have an assertion error here, and we actually are going to print the error, right? So else, if there is no assertion error, so we're going to have an else clause and we're going to print saying executing the else clause, right? So let me quickly open up my PyCharm and we can run this piece of code, guys. So as soon as I go ahead and run this, it says function can only run on a particular Linux system, right? So as you can check out the output, it says the function can run only on Linux systems, right? So in this case, I have a Windows machine, so we are actually not printing the except clause here. But if you are running this on a particular Linux machine, this is the output that you would get, guys. So it says doing something and executing the else clause, correct? This happened because the program did not run into exceptions, any exceptions, right? So else clause was actually executed. Well, you can actually try to run the code inside the else clause and catch possible exceptions there as well. Well, again, we have the same Linux interaction here. We're going to print it, right? So the Linux output says doing something and no such file or directory found. Well, this is basically for the else clause and we're using the same file example here, but then we're actually trying to catch an exception in the else block as well. So the output is pretty much straightforward as well, right? Well, from the output, you can actually tell that the Linux interaction function actually ran. Well, because no exceptions were encountered, an attempt to open file.log was actually made. And that file did not exist. And instead of opening the file, you actually caught the exception, which is the file not found exception. Pretty simple, right? And I hope you guys are clear with all of the concepts that we discussed until now. And next up, we need to check out how we can actually use the finally clause, guys. Well, to begin with, imagine that you always had to implement some sort of action to clean up executing your code, guys. Well, Python basically enables you to do so using the finally clause. Have a look at the following example, guys. Check out the workflow on your screen. I'm pretty sure we're all familiar with try, except, and else at this point of time, right? So this is the chronological order that you need to go into. First, we have the try to check for an exception. Then we actually handle if there is an exception using the except, or else if there is no exception, we're going to print whatever is there in the else block. And lastly, we have something called as finally, guys. So no matter what, we're going to execute this. In case if there is an exception, the finally block is going to run. In case there is no exception, finally block is going to run there as well. So let us quickly check out a coding example, guys. So basically, this is the particular code I have for you guys. And let me jump back into my PyCharm and we can actually execute this. So guys, I'm back into my PyCharm. So let me quickly go ahead and run this. Well, as you can check it out, it says that the function can only run on Linux machines. This is because I'm on a Windows machine right now. And no matter what, right? So exception or no exception, we have this message which is cleaning up irrespective of any exception, guys. So this is basically the use of finally, guys. And that is as simple as it gets. So it's pretty much simple, right? Well, try, except, else, finally, all of this is a really simple concept. And once you understand what it actually does, you can go about doing a lot using Python, guys. Well, no matter what the Python application is, there is a very good chance that you'll actually make use of exceptions, guys. Well, on that note, let me quickly summarize the entire session for you guys. Well, in this session, we covered the following topics. Well, basically, we started out with the introduction to exception handling, and later we looked at why we actually need it, right? And then we checked out the following concepts in the screen. So we checked out race, we checked out assert, we checked out try, we checked out except, else, and finally, guys. Well, guys, I would suggest you actually take a screenshot of this right now or take a note of all of the keywords and how you can use them in Python, guys. So this will actually take you a really long way in your Python career. And knowing exceptions in Python is always an upper hand when you're coding, guys.
So let's begin with our session and talk about the agenda for this session. First of all, I'll be starting with what exactly is a Python module. And after that, we will learn how we can create a module in Python. Moving further, we will learn to use that module we have just made inside a program. And we will also learn about the built-in modules in Python. And finally, I will sum up this session with a little demo using the Python modules. Also, I suggest you subscribe to the Edureka channel to kickstart your learning, and also press the bell icon to get the notifications for the latest update on the channel. So let's try to understand what exactly is a Python module. So before talking about Python module, let me talk about modular programming. So what exactly is modular programming? It is a design technique to break your code into separate parts. Now these parts that we are breaking the code into are actually called the modules. Now we will talk about them in detail. So the basic focus for breaking down the code is to have the modules with no or minimal dependencies on each other. The benefits include you have to write lesser line of codes first of all, and then a single procedure can be developed for reuse as well. And also you are eliminating the need to write the same code again and again. We can write programs that can be designed easily because the whole team is going to be working on just a part of the whole code. Now coming back to the Python modules, they are simply a program logic or a Python script that can be used for a variety of applications and functions. Let's try to understand this with a basic example. Let's suppose we have a calculator app or a calculator program. So what all operations can you think of right now? There'll be addition, subtraction, multiplication, and division. So let's stick to these four for now. So the basic concept of modules is to break down the code into separate parts. So what we are going to do here is we are going to break down the code into 4 different modules, and we are going to save that code into different files. We can do that in a single file also, but the purpose of doing that is actually minimizing the line of codes. So when we are making these 4 modules for different operations such as addition, subtraction, multiplication, and division, we can use them in the main file that we will make for the calculator app. So now that we have understood what exactly is a Python module, also I have to tell you guys that if you have made a module, it is not necessary that it will be used for that particular program only. If you're making a custom module, there are ways you can save that file inside side packages where you can actually use the module for different programs as well. So now that we are done understanding what exactly is a Python module, let's try to understand how we can create one in Python. We can declare various functions, classes, and variables in the module. It's as simple as writing a simple Python script with a .py extension to our file. Once we have created a Python script, we can use it in the program using the import keyword. So we are going to do that later, guys. So for the example that I was talking about, this is a Python file or a Python script which has these 4 different functions, which has the logic for the operations for addition, subtraction, multiplication, and division. So I'm going to save this file. So let's take it up to PyCharm, guys. We will try to understand this better. So this is our file, guys, where I have actually defined 4 functions. Let's actually get into the presentation mode. So as you can see, I have these 4 functions. This is the logic for addition, then this is the logic for subtraction, multiplication, and division. So I have saved this file with the name mod1. So this is going to be my module for my calculator app. So this is actually how you can create a module inside Python. So it is as easy as writing a script. So instead of functions also, I can use classes, I can use any variables I want, data types, etc. So now that we have learned how we can create a module in Python, so let's try to understand how we can actually use that module we have just made. We use the import keyword, which will incorporate the module into our program. And there are different ways where you can import all of the functions and classes using the asterisk, or you can just write an alias when you are importing the module using the as keyword. You can use the from keyword to only import a few parts of your module as well. So this is actually the procedure of using the module that we have just created. Now let's take it up to PyCharm to understand how we are going to use that module we have just created. So we'll exit the presentation mode. Okay, so I have my main file over here. So I'll just write it from the beginning. So what I'm going to do is I'll write the import keyword, and then I'll import the file that I have created over here. That is the mod1. Okay, let's take it up to the presentation mode again. So I'll write mod1. As you can see, I'm getting the module over there, and I will use the alias. Let's say I'll use MD over here. So for addition, let's say I want to perform addition. This will be my variable, and to add, I'll use the alias, and then I will call the functions that are there in the module. So I'll use the add function, and then in here I'll specify two variables, let's say 10 and 15. So when I use the print statement, I'll print addition here. So when I run this, I'm getting the output as 25. So as you can see, this is how you can actually import a module into your program. Now for similarly, I can do the subtraction. Okay, instead of addition, I'll just put it as result. Now instead of addition, let's say I want to perform subtraction. So here I'll just do 20, and when I get the output, it will be 5. That is the subtraction between the two numbers. And similarly, multiplication. As you can see in the output, we are getting the multiplication as well, and we will get the division. Now there's a division as well. So right now I've shown you how you can actually do these operations using the module you have just created. Now instead of using the alias, I want to show you another approach. So I'll just write from mod1 import. Let's say I want to import just divide. So I'll write that. Now instead, I haven't used this alias over here, so I'll just remove it. And if I run this now, I'll get the output as I was getting before. So this is how you can actually import your module in another way. So instead of just divide, if I want to actually import all the functions and everything in what is there in my module, I'll just write asterisk. Now instead of divide, I can write sum, I can write subtraction, I can write multiplication, and I'll get the results as I was getting before. So this is a basic example, guys, where I have created a module for where I have actually specified 4 functions with the operations for addition, subtraction, multiplication, and division. So I have also created one more module which is actually with the name of sample, guys. I'll show you the file later. So I'll just import sample over here and give it an alias, let's say s. Now what I'll do is I'll just write print s dot. So we'll see what all operations are there that I have created in the sample module. So as you can see, there are 2 functions, that is fact and palindrome. So these are the 2 functions I've created to check if the number is palindrome or not. And then I have one more which is actually used to find out the factorial of a number. So I'll just write 151 over here. And now one more statement, I'll just write s dot fact, and we will find out the factorial of the number 5. So I'm sure you guys must be knowing what is the factorial of the number 5, which is actually 120. So let's see if we are getting the output as same or not. So 151 is actually a palindrome, and then there is the factorial of this number. So now I'll show you guys what the file I had made for the sample module. So this is the file or the module that I had made for the sample module, and I have 2 functions over here which has the logic for actually finding out or calculating the factorial of a number, and then there is finding out if a number is palindrome or not. So this is a very basic example of how you can actually make a module and use that same module inside your program, guys. Now that we are done with how we can create a module and how you are going to call that module in your program, let's talk about built-in modules in Python, guys. So what exactly are built-in modules? Built-in modules are written in C and integrated with the Python interpreter. Each built-in module contains the logic or the resources for certain system-specific functionalities such as OS management, disk input, output, etc. The standard library also contains many Python scripts with the .py extension containing useful utilities. Now, there are several built-in modules in Python at our disposal that we can use whenever we want. So to get the list of all the built-in modules in Python, you can just write, okay, I'll just show you in the PyCharm only. So we'll exit the presentation mode. So I'll open the Python console, guys. I hope this is visible to you guys. So what we'll do in the Python console, I'll just write help and I'll write modules over here. What this statement is going to do for us is get the sorted list of all the functions or all the built-in modules that we have in Python. We'll wait for it for a while. So now as you can see, this is the list of all the available modules that we have in Python. As you can see, there is pip, and then there is traceback, turtle, types, typing, pstats. So these are all the, like, there is random, there'll be math as well. So let's talk about a few modules, few built-in modules. So I'll just talk about math over here. So let me take a quick, so I'll just write one thing. Okay, before talking about any built-in module, let me talk about directory function, guys. So what this directory function does is, we'll go to the presentation mode now. So what this directory built-in function will do is, it will return a sorted list of strings containing the names defined by a module. So the list will contain the names of all the modules, the variables, and the functions that are defined inside a module. So when I run this, we'll get the list of all these things that we have in PyPlot. As you can see, there are so many things that you can use inside this PyPlot module. I'll be showing you the demo for using the PyPlot module, guys, don't worry. Now let's check it for the module that we have just made, guys. So I'll just write import, all right, sample, that is our module, guys. So I'll just use the directory function again, and now I'll write sample over here, and I run this. I'm getting all these files and names of all the functions and everything. So I have two functions over here that I mentioned, that was factorial and palindrome, which are actually here. So this is what it is about directory function, guys. So we can check it for mod1 as well that we have created. So we'll check it for mod1 as well. So instead of just sample, I'll write mod1. So as you can see, I'm getting all these files and names of variables and everything, and the functions as well. So I'll be having addition, yes, I have addition, divide, multiply, and subtract. So to actually get the list of all the values or the functions, variables, everything you want in a module, you can just write directory function and you will get the sorted list of everything. So now that we are done discussing how we can get a list of all the built-in modules in Python, let me talk about Python module search path. So what exactly is a Python module search path? So whenever we are importing a module, Python is going to look for it inside the built-in module directory. But if it does not find it over there, suppose you're making a custom module, how it is going to search is another story, guys. So what it is going to do is, it is going to search through the list in the sys.path. So first of all, it will search in the current directory, then it will go to the Python path, and then it will go to the default directory. So I'll just show you guys. If you import sys and then you write sys.path, print this, and when I get the output over here, it is going to show me the path, and in here you can make the changes to actually get your module to work for all the programs that you're going to need. So this was all about Python search path, guys. So let me talk about a few built-in modules that we have in Python. So first of all, let me talk about the math module. So I'll import math over here. So we have imported the math module over here. So let's see what all functions or what all properties that math have that we can perform. So we have factorial, A cos, H, A sin H, tan. So there are so many functions that are already mentioned. So let's check the factorial first. So factorial of a number, let's say 10. Okay, just write 5. So we are getting 120 as the output when we were mentioning it in our custom module. Let's see if the math module does the same. Okay, we are getting the same output as we were getting before. Actually, the advantage of using the modules is similar to not writing the logic for everything else, because this is already mentioned inside a module that is created inside the Python already. So as you can see, I don't have to write the logic for factorial like I have done in the sample module, guys. I can already find it inside the math module. So these are the functions that are already there inside the math module. Exponent is also there, floor, fmod. There are so many functions, guys. We have pi as well, we have power, radians, reminder, sin h, square root also. Let's find out the square root of 164, guys. I'm sure you must be knowing the square root of 164, guys. If you're not, just check it up on Google and you'll get the output as 12.80624. So this is all about math module, guys. If you want more practice, you can just make a program using the math module and you will be through with it in no time. So next one is the random module. I will import the random module, guys. So we'll see what all random offers. So we'll just write rand range. All right, 50 over here. So what it does is it is going to give me the values from, okay, I'll write 0 to 50. So it is going to show me the values from 0 until 50 randomly. So each time I get the output, I'm going to get the different value. See, I'm getting 13. Now I'll be getting some other value from 0 to 50. I'll write 0 to 5 over here to understand this better. So I'm getting 0. Then I'll be getting 4. So there's no telling what value you're going to get. So there's one more inbuilt module I want to talk about. That is the date time module, guys. So when I import date time, what I can do is I'll get the date time. So using the date time, I can get the date of today. Let's see what it does for us. So I'm getting the date for today, which is 2019 and 15th of May. So this is what you can do using the date time module, guys. So we'll exit the presentation mode now. So now I'll be showing you a little demo where I'll be using the pyplot module that we have in matplotlib, guys. So this is a very basic example of using the matplotlib module, guys. So I have imported matplotlib, and inside that I have imported pyplot and given it the alias as plt. So I have values such as, I'm using values of BMW and Audi. So this is my data, guys. This is inside a list. So I'll be actually plotting a graph here, which is going to be a bar graph. So these are all the operations that you can actually get from using the plt alias, and which is exactly using the functions defined inside the pyplot. So I'll show you what all are there inside the pyplot that you can use. So as you can see, these are all the functions that you can actually use inside a pyplot. There are so many. I'll show you the output, guys, then you will understand how it is going to make our life easier as a developer. So the next code is actually for pie chart, guys. So we have the values like day, sleeping, eating, working, playing, and then we have specifications like what all activities we'll be having, like 4 columns we'll have in the pyplot. So let's run this and we'll get a graph, guys. Okay, there's a mistake over here. I have forgot to write the color over here, so I'll run it again. So as you can see, we are getting a bar graph with the information which has the values that we have specified in the data given over here. So as you can see, using the pyplot module, data visualization becomes very easy, and the code for this bar graph that you're getting is actually completed in 11 line of codes. So that should make you realize the importance of using the Python modules, guys. Because if you were to write the logic for getting the bar graph by yourself, imagine the horror, guys. So I'll just stick to the main part. So I'll get the pyplot over here. So as you can see, we are getting the pyplot like we have mentioned over here, the data and everything. Using pyplot module will actually make your life easier when you're working on a data analysis or you're analyzing a data or anything like that. So now that we are done with the demo over here, we'll exit the presentation mode. I hope you guys are clear with the concept of modules, guys. So we had created 2 modules, the custom modules. So these are a very basic custom module, guys, that I have just created. When we are working on a big company or a product based company, there'll be a lot more complex modules that we will be working on. But to get the hindsight, this is how you actually make a module in Python. And we had made sample as well, and we have shown you a demo for using the pyplot module inside matplotlib.
Time is definitely the most impactful factor for life, and therefore it becomes equally important to access, set, and modify it. So before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards this session, we shall be dealing with 2 modules, namely time and the date time module, to manipulate our clocks and calendars using some of the built-in functions and format codes. I'll be showing you all what these format codes are, but before that, let's move on and take a quick look at the time module and its built-in methods. The time module consists of all time-related functions that are required to perform various operations using time. It also allows you to access several types of clocks required for various purposes. The time module begins recording time from the epoch. Epoch literally means a time in history, and it begins on 1st January 1970. As you can see on the screen, I've listed down some of the most important functions that are available in this module. So talking about the first function, which is time, it returns the number of seconds that have passed since the epoch. The ctime method returns the current date and time by taking the elapsed seconds as its parameter. Sleep stops the execution of a thread for a given period of time. The local time method returns the date and time in the struct time format by taking the number of seconds passed since the epoch as the parameter. GM time, on the other hand, returns the current date and time in the UTC format. The MK time method is inverse of local time. It can take a tuple of maximum 9 parameters and returns the seconds passed since the epoch. And finally, the ASC time method, which can also take up to 9 parameters and returns a string representing the same. Okay, so now I'll jump on to my Jupyter notebook and show you all how this works. So the first thing that you'll have to do is import the time module. So I'll say import time and I'll hit run. Okay, so first I'll be making use of the time method present in the time module. So I'll just say time.time and I'll hit run. So like I've already told you all, this method returns the number of seconds that have passed since the epoch. So I'll hit run. Okay, so here is the number of seconds that have passed since the epoch. Now, if I want to convert it to the current date and time, I can make use of the ctype method. So I'll just have to use time.ctime. Now, if I want to convert this into the current date and time, I can make use of the ctime method. To do this, I'll just use time.ctime. And I'll have to pass the number of seconds as a parameter to this. So as you all can see on the screen, I've passed the number of seconds which was returned by the time method to the ctime method, and I've got the current date and time. If you want more information about these functions and methods, all you can do is use the help method. So I'll just say help time, and if I want to fetch data about the time method, I'll just say time.time and I'll hit run. So as you all can see, it says that this method returns the current time in seconds since the epoch. Similarly, if you use help on any method or function, it will return the corresponding information about that function. Okay, so moving on, I'll be making use of the local time method and see what it returns. So I'll just say time.localTime and I'll hit run. So as you can see on the screen, I've got the current date and time in the struct time format. Now to make you all understand what this struct time class is, let me get back to my presentation. Okay, so as you all can see, the struct time class basically has 9 attributes, starting from the year, whose value starts from 0 and goes up to 9,999. The second attribute is month, whose value will be anything from 1 to 12. After that is mday, which means the day of the month, and the values can range anything from 1 to 31. Similarly, hour, minutes and seconds have the values 0 to 23, 0 to 59 and 0 to 61. The weekday value can be from 0 to 6, where 0 is Monday. Y day or year day can be anything between 1 to 366, and the final attribute is daylight saving time. It's 1 if it's summer, 0 if not, and -1 if unknown. Okay, now that you're aware of what this struct time format is, let's come back and see what our output actually means. Year is 2019, month is 8th or August, the date today is 8 as well, and so on. So I hope you're clear with this. Okay, so now, in case you want to fetch the number of seconds that have passed since the epoch. So to do this, you can make use of the mktime method. Okay, so all I'm going to do over here is first store the local time in a variable, say A, and after that I'll take another variable B, wherein I'll be using the mktime method, and I'll pass the parameter to it as A. Finally, I'll just print out B. So as you can see on the screen, the mktime method has returned the number of seconds that have passed since the epoch till now. So now, in case you want to fetch the current date and time from the struct time format and return it in local format, you can make use of the ASC time method. So like I've already told you all before, the local time method returns the current time in the struct time format. I'll be using the variable A, which stores the struct time format of the current date and time to convert it to the local format. And to do this, I'll create some new variable, say C, and then I'll use ASC time method. So time.asc time, and I'll pass the parameter to it as A. And then I'll just print out C. Okay, so as you all can see over here, it has taken the struct format and has returned the local format of date and time. Python also allows you to format and pass strings using the strf time method and the strp time method. The strf time method can take a tuple containing 9 parameters and returns a string representing the same depending on the format code used. The strp method passes a string and returns it in the struct time format. To show you all what these format codes are, I'll just use the help method and I'll pass time.strf time as a parameter to this, and I'll hit run. Oh, I've made a spelling mistake over here. Sorry guys. It's strf time. So as you all can see over here, I have a number of format codes which I can use to format my date time strings. Okay, so first let's make use of the strf time method. So as we all have seen, I've created a variable A in which I've stored the current time in the struct time format. So let me just print this out again. Okay, so now I want to format this output in a manner which is convenient for me. So to do this, I'll use the strf method. So I'll just say time. I'll take another variable, say x is equal to time.strf time. I'll use the strf time method, within which I'll be using the format codes to format the date as per my choice. So first I want to print out the month. So I'll use the format code mod m. It's small m guys, please be careful because this is case sensitive. And then between this I just want to see a slash. After this I'll just print the date. I'll use mod d and then the year. So I'll use mod y. Sorry for the spelling mistake. I'll just print x. So as you can see on the screen, I've returned the current date in the month, day, year format. Similarly, you can also pass a string and return it in the struct time format. To do this, you can make use of the strp time method. To do this, I'll take another variable, say y, and I'll pass a string to this. I'll say 8th August 2019. And then I'll make use of the strp method to pass this string. So I'll just say time.strp time. And I'll pass y as a parameter to this and the format of it, which is day, month, and year. Capital B means the full name of the month. And now hit run. Okay, so as you all can see over here, I've passed a string using the strp method and returned it in the struct time format. So now let's get back to our presentation and take a look at the date time module. The date time module is similar to the time module, consisting of all the required methods that are essential for working with date and time. Some of the important methods present in this module are the datetime method, which is a constructor, and it consists of two methods, which is today and now, that will return the current date and time. The date method will help you create a date, and the time method will help you create time, which includes hour, minutes, seconds, microseconds, and the time zone information. The datetime module also consists of a from stamp method, which converts the seconds to return the corresponding date and time. Another very important function that's present in this module is time delta. Time delta basically returns a duration, which will be the difference between two different times. Okay, so now let's get back to our Jupyter Notebook and see how this module actually works. I'll just create a heading over here. Say date time. And I hit run. The first thing that I'll have to do is import this module. So I'll say import date time. After this, I'll be making use of the datetime constructor to create some date. So I'll say date time. And then I'll pass some values to this, starting with the year, which is 2019, and the month as 6, date as 7, time as 4, minutes, seconds, and milliseconds. And then I'll just print this out. So as you can see on the screen, I've created some random date using the datetime constructor. Now, in case you want to fetch the current date and time, all you can do is use the today and the now methods like I've already told you all previously. So I'll say date time. So I'll just copy this. And then I'll use the today method. So as you can see over here, it has returned the current date and time along with milliseconds, which is very precise. I can also use the now method instead of today method over here. So I'll just say now and I'll hit run. So as you can see, both these methods return the current date and time. Now in case you want to access some particular value from this date, all you can do is use the attribute name to access that particular value. So in case I want to access the year and the month, all I can do is save this into a variable, say v, and then I can use v.year to access the year. So as you can see, I've accessed just the year from the current date. Similarly, you can access anything of your choice. So if I say print v.month, and then I'll say print v.hour, and I'll hit run. So as you can see, the month and the hour have been returned. Similarly, you can access any values of your choice using these attributes. Now, in case you want to set only date without time, you can use the date method. So you just say date time dot date, and then pass the date as a parameter. The time method can be used to create time without date. So I'll just say it's 3 hours, 45 minutes, and 23 seconds. So now moving on towards time delta, which is a very important method that's present in this module. Like I've already told y'all, this method represents a duration which can either be the sum or the difference between two different dates. Now to make use of this method, I'll just take some variable, say b1, and I'll say date time dot time delta, and I'll pass the number of days as 20 to this. You can also pass other parameters like microseconds, minutes, etc. Okay, I'll take another variable, say b2, and I'll use the same method again. And to this, I'll pass the number of days as 30. Now, I'll take another variable, say b3, within which I'll just store the difference of b1 and b2. So I'll say b1 minus b2, and then I'll print what is b3 and the type of b3. So as you can see over here, the difference between b1 and b2 is minus 10 days, and the time, since I've not specified anything, is 0. And the type of b3 comes under the time delta class.
In today's session, we are going to focus on NumPy module available in Python. So let us move forward and have a look at the agenda for today. First, we'll see what is NumPy. Then we are going to compare it with list, and we'll see why it is better than list. Then we are going to see various operations that we can perform with the NumPy arrays, and there are certain special functions as well that we are going to focus on later in the session. So let us move forward and understand what exactly is NumPy. So what is NumPy? NumPy is basically a module, or you can say a library, that is available in Python for scientific computing. Now it contains a lot of things. It contains a powerful n-dimensional array object, then tools for integrating with C, C++. It is also very useful in linear algebra, Fourier transform, and random number capabilities. Now let me tell you guys, NumPy can also be used as an efficient multi-dimensional container for data, for generic data. Now let me tell you what exactly is multi-dimensional array. Now over here, this picture actually depicts multi-dimensional array. So we have various elements that are stored in their respective memory locations. So we have 1, 2, 3 in their own memory locations. Now why is it two-dimensional? It is two-dimensional because it has rows as well as columns. So you can see we have 3 columns and we have 4 rows available. So that is the reason why it becomes a two-dimensional array. So if I would have had only one row, then I would have said that it is a one-dimensional array. But since it contains rows as well as columns, that is, it is represented in a matrix form. That is why we call this as a two-dimensional array. So I hope we are clear with what exactly two-dimensional array is. So let me open my PyCharm and I'll tell you practically how to actually create a NumPy array. So this is my PyCharm, guys. Over here, the first thing that you need to do is first install the NumPy module. And how you're going to do that, click on File, go to Settings tab, and you'll see the Project Interpreter option. And on the right hand side, you'll see a plus symbol. Just go on and type the module that you want to install. So I'm going to install NumPy. Just go there, click on it, and install package. I've already done that, so I'm not going to repeat it. So this is my PyCharm. So first thing that I need to do is import NumPy as NP. Now after that, I need to create a NumPy array. So for that, I'm going to define a variable, let it be A, and I'm going to type in here np.array and certain elements inside it. So I'm going to put in 1, 2, 3 and print it. That's all. So this will actually print a single dimensional array. So 1, 2, 3 has appeared. Now if I want to convert this to a 2D array, so for that I'll keep this in parentheses, and after a comma I'll add one more element, and I'm going to give certain values inside that. So I can give, say, 4, 5 and 6. Now go ahead and print this. So as you can see that it is now a two-dimensional array. So this is how you actually create arrays using NumPy module. So now I'm going to open my slides and we'll move forward and see what is our next topic. Now let us see why are we using NumPy instead of a list. Alright, so many of you might be thinking, why are we using NumPy when we have lists? Alright, so basically we use NumPy because of 3 main reasons. The first thing is it occupies less memory when compared to lists. Then it is actually pretty fast when you compare it with list, and at the same time it is very convenient to work with NumPy. So these are the 3 major advantages that NumPy has over lists. And that is the reason why we use NumPy instead of lists. Now don't worry, I'm actually going to prove it to you practically by opening my PyCharm. So guys, this is my PyCharm again. So first thing that I need to do is import NumPy as NP. And now what I'm going to do is I'm going to import a couple of more modules. I'm going to import time and I'm going to import sys. Alright, done. So our first step is to actually define a list. And the name that I'm going to give to my list is, say, S, and I'll type in here range 1000. So what this will actually do, it'll actually take all the integer values between 0 to 1000 and it will give it to a variable S. So this list will contain the integer values between 0 to 1000, but it won't include 1000. It will be only there till 999, that is 999. And now I'm going to print the space occupied by this particular list. So for that, what I need to do is I need to type in print sys dot get size of any one element. Okay, so you can give 3, 4, 5, anything. I'm going to give it as 5, any one element, and multiply that with the length of my list. That's all. So this will actually give me the space that has been occupied by the list, because sys.getSizeOf will actually give me the memory occupied by one element, and when I multiply that with length of my list, I get the entire memory that has been occupied by my list. Now the same I'm going to do with my NumPy array as well. Let me give a name to that. I'm going to type in D np dot a range, and the range will be 1000. Now a range function is pretty much similar to the range which is there. So the same thing will happen here. The integer values between 0 to 1000, but it won't include 1000, will be present in my variable d. So we have created a numpy array. Now let us print the space occupied by it. So the first thing is I'm going to type in here d dot size. So this will actually give me the space occupied by one single element, and when I multiply that with the length of my numpy array, I get the entire memory that is occupied by the numpy array. So I'm going to type in here d dot item size. That's all. Now go ahead and print this. So this actually shows the memory that has been occupied by my list, and this shows the memory that has been occupied by my numpy array. So as you can see, there is quite a lot of difference between both of them. So we have proved our first point that it actually occupies less memory. Now when I talk about numpy array is faster and more convenient than a list. So the next step is I'm going to prove it to you that numpy array is actually faster and more convenient than list. So I'll remove all of this, and so now I'm going to show you that numpy arrays are faster than list. And at the same time, it is easier and more convenient in order to work with numpy arrays when compared to list. Let me show you practically. So first what I'm going to do is I'm going to define a variable, say size, which is equal to say 1000, and then I'm going to define two lists. Now what I'm going to do is I'm going to add those two lists, as well as I'm going to add two numpy arrays, which I'm going to define now. And then I'm going to compare the time taken in order to find the sum for list and the sum for numpy arrays. So first let me define two lists and two arrays. So my first list will be equal to range size. Same goes for my second list as well. Just change the name to L2. And now I'm going to define two numpy arrays. A1 equal to np dot a range size. Go ahead and do the same for the second numpy array as well, and change the name as A2. So we have two lists and two arrays, and we need to compute the sum of both of these lists as well as arrays. Now before that, I'm going to define a variable, say start, which is equals to time dot time, and now I'm going to calculate the sum. So I'm going to save that in result, and first I'm going to calculate the sum of list, that is L1 and L2. So for that, what I need to do is I need to run a for loop, because if I directly write L1 plus L2, it is going to give me a result which is nothing but the concatenation of both the lists. So in order to calculate the sum, I need to use for loop. Let me show you how to do that. First I'm going to type in x comma y, and we have already studied loops in detail. For x comma y in zip, and the name of the two lists, that is L1 comma L2. That's all. So what will happen here, it will first take the first element of list L1, and then it will take the first element of list L2. It will calculate the sum, and it will store in result, and it will keep on repeating until the range has been exceeded. Now this is how you calculate sum in lists. But when you talk about arrays, what you need to do is you need to just write in A1 plus A2. That's all. That's why I'm saying that it is more convenient in order to work with numpy arrays when compared to lists. Now our next step is to define the same variable start and initialize it with time.time. And now I'm going to find the sum of my two numpy arrays, which is nothing but A1 plus A2. That's all. And now print the time taken. So print time.time minus start, and then multiply it with 1000. Because by default it will take it in seconds, and I need to convert it into milliseconds. Now I forgot to actually print the same thing for my list, so I'm going to do it over here. So this will actually give me the time taken by my list in order to compute the sum, and this statement will give me the time taken by my numpy array in order to compute the sum. So let us go ahead and execute this, and we'll see what happens. So it gives me 0 milliseconds because the size is small. Let me just add a couple more zeros. Let's make it 1,000,000. Now go ahead and execute this. Now you can notice the difference, that there is a significant change. Lists took 208 milliseconds, whereas numpy array took almost 67 milliseconds. So there's a huge difference between the compute time of a list as well as numpy array. That's why I say that numpy array are faster, convenient, and at the same time they occupy less space when compared to list. So that is the reason why we choose numpy arrays over list. So let us go ahead and move forward towards the next topic, that is numpy operations. So let me go back to my slides. So now is the time to see various operations that you can perform with the numpy arrays. So you can find the dimension of your array, whether it is a two-dimensional or a single-dimensional array. Then you can even calculate the byte size of each element. It is pretty easy. I'm going to tell you that practically. You don't need to worry about that. And you can even find the data types of the elements that are stored in your array. So if you want to know what is the data type of the elements, you can do that as well. So let me show you these three operations first, and then we'll move forward to the other operations. I'm going to open my PyCharm once more, guys. Let me remove all of this. So we have imported the numpy module. Now what I'm going to do is I'm going to define a numpy array. I'm going to name it as A, and I'll write here np.array 1, 2, 3. Put that in parentheses. Now add one more element, say 2, 3, 4. Alright, so it's a two-dimensional array. Now if I want to know whether it's a two-dimensional or a single-dimensional array, so I'm just going to type in print a.endim, and it'll give me the dimension. So let me show you that, and I'm going to run this. So it says 2, that means it is a two-dimensional array. So what if I move this part and make it as a single-dimensional array? It should give us the result as 1. Let's see if it does that or not, and yep, it gives us 1 as a result. So this is how you actually calculate the dimension of your array. Now if you want to find the byte size of each of the elements, so what you need to do is, instead of endim, you can call a function called item size. Go ahead, execute this, and you'll get, so each element occupies 4 bytes. After that, if you want to know the data type that is stored in the array, so you can just type in here dtype. Go ahead, execute this. It should give us integers 32-bit. Alright, so this is how you can actually perform these three functions that I've told you in my slides. Now let us move forward and see what are the other operations that you can perform with numpy module. So by using numpy array, you can actually find the size of your array. How you can do that, I'll show you practically. You don't need to worry about that. So when I say size of the array, that means the total number of elements that are present in the array. So if this is an array, so the total number of elements become 4. 1, 2, 3, and 4. Now you can even find the shape of your array. Now what do you mean by shape? So basically the total number of columns and rows. Now over here we have 3 columns and 4 rows. So our shape is actually 3 columns and 4 rows. Now let me show you practically how you can do that. Again, I'm going to open my PyCharm and show you. Let me remove this print statement from here. Now if I want to find the size of my numpy array, I just need to type in print a.size. That's all you have to do, and it'll give the size of your array. So there are 3 elements. So if I go on and add some more elements, say 4, 5, 6, 7, then if I execute this, you'll see that 7 elements have appeared. That means the total number of elements in my array is 7. Then comes the shape part that I was talking about. So in order to find the shape, what you can do is you can just type in here a.shape, and it'll give you the shape. So let us see what happens. So it has 7 columns, but there are no rows, so it has given 7 comma blank. So what I can do is I can close this in parentheses, and I can define one more element, say 8, 9, 10, 11, 12, 13, 14. Go ahead and execute this, and you can see 2 comma 7 because we have 2 rows and 7 columns available with us. So this is how you can actually find the size of your array, as well as you can find the shape of your array. Now let us move forward and see what are the other operations that you can perform with numpy module. So we saw how to find the size and the shape of an array. So we can perform reshape as well as slicing operation using numpy array. Now when I talk about reshape, what do you actually mean by reshape? When you change the number of rows and columns, that is called reshaping. Now over here there is an example. So we have 3 columns and 2 rows, which we have converted to 2 columns and 3 rows. Now let me show you that practically how you can do it. In a variable, and I'm going to start a numpy array, and I'll have 2 elements in that. My first element will be 1, 2, 3, 4, and my other element will be, say, 3, 4, 5, 6. So I have a 2-dimensional array that contains 2 rows and 4 columns. Now I can convert that to 4 rows and 2 columns. Let me show you how to do that. You're just going to type in A is equal to A dot reshape, and I want to convert it to say 4 rows and 2 columns. Go ahead and print this. So it has converted that to 4 rows and 2 columns, as you can see in front of your screen. Now let me show you that earlier this is not the case. I'm going to type in a print statement here as well in order to show you that how it has reshaped. So earlier we had 4 columns as well as 2 rows, but now we have 2 columns and 4 rows. So this is how you can perform the reshape operation. Now let us talk about slicing. So slicing is basically extracting particular set of elements from your array. And the slicing operation that happens here is pretty much similar to the one which is there in list as well. So suppose if I want only this particular element, that is 3. So for that, what I need to print, I'll show you, print A and the index value of 3, which is present at 0, comma, and the index is 2. Let me tell you how indexing happened. So this element will be 0, this element will be 1. Now if I want 3 from here, from the 0th element, I want the index 2. Indexing starts from 0, 1 and 2. So that's why I've written 0, 2, and it should print 3 for me. Let us see if it does that or not. And yep, it prints 3. Now say if I want to print 4 and 6. Now for that, what I need to do is I need to remove this 2 here, and I'm going to put a colon that says all the rows including 0, and in that row I want only index 3. So we have only 2 rows. So if I would have written 0, 1, then it wouldn't have included this particular row. So if I have one more element here, so I can actually write here 2. So that won't actually include the element which is present at the second index. So when I say 0, this actually means all the rows that include 0 as well. So we have only 2 rows. It will include both the rows, and at the same time it'll actually going to print the third index from both of these rows. So let me show you if that happens or not, and yep, it happens. We have 4 and 6 available with us. Now just to remove confusion, what I'm going to do is I'm going to add one more element, and I'm going to give values to it, say 7, 8, 9 and 10. So now if I want 4 and 6, I can't just write 0, because if I do that, it'll print 10 as well. Let me show you that. Yep, it has printed 10. Now in order to avoid that, what I can do is I can write in here 2. So as I've told you, this is the 0th element, first element and the second element. So when I write 0, 2, it won't include the second element. It'll only include 0th as well as the first element. Now inside that, we have index 3 from both of these rows. That is why we'll actually get 4 and 6. Let us see if that happens or not. And you can see 4 and 6 is now available. So this is how you can perform slicing when we in numpy arrays. Now what I'm going to do is I'm going to type in A equal to np dot line space, and now over here first I'll write 1 comma say 3, and I want say 5 values between 1 comma 3. What this will do is it'll actually print the 5 values which are equally spaced between 1 to 3. So let me print this first. I'm going to type in print A and go ahead, execute this, and you can see that we have 1, then we have 1.5, then we have 2, 2.5 as well as 3. So if I would have written here 10, it will actually give me 10 values between 1 to 3. And yep, you can see we have the 10 values between 1 to 3. So this is how you can perform line spacing as well. So let me open my slides and we'll see what are the other operations that you can perform with numpy. So we saw how to perform reshaping and slicing. Now let us see what are the other operations. So we are now going to find out the minimum, maximum as well as the sum of our numpy arrays. So let us go ahead and execute that practically. Let me remove all of this, and now I'm going to define one more numpy array, np.array, and I want elements in it, say 1, 2, 3. Now if I want to find the element which has the maximum value, so what I can do is I can just type in here print a.max, that's all, and it'll give me the maximum value in my a numpy array, which is 3 obviously. If I want to find minimum value, so I'm just going to type in here min, and it'll print the same for me, which is 1. Now if I want to calculate sum, it is pretty easy. Just go on and type sum and it'll give you the sum. That's all guys, it's that simple. I'm pretty sure there won't be any doubts here. If there are, you can just ask me. Fine, so there are no doubts. So Janice has a question. She's asking me, is it that simple to work with numpy? All right, Janice. So let me tell you that whatever I'm telling you, these are all the basics that you require. After that, whatever your requirement is there, on that basis, you need to use those basic knowledge that you have and implement it. Now, the best way to do that, now the best way to understand any programming language is to play around with it. So you know the basics. With the help of those basics, just install PyCharm first, then try out new things like how should I get that, how should I get this, and if I'm not getting it, what is the reason behind it. So go on and try to discover new things. So the conclusion is you need to actually perform things practically. You need to make sure that you are not only getting the theoretical knowledge, you need to perform it practically. That's why I always say that side by side when I'm executing these practicals, you need to do that as well. Although you might find it pretty basic, but with the help of this knowledge, you can perform a lot bigger tasks as well. All right, so Janice looks happy now. So let us move forward with our slides. So now comes the axis concept here, guys. It is pretty similar. We have a numpy array which looks like this, and the rows are called axis 1 and columns are called axis 0. Now you must be thinking, what is the use of this axis? Suppose if you want to calculate the sum of all the rows, then you can actually use these axes and you can do that. Now let me show you practically how it happens. I'm going to open my PyCharm again and I'm going to show it to you. Let me remove this and let me add one more element here. 3, 4, 5. All right. So if I want to find the sum of axis 0, it's very easy. Just go on and type print a dot sum and type in axis equal to 0. Go ahead and print this and you can see 4, 6 and 8. 1 plus 3 is 4. 2 plus 4 is 6. Similarly, 3 plus 5 is 8. If I make this as axis 1 and print this, so it gives me 6 and 12 because 3 plus 2 plus 1 is 6. Similarly, 4 plus 5 plus 3 is 12. So this is pretty easy, I know. Now let us go back to our slides and see what are the other operations. So there are many mathematical functions that you can perform with numpy. That is to find the square root of each element. You can even find the standard deviation. So these two operations can be performed with the help of numpy. You can find the square root, you can find the standard deviation. Now let me show you that how you can do it. This is my PyCharm again. So now I'm going to remove this print statement here. And I want to print the square root of each of the elements that are there in my numpy array, which is actually assigned to a variable a. So I'm going to type in here print np dot sqrt, that is square root of my numpy array a. Go ahead and execute this, and it has actually printed the square root of each of the elements. The square root of 1 is 1, for 2 it is 1.414, for 3 it is 1.73, again for 3 it is 1.73, then for 4 it is 2, then for 5 it is 2.23. This is how you can find the square root of each of the element. Now when I talk about standard deviation, so you can find that by typing here. So now if I want to find the standard deviation, what I need to do is instead of sqrt, I'll just type in here std, and it'll give me the standard deviation, that is how much each element varies from the mean value of my numpy array. And this is the standard deviation, guys. It's that simple. So this is how you find standard deviation. Now let us go back to our slides and see what are the other operations that are still left. Now these are the basic mathematical functions that you can perform with numpy arrays, like addition, multiplication, subtraction and division, and that will actually happen element wise. So basically you are performing matrix addition, matrix multiplication, matrix division, as well as matrix subtraction. Let me go ahead and show it to you practically. It is very simple, guys. So similarly I'm going to define one more array and let me name it as B. Let me remove this print statement. Now if I want to calculate the sum, so what I need to do is I need to type in print a plus b. That's all you need to do. But when I talk about list, again I'm telling you that when I talk about list, if I do that, it will concatenate both the lists. So if I want to print list, that is the addition of two lists, I need to use for loop. So that is where numpy array stands apart, and it is pretty convenient. Go ahead and execute this and you'll see that element wise addition has happened. 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6. Similarly 3 plus 3 is 6, then 4 plus 4 is 8, 5 plus 5 is 10. Alright, so this is how you can perform addition. You can perform subtraction by using the subtraction operator. Go ahead, execute this and you'll find all zeros because 1 minus 1, 2 minus 2, 3 minus 3, 3 minus 3, 4 minus 4, 5 minus 5 will be 0 only, right? No rocket science. Now go ahead and multiply it as well and see what happens. So you have 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9, again 3 into 3 is 9, 4 into 4 is 16, 5 into 5 is 25. If I go ahead and divide this, it'll give me all ones, and yep, it does. So this is how you can actually perform addition, subtraction, multiplication and division using a numpy arrays. Now let me go back to my slides and see what are the other operations present. So now guys, let me tell you one more thing. If I actually want to concatenate two arrays, I don't just want to add those two arrays. You can say that if my one array is a box, then I want another array on top of it. So let me show you how you can do that. Actually, there are two ways to do that. One is called vertical stacking and another is called horizontal stacking. Let me show it to you one by one. First, I'm going to show you vertical stacking. For that, what I need to do is print np.vstack and a comma b. Let us see what happens when I run this. So we have 1, 2, 3, 3, 4, 5. Then again we have 1, 2, 3 and 3, 4, 5. So this is called vertical stacking. If I want that horizontally, I'll just write in here hstack and I'm going to run this now. And you can see that we have 1, 2, 3. Then again 1, 2, 3. That means these two are present added horizontally. And we have 3, 4, 5. Again we have 3, 4, 5. So this is how you can perform stacking as well. Now there's one more thing that I want to show you. If I actually want to convert this particular numpy array, that is A, to say a single column. So how I can do that? Just type in here print a dot revel. That's all you have to do. Go ahead and execute this. So you'll have 1, 2, 3, 3, 4, 5. So you have 1, 2, 3, 3, 4, 5. Let me go back to my slides and see what are the other topics that we are going to cover. Now come certain numpy special functions. Now I'm going to talk about sine function and cosine function first. Now I hope all of us know what is a sine function and what is a cosine function. So what I'm going to do is I'm going to use this cosine and sine function and I'm going to plot sine and a cosine graph. So for that I'm going to import a module called matplotlib. So you don't need to worry about that module because I'm going to discuss about matplotlib in the upcoming sessions. So there'll be a detailed session, especially on matplotlib, so you don't need to worry about what exactly matplotlib is and how it works and all those things, because that'll be covered in the upcoming session. For now, what we are going to do, we are just going to use sine and cosine function in order to print their graph. So for that, I'll open my PyCharm and let me remove this and import matplotlib dot pyplot as plt. Now we are going to define two coordinates, that is x and y. First, x is equal to np.arange 0, 3 into np.py, 0.1. Now I'm going to define y. So for that I'll type y np.sin x. Now I'm going to use PLT in order to plot the graph x comma y. Now finally show the plot. For that I'll type plot.show. You must plot.show to make a graphics appear. So plot.show and here we go. Go ahead and execute this and you might be able to see a graph and yep, it is here. Similarly, what if I change the sine to cos and should give me the cosine graph? Go ahead and run this and you can see we have a cosine graph as well. Similarly, if I write in here tan, that is any other trigonometric function, and I print this, so I get the graph for tan as well. So any doubts still here, guys? No doubts, fine. So I'll open my presentation once more and we are going to see what are the other special functions that we can use with numpy. Now numpy comes with two very good functionalities, I would say, that is called exponential function and logarithmic functions. Now exponential, this e value is somewhere equal to 2.7 and we all know log. So when I talk about log, it is actually log base 10, and when I'm talking about natural log, that is log base e, I will write it as ln. So instead of that I've written log, that means log base 10. So you can perform these operations with the help of numpy. Let me show you how you can do that. So I'll open my PyCharm. Let me remove this and I'm going to define a numpy array. Let it be ar equal to np.array 1, 2, 3. Now I want to calculate the exponential value. I'm going to throw in a print statement and I'm going to write in here np.exp ar
and this will calculate the exponential value for me, and let us see if it does that or not. So yep, as I've told you earlier as well, value of e is 2.71. So e to the power of 1 is actually equal to e, so it has returned the e value, but e to the power of 2 will be somewhere equal to 7.38. E to the power of 3 will be somewhere equal to 20.0855. Now, in order to calculate log, what you can do is you can just type in here log. Now, this will give you natural log. So when I talk about natural log, it is nothing but ln, or you can say log base e. But if I want to calculate log base 10, so I need to type in here 10. First, let me show you how you can find the natural log. Just go ahead and execute this. All right. So when I talk about 1, so e to the power of 0 will be equal to 1, right? So log or ln AR equals to 0. Similarly, the other values as well. Now, if I want log base 10 instead of ln, or you can say natural log, I can just write in 10 and go ahead and execute this, and you'll find log base 10 values. So obviously when answer is 1, that means anything to the power of 0 is equal to 1. So the answer will be 0 here, and similarly we have other answers as well. If you're unsure about it, you can open your calculators and do that.
Mathematics and scientific research are definitely the ruling domains in every era, and to solve all the problems contained in them is SciPy. And in this session, you'll be learning how to use the SciPy library of Python. So if you have love for numbers, this is where you have to be. Before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards this session, we shall first begin with a small introduction to SciPy and the difference between NumPy and SciPy. Following that, we shall take a look at the sub-packages present in SciPy and then take a deeper look at each of them, starting with basic functions, followed by special functions, integration functions, Fourier transforms, linear algebra, and interpolation functions. So let's move on towards the first topic, which is what exactly is SciPy. SciPy is an open source Python library which is used to solve scientific and mathematical problems. It is built on NumPy extension and allows users to manipulate and visualize data with a wide range of high-level commands. As mentioned earlier, SciPy builds on NumPy, and therefore if you have to import SciPy, there is no need to import NumPy. So now you'd be wondering, what is the difference between NumPy and SciPy? Both NumPy and SciPy are Python libraries used for mathematical and numerical analysis. NumPy contains array data and basic operations such as sorting, indexing, etc., whereas SciPy contains all the numerical code. Though NumPy provides a number of functions that can help resolve linear algebra, Fourier transforms, etc., SciPy is the actual library that contains full-featured versions of these functions. However, if you're doing scientific analysis using Python, you'll have to import both the NumPy and the SciPy libraries. Okay, so now let's move on and take a look at the sub-packages present in SciPy. SciPy has a number of sub-packages for various scientific computations. As you can see on the screen, the cluster sub-package is available for clustering algorithms. Constants deals with physical and mathematical constants. Similarly, FFT-Pack is for fast Fourier transform routines, Integrate for integration and ordinary differential equations, Interpolate for interpolation and smoothing splines, etc. For a detailed description on each of these, you can follow the official documentation. So now let's move on and take a look at the basic functions that you can use over here. Since SciPy builds on NumPy, you can make use of NumPy functions itself to handle arrays. To know in depth about these functions, you can simply make use of help, info, or source functions. The help function returns information about any function or a keyword or class, etc. Now this function can be used in two ways. One is without using any parameter, and the second is using a parameter. I'll be showing both these methods to you in a while. Similar to the help function is the info function. This function also returns information about any function or a keyword, class, etc. The source function, on the other hand, returns the source code only for objects written in Python. This function does not return useful information in case the methods or objects are written in any other language. So now let's move on towards a Jupyter Notebook and see how you can make use of these functions. Okay, so first let's take a look at the help function. Like I've already told you all before, the help function can be used in two ways. One is by supplying a parameter, and the second is to use it without any parameters. I'll be showing you all both these methods. One thing I want you all to note is that all sub-packages present in SciPy need to be imported exclusively prior to using them. So in case I have to use the cluster package, I'll have to import it exclusively from the SciPy library. So for that, I'll have to type from SciPy import cluster. And then I'll hit run. Okay, so now making use of the help function to retrieve information about this sub-package. All I have to do is type help, and within that, type cluster and hit run. So as you can see, all the necessary information about this sub-package has been returned by the help function. So now, if I want to use the help function without passing any parameters, all I have to do is type help and hit run. So as you can see, it's asking me to enter the name of any module or a keyword of which I want to retrieve information. So here, I'll just type scipy.cluster. So as you can see on the screen, it has returned all the necessary information about this sub-package. Now, in case you want to stop this function from execution, all you have to do is type quit and hit enter. So now, if I want to use the info function, all I'm going to do is import scipy and then type scipy.info and pass the name of the package as cluster. Now I'll hit run. So as you can see, this function has also returned the necessary information about this sub-package. Same is the case with the source function. All I have to type is scipy.source and pass the parameter as cluster. Please make a note that every time I'm using the cluster keyword only because I've imported this package. If I use the name of any other package without importing it, it's going to throw an error. So now I'll hit run. Okay, so I hope you've understood how these three functions work. Okay, so now let's move on towards the next topic, which are special functions. SciPy provides a number of special functions that are used in mathematical physics. These functions can be anything such as convenience functions, gamma functions, beta functions, etc. In today's session, we'll take a look at the exponential and trigonometric functions which are present within the convenience functions. SciPy provides two functions using which you can compute 10 power x or 2 power x, where x can be any integer. Okay, so now let's jump onto our Jupyter Notebook and see how these functions work. So the first thing I'm going to do is create a heading over here. And I'll name this as special functions, or I'll just say special. Now I'll have to import this package from the SciPy library. So I'll use from SciPy import special. After this, I'll take any variable, say a, and I'll type special.exp of 10, which is to compute 10 power x. And for the value of x, I'll write 2, and then I'll just print a. Sorry guys, I had to type special.exp of 10. So as you all can see on the screen, this function has returned the value for 10 power 2, which is 100. Similarly, if I have to calculate the values of 2 power x, I can make use of the exp2 function. So all I'm going to do over here is take another variable, say b, and then I'll type special.exp of 2, and the value I'll pass as 3. Then I'll just print b and hit run. So as you can see, I've got the output for 2 power 3, which is 8. SciPy provides a number of functions that deal with trigonometry. Using these functions, you can calculate anything such as sine, cos, tan, etc. So now let's get back to our Jupyter Notebook and see how this works. Okay, so I'll take another variable, say c, and then I'll use the sine theta function over here. I'll take another variable, say c, and then I'll calculate the sine value of 90 degrees. I'll use the sine dg function, and I'll pass the value as 90. After this, I'll just print c. As you can see, the sine value of 90 degrees is 1. Similarly, you can also use the cos dg function. So I'll just change the name from sine to cos over here and then hit run. Okay, so as you can see, it has returned the value for cos 90. So I hope everyone's clear till here. In case you have any doubts, please do let me know in the chat box and my team is here to help you. So now let's move on and take a look at some of the integration functions that are present in SciPy. Integration is a way of adding slices to find the whole. It can be used to find areas, volumes, central points, etc. In today's session, we'll be seeing how to solve general and double integration problems. SciPy provides a function named quad that can calculate the integral of a function which has just one variable. The limits can range anywhere between plus and minus infinity. So now let me jump onto my Jupyter notebook and see how this function works. I'll just create a heading over here. So before I make use of the quad function, I'll have to import the integrate submodule from the SciPy library. And to do this, I'll type from SciPy import integrate. After this, I'll use the help function to retrieve information about the quad function present in the integrate module. As you can see over here, it has returned all the necessary information about this function. The quad function basically takes another function as a parameter and a and b, which are the lower and the upper limits. All the other parameters are optional and you can try them out by yourself. Okay, so here I'll take a variable, say I, and then I'll type scipy dot integrate dot quad, the name of the function. And the first thing I'll have to do is pass a function as a parameter. So I'll just use a lambda function. So I'll just type lambda of x and I'll compute the exponent of 10 for this x. So I'll type special dot exp of 10, which is the name of the function, and the parameter of this will be x. So this was our first parameter. And now I'll have to pass the lower and the upper limits. So I'll just say 0, 1, and then I'll just print I. Okay, so I hope you all are clear till here. Now let's get back and see how we can solve double integration problems. A double integral, as many of us know, consists of two real variables. To compute this, you can make use of the dbl quad function, which will take the function to be integrated as its parameter, along with 4 other variables which define the limits and the functions dy and dx. So to make use of this function, all I'm going to do is take some variable, say e, and to this, I'll just assign a lambda function, and I'll pass any expression of my choice. So I'll just say x star y part 2. Now I'll take another variable, say f, within which I'll store another lambda function, and to this lambda function, I'll just take one argument. Now I have to define another variable. I'll name it as g, and then a lambda function again. Now I'll just make use of the double integral function. So integrate dot dbl quad, and I'll have to pass the parameters starting with e, and then the limits. I'll just say 0, 2, and then the functions f and g. Okay, so as you all can see, this function has returned the value of the double integral. I hope everyone's clear till here. So now let's get back to our presentation and take a look at some of the Fourier transform functions present in SciPy. Fourier analysis is a method that deals with expressing a function as a sum of periodic components and recovering the signal from those components. To calculate this, you can make use of the FFT function and the IFFT function, which return the discrete Fourier transform and the inverse Fourier transform of a real and complex sequence. So now, let's move on and see how this works. The SciPy subpackage that contains these functions is the FFT pack. So from scipy.fft pack, I'll import FFT and IFFT function. And now I'll just import the NumPy library as np. Sorry, I made a spelling mistake over here. It's NumPy. And then I'll just take a variable x within which I'll store a NumPy array with some random values. I'll take another variable, say y, within which I'll store the Fourier transform of x. So I'll just say FFT of x and then print x. Sorry guys, I wanted to print y and I printed x by mistake. Okay, so as you can see, I've got a list containing the Fourier transform of x. In case you want to find the inverse of it, all you have to do is use the IFFT function and hit run. Okay, so as you can see, the IFFT function has returned the inverse Fourier transform of x. So I hope everyone's clear till here. In case you have any doubts, please do let me know in the chat box and my team is here to help you. So the next topic that we'll be covering in this session is linear algebra. Linear algebra deals with linear equations and their representations using vector spaces and matrices. SciPy is built on Atlas, LAPACK, and BLAS libraries and is extremely fast in solving problems related to linear algebra. In addition to all the functions present in the NumPy library, SciPy also provides a number of other advanced functions. Also, if NumPy is not used along with Atlas, LAPACK, and BLAS support, SciPy is much faster compared to NumPy. So now let's move on towards our Jupyter Notebook and see how to solve linear algebra problems. Okay, the example that I'm taking over here is finding the inverse of a matrix. Mathematically, the inverse of a matrix A is a matrix B such that A star B is equal to an identity matrix. An identity matrix is a matrix consisting of ones down the main diagonal. To compute this, you can make use of the INV function present in SciPy. To do this, I'll just take a variable, say A, and within this, I'll just store a NumPy array, and this time I'm going to create a two-dimensional array. I'll just pass some random values. And I'll store the inverse of A in B. Finally, I'll just print B. Oh, one thing I forgot to do over here is import the submodule. So I'll just type from SciPy, import linalg, and then I'll hit run. Okay, as you all can see, I've computed the inverse of A using the INV function. So now let's get back to our presentation and take a look at the final topic of this session, wherein we'll take a look at the interpolate subpackage of SciPy. In the field of numerical analysis, interpolation refers to constructing new data points within a set of known data points. The SciPy library consists of a subpackage named scipy.interpolate that consists of spline functions and classes, one-dimensional and multi-dimensional interpolation classes, etc. In today's session, I'll be showing y'all how you can solve univariate interpolation problems. Univariate interpolation is basically an area of curve fitting which finds the curve that provides an exact fit to the series of two-dimensional data points. To do this, you can make use of the interp1d function present in SciPy. So I already have a code for this. I'll just copy it and I'll paste it over here. So as you can see, I'm making use of the interp1d function to find x1 and y1 which range between x and y. So all I'm going to do is hit run. So as you all can see, x1 and y1 have been computed between x and y.
In today's session, we'll be focusing on data analysis with Python. So let us move forward and have a look at the agenda for today. So first we'll see various applications of Python. After that, we'll understand the data lifecycle starting from data warehousing till data visualization. Then we'll focus on data analysis and we'll see how we can use Python for that purpose. We'll also look at what is Pandas library, and we'll also understand a bit about NumPy and SciPy. Then we'll focus on various Pandas operations, merging, joining, all those things. And we'll see after that Python for statistics and Python for Hadoop. So we'll move forward and we'll see what are the various applications of Python. So these are the applications of Python. I have listed down only 4 of those, although there are many more. So you can perform web scraping with Python. That is, you can extract certain contents from a particular web page. You can perform a web development. You can perform testing, as well as you can perform data analysis. So for today's session, we'll be focusing on a data analysis part of Python. So guys, let us move forward and see what exactly is data lifecycle. So this is the data lifecycle, guys. Over here, what happened, data is stored in different formats. We have a CSV file, we can have an Excel file or an HTML file. So data is basically stored in different formats. Now what do? You actually convert that data or transform that data into a single format and you store it somewhere. That's where data warehousing comes into picture. Now once you have stored your data, you can perform certain analysis on it. You can perform predictive modeling, you can join, merge data, so various other things that we are going to see in today's session. Now once you have done the analysis, you can even plot it in the form of a graph, and that stage is called a data visualization. So this is just a general overview about data lifecycle, and in today's session, let me tell you guys, we'll be focusing on only data analysis here. So let's move forward and understand what exactly is data analysis. So what is data analysis? So let us understand data analysis with the help of an example that is there in front of your screen. Over here, what happens, we have a data set in which we have data about the unemployed youth across the globe. So country-wise, from 2010 to 2014, the percentage of youth that is unemployed within that particular country, we have data about that. Now what if I want to find only for a particular country, say Afghanistan in this example, and in that particular country I want to find the unemployed youth between 2010 to 2011. Or you can say percentage increase in the unemployed youth in Afghanistan between 2010 to 2011. Now what should I do? So basically what I need to do is, in this particular data set, I need to perform certain analysis. That analysis should give me the percentage increase in unemployed youth in Afghanistan between 2010 to 2011. So this basically explains what is data analysis and why we use it. So let us move forward and understand how you can actually perform data analysis with Python. So basically, to perform data analysis with Python, you need to import a particular module which is called Pandas. So let us discuss about Pandas in the upcoming slides. What is Pandas? Pandas is a software module written for Python programming language which is used for data manipulation and data analysis. Now it can perform that at a fairly high performance rate when it is compared to other Python procedures. Now we can say that Pandas is actually built on top of NumPy, SciPy and Matplotlib. Matplotlib is basically a data visualization module that we use in Python. Now when we talk about NumPy and SciPy, NumPy is actually a fundamental package for scientific computing in Python. So it contains a powerful n-dimensional array object, it has tools for integrating with C, C++, and it is very useful in performing linear algebra, Fourier transform, random number capabilities, etc. When I talk about SciPy, SciPy is again an open source Python module used for scientific computing and technical computing. SciPy contains module for optimization, linear algebra, integration, interpolation, special functions, Fourier transforms, all those things, right? We'll actually focus on NumPy and SciPy in the next session. For this session, we'll be only focusing on Pandas. And we have a separate session on Matplotlib as well, where I'll teach you exactly how to perform data visualization using Matplotlib. So I'll open my PyCharm and I'll actually tell you how to import this Pandas library and how to actually create a data frame. So for that, I'll open my PyCharm once. So this is my PyCharm, guys. So over here, what I need to do is I need to first import the Pandas module. So for that, I'll type import Pandas as PD. That's what they usually keep. So yeah, let's follow the protocols. And now what I'm going to do is I'm going to define a dictionary, say that contains the data about, say, my website. So we can have columns like day, visitors, bounce rate. All right. So let's go ahead with that. I'm going to name my dictionary, say, as XYZ underscore web. So over here, my first key will be day, and It'll actually include the days, so it'll have a list of days 1, 2, 3, 4, 5, and 6. Yeah. Now my next key value pair will be actually about visitors. So I'll write in visitors. So visitors in day 1, say we had around 1,000 visitors. Then we had 700. Then we had say 6,000. Then we had around 1K again. Then 400. And then say 350. Yep. So the next key value pair that I'm going to add is say bounce rate. Bounce rate is nothing but the number of people who have visited your website but have left your website immediately. So yeah, which is not good for any website. Bounce underscore rate. So bounce rate will be around say 20, again 20, second day also, make it 23, then say 15, 10, and 34. Yep. So now what I'm going to do is I'm going to close this dictionary. And now what I'm going to do is I'm going to convert this dictionary into a pandas data frame. Now how we do that? Let me first declare a variable, say df. And over here what I'm going to type in, I'm going to type in as pd for pandas, pd dot data frame, and the name of my dictionary, which is xyz web. Now go ahead and print this data frame and we'll see what exactly happens. So yep, it has converted our dictionary into a data frame. So what all columns we have? We have bounce rate, we have day, and we have visitors. So this is a very basic introductory example for you all guys in order to show you how to make data frames using pandas library. So I'll open my slides and we'll move forward and have a look at various operations that you can perform on pandas data frame. So these are the operations that you can perform with pandas data frame. You can slice the data frame. That is, if you want only a particular part of that data frame, you can do that. You can change the index value. You can convert the data into a different format. You can actually change the column headers. You can perform concatenation of multiple data frames. And you can even perform joining and merging of 2 or more data frames. These are all the basic operations that you can perform with pandas. So we'll move forward and have a look at these operations one by one. First, we'll look at slicing. So over here we have a data in which there is an index value which is nothing but the year 2001, 2, 3 and 4. Here we have interest rate and here we have US GDP in thousands. Now I want to slice a particular column from this particular data frame. So what will happen if I do that? It should only give me, so when I slice only the starting 2 rows, it will give me only till 2002. But when I slice the last 2 rows, it will give me only for 2003 and 2004. So this is how you can perform slicing. So let me show you guys practically how to do that. So this is our data frame guys, and over here if I only want say the starting 2 rows, so for that what I can do is instead of print df I can do it as print df dot head, and I want only the starting 2 rows, so I'll keep 2 here and we'll see what happens when I execute this. So yep, there are only 2 rows that are present. So this is how you can actually print only a part of the data. And if I want only the last part of the data, that is the last 2 rows. So what I can do is I can convert this to tail instead, and we can do that as well. Go ahead and execute this, and yep, you can see that it has printed the last 2 rows. So this is how you can perform slicing. So I'll move forward and we'll look at the other operations that you can perform with pandas. After slicing, we are going to talk about merging. So what is merging? Let me explain you that with the help of an example that is there in front of your screen. So over here we have 2 data frames, and in one data frame we have index values from 2001 till 2004, and in another data frame we have index values from 2005 to 2008. Now what happens when I merge both of these data frames? Let us see what happens. Now these 2 data frames can be merged together to form a single data frame, and we can actually make sure what all columns that we need to keep common. So over here we have common columns as HPI, interest rate and index. But when I talk about GDP, we have 2 US GDPs, one is X and another is Y. So this is how actually you can perform merging. You can actually make sure what all columns you want in your final merged data frame. So I'll open my PyCharm once again. So this is my PyCharm again guys. I'm going to show you the merge operation. So for that what I need to do is I need to import this pandas module. So for that I'll type in import pandas as PD. And now what I'm going to do is I'm going to define 3 data frames. Let me name it as df1, and over here what I'll type in pd dot data frame, and I'm going to use a tuple, and inside the tuple I'm going to define a dictionary, and I'll be using multiple lists inside that dictionary. So the first key that I'll use is HPI, house pricing index, and the value that I'll assign it to HPI is a list, and in that list I'll place certain values. So let it be 80, 90, 70, 60. Alright, so now I'm going to define one more key, and I'm going to name it as interest underscore rate, and the value that is assigned to this is a list which contains the interest rate. So I'll type in 2, 1, 2, 3. Now I'm going to define one more key, and I'm going to name it as, say, IND underscore GDP. And now I'm going to define a list here. So for that I'll type in the values 50, 45, 45, 67. Alright, so what I'm going to do now is I'm going to close this dictionary, and I'm going to define the index values. So for that I'll type in as index equal to whatever the values that I want in my index. So I just want the year, so I'll type in 2001, 2002, 2003, 2004. So this is our first data frame. In our second data frame also we'll do something like similar to this. I'll type in pd dot data frame, open and close parenthesis, and over here I'm going to define the same key value pair, that is HPI. Let me copy it. Alright, so we have HPI. Now I'll define one more key value pair, and that is interest rate. So again I'm going to copy this whole thing, and I'm going to paste it here. And the same India's GDP also I'm going to copy in, and I'm going to paste it here. Now as I've done in the previous data frame as well, I'm going to define the index values. For that I'll type in index equal to a list, and my index values will start from 2005. So I'll type in 2005, 2006, 2007, 2008. I forgot the comma here, so yeah, comma, and now we have 2 data frames. So now what I can do is I can go on and merge these 2 data frames. So for that what I'll type in, I'll define one variable, say merge equal to pd dot merge, and the data frames, that is df1, df2. Now go ahead and print merge, and we'll see what happens. Print merge. Go on and print this. So as you can see that we have merged the 2 data frame, that is df1 and df2, and we have got one single data frame. Now what if I don't want to keep certain columns as common when I perform the merge operation? So what I can do is I can write in the columns that I want to keep as common. So suppose if I want only the HPI column to be common, so I'll just type in here on HPI, and when I go ahead and print this, so as you can see only this particular column is common, that is HPI. Rest everything we have 2 different columns for that, that is India's GDP, that is X and Y. Again we have interest rate as X and Y. What I'll do, I'll again open my slides, and we'll see the other operations that you can perform with pandas. So we saw merging operation right now. Let us move forward and have a look at the next operation, that is joining. So in joining what happens, the 2 data frames are joined on the basis of their index values. So let me show you that. So we have 2 data frames, one is this and another one is this. So over here what happens when we join both of these data frames? So let us see what happens. As you can see that by joining these 2 data frames we get this one single data frame. Now one thing to notice here guys, as I've told you earlier as well, joining happens with the index values. So over here you can see that we don't have any index called 2005. Over here as you can see that we have no index, that is 2005. But after joining, the 2005 index appears in the data frame, but there is no interest rate or US GDP thousands associated with it. Similarly, when I talk about the data frame 2, that is the second data frame, over here we don't have any 2002 index value. So the value with respect to 2002 will be NAN, and for unemployment also it will remain as NAN. Now you must be wondering what is NAN. So when there is no value attached to a particular index, it writes this as NAN, that means not a number. So let me practically show you how to perform joining. I'll again open my PyCharm and we are going to perform join operation in that. So this is my PyCharm, guys, and over here I have two data frames, df1 and df2, which I actually used in order to show you the merge operation. Now for join operation, what I'm going to do is I'm going to remove this HPI key value pair from the dictionary, and same I'm going to do it for the second data frame as well. And instead of interest rate, I'm going to write in here as low tier HPI, low underscore tier underscore HPI, and certain values to it. So yep, I'm going to type in here as 50, 45, 67, 34. And instead of India's GDP, I am going to type in here as unemployment and certain values to it. So I'm going to name it as 1356, sorry. All right, XYZ, anything, doesn't matter. Now let me just change these index values. So I'm going to type in here as 2001, 2003, 2004, and yeah, let this be 2004 only. And now what I'm going to do is I'm going to type in joined equal to df1 dot join df2 and print joined. Let's go ahead and execute this and see what happens. So over here what happens in 2002, we have no values that is attached to lower tier HPI and unemployment. So it has actually printed NAN, that is not a number. And in 2004 we actually have both the values available. So it has printed that. So I'll again open my slides and we'll see the other operations that we can perform with pandas. So we saw exactly how to join two data frames, and let us move forward and see what is the other operation. Now we are going to change the index and column headers. Now let us see how this actually happens. So we have two data frames here. So one contains index, interest rate and US GDP in thousands. Another has index as the year, and we have only US GDP thousands. There is no interest rate here. So what happens when I change the column headers or I change the index? So over here, as you can see, I've changed the index value as the interest rate, and I've changed the column header as GDP instead of US GDP in thousands. So don't worry guys, I'll actually open my PyCharm and show you practically how to do this. Now first what I'm going to do is I'm going to remove all of this and I'm going to define one data frame, let it be df. And now over here I'm going to type in key value pairs in the dictionary. So first of all I'll write in say day, and inside that I'll type in 1, 2, 3, 5 or 4. Now one more key value pair, so I'll type in here as visitors. So in day 1 we had around 200 visitors, then we had 100 visitors, then 230, and then we had 300 visitors. 230 and then we had 300 visitors. And now give a one more comma and I'm going to define one more key value pair. So for that I'm going to use the key as bounce rate, and I've already explained you what exactly bounce rate is. So I'm just going to type in the values 20, 45, 60, 10. Alright, so we have this particular dictionary. So in that dictionary, let me convert this to a pandas data frame. For that I'll type in pd.dataframe and it'll convert this to a data frame. Let me open and close parentheses, as I forgot. I'll convert this O to a lowercase o. And yeah, I have made a mistake in the syntax. So it actually has open and close parentheses. I need to add E also here. Now go ahead and print this. So we have got this particular data frame. Now I want to change this index value. Say I want day here to be my index value. So for that what I can do is I can type in here as df.set underscore index, and I want my index to be day, and that's it. Now go ahead and print this and we'll see what happens. And over here I need to type in here as in place equals to true. Now when I go ahead and print this, as you can see, day has become my index value. So this is pretty easy guys. So you just need to set your index value whatever you want and you can get that data frame with it. Now my next task is to convert one of the column headers. So say instead of day I want to convert it to date. So let me first remove this. So now I want to convert one of the column headers. So for that what I can do is df So as you can see, we have successfully changed the index value to day. I can even plot this. So for that, what I need to do is I need to just import one more library, which is matplotlib. I'll have a separate session on matplotlib, so you don't need to worry much about it. Matplotlib.pyplot as plt. Now import from matplotlib, import style. Import style. All right. And now what I'm going to type in here, I'm going to type in style.use 538. Yep, I'll keep it as 538. And now I'll remove this print statement. Now what I'm going to do is I'm going to type in df.plot plt.show. Go ahead and execute this. So we have got a graph in which the bounce rate is represented by the blue color line and the red color line represents visitors. So these are our index value, or you can say the day, and these are the values corresponding to that particular day. So this is how you can actually plot it. Now our next task is to actually change one of the column headers. So for that, what I can do is, first let me remove all of this. Now suppose if I want to change the column header from visitors to users. So how am I going to approach this task? Now what I'm going to do is I'm going to type in here as df equals to df dot rename columns equal to, I want to replace visitors with what I want to replace here. I can replace it with users. Now go ahead and print df, and you can see that column header has been changed. Instead of visitors, we have users now. So this is how you can actually change the column headers and index values. So I'll open my slides again and we'll see what are the other operations with pandas. Concatenation. So you have a student data in which you have name, age, sex and phone number. Now you want to add email address to this particular data. So you can perform concatenation and add the email address field at the end of this particular data. Don't worry guys, I'll actually show you practically how to perform concatenation. So this is my PyCharm guys. So in order to show you concatenation, I'm going to paste the two data frames that I have created earlier. I don't want to type it again because it's going to take a lot of time, so I'm just pasting it. Now in order to perform concatenation, I'm going to declare a variable, say concat equal to pd dot concat df1 comma df2. Go ahead and print this and we'll see what happens. So yep, as you can see that we have concatenated the two data frames. So the index values are from 2004 for the first data frame, and then it starts from 2005 to 2008 for the second data frame. So as you can see that concatenation has been successfully performed. So we have index values from 2001 to 2008, and for the first data frame it is till 2004, and for the second data frame it starts from 2005 till 2008. So this is how you can perform concatenation. So I'll again go back to my slides and see what is the next operation that we are going to see. Now comes data munging. So data munging basically means that you can actually convert a particular format of data into a different format. So if you have a data which is in say CSV file, you can convert that to an HTML. Similarly, you can perform that operation with the other data formats as well. So let me actually show you that. I'll again open my PyCharm. So this is my PyCharm guys. So let me first remove all of this, and I'm going to actually read a CSV file which is there in my system. Locally it is present in my system, so I'm going to read that file. So for that, what I'm going to do is I'm going to type in this. This is nothing but I have defined a variable country, and in that country what I'm doing is I'm using the pandas module in order to read the CSV file which is present at this particular location. And finally, this index underscore call equals to 0 actually makes sure that I have no index present in that particular data frame. That's all. So now what is the operation that we are going to see here? We are going to convert the CSV file into an HTML file. So for that, what I'm going to type in country dot to underscore HTML, open close parenthesis, and I can say edu.html. Now go ahead and execute this and we'll see what happens. And I'm going to open my projects folder. As you can see that edu.html is added. When I click over there, it gives me the HTML code for that. Now what I can do, I can copy this path and I'm going to open my browser and I'm going to paste that path and we'll see what happens. Yep, so we have got this particular HTML table. So it was in CSV format, we converted this to an HTML format. So this is how you perform data munging with pandas. So we'll be more specific and we'll see a use case in which we have the data about the global youth unemployment. And let me show you how it looks. I'll open my slides again. So we have a data set in which we have the percentage of unemployed youth globally. So for every country, we have the data of the percentage of unemployed youth from 2010 till 2014. So what is the problem statement for this particular case study? Let us move forward and see that. So basically, I want to find the change in the percentage of unemployed youth for every country from 2010 to 2011. So what I want to see how the trend is. What is the percentage change between 2010 to 2011 for every country? So we'll see that. First, let me show you how the data set looks like. So it looks something like this. We have the country name, then we have country code. For then 2010, the percentage of unemployed youth. Same goes for 11, 12, 13 and 14. So this is how our data set actually looks like. So this is how our data set looks like. We have the country name, then we have the country code. And then over here we have in 2010, the percentage of unemployed youth, for similarly for 11, 12, 13 and 14 as well. So let us move forward and actually perform this data analysis in which we are going to find out the percentage change in the unemployed youth between 2010 to 2011. So for that, again, I'll open my PyCharm. So let me first remove all of this. So now I already have the code in order to do that. So what I'm going to do is I'm going to paste it and I'm going to explain you what exactly I'm doing. So this is the code, guys. Over here, first I've imported a couple of libraries. I wanted pandas. I've imported pandas, matplotlib for visualization, and the style is 538. Let me tell you guys, you don't need to worry a lot about visualization because I'm going to teach you visualization in detail in the upcoming sessions. So for now, just focus on pandas and the various operations that we can perform with it. Now I've defined one data frame, that is country. And this is pd read.csv, which is present in this particular path. So I have my data set which is present in this particular path. And then what I've done, I've made the index value as 0. That means I don't want any index. That's all. After that, I've defined one more data set, df, in which there will be only the top 5 values of the particular data set. That means it will contain only the first 5 rows of the data frame country. After that, what I have done, I have defined an index value, that is country code. I only wanted country code to be my index value. And after that, I have defined one more data frame, SD, in which I want to re-index the columns. That is, I want only 2010 and 2011 to be my columns. That's all. So let me first show you how this SD data frame looks like. Let me comment this first. And I'll show you how SD looks like. So yep, as you can see, we have the index value as country code and we have only 2010 and 2011 column headers. That is only for the 5 rows. Alright, so this is how my SD data frame looks like. Now let me uncomment these lines and I'll remove this print statement. Now after that, what I've done, I've defined one more data frame, DB, which is nothing but the difference of index difference between the two columns, that is 2010 and 2011. So that will actually give me the percentage change in each and every country between 2010 to 2011 in the percentage of unemployed youth. So after that, I'm using a bar plot. So finally, I've just shown it with the help of a graph. Let me show you how this looks like. I'm going to run this and we'll see what happens. So yep, this is a graph. Over here, as you can notice, in Afghanistan between 2010 to 2011, there has been almost a rise of 0.25% of unemployed youth. And when I talk about AGO, that is Angola, in that there is a negative trend. That means the percentage of unemployed youth in Angola has been reduced. When I talk about Albania, in Albania it has increased. That is from 2010 to 2011, there is an increase of around 1.25% of unemployed youth in the country. When I talk about Arab world, almost 3.1% of increase is there in terms respect to percentage of unemployed youth between 2010 to 2011. And for ARE, that is United Arab Emirates, there has been no change. That means in 2010 and 2011, there were exactly the same percentage of youth that was unemployed. Now over here I can perform multiple operations as well. Say if I want to find out this for 2011 and 2012. So I can just keep it that way and I can just go on and run this. So as you can see here in Afghanistan between 2011 to 2012, the percentage of unemployed youth has went down by almost 1.25%. When I talk about Angola, there is no change. For Albania, it has increased around 1.5%. And it has increased to 1%. For United Arab Emirates, there has been no change. This is one example that I've shown you where we have performed an analysis on global youth unemployment data. This is just an introductory example, pretty basic example that I've shown you. There are a lot more things that you can perform with pandas. So we are going to discuss all those things in the upcoming sessions. But for now, this is what pandas is, and this is how you can perform data analysis. I'll open my slides and we'll see what it has to offer us. Now we are going to see how we can use Python for statistics. So I've shown you 4 basic operations that are mean, mode, median and variance. Let me explain you all of these terms. So what do you mean by mean? Mean is nothing but the arithmetic mean or the average value of a particular list or any particular sequence. When we talk about median, median is what? The median, the middle value. So there can be high median and low median. When we have a sequence in which there are odd number of elements, so at that time median will be the centermost value. But when we have even number of elements in a particular sequence, at that time we have high median and low median. In high median, what happens? The 2 center values, the higher value is taken as a median, and in low median, amongst the 2 center values, the lower value is taken as the median. When we only calculate the median for even number of elements, then the 2 centermost values, the average of those values will be taken as median. So I hope you are clear with what exactly median is. There's no rocket science behind it. It's pretty easy. Now when we talk about mode, mode means nothing but a value that has been repeated the most. So over here we can see that 1 has been repeated 4 times, 3 once, 4 thrice, 5 once, and 2 as also once. Now when we talk about variance, variance is nothing but what is the variation of each and every element in the sequence from the arithmetic mean. I am going to open my PyCharm and perform these things practically. So this is my PyCharm, guys. So over here what I'm going to do is I'm going to import certain modules. So I'll type in from statistics, import mean, and I'll type in print mean and the sequence. So I can type in 1 2 2 2 1 3 4 1 5 1 5. Now go ahead and execute this, and yep, it has given us the mean value or the arithmetic mean of the sequence that we have given. So now from median, I'm again going to import the statistics module, and from that import median. Print median and the sequence. So let it be 1 comma 1 comma 1 comma 2 comma 2. All right, let's keep it as 5 elements. So it'll print the centermost element, that is 1. As you can see here, 1 is here, that is at the 3rd position. We have 2 elements here and 2 elements here. So it has printed the centermost element or the middle element. Now instead of median, if I want to find in mode here, so for that I'll just type in mode and I'll change this to mode. Go ahead, execute this, and yep, as you can see, 1 has been repeated thrice, whereas 2 has been repeated only twice. So 1 has been repeated the most, so it becomes the mode. Now you can even find variance here. Variance, as I've told you earlier as well, it gives you the variation in the elements from the arithmetic mean. Go ahead, execute this, and yep, you can see the variation is 0.3. So this is how you can actually use it for statistics as well. So we'll move forward and understand how you can use Python with Hadoop. So I'll open my slides once more. So guys, you can use Python for Hadoop as well. Now what happens, you need to import a library called PyDoop, and you can write a MapReduce program in Python and process data that is present in HDFS cluster. Now let me explain to you with the help of flow diagram that is there in front of your screen. So you have some input data which is stored in your HDFS cluster across various data nodes. Now what happens, you write a logic in Python in order to process that data on the respective node managers where data is stored. Now this stage is basically called map phase, and it will produce some intermediate output. So how much ever node managers you have, you'll have that many outputs, and that will be given to our reducer. Now what happens in the reduce phase? So this reduce phase happens in the node managers. What will happen, whatever the output that comes from the map phase will be provided as the input to this reduce phase, and it will aggregate that and provide us with the output. Now I know you might not understand node managers, you might not understand data nodes, all those things. So we are actually going to discuss about this later in the upcoming sessions. So you don't need to worry about it right now, but I'm just giving a general overview, and I'm just basically telling you that you can use Python in order to process big data across the HDFS cluster, which is present across the HDFS cluster. In today's session, we'll be focusing on matplotlib module present in Python. So let us move forward and have a look at the agenda for today. First, we'll see why we need data visualization and what exactly is data visualization. After that, we'll understand matplotlib and various types of plots like bar plot, histograms, all those things. Then we'll get started with it, and I'll tell you how to plot each of these graphs using Python. So we'll move forward and we'll understand why we need data visualization. So why we need data visualization? Now let us take an example. Suppose you work in an organization as an analyst and you have made certain analysis. Now you need to show that analysis to your boss or your CEO, whatever. Now you can understand it by just looking at the Excel sheet and the numbers. But the other person is not an analyst. He's not that technically sound as you are. So what do you need to do? You need to present your analysis or your data in such a way that the other person can understand. And how you can do that? You can do that by representing it in the form of a graph. And it is a well-known fact that human brain can process information easily when it is in pictorial or graphical form. So that is one of the key reasons why we use a data visualization in order to understand the trend better and make better decisions. So let us move forward and understand one more reason why we need data visualization. Now basically it allows us to quickly interpret the data, like whatever the trend the data is showing us. Now basically it allows us to quickly interpret the data. So just by looking at the graph, we can understand what the data is about and what is the trend. But if you are not from an analytics background and you see just the Excel sheet, then it is very tough for you to understand it. So if it is there in the graphical form, you'll quickly understand it and you can experiment as well. Now what happens if you want to change certain variables and see what will be the outcome? So with the help of the graphical representation of your data, that will give you a very good idea as to what all variables are useful for you and what all variables are useless. You don't need to include in your analysis. In order to perform that experiment in an efficient and a quick way, you need data visualization. So guys, these were the two key reasons why we need a data visualization. So we'll move forward and understand what exactly is data visualization. So what is data visualization? So data visualization is nothing but the presentation of your data in a pictorial or a graphical format. Now why we do that? We do that in order to enable the decision makers of an organization to see the analytics presented visually so that they can grasp some difficult concepts or identify new patterns. You can use it to identify the areas that need attention or improvement in the organization. You can even use it in order to clarify which factors influence customer behavior. Now, it might depend on the season or anything else basically. Now, you can even use it to understand which products to place where. Now, this is very important, guys. Obviously, you won't be selling jackets or sweaters in summers, right? You won't be selling shaving cream to kids. So you should know what are your target audience and where you are selling your product and to whom are you selling your product. So that is one very important field where we need data visualization, and you can even use it to predict sales volume as well. Fine guys, so we have looked at a lot of examples for data visualization. Now let us understand the diagram that is there in front of your screen. So it basically tells you about how to find insights from your data. Now for that we need data visualization. It plays a very, very important role, and it is one of the major applications of data visualization in order to find insights in data. Now there's a process that has to be followed in order to do that. So it starts with visualize. The first step is visualize. So basically you understand what your data is. You visualize it in a form of a graph and you understand what that data is actually talking about. Now we'll take an example. Suppose you have a data set that tells you about the youth percentage of unemployed youth country-wise from 2010 to 2014. All right, so you have that data, then you visualize it. The moment you visualize it, you'll get to know that, okay, it's fine. This country has a lot of unemployed youth, whereas this country is doing pretty good. So accordingly, you just grasp it pretty easily when you visualize it. After that, you make certain analysis. Now, what sort of analysis? Suppose if I take the same example forward, if I want to find out the change in the percentage of unemployed youth between 2011 to 2010, so that will come under analysis phase. So I'll analyze it. After that, what comes is document insight. Now you have done that analysis, but what is the outcome of that analysis? Now I'll see what all countries are doing good. I mean, the percentage of unemployed youth have gone up and which country it has gone down, and from what all countries it is stable. There's no change. So we'll see that and make a document. After that, we transform our data set. Now there might be certain fields in my data that I don't need. So at that time, what I'll do, I'll transform my data set, I'll remove those fields, or there might be certain fields that I need and which is not there. So I'll add those fields. So accordingly, I'll transform my data set. And once I've done that, I'll again visualize it in order to understand what my data is now talking about. And this process will keep on repeating. So this is how you find insights in data, where visualization plays a very, very important role, guys. So we'll move forward and understand what exactly is Matplotlib. Now it is very important for us to understand as to how Matplotlib works fundamentally. Now it is pretty easy and pretty basic. You have some data, then your computer will draw that data to a canvas of some sort, but it is only in the computer's memory. Now once your computer has drawn that data, you can show that data. So this is so the computer can first draw everything and then perform the more laborious task of showing it on the screen. Very basic. I know you might find it pretty lame, but it is very important for us to understand how fundamentally Matplotlib works. So you have an example in front of your screen. So again, we have that data in which we have country-wise percentage of unemployed youth. And I've done some analysis and I've shown it graphically, the percentage change in the unemployed youth country-wise between 2010 to 2011. So this is how that plot looks like. It is nothing but a bar plot. Now there are various types of plots available. We'll have a look at few of those in the next slide. So we'll move forward and see what are the various types of plots. So I've listed down 6 types of plots. First is the bar graph, then histograms, scatter plot, pie plot, hexagonal bin plot, and area plot. We are going to plot all these things in today's session with the help of Matplotlib module. So we'll move forward and we'll get started with it. We'll write our first Matplotlib code. So here's the most basic code in order to generate one of the most simple graph. So let me explain to you this code. First of all, what I've done, I have imported PyPlot from Matplotlib as PLT. Then I'll use this PyPlot in order to plot the graph in the canvas. And then finally, I'll use this PLT, which is nothing but PyPlot, in order to show what we have got. All right. So pretty basic, guys. So what I'll do, I'll open my PyCharm and execute this practically. So this is my PyCharm, guys. So over here, I'll first create a Python file with .py extension, and I'm going to name it as first code. Now over here, I'll first import PyPlot from Matplotlib. So for that, I'll type from Matplotlib import PyPlot as PLT. Now this PLT is pretty much similar to NP that we were using in NumPy, if you can recall. So it is not mandatory to use PLT only. You can use whatever you want, but a lot of people use it as PLT, and I'll keep it that way. Now our next step is to plot our graph to the canvas. So for that, what I'll do, I'll type in plt.plot, and I'll write in here my X and Y axis values. So for X axis, I'll keep it as 1, 2, 3. Then for Y axis, I'm gonna add values such as 4, 5, and 1. So this will plot our graph in the canvas. Now final step is to show that plot. How we'll do that? I'll just type in here plt.show, and we'll execute this and see what happens. Run first code, and yep, this is how our first basic graph looks like. So with 3 lines of code, you have got this graph. So we'll move forward and we'll see how to actually add title labels to our graph. For that, I'll open my slides once more. So now, of course, there are some problems with our graph. First off, we have actually learned in school that we are supposed to put labels on each axis. And we need to also add a title to our graph. It actually doesn't make sense. Our graph doesn't make sense if there are no X and Y axis labels and a title. So you don't know what is axis, you don't know what is X axis, you don't know what is Y axis, and what is the graph about. Plus, in terms of programming, it is very unlikely that you'll be actually filling in data to the plt.plot function. Now over here, you can notice that we are actually filling in data like 1, 2, 3, 4, 5, 1. Instead, you will be passing variables into it. All right. So it should be something like plt.plot, and you can say X, Y if you have defined variables X, Y. All right. So now let us show plotting variables as well as adding some descriptive labels and a good title. So we'll move forward and see how to add title, labels, and plotting variables. Now the code is pretty much similar to the previous one, but it has few extra fields. Let me explain you that. So of course I've imported pyplot from matplotlib. After that, what I've done, I've defined two variables, x and y, and I have certain values in it, like 5, 8, 10 and 12, 16, 6. You can put whatever values you want, and this can even contain a data frame, a pandas data frame that has a data set. After that, what I've done, I've defined plt.plot function in which I have x and y. Instead of filling the data, I'm putting in variables that actually contain data. After that, I've added a title, which is info, then y label, which is nothing but y-axis, and x label, which is nothing but x-axis. After that, I need to show my plot. So for that, I've done plt.show. And the result is there in front of your screen. We have a title, we have labels for x-axis and y-axis. Now let me open my PyCharm and execute this practically. This is my PyCharm again, guys. So I'll remove till here, and obviously I need pyplot function from matplotlib. So now I will define x and y variable. So in x, it'll have a list of numbers, say 5, 8, and 10. And now I'll define one more variable, y, which again has a list of numbers 12, 16, and 6. 12, 16, and 6. Yep. Now what is our next step, guys? Can anyone answer me? Alright, so I've got a correct answer from Theon. He's saying a plt.plot function, which is absolutely correct. So I'll write in here plt.plot, and instead of filling in data, I'll be passing variables. Alright. And now our next step is to add title and x label as well as y label. So in order to add title, I will write here plt.title and the title of my graph. So I can just write here info. And now I'm going to define x and y labels. For that, I'll type in plt.y label, and I'm going to name it as y-axis. Similarly, for x label, I'm going to do the same thing, x-axis. All right. Now finally, I'll type in plt.show. Now go ahead and run this. So you can see that we have a graph that contains the title info, y-axis as a y label, as well as x-axis as the x label. Now I'll again open my slides and we'll see what next are we going to see. Now this graph is pretty much incomplete or ugly, I would say, because what if I want to change the width of this particular line? What if I want to add some grid lines? What if I want to change the color? So all those things, how will I do that? Don't worry, the next slide will actually tell you the same, how to add style to your graph. So how to add style to your graph? For that, first thing that you need to do is import the style function from matplotlib module. After that, you need to call it style.use ggplot. So whatever plot that you want to use, I'm using ggplot right now. Then again, I've defined 4 variables, x, y, x2, and y2. And all of these contains a list of numbers. Again, I'm telling you, it can be a data frame as well, which contains a data set. Then what I've done, again, I have used plt.plot function. But over here, apart from x and y, there are many other fields. So don't get confused. I'll explain it to you. It's very, very easy. So this thing G actually tells me that the color of my line should be green. Then this is label. So this label is not for your x-axis or y-axis. It is for your curve, which is line 1. You can give whatever name you want. Then we have line width. I want the width of my line to be 5. So I've put in here 5. Similarly, I've done for the next plot as well. Then I've added title, which you know how to do that. Similarly, y label and x label. Now after that, I'm using this legend function in order to add a legend to my graph. Over here, you can notice that we have it present in our graph where I'm pointing with my highlighter right now. So we have line 1 and line 2. After that, what I've done, I've added grid lines to my graph, which is of the color K, which is nothing but black. So you can see it in my graph as well. We have grid lines available. And finally, plt.show. So I'll open my PyCharm again and I'll show you how you can do that practically. So this is my PyCharm again, guys. Let me first remove all of this, and I need to import the style function. So for that, I'll type from matplotlib import style. That's it. Style.use ggplot. Now define the variables. First will be x, add certain values to it. I'll add in 5, 8, 10. 5, 8, 10. Then y. I'm going to add a list of numbers 12, 16, 6. Now one more variable x2, again it'll have list of numbers which will be 6, 9, 11. Then I'm going to use y2 variable and I'll add some numbers to it, 6, 15 and 7. Alright, so now I'm going to use plt.plot function, and over here first I write x comma y. Then now given a color to it, I'm going to give it as green. Next, label line 1. Now line width which is equal to 5. Now again for x2 and y2 I'm going to type in plt.plot x2 comma y2 comma the color, then label. So I'm going to type in line 2, then comes line width. Alright, so now our next step is to add title to our plot. So plot plt.title, and the title that I'm going to give is info again. Then x and y labels, plt.y label, y-axis, then plt.x label, x-axis, plt.show. Now go ahead and run this. So over here I've not added any grid lines. I can do that as well. So for that, let me first close it. Fine, so I've defined title, x label as well as y label. Now our last task is to actually add grid lines. So for that I'll type plt.grid and just write in here true, comma, give a color. I want it black, so I'll keep it that way. Finally, show your plot. So plt.show, that's all. Go ahead and run this. So you can see that this is our graph. So we have changed the default line width. We have added grid lines. We have added labels, titles, plus we can add legend as well. So let me show you how you can add a legend. So for that, I'll go back to my code once more. Just write in here plt.legend. Go ahead and run this again and you'll see that legend has been added. So here we have line 1 and line 2 as our legend, and we have changed the default line width, title, y-axis, x-axis labels, plus we have grid lines. So this is how you can customize and add style to your graph. So what I'll do, I'll open my slides again and we are going to look at how to plot various types of graphs. For example, a bar graph or a histogram, all those things. Fine, so first we'll look at how to plot a bar graph. So these are all the linear graphs that we have seen till now. Now we'll see how to plot a bar graph. So before I tell you how to plot a bar graph using Matplotlib, let us understand why we actually use a bar graph. So bar graphs are basically used to compare things between different groups. And when we are trying to measure changes over time, bar graphs are very well suited when changes are larger. So this is why we use bar graph. Now let us understand how we can do that using Matplotlib. Now since we know why we use bar graph, let me explain you the code and how you can do that using Matplotlib. So first import pyplot like we do every time. After that, instead of plt.plot, I'll use plt.bar, and I have filled in data here. You can fill in variables as well that contains data. Then I have defined a label, example1. After that, I have one more plot in which I have filled in data plus a label, and I've given a color as well. I don't want the default color, I want some change, so I've written it as green. After that, I've plotted the legend. After that comes legend and then X label and Y label that you have seen in the previous graphs as well. Then I've added a title and then finally show it. Don't worry guys, I'll execute this practically in my PyCharm now. So this is my PyCharm guys. So over here what I've done, first of all I have imported the pyplot function. Then instead of plt.plot, I'm using plt.bar, and inside that I have data filled in. Instead of that, I can even have variables that contains data. Then comes label, in which I am using example1. Then comes label. For this instance, it is example1. Then again, for one more plot, I have plt.bar. Inside that, I have data filled in, then label, and then in order to differentiate between both of them, I'm using a color green for this particular bar graph. Then comes legend, and then after that I've defined X label as well as Y label. After that I have title, and then finally show it. Now go ahead and run this and see if it works or not. And yes, it does. So we have legend here, we have X label, we have Y label as well as X label, and we have a title for our graph. Alright, so let us move forward and focus on the code that you have in front of your screen. So let me explain you this code. So over here we have population ages. So we have defined a list in which we have multiple numbers. After that we have defined one more list or a variable bins in which we have multiple numbers again. Now instead of using plt.bar for bar plot, for histogram we use hist, plt.hist. Then comes population ages. Instead of data I am filling in here variables that contains data. Then bins. Then hist type, I want it to be a bar type. Now when I talk about hist type, I want it to be bar. Then the width should be 0.8. That's all. The rest all you can understand. It is X label, Y label, title, legend, and finally show the plot. Now I'll go ahead and execute this practically in my PyCharm. So this is my PyCharm, guys, and just to save time, what I've done, I've actually copied it already. So over here you can see we have imported the matplotlib module. Then we have a variable population ages and bins. Now instead of using plt.bar, I'm using plt.hist for histograms. Then comes the two variables, and then hist type is equals to bar, and then I've defined width. Similarly, I've defined X label, Y label, and title like the previous examples. Then comes legend, and then finally show the plot. So let us go ahead and execute this and see if it works or not. Yep, it does. So we'll move forward and understand scatter plot as well. Now before we understand how to plot a scatter graph, we need to understand why we actually use scatter plots. Usually we use scatter plots in order to compare two variables, or three if you're plotting in 3 dimensions, looking for a correlation or groups. So basically you try to find out how much 2 or 3 variables related to each other. So over here, as you can see, there is one point here and there's another point here. So these two are pretty much dissimilar to each other, right? Now when I talk about these 2 points, they're pretty close to each other. So you can say that these two are pretty much similar. And basically what we are doing here, we're trying to find the relationship between the 2 variables. And that is actually called your correlation. Now let us understand the code. Now let me explain you the code. So first of all, we have imported the pyplot function from the matplotlib module. Then we have 2 variables X and Y, which contains a certain set of values. Now, instead of calling plt.plot or plt.bar or plt.hist, I'm using scatter because I'm doing it for a scatter plot, right? Now inside the parenthesis, I have X and Y variables. These variables contain data, and I can even write the data instead of just writing the variables as well. Now I've defined a label and then color. Then rest of the things you know, we have X label, Y label, the title, then legend, and then show. That's all. Now let's go ahead and execute this practically in my PyCharm. Now this is my PyCharm, and over here I've already pasted the code. So I'll just go and run this and we'll see what happens. So this is how our scatter plot looks like. So here we have our legend, then we have the title, then we have our Y-axis, then X-axis. These two are the labels for that. So let me close it and see what is the other plot that we are going to focus on. Now once scatter plot is done, we'll have a look at the area plot, or you can even call it as a stack plot. So basically these area graphs are very similar to the line graphs, okay? They can be used to track changes over time for one or more groups. Area graphs are good to use when you are tracking the changes in 2 or more related groups that make up one whole category. You can take an example of, say, public and private groups, okay? So before I explain you the code, let me tell you one thing, guys. The problem here is with polygons, we cannot actually have labels for our data. In order to solve that problem, all we did here was plot some empty lines, giving them the same color and the correct labels in accordance with our stack plot. We also gave them a line width of 5, as you can notice here, to make the lines a bit thicker in the legend. Now we can easily see that we are spending our day sleeping, eating, working, and playing. So this is how the code works. Now let me execute that practically in my PyCharm. So I've copied the code already just to save time again. Now this is our code. Over here I've already explained to you why are we defining these empty lines, just to add labels. Now let us go ahead and execute this and see what happens. So this is our graph, guys, and again we have legends, title to our graph, and Y label as well as X label. So we'll move forward and look at various other plots. This is called a pie plot. So let me tell you about pie charts a bit. So pie charts are pretty much similar to stack plots, only they are for a certain point in time. Typically a pie chart is used to show parts to the whole and often a percentage share. You can consider the example of percentage of market share and things like that, right? Now let me tell you guys, Matplotlib handles the sizes of the slices and everything. So all we need to do is just feed it the numbers. That's what we have done here. So let me explain you the code here. So over here we use plt.pie to plot a pie chart. We have slices. We have specified slices. Now slices, which are nothing but the relevant sizes for each part. Then we specify the labels and then the color list for the corresponding slices. Next, we can optionally specify the start angle for the graph. This lets you start the line where you want. In our case, we chose a 90-degree angle for the pie chart, which means the first division will be a vertical line. Next, we can optionally add a shadow as well. And after that, we can even use explode to pull out a slice a bit. So we have explode that says 0, 0.1, 0, 0. So because of that, you can see that eating has been pulled out a bit. Now basically we have 4 total slices. So with explode, if we didn't want to pull out any slice at all, we would have just written here 0, 0, 0, 0. Now if we want to pull out the first slice a bit, we would do 0.1, 0, 0, 0. And if we want to pull out the second slice a bit, what we can do is 0, 0.1, 0, 0, like in our case. Now finally we do an autopact. Now this autopact overlay the percentages on the graph itself. So you can see that we have 8.3, 29.2%, 54.2%, all those things written on the graph itself. And then finally add a title and then show it. Now let me execute this practically, guys. Now just to save time, I've already written the code. So I'm just going to go ahead and execute this and we'll see if it comes or not. Yep, here is our pie chart. So we have seen multiple types of plots. We have seen pie plot, bar plot, histograms, area plot. Now what we need to understand is how to handle multiple plots. So at that time, what will you do? Let me open my slides again and we'll move forward with that. So this slide actually tells you how to deal with multiple plots. Now you can notice in the figure as well, we have 2 plots available. Now let me help you out with the code that is there in front of your screen. So in the beginning, we are importing a couple of modules. One is matplotlib.pyplot, which you are already familiar with. After that, there is a numpy module as well. Now after that, you might find this part confusing if you're not familiar with numpy. Now let me just tell you what it does. It will create a numpy array that will have elements between 0 till 5 in the steps of 0.1. Now similarly, T2 will also be a numpy array that will have elements ranging from 0 till 5 and in the steps of 0.02. Now after that, the code is pretty much similar to the previous examples that we have seen. But there is one new concept that is called subplot. Now let me tell you what this subplot does. It helps us to plot multiple plots, alright? So when we write subplot 211, this means that we have 2 plots. Horizontally, we have only 1 plot present and vertically we have 2 plots. And in that vertical position, this plot will be our first graph. Now you can notice that we have one more subplot that is 212. So vertically we have 2 plots, horizontally we have 1, and this is the second plot. So what I'll do, I'll open my PyCharm and I'll play around with it a bit so that you'll be able to understand it better. So now this is the code, guys. First I'll go ahead and execute this and we'll see the result. So we have a graph, something which is like this, right? We have 2 plots which are aligned vertically. Now what I'm going to do is I'm going to just minimize this and I'm going to change the subplot value so that you'll be able to understand better how we are dealing with multiple plots. Now over here, if I make this as 2 and this one as well as 2, so let us see what we get. So we have got the same graph, but it is aligned horizontally, if you can notice. This is our another graph and this is our first graph. So you can notice the difference between both of these graphs, right? So this is why we use subplot.
Data visualization is known to be a challenging task, but Seaborn just makes it so simple. Before we move on, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Coming back towards this session, we shall first begin with a small introduction to Seaborn and the advantages of Seaborn over Matplotlib. Then, I'll be showing you all the installation of Seaborn along with its dependencies. Following that, we shall take a look at the various plotting functions in Seaborn and how you can create multi-plot grids. And finally, we shall be studying the various plot aesthetics available in Seaborn. So let's get started. Seaborn, as we all know, is a data visualization library available in Python. It's based on Matplotlib and allows creation of statistical graphics. It also has a number of functionalities such as an API that is based on datasets allowing comparison between multiple variables, It also supports multi-plot grids that in turn ease building complex visualizations. It has univariate as well as bivariate visualizations available to compare between subsets of data. The availability of different color palettes to reveal various kinds of patterns. It also estimates and plots linear regression automatically. So now, if you were wondering why use Seaborn when you already have Matplotlib, here is the answer to it. Michael Wascom, who's the creator of Seaborn, says, if Matplotlib tries to make easy things easy and hard things possible, Seaborn tries to make a well-defined set of hard things easy too. Factually, Matplotlib is good, but Seaborn is better. There are basically two shortcomings of Matplotlib that Seaborn fixes. Matplotlib can be personalized, but it's difficult to figure out what settings are required to make plots more attractive. On the other hand, Seaborn comes with numerous customized themes and high-level interfaces to solve this issue. When working with pandas, Matplotlib doesn't serve well when it comes to dealing with data frames, while Seaborn functions actually work on data frames. Now that you have an idea about Seaborn, let's move on to see how you can actually install this library. To install Seaborn, you can use the simple pip install Seaborn command, or if you are using an Anaconda platform, you can just go to the Anaconda prompt and type conda install Seaborn. Since I already have it installed over here, I'm not going to redo it again. Now let's get back to our presentation and take a look at the dependencies of Seaborn. Seaborn basically has 4 mandatory dependencies, which is NumPy, SciPy, Matplotlib, and the Pandas library. It also has a recommended dependency, which is the stats models library of Python. So just like we've installed Seaborn, we'll have to install NumPy, SciPy, Matplotlib, and the Pandas library. To install these libraries, you can use the same commands which I showed earlier with the name of that particular library. Okay, so I hope everyone's clear till here. If you have any doubts, please do let me know in the chat box and my team is here to help you. So now let's move on and take a look at the various plotting functions in Seaborn. Seaborn has a number of functions that are available for visualizing statistical relationships, plotting with categorical data, visualizing the distribution of a dataset. Let's begin with visualizing statistical relationships. The process of understanding relationships between variables of a dataset and how these relationships in turn depend on other variables is known as statistical analysis. In today's session, I'll be using the relplot function to plot various statistical relationships. Relplot is a figure-level function that makes use of 2 other access functions for visualizing statistical relationships. These access-level functions are scatterplot and lineplot, which can be specified using the kind parameter of the relplot. To explain this in detail, let me jump onto my Jupyter notebook from here. I'll just open a new Python notebook. I hope everyone's familiar with Jupyter. Okay, I'll just rename this to Python Seaborn tutorial. Or I'll just say Python Seaborn and I'll rename this. Before we begin data visualization with Seaborn, we'll have to import Seaborn along with its dependencies. So the first thing I'm going to import is NumPy. Import NumPy as NP. Then I'll import Pandas as PD. Import Matplotlib .pyplot as PLT, and then I'll import Seaborn. Import Seaborn. Sorry for the spelling mistake, guys. This is import Seaborn. Import Seaborn as SNS, and I'll just execute this. Like I've already told you all before, you can load any dataset present on the GitHub and make use of it with Seaborn. Seaborn also allows you to load any dataset from Git using the load dataset function. So let me just load the flights dataset. So I'll just say sns.load_dataset. And I'll specify the name, which is flights. Okay, so now let me just go to the GitHub website and open the flights dataset over here. As you can see, there are a number of datasets that are available which you can use along with Seaborn. So let me just open the flights dataset and scroll down. So as you can see over here, there are 3 columns for the year, month, and the number of passengers. So I'll just come back to my Jupyter notebook and I'll use sns.relplot. And I'll specify what I want my x-axis to be. So I'll just give x-axis as the number of passengers. And to the y-axis, I'll give month as the parameter. And for the data, I'll use a, which is the variable wherein I'm loading the data set. And I'll execute this. Okay, so I hope you're clear with this. So as you can see over here, the y-axis has month and the x-axis has the number of passengers. These points are plotted in 2 dimensions. To add another dimension, you can add the hue semantic. So I'll just copy this, Control-C, and I'll paste it over here. And I'll give another parameter over here, which is hue, and I'll say that is year to be the hue semantic, and I'll hit run. So I hope you see the difference over here. The year has been marked as the hue semantic, month, which is in the y-axis, and the number of passengers, which is on the x-axis. So as you can see on the screen, this is nothing but the scatter plot. So in case you want a line plot, all you have to do is specify the kind parameter of rel plot with the keyword line. So let me just load another data set over here. So I'll say b is equal to sns.load underscore dataset, and I'll load the tips dataset this time. After this, I'll use sns.relplot. I'll specify the x-axis to be the time and y-axis to be the tip. Data is nothing but b and kind is line. Now let me hit run. Okay, so I hope you're clear with this. If you have any doubts, please do let me know in the chat box and my team is here to help you. Now let's get back to our presentation and see how you can plot categorical data in Seaborn. This approach basically comes into picture when our main variable is divided into discrete groups. To achieve this, we'll be using the catplot function available in Seaborn. Like relplot, catplot is also a figure-level function characterized by 3 families of axis-level functions, which are scatterplots, distribution plots, or estimate plots. Okay. Now let me jump onto my Jupyter notebook and show you all a few examples regarding this. Okay, so here I'll use the same tips dataset, and since I've already stored it in the variable b, I'll just use sns.catplot, and I'll specify the x-axis to be the day, y-axis as the total bill, and data is b. Now let me hit run. Okay, as you can see over here, this is the scatter plot that we've got using the catplot function. Scatterplot is basically the default type of catplot. However, you can change the kind of plot you want by specifying the kind parameter like we've done previously. You can choose between any options, which is strip plot, swarm plot, box plot, violin plot, etc. Let me just show you what happens when I change the kind parameter of this catplot. So I'll just copy this and I'll paste it over here, and I'll specify kind to be as violin plot. So I'll specify the keyword violin and I'll hit run. Okay, so I hope you see the difference. This is our scatter plot and this is our violin plot. So if I change the kind parameter, our plot will change correspondingly. Let me just give the type as boxin now. Okay, so I hope you're seeing the difference, guys. So now let's get back to our presentation and see how to visualize the distribution of a dataset. Visualizing dataset basically deals with understanding datasets with context to being univariate or bivariate. Okay, so now let's get back to our Jupyter notebook and see how you can actually plot univariate and bivariate distributions. So before doing this, I'll just import stats from the SciPy library. So from SciPy, import stats. And I'll hit run. Okay, so first let us plot univariate distributions. To plot univariate distributions, you can use the distplot function. So let me just take an example. C is equal to np.random I'll just use random.normal functions to draw random samples from a normal distribution. So I'll just give the corresponding parameters to it. You can give any parameters of your choice. I'll say size equal to 100 and scale. I'll specify the scale to be as 2 and I'll hit run. I did not specify the distplot function, so I'll use sns.distplot and I'll pass the data to it as C. Okay, so this is how the distplot function works. So this is an example of a univariate distribution. So now let's move on and see how a bivariate graph is going to look. To plot bivariate distributions, you can make use of the joint plot function. I already have a small example typed over here, so I'll just copy paste that and I'll show you all how it actually looks. Okay, so this is basically a bivariate distribution. So I hope you see the difference. This was our univariate distribution and this is our bivariate distribution. Okay, if you have any doubts, please do let me know in the chat box and my team is here to help you. Moving on, Python Seaborn also allows you to plot multiple grids side by side. These are basically plots or graphs that are plotted using the same scale and axis to aid comparison between them. This in turn helps the programmer to differentiate between the plots and obtain large amounts of information. To plot multiple graphs, you can either use the facet grid function or the pair grid function of Seaborn. Let me jump onto my Jupyter notebook and show you all an example of each of these. So first I'll be using the facet plot function. Okay, so here I'll load another data set. So I'll just say A is equal to sns.load dataset. And this time I'll load the iris dataset. And I'll say B is equal to sns.facetGrid, which is the name of our function. And I'll specify A wherein our data is present. And I'll specify the column to be the species. I'll specify the column as the species of flowers. And then I'll just use the map function and I'll specify all of them to be as histograms and I'll give the parameter as sepal length. Now let me hit run. Oh, sorry, I made a spelling mistake over here. It's capital F. Okay. So I hope you're clear with this. I basically have 3 graphs that are available for the 3 species of flowers, which is Setosa, versicolor and virginica. As you all can see, it becomes very easy to differentiate between them. You can also make use of the pair grid function when you have a pair of variables to compare. Let me show you a small example of that as well. So here I'll just say A is equal to load underscore dataset and I'll load the flights dataset. And then I'll specify B as sns.pairgrid, and I'll specify the data to this as A, and I'll use the map function again to plot them. This time I'll use a scatter plot, so plt.scatter. Sorry guys, I forgot to specify SNS over here, sns.load underscore dataset. Okay, so I hope you're clear with this. So as you can see, the output clearly compares between the year and the number of passengers in different ways. Seaborn also allows you to make your plots more attractive and delightful. So till now, as you've been seeing, I've just had a white background for all my plots. So in case I want to change this, or if I want to change the color palettes that are available in my graph, I can do so easily. Let me just jump onto my Jupyter notebook to show you all how to do this. So here, I'll just copy paste the previous example. I'll just copy this and I'll paste it over here. And to this, I'll just use another function, which is the set function, and I'll specify the style of my plot to be dark grid. And I'll hit run. I hope you see the difference between the two. Here I have a white background, whereas when I specified dark grid, I have a different background with dark grids that are seen clearly. You can change the style parameter to any of the available themes, which is dark grid, dark, white, etc. So if I just specify dark and I hit run, you can see that the grids have vanished, but the background is dark. Not just this, guys, you can make many other changes to your graphs, such as adding or removing axes, the colors that are available, etc. Now let me just show you all how you can remove the axis lines that are present in your graphs. I'll take another example over here. So sns.set. I'll set the background this time as white. I'll say style equal to white. And I'll specify the color code parameter to be true. I'll load the tips dataset again. sns.load dataset. And I'll load the tips dataset. Then I'll use a box and plot. Or I've used the box and plot, so this time I'll use the box plot function. And I'll specify x-axis to be the days. And sorry, it's day, not days. And the y-axis to be the total bill. And data is nothing but A. Oh, sorry guys, I've made a spelling mistake over here. It's color codes. Okay. So here, as you can see, my plot has axes all around it. Now, if I want to remove any of these axes, all I can do is use the despine function. So I'll just copy paste this and I'll use the despine function. I'll specify the offset parameter to be 10 and I'll specify trim parameter as true and I'll hit run. Okay, so I hope you see the difference. So as you can see over here, I've specified the offset to be 10. I do not have the axes that are present before that. Seaborn also provides a number of color palettes, and to check the color palettes that are available in Seaborn, you can just use the color palette function. So I'll just use C is equal to SNS dot color palette. And this time I'll use the palplot function. And the data is C. Okay, so as you can see, these are the color palettes that are currently available in Seaborn. For deeper variations, you can use other functions such as the HLS palette, HUSL palette, etc.
Once in every 4 years, the world celebrates a festival called FIFA World Cup. And with that, everything seems to change. Priorities switch to football and predictions switch to the teams and players that would perform in the tournament. As everybody must be knowing that World Cup has already started in Russia and people are going crazy about it. So keeping that in mind, I have come up with a use case wherein I'll be analyzing the world's best playing 11 in FIFA 2018. So for all the football lovers out there, I hope that excites you. So let's make this fun and let us see our problem statement first. But guys, let me make it very clear that this list is based on my opinion only and you are entitled to have a completely different opinion. So if you do have a different opinion, let me know about your list in the comment section below. Now, as I told you that I'll be predicting the world's best and strongest 11 players taking part in this FIFA World Cup. And I would be using Python for the analytical implementation. So I'll start this analysis by first analyzing the world's best goalkeeper, then 4 best defenders, 3 best midfielders and 3 best attackers. So if you notice over here, I am following a 4-3-3 lineup. Well, it's often said that 4-3-3 is the best lineup, but obviously it is not fixed. So based on my players availability, I have choose this lineup as 4-3-3. So guys, it's totally up to you. You can choose any position you want. Now, as I've said guys, that I'll be using a 4-3-3 position. So here I have 4 defenders, red marked as 3 midfielders, blue marked as 3 attackers, and mustard orange for a goalkeeper. So I hope you guys are clear with this 4-3-3 position. So if you notice over here, I have a question mark on all these positions. Now why? Because this exactly my problem statement is. That is, I need to find out the players who will play the best in these respective positions. So this sounds pretty interesting, right? So let's begin an analysis. So here I'll be following 5 steps wherein I'll first load my dataset and then import the required libraries. Now I'll be using FIFA dataset from Kaggle. So don't worry about the dataset guys, I'll be mentioning the link of Kaggle website in the description below. So once you have loaded the dataset and imported all the required libraries, we'll then analyze it, explore the dataset, and then we'll figure out the best goalkeeper, the best defender, best midfielders, and best attackers. So let us go through all these steps one by one. Now my very first step is to collect, or you can say load, the dataset and then analyze it. So if you notice over here, I have a screenshot which displays the dataset. So over here I have the name of the player, I have the nationality, that is the country he belongs to. Then I have the national position in which the player plays at the national level. Then we have the national kit, we have club position, club kit, and we have so many others like that. So this is a dataset which is provided by Kaggle. So I'll just mention this in my description box and you can just download the dataset from there. Now I'll be using different libraries as well. So over here I'll be using pandas for data analysis, manipulation, cleaning, and all those stuff. Then I'll be using NumPy for the scientific computation part, and Matplotlib and Seaborn for visualizing plots. So in this step, I'll be just loading my dataset and then importing the required libraries. So let me just go to my Jupyter notebook and let us implement all these steps one by one. So guys, this is my Jupyter notebook. Now, as you can see, we need to figure out the world's best playing 11. So over here, I have first imported all my libraries, that is import pandas as PD, then Seaborn as SNS, NumPy as NP, and then I've imported Matplotlib. And then I've just written percentage Matplotlib inline, that is to visualize the plots in the Jupyter notebook itself. Then what I've done, I have just read my dataset. So the name of my dataset is full data. Now using pandas, I have read the CSV and then displayed the top 7 rows. So over here I have already discussed that the dataset contains the columns such as names, nationality, national positions, and we have so many like that. So here I have just printed 7 rows, and if you notice that we have 53 columns over here. So you can just go through it, explore, do experiment with them and gain insights out of them. So here if you see, you have characteristics of all the players and their score. So you can just go ahead, download this dataset and explore as much as you can. Now, analyzing this huge dataset is a tedious task as it involves quite a few pre-processing steps as well. Now, there might be a lot of redundant and unwanted columns which you may want to remove. Therefore, you can delete certain columns if needed. So, let me show you that as well. So, here what I have done, I have deleted one column, that is national kit. So, I don't require the column as national kit. So, what I'll do, I'll say delete. So, I'll just write DEL. DF is the name where I have stored my dataset, and then I have just mentioned the column name. Over here, I don't want the national kit column, so I've just write this and then I've just printed the head of it. So once I run this, you'll see that the national kit column no longer exists. And if you notice, I just have 5 rows and 52 columns, whereas in totality, we were having 53 columns. Similarly, you can delete as many columns as you want. You can actually do a lot of transformation. You can remove the null values, that is nothing but the cleaning of data. So you can do the analysis on your dataset as well. So I'll just leave this part on you. So you can just go ahead and analyze as much as you can. Now once you have simplified this data, you can then start with the analysis part. So to explore, or you can say analyze your data, the best thing you can do is to visualize the data in the form of plots. So what happens with that is you can easily read out your conclusions. You don't have to calculate a lot of things. You don't have to play with numbers in fact. You can simply see that, okay, this has the highest peak, means this is the most likely outcome to be happen. So that is how you can visualize everything using Matplotlib and Seaborn libraries. So here what I have done, I have plotted a simple count plot which basically gives me the number of players representing a particular country. So over here I have count plot, and on the y-axis I have the nationality, and on the x-axis I have the count, that is the players count. So as you can see here from the graph, you can easily conclude that most of the players are from England, then from Argentina, Spain, France, Brazil, and the list goes on. Now these graphs are best used to gain statistical insights. So you can just go ahead, plot with different columns and analyze your data set. Now in this case, the graph won't add a lot of value because we would be picking the best 11 and the results may vary accordingly. So these graphs are just for analysis part. So over here, the results that we got is purely dependent on your data set. So right now I'm getting the maximum count from England and then from the Argentina. So guys, don't take it personally. It's just displaying what my data set contains. Now moving ahead with the analysis, you can try out different visualization. Let's say with the player's age, with the preferred position he plays, then the rating of it, then the club he is, and you have a lot more columns like that. So let me show you one more visualization and then we'll switch to an analysis of fetching the best playing 11 for the World Cup. So here I have again plotted a count plot wherein I have the player's age on the x-axis and the count on the y-axis. So here it is quite evident that the majority of players are between the age 20 to 29, and it has the largest peak at 25 years. So that is how you can conclude a lot of other things by just going through your dataset and taking up different columns and plotting different graphs with them. So now is the time we try and find answer to the question we put forth in the problem statement. That is, who will be the world's best playing 11? So let us begin our analysis. So as discussed earlier as well, I'll be using a 4-3-3 lineup, which means we need to find 4 best defenders, 3 best midfielders and 3 best attackers. And we'll be having one goalkeeper as well. So let us start our quest by finding a goalkeeper first. Now over here, as you can see, I have assigned some weights to these variables. So if you notice over here, I have given the minimum weight of 0.5 to the variable A, then I have given B as 1, C as 2 and the maximum weightage 3 to the variable D. Now I'll be telling you why we have assigned these weights and when we will be using these as well. Now in order to find the best goalkeeper, what I'll be doing, I'll be analyzing the data for the two parameters, that is the shot stopper and the sweeper. So a shot stopper is a goalkeeper who is strong in stopping the shots taken by the opponents, whereas a sweeper is a player who is quite strong in playing with his feet and making the passes. So that is why I have taken these two characteristics and then assigned all the weightage to the characteristics. Now in my dataset, I have various features such as we have reactions, we have a column of composure, we have the column of speed, strength, and we have many other features like that. Now that is why I've assigned weights to it. Now in short stopper, what I'll be doing, I'll be giving weightage to all these characteristics. So let's say I'm giving the weightage of A to the speed. Now A is the minimum weightage. And similarly, if you see for sweeper, I'm giving a bit higher value to the sweeper. Now why? Because sweeper is the one who sweeps up the ball if an opponent manages to breach the defensive line. So that is why I've given B weightage to him. Similarly, for jumping, I've given C weightage for short stopper and I've given lesser weightage for sweeper. Then moving ahead, I've given the D weightage, which is the maximum weightage to the reflexes. So both the characteristics, either it is short stopper or a sweeper, both must be having very good reflexes. So that is why I've given the weightage D to both of them. So that is how you can assign weights to all of them. And then what you can do, you can simply plot them and then pick the best one. So what I'll be doing, I'll be first plotting my short stopper. Now over here, what I have done, I have simply plotted a bar plot wherein I'll be passing the variable that is GK short stopper, and then using the function sort values, we have arranged them in the descending order, and then I just want the top 5 of them. Then on my x-axis I have the name of the players, and on the y-axis I have the short stopper score. So based on these parameters, you'll get a graph somewhat like this. Now it is quite evident from this graph that Manuel Neuer is the best goalkeeper. As you can see, he tops this chart. Now let us plot the other parameter, that was sweeper. So I'll just copy the same code, I'll just pass in the value that is GK sweeper, and then pass the same in my sort values function and then arrange them in the descending order for the first top 5. So over here again, we have the player's name on the x-axis and we have the sweeper score on the y-axis. So as you can see over here, Manuel Neuer tops the chart here as well. So based on these two parameters, we conclude that Manuel Neuer would be the best choice goalkeeper for this World Cup. So by going through the two characteristics, that was short stopper and sweeper, we came to a conclusion that Manuel Neuer is my best choice for a goalkeeper. So let me just go back to my presentation and let's see what all we have covered. So we have seen this, we have collected the data and we have imported the required libraries. Then what we have done, we have analyzed the data, we explored the data set wherein we have plotted two count plots, one with the nationality and the other one with the age. So by plotting these two graphs, you basically find out a relationship between one variable, or you can say one column and another column, and then you can predict better results. So analysis, exploring a data set and visualizing them brings you a lot of insight. So you should definitely do that. Now, I've already told you that you can go through the data set, you will find a lot of columns, you can just pick up the ones which are relevant for you, and then you can start your analysis on that. Next, my second step was to analyze my best goalkeeper. So over here, I have plotted two graphs, one with a short stopping score and the other with the sweeping score. So as I told you guys that a short stopper who is quite strong in stopping the shots taken by the opponents, whereas the sweeper is the one who is strong in playing with his feet and making the passes. Now, when we plot these two graphs, we come to a conclusion that Manuel Neuer is the best goalkeeper for this FIFA World Cup, and hence we chose him. Now, next in our quest to find the world's best playing 11, it's time we choose some defenders as well. Now, in order to find the best defenders, I'll be using these attributes to fetch the best defenders. So as per my position, I am using 4-3-3. So I need to fetch 4 defenders. So here I'll be fetching 2 center backs and 2 wing backs. So in center backs we need 2 center backs, that is one who plays from the left and the one who plays from the right. So here we have LCB and we have RCB. Just the positioning is different. Then we have wing back. So again we need 2 wing backs, one who plays on the left hand side and the other who plays on the right. And based on these parameters I'll be predicting the 4 best defenders. So let me go back to my Jupyter notebook and let us plot each one of them and find out who are my best defenders. So as discussed guys, I have taken DF center backs, that is defender center back and defender wing backs. Now I'll be using the same characteristics for left center back and for right center back. And I'll just change the positioning. Let's say I want to know the who is my best left center back, so I'll give the position as LCB. And if I want to know the right center back, I'll give the position as RCB, that is right center back. So that is how you can sort the players by assigning the positions to them. Now, if I have to calculate the center back, I should know that they should be having a high defending capabilities. So the interception, the tackling power, the jumping, then your stamina, marking, all these things should be high. So if you see over here, I have my sliding tackle and standing tackle as D, which is the highest weightage. So that is why I've assigned the weight D to them. Similarly, I've given D to marking as well, then to heading as well. So that is how you can give weights to all of the parameters. Now for wingbacks as well, you must be having high defending capabilities. So the interception should be high, the tackling power should be high. So here also I've given the standing tackle and sliding tackle as the weightage of D. Then I've given acceleration to D. And let's say finishing to A, because a wing back is not that involved in finishing. So that is why I've given the lowest weight, that is A. So now is the time we plot the center backs. So here first we'll plot the left central back. So over here if you see I've given the position as LCB and then it's the same code guys. I've just passed in the values of center back. And using the sort value function, I have arranged them in descending values and I need to print the only top 5 values. Then on my x-axis I have the name and on the y-axis I have the score of this. Also notice guys that I have given a position LCB, that is the club position. So if you have explored the dataset, you can actually take any other column. Let's say you also have a column of national position. So you can take up that position and then you can find out the results. But for now I have used the club position because the player plays the best in the club. So that is why I have taken club position. Now you can go ahead with the national position as well and then you can perform the analysis. So do let me know what is your result or what is your take on the national position and then we can see the results as in how different our results come out. So do let us know about your result or your list that comes up after taking different parameters and different weightage and everything. So guys, this is my list based on these parameters. So you can just go ahead, analyze the dataset and you can actually do wonders with the dataset. Now, if I see the result of this particular graph, I have Sergio Ramos as my best left central back. Now, let me plot the right central back as well. So over here, I'll be giving the club position as RCB and then the whole code is same. So let me just see the result. So my best right central back is Cesar Azpilicueta. So now, next let's move ahead and plot the wing backs as well. So over here, let me plot the left wing back. So here I'll be giving the position as left LWB or you can say LB. So LWB stands for left wing back and or you can say left back. And then it's the same exact code. Over here, my left winger or you can say left wing back is David Alaba. Since David Alaba's team does not qualify in this World Cup 2018, so I'll be picking up Alex Sandro as the best left winger defender. Then it's time to plot the right wing back as well. So over here I have given the position as RWB or you can say right back. So as per this analysis, it is evident that Kyle Walker is the best right wing back for the World Cup. So that is how we have calculated the 4 best defenders, that is 2 central backs and 2 wing backs. Having said that, I got a list of my 4 best defenders. So let me just go back to my presentation and show you them as well. So over here, I got the result as left wing back as Alexandro. Then we have central back as Sergio Ramos. Then we have right central back as Cesar Azpilicueta. And we have the right wing back as Kyle Walker. So moving ahead with the world's best playing 11, it's time we choose some midfielders as well. So as per the game formation that was 4-3-3, I have to choose 3 midfielders. Now in order to find these, I'll be analyzing the data for these parameters. So over here I have a controller, a playmaker and a beast. So let me explain you these terms. Now a controller is the person who is orchestrating your midfield engine by either sitting back or going forward based on the dynamic need. Secondly, we have a playmaker. So a playmaker is someone who will move the ball to the attacking from defense or you can say midfield. Then we have a beast. So a beast is a typical box-to-box player with loads of energy and who can basically boss the midfield. So that is how I have categorized the midfielder in terms of controller, playmaker and a beast. So let me just go back to my Jupyter notebook and let us implement and give weightage to all the characteristics. So as discussed, we have a controller, a playmaker, and a beast. Now when I talk about controller, I have given the position of controller as LCM, or you can say left midfielder. The controller must be good in passing the ball, then you have dribbling. So basically the characteristics that involves the highest weightage is ball control, then you have composure, you have short pass, long pass, and all those things. So if you see over here in controller, I have given D weightage to the ball control. Then we have short pass, long pass. So we have given that weightage. Then we have a playmaker. So a playmaker is someone who will move the ball to the attacking from the defense or midfield. So a playmaker must be having good dribbling. The agility should be very high. Then the ball control. Then you can say short pass and long pass. Everything should be high. So over here I've given D weightage to the ball control. Then D for the dribbling. Then for the short pass, long pass, and similarly you can assign weightage to all the relevant characteristics. Then we have a beast. So a beast is basically a box-to-box player with lots of energy and basically who can boss the midfield. So he is the one who will be playing from the position that is RCM, or you can say RM. So he'll be becoming a right central midfielder. Now in order to find the best beast, what should be his plus point? So I want that beast to be strong in defending as well as physical. So in defending you have interception, strength, tackling power. Then in physical you have the speed, stamina, agility, and all those characteristics. So I have given here D weightage to the agility. Then it must be having good stamina. So I've given D weightage again. And similarly I have assigned the weightage for the relevant characteristics. So over here I have just assigned the weightage of all these three, and now is the time you need to plot them. So the very first plot is to plot a controller. Now when I talk about controller, I told you that I'll be giving the position of LCM, that is the left control midfielder, or you can say LM. So over here I have just added one column, that is club position, LCM or LM, and then I have just sorted the values. So as per this analysis, I'm getting the best controller or the best left controller midfielder is Iniesta. Next, what I'll do, I'll be plotting playmaker as well. So in playmaker, I want the position as CAM, that is center attacking midfield, or LAM, that is left attacking midfield. So over here, let us see the results. So the best playmaker, or you can say the best center attacking midfielder is Mesut Ozil. So we have already come to two best midfielders. That was Iniesta and Ozil. Next, we need to plot the beast. So over here, I've given the position as RCM or RM, and then we have just plotted it. So let me just see the results. So over here, as per the analysis, I'm getting Kante as the best beast, or you can say the right central midfielder. So here we have completed a hunt of finding the best three midfielders. So let me just go back to the presentation and let me show you them as well. So here I have the controller, or you can say the left midfielder as Iniesta. Then I have the playmaker as Ozil, and we have the beast, or you can say the right central midfielder as Kante. So now we are done with the best goalkeeper, we are done with the best defenders, and we are done with the best midfielders. So now is the time we find some attackers as well. Now in order to find the best attacker, I'll be plotting the three graphs, which is for left wing attacker, then for right wing attacker, and one for the striker. So a left wing attacker is a player who attacks from the left flank, then a right wing is the player who attacks from the right flank, and a striker is the one who attacks from the center. So let me just go to my Jupyter notebook and let us assign weightage, and then let's see the results. So over here I have three positions, that is left wing, right wing, and a striker. So in order to have a best left wing, he must be having strong pace. Then he should also be good in shooting, or you can say passing. So basically the attributes that contributes him is acceleration, speed, then the finishing of it, then crossing. So all these things are the characteristics. So here I have given the acceleration D. Then I've also given the finishing as D because attackers must be having high finishing, and also the shooting capabilities. Now I have allocated both these characteristics as same because a left wing and a right wing both have the same capabilities, it's just the positioning difference. So over here if you notice I have given the same weightage to each one of them. And then when I'll be going to plot, I'll be just specifying the position to left wing and to right wing. Then comes my striker. So a striker is the one who should be good in dribbling, he should be good in ball control, reactions, then the finishing also should be high, the balance should be high. So all these things are the characteristics of a striker. So here we have ball control, then we have the balance. So here we have given the weightage D. Then we have high finishing, so again the weightage D. For heading also we have given D. And we have similarly assigned weightage to all the other characteristics. So now let us go ahead and plot each one of them. So here we have the very first graph which basically plots the left wing. So here I have given the position as LW, LM or LS. So on the x-axis I have the player's name and on the y I have the score. So now let me just see the results. So it's quite evident that the best left wing is Ronaldo. And now let me just plot the right wing as well. So over here I've given the position as RW, RM and RS. So I'll go to the results. Alright, so I'm getting Messi as the best right wing attacker. So here we have the left best attacker as Ronaldo and we have the right wing as Messi. Now comes the striker. So here I have just given the position striker to ST, or you can say left striker or right striker. So let me just plot this as well. So as per analysis, we are getting Robert Lewandowski as the best striker. So that is how we have calculated the best three attackers. That was Ronaldo, Messi and Lewandowski. So let me just go back to my presentation and let me show you there as well. So on my left hand side, we have left wing as Cristiano Ronaldo. Then on the right wing, we have Messi and striker as Lewandowski. So guys, this brings us to the end of this use case. We now have the best goalkeeper, 4 best defenders, 3 best midfielders and 3 best attackers. So let me just show you the complete picture of my analysis. So these are the world's best playing 11 for the FIFA World Cup in the 4-3-3 position. So here I started from choosing the best goalkeeper, that comes out to Manuel Neuer. Then we have picked up 4 best defenders. So my left wing was Alexandro, then it was Ramos, Cesar and Kyle Walker. Then we have gone ahead with analysis and then we chose the best 3 midfielders. So the midfielders that came out were Iniesta, Ozil and Kante. And finally towards the end we have analyzed the best attackers as well. So on the left hand side we have Ronaldo, on the right hand side we have Messi and on the striking we have Lewandowski. So I hope you guys like these results. So I'll repeat it one more time guys, that this list of players and the formation is totally based on my opinion and you are entitled to have a completely different opinion. So if you do have a different opinion, do let me know about your list in the comment section below. So here I'll just wrap it up and I hope you guys like the coverage of Python in this FIFA tournament. So guys, this is just one use case on FIFA dataset. You can actually achieve a lot more by applying various machine learning theorems. Then you can go through statistics and you can do wonders with the dataset. So this was just the beginning and this was quite a basic use case for the FIFA dataset. You can just go ahead with the dataset and you can actually apply machine learning and predict a lot of things. Also, in order to learn more about Python and data science or machine learning, you can let us know in the comment section and we will reply you back with the detailed code content. Now, if you're investing in learning something, be assured guys that this is something which is not going out of the date anytime soon. So Python is totally worth the effort guys. So don't just learn it, master it with Edureka.
Today's session is all about computer vision using OpenCV in Python. For now, let us move forward and have a look at the agenda for today. So guys, this is what we'll be discussing today. We'll begin by understanding what exactly is the meaning of computer vision and how a computer reads an image. Then I'll tell you what is OpenCV and how it works. After that, we'll see how to create an image detector as well as a motion detector using OpenCV. So I hope you guys are clear with the agenda. Let us move forward and we will understand what exactly is the meaning of computer vision. So before I explain you anything guys, I believe all of you are on Facebook, and the moment you upload any picture on Facebook, there's a feature called auto tag, right? So Facebook will give you suggestions to tag people who are there in the image, right? So how do you think that happens? That happens all because of computer vision. So computer vision is an interdisciplinary field that deals with how computers can be made to gain high level understanding from digital images or videos. So the idea is to automate tasks that the human visual systems can do. So a computer should be able to recognize that this is a face of a human being, this is what a lamppost looks like, this is basically a statue, so things like that, right? So I hope I'm clear what is the meaning of computer vision. And I don't think so I need to explain to you what are the applications of computer vision, right? So let's move forward guys, and we're going to see how a computer reads an image. Now this is very interesting. So notice the image that is there in front of your screen, right? So a normal human can easily tell that there is a New York skyline in this image. But can computers really see this? Well, the answer is no. Computers see a matrix of numbers between 0 to 25, 0 to 255, right? So for a colored image, there will be firstly 3 channels, red, green, and blue. And there'll be a matrix associated with each of these channels, right? And each element of this matrix represents the intensity of brightness of that pixel. All of these channels will have their separate matrices, and these will be stacked onto each other to create a 3-dimensional matrix. So a computer will interpret a colored image as a 3D matrix. I hope I'm clear. So when I say that the size of an image is 700 cross 700 and it is a colored image, that means there are 700 rows, 700 columns, and there are 3 channels because it's a colored image. Similarly, if I say 300 cross 700, that means there are 300 rows and 700 columns, and if it's a colored image, there'll be 3 channels. Now in the example which is there in front of your screen, we have an image which has a size of B cross A, and since it is a colored image, there'll be 3 channels. One thing to note here, guys, for a grayscale or a black and white image, there's only one channel. So if there's a black and white image and I say that the size of the image is 700 cross 700, it means there are 700 rows and 700 columns in one single channel, right? So I hope I'm clear. For a black and white image, there's only one channel. For a colored image, there are 3 channels, popularly called as RGB. And each element of the matrix represents the intensity of the brightness of the pixel. So this is how basically a computer reads an image. It will read an image in the form of matrix. It depends if it's a colored image, then it'll be a 3D matrix. And if it is a grayscale or a black and white image, then it'll be a 2D matrix. Similarly, if I want to calculate the number of pixels, all I have to do is multiply the number of rows, number of columns, and the number of channels. So if I say that the size of the image is 700 cross 700 cross 3 because it's a colored image, then you can go ahead and multiply these numbers and you'll find the number of total pixels. So I hope you have understood this. Let us move forward and we are going to focus on what exactly is OpenCV. Now, first of all, OpenCV is a library which is used for computer vision. It was first developed in the year 1999 at Intel by Gary Bradsky, and the first release came out in 2000. Let me tell you that OpenCV supports a wide variety of programming languages such as C++, Python, Java, etc., and also supports different platforms including Windows, Linux, etc., etc. Now, OpenCV Python is nothing but a Python wrapper for the original OpenCV C++ implementation. And in OpenCV, all the images are converted from or to NumPy arrays, right? So if there's any image, then OpenCV will first convert it into a NumPy array, right? And this makes it easier to integrate it with other libraries that uses NumPy, for example, SciPy and Matplotlib. But for now, understand that all the images will be first converted to a NumPy array, right? So that's how OpenCV works. Since we saw that computer will first convert the image to a matrix, in this case, it will convert it into a NumPy matrix or a NumPy array, you can say. Now we'll directly jump into certain basics of OpenCV. So what I'll first teach you is how you can read an image, how you can perform basic operations, for example, resizing the image or displaying the image and things like that. So that's what I'm going to first focus on. So for that, what I'll do is I'll open my PyCharm and I'll execute the code there. But let me just first explain you what I'm going to show you. So first of all, I'm going to teach you how we can read a particular image. The first thing you need to do is obviously import the OpenCV module. Then we are going to read the image with the help of this IMRead function. So this one represents that it'll be a colored image if it is a colored image. And if we put 0 here, then it'll convert it into a black and white or a grayscale image, right? And let me tell you that OpenCV will read it as a NumPy array. So basically Python stores the images as NumPy arrays or matrix of numbers. So if it's a colored image, it'll be a 3D matrix. And if it's a grayscale image, it'll be a 2D matrix. So what I'll do, I'll just quickly open my PyCharm and I'll show you certain basic operations there itself. So guys, this is my PyCharm. So what I've done here is I've imported the CV2 module. And what I'm doing here is I'm using this IMRead function and I've given the path to the image. So you can see the name of my image is frank.jpg, which is present in this particular path. And one basically tells it to keep it as a colored image itself, right? So since I was telling you that all the images are converted to NumPy arrays, so it is a colored image, it'll convert it into a 3D matrix. Let us see if that happens or not. So I'm just going to print this and let me go ahead and execute it. And you will obviously see a 3D array here, right? Similarly, if I go ahead and convert this to a grayscale image, if just all I have to do is put 0 here and we have a grayscale image here. So let me just go ahead and run this and you will notice a 2D array. Notice the difference, guys, right? And if you want to see what kind of a matrix this is, all you have to do is type in here type and it will show you the type, which is a NumPy n-dimensional array. All right. So I've told you earlier as well that OpenCV will convert all the images to a NumPy array. Now, what if I want to know the size of my image? For that, all I have to do is use the shape function and you will know the size of the image. Since it's a NumPy array, all I have to do is img.shape and let us see what is the shape of our image. So it is 600 cross 800 because we have converted this colored image to a grayscale image. That means we have 600 rows, 800 columns, and one single channel because it's a black and white image. Now, if I convert this to a colored image, you will notice the difference in the shape and you can see that 3 is added here, which basically means there are 3 channels, RGB. So there are 600 rows, 800 columns, and there are 3 channels. So I hope you guys are clear how OpenCV reads an image, how to know the shape or size of the image. How do we know that whether it's a colored image or a black and white image? What is the difference? What do you mean by RGB channel? So we saw how to read an image, we saw how to print an image, how to print an n-dimensional array. Then we also saw how to print the shape of the image and what will happen if we convert it into a colored image. Then we saw that 3 was added in the end, which basically means 3 channels, right? Now what we are going to do is we are going to display the image. How we are going to do that? We are going to use this wait key function, in which if we don't specify any parameter and we keep it as 0, it means that the moment user presses a key, the window will be closed. And if we specify a time frame, for example 2000 milliseconds, then the window will wait for 2000 milliseconds and then it will be destroyed. So this destroy all windows basically closes the windows based on my wait for key parameter. So if it is 0, the moment any person presses any key, then all the windows will be destroyed. And if I've given certain parameters like 2000 milliseconds, then it will wait for 2000 milliseconds and it will automatically close the window. So I hope you have understood this. Let me just go ahead and open my PyCharm and I will show you there as well. So guys, this is the PyCharm. All I will do here is I basically want to print it or I want to display my image. So I'll use this ImShow function. I have to give a name to this image. So let it be a legend. And we are going to type in here the name of the image here. This is my file name and this is the image name, right? So I have given the path here if you can see. Now what I'm going to do is I'm going to add the wait for key parameter. So for that, all I have to type here is cv2 dot wait key. And for now, I'll just keep it 0, which means that the user has to press any key to close the window, right? Now, what I'm going to do is destroy all windows function and let us go ahead and execute this and we will see the image. And the moment I press any key, it is gone. Similarly, if I type in here 2000 milliseconds, right? So it'll appear for 2000 milliseconds and it'll automatically go away, right? So I hope you have understood how we can, display the image and how we can close the windows by using wait key and destroy all windows function. So this is pretty easy, guys. I hope you have no doubts here. And still, if you have any doubts, again, I'm telling, mention it in the comment section. I will reply you ASAP. So now we saw how to basically read an image, how to perform basic operations, how to show the image, how to close the windows and things like that. Now I'm going to tell you how we can resize a particular image. So let me just go back and what I'll do is I'm going to resize this image. I'll go back to my PyCharm again and let me just create one more variable. Let it be resized, which is equal to cv2 dot resize, the name of my image and the shape that I want. So probably I want 600 cross 600, right? Let me just go ahead and run this. I want 600 cross 600. So instead of img, I'll type in here resized and let us see what happens once I do this. So you see that I have a resized image here, right? Now, obviously that is not symmetrical, right? So what can I do to make it symmetrical? I can just go ahead and divide it by 2 or 3 the way I want to reduce the size. So for now, I'm just going to divide it by 2 and let us see what happens. So basically, if you see the code here as well, what I'm doing here, I'm reducing it by 2, right? So image shape divide by 2 and I'm converting it into an integer because even if it turns out to be a float value, I will convert it into an integer. So new image shape is equals to old image shape by 2. That's what I'm doing basically, right? So again, I'm going to use the resize function. For that, I'll open my PyCharm. So all I have to do here is type in here int to convert it into an integer. img.shape function I'm going to use 1 divided by 2. And I'm going to close the parenthesis. Similarly here as well, int, open the parenthesis, img.shape 0 divided by 2 and close the parenthesis. And I think we are good to go. So the size of the new image will become half of the old image. Let us go ahead and run this. So yes, we can see that we have reduced the size. Let me just keep it as 0 so that if I press any key, then only the window will be closed. Now, similarly, I can increase the size as well. So let me just go ahead and multiply it by 2 and increase the size. So my new image will be twice the size of the old image. Let us see if that happens or not. We'll run this and yep, it's a pretty huge image. Let me just close it for now. Alrighty then. Fine. So we have learned how to basically resize an image. Let me go back to my slides and we are going to focus on what we are going to discuss next. So we saw how to resize the image. Next up, we are going to see how we can detect a face in a particular image. So it's pretty easy, guys. What you need is an image, obviously. You need to create a cascade classifier and it will contain the features of the face, right? So that your code can determine, okay, where is the face? Then we'll use OpenCV that will read the image and the feature file
and it will convert the image into NumPy arrays. So it will search for the row and column values of the face, right? So NumPy n-dimensional array, the face coordinates, and it will display the image with the rectangular face box. Let me repeat it again for you guys. What we need for face detection, we need an image. Then what we are going to do is we have a cascade classifier which contains the features of the face. Then we will use OpenCV that will read the images and the features. So it will convert that image into a NumPy array, and it will search for the row and column values of the faces of the face NumPy n-dimensional array, basically the face rectangle coordinates. And then what we'll do is basically we'll display the image with the rectangular face box, right? So what we are basically doing here is we are going to first read this cascade classifier. We'll give the paths to it. Then what we are doing is we are reading the image that we are talking about. We'll give the paths to it as well. We are converting it into a grayscale image. cv2.color bg2 bgr to gray is basically going to convert it into a black and white image or a grayscale image. Then what we are going to do is search for the coordinates of the image, right? So we have this gray image. We are going to search for the coordinates with the help of detect multiscale. This is basically to figure out where is the face, right? Let me just drill it down a bit. So this will create a cascade classifier object, right? And this is the path to the XML file which contains the face features. Then we are converting the colored image to the grayscale image. After that, what we are doing, we are using a method to search for the face rectangle coordinates. So this detect multiscale is basically a method which will help us to search for the face rectangle coordinates. And scale factor basically decreases the shape value by 5%. And until the face is found. So smaller this value, the greater is accuracy. So scale factor is something I don't want you to focus too much right now. This decreases the shape value by 5% until the face is found. It keeps on decreasing it, right? The smaller this value, the greater is your accuracy, right? And after that, we are just printing the type and the face. And how we are going to add the rectangular face box. For that, we are going to use a for loop and a method to create the face rectangle. This is nothing but a method to create that rectangle. This is our image object, right? And this is nothing but the RGB value of the rectangle outline. So I've given it as some color. You can give it whatever color that you want. Now this is the width of the rectangular face box, and these are nothing but the coordinates x comma y. Then we have x plus width and y plus h. So this is nothing but x plus w plus comma y plus h, right? So I hope you guys are clear with it. And let me just quickly open my PyCharm and I will execute the code there. I've already written the code, so let me just take you through it. It's very easy, guys. I have a cascade a classifier object here that I've created, which will contain the face features. Then I'm reading the image which I want to create a rectangular face box around or detect the face. I'm converting it into a grayscale image. Then what I'm going to do is I'm going to determine the coordinates of the face. For that, I'm going to use this detect multiscale method. Then I'm going to add a rectangular face box around it. For that, I'm going to use this for loop. And this rectangle is nothing but a method to create that rectangular face box. After that, I'm resizing my image and that's all I'm doing. So what I can do is I can divide it by 2 so that it becomes easier for you to see. But I don't think so I need to resize this image. What I'll do is I'll just keep it the way it is and we're going to see that particular image itself. I don't think so I need to resize it. So I'll just type in here IMG and we have our code ready that will detect the face in the image. Yep, it successfully did that. So I hope you guys have understood how we can detect faces in a particular image using OpenCV. So guys, this is nothing but the type, right? So we have a NumPy n-dimensional array. So this is nothing but the coordinates of the face. Now, if I go back to my slides, you can see here, these are nothing but the coordinates which I have displayed here, right? It's that easy, guys. Now let me go back to my slides again and we are going to see how we can capture videos using OpenCV. Interesting, right? Let's see how to use OpenCV to capture video with computer webcam. Now, before I move forward, guys, let me just tell you a few things. So what we'll be doing, we'll be using OpenCV for reading frames or images one by one. So what basically a video is nothing but multiple images or multiple frames which are displayed very quickly so that it looks like a video. So what we'll be doing, we'll be using loops to build a window where images will appear really fast so that you can see it as a video. Something like this guy. He's basically smoking a cigarette. It is nothing but 2 images, but since I'm doing it pretty fast, you can see it as a video, like he's smoking. Although I don't want you guys to smoke. Now, let us see how we can capture video using OpenCV. The first thing we need to do is import OpenCV, obviously. Then what we are going to do is create a video capture object. And this number basically tells the computer to use our built-in camera, right? If I want to use an external camera, for example, I have an external cam and I can put 1 to use that. Similarly, if I have two external cameras and I want to use the third cam, I can put two here. Apart from that, even if I have a video file, I can give the path to that video file as well. Then this will basically release the camera in some milliseconds, right? So let me just quickly execute this and you will see what happens there, right? I'll quickly open my PyCharm. Let me just go to the basics of py file and I'll just type in here video equal to cv2 dot video capture, and I'm typing in here 0 to use my built-in camera, and after that I'm going to release this, so I'm just going to type in here video dot release. That's all I have to do. Go ahead and execute this, run it again. Notice that the camera light will be on for split seconds. Again and again execute it. It'll be on for split seconds, right? So let me go back to my slides and I'll explain you there what I'm talking about. So basically when you execute the code, you will notice that your cam light switches on for a split seconds and then it turns off. So what we need to do is we need to add a time delay, and for that what we need is a time module, right? So what I'm going to do is I'm just going to type in here time.sleep3, which will stop the script for 3 seconds. For 3 seconds, your camera will be on, right? So when you execute the code, the webcam will be on for 3 seconds. Let us see if that happens or not. I'm going to execute this now. So for that, I'll open my PyCharm again. So this is my PyCharm again, guys. I need to first add time module here. And now I'll add that time delay. Time.sleep for 3 seconds. Keep my webcam on. And here we go. So we have successfully added the time delay. It was that easy, guys. Now let's add a window that shows the video. Till now, we didn't see the video. We didn't see what's happening, right? So how can I add that window? It's very, very easy, guys. I hope you guys know this. This is basically a video capture object. Now this check is a bool data type that returns true if Python is able to read the video capture object. This is just basically a true and false kind of a variable that will return true if Python is able to read the video capture object. Otherwise, it will return false. Frame is a NumPy array. It represents the first image that video captures, right? Since we saw that video is nothing but multiple images which appears really fast and it looks like a video, right? So the first image or the first frame is basically what we will store in this particular frame, the NumPy array of that particular image. So it is a NumPy array. It represents the first image that video captures. We are going to print both check and frame, and we're going to add a time delay as well. So let us just quickly open the PyCharm and we're going to execute this code there. Let me just open it for now. What we are doing here is check comma frame equal to video dot read. Let me just print check, and I will also print frame, and let us go ahead and execute this. We'll see what happens. All right. So what happened here, Python was able to read the video capture object. That's why we have got the output as true. Basically, our check has returned true because Python was able to read that particular video capture object. Apart from that, this is nothing but the NumPy array for my frame, right? Which is pretty visible. I don't think so I need to explain you why it is a NumPy array, why it is 3-dimensional. I think we have discussed quite a lot about NumPy arrays in the previous slides. So for now, I think you have understood this. What check and frame is. Check is basically a bool data type. It will return true if Python is able to read the video capture object, and frame is nothing but the n-dimensional array. So guys, now we'll see how we can actually create a window, right? So what we need to do is we need to create a frame object which will read the images of the video capture object. And we will recessively show each frame of the video being captured. So all I'm doing here is using this ImShow function again, right? And I'm going to give a name to it. And I'm going to show all the frames which are going to come till I close the window. All right. So it's pretty easy, guys. For 3 seconds, you're going to see a video being displayed on a window. And for that, I'm just quickly going to open my PyCharm. And I just need to add this ImShow function there. And let us go ahead and do that. cv2.imshow. I'm going to give a name, say, let us call it as capture. I'm going to type in here frame. Now we need to use this wait for key function. Wait key. Let us keep it as 0. So that whenever I press any button, it'll close the window. And finally, I'm going to type in here cv2, destroy all windows. So now let us go ahead and execute it. So we'll see a window that will capture our first frame. And let us see if that happens or not. Here we go. So yes, the moment I press any key, the window will disappear. All right. So this is how we can display the video on the window, right? Let me just go back. Now, how to capture the video instead of the first frame, right? For till now, what we did, we just captured the first frame that appeared in front of the camera, right? Because that is basically what video is basically what it is, nothing but multiple frames which appear really quickly, and that comes out as a video. So what we need is now we need to capture the entire video. So for that, what we'll do, we'll use a loop, because I've told you earlier as well, that is what we're going to use. In order to capture the video, we will be using a while loop, right? And the condition will be such that unless check is true, Python will display the frame. Because what is check? Check will basically return true if Python is able to read the video capture object. And if it is not able to read it, then it becomes false. So our condition will be such that if check is equals to true, then Python will display the frames, right? It will display the frame on a window. So let me just take you through the code that I've written here. Video is equals to cv2.video capture equal to 0, which is basically a video capture object. I'm not going to repeat that. I have a variable a which is equal to 1. While true, while Python is able to read the video capture object, it'll enter the loop. A is equal to a plus 1, which will keep on increasing. Check comma frame. So it'll print the frame, basically the NumPy array object. And what I'm doing here is converting the frame, the image, into a grayscale image. Then I'm going to show that grayscale image, and I've given it a time frame that is 1 millisecond. So it will be this will generate a new frame after every 1 millisecond. So this will basically generate a new frame after every 1 millisecond, right? So it is nothing but a wait key, and after every millisecond the frame will change. All right, guys. And the moment I press Q, this break statement will come out of the loop and the window will close, right? Print A, this will print the number of frames that we have captured, right? And video.release, destroy all windows, right? So let me just take you through the code again. We are importing CV2 and time module. Then what we are doing, we are creating a video capture object. After that, we have a variable a equal to 1, which is nothing but it will tell us the number of frames that we have captured. While true, which means that while Python is able to read the video capture object, increase the a value by 1. Then these two statements, we are printing nothing but the frame, the n-dimensional array object. Then we are converting that frame to a grayscale image. Then we are showing it, and after that we are generating a new frame after every 1 millisecond. That's what it is doing here. Then once we press Q, we are out of the loop, and console will print the number of frames and all those things, right? So let me just quickly open my PyCharm and I will execute it there. All right. So for that, let me just remove these things for now, right? So after this, I have a video capture object that you can see. Below this, I have a variable a equal to 1. Now I'm going to use while loop, while true, enter the loop, a equals a plus 1. Now I'm over here, I'm just going to print the frame, and now I'm going to convert this to a grayscale image. Gray is equals to cv2 dot cvt color frame, comma. Now I'm going to type in here cv2 dot bgr underscore cv2 dot color underscore bgr to gray. All right. Next up, we are going to use this imShow function. Let me just show you what I'm going to do here. I'll just type in here cv2 dot imShow. Let it be capture again, and I'm going to show you the grayscale image. And then finally, I want a new frame after every 1 millisecond. For that, I'll type in here cv2 dot wait key, and after every 1 millisecond. And over here, I'm just going to use a conditional statement which says that if key is equal to ord q, and then a colon, break the loop, right? And now I'm going to type in here print a, which is basically the number of frames. Now video dot release, and then finally cv2 dot destroy all windows, right? So I hope you guys have understood the code. I'll just quickly take you through it. Import couple of modules, cv2 and time. Then we are creating a video capture object. We are defining a variable a equals to 1, and while the condition is true, that is my Python is able to read the video capture object, we are going to create two variables, check and frame, where check is a bool type variable, frame is nothing but an n-dimensional array which will read the video, right? After that, we are printing the n-dimensional object, converting it into a grayscale image. We are showing it. We are also mentioning that after every 1 millisecond, the new frame should appear. And then once a user press Q, then the window will disappear and the control will come out of the loop, right? And then we are printing this number of frames Video.release, we know what is destroy all windows. So let us see what will happen once we execute this. And here we go. Oops, so there is an error. So all I have to do is define this variable key, and here we go. So let me go ahead and execute this. So yep, you can see the frame that is behind me, and you can see my hand as well. So let me just quickly press Q, and you'll see that window will disappear. All right, so I hope guys you have understood that how we can actually capture the video and how we can display it on the window and then things like that. So I hope it was clear to you all guys. So let me go back to my slides again. And now we're going to talk about a motion detector, right? So this is our use case, guys, and I know all of you must be waiting for it, right? So let me just take you through the problem statement, why we are executing this use case, right? Everything exists for a reason. So let us understand what are the problems that this motion detector will help us to solve. So you have been approached by an organization that is studying human behavior. Now your task is to give them a camera that can detect any motion in front of it. And it should return a graph which should contain for how long the object or the human was in front of the camera. So this is how the graph should look like. This should be the starting time, right? The moment object appeared in front of the camera, for how long it stayed in front of the camera, then it went off. Then again it appeared at this particular time, then again it went off. So this is how it should look. Time at which object appears in front of the camera, and the time at which the object moves away from the camera. So how we are going to execute it. So this is the flow diagram for that, guys. And first of all, we need to save the initial frame. So what will happen, since I've told you earlier as well, video is nothing but fast moving images. All right. So what we'll do, the moment we switch on the camera, the first frame, the first image that will appear, we will save it, right? Then we'll convert that image to a Gaussian blur image. You don't need to worry about it. I'll explain you what is Gaussian blur image. Then we'll take the frames with the object and convert it into Gaussian blur image. So basically this is done to give us the accurate results, right? So Gaussian blur image is something like that. You don't have to go into too much detail here to execute it, but just understand it. Just to increase the efficiency, we are converting our images to Gaussian blur. So we are converting our first image also to Gaussian blur, and the subsequent frames as well that will appear will also be converted to Gaussian blur image. Then what we'll do, we'll calculate the difference between the first frame and the frames that will appear after the first frame. Since the first frame is stored already, we are going to subtract that with the frames that will appear after that, right? Then what we need is, now because of this, we'll know, okay, there's a change in the frame. The initial image looked like this, but now since there's some movement or some motion, we can see that there's a difference in the subsequent frames, right? So we know that there is some motion or there is some object, but that object might be too small that we don't want to capture that. For that, what we do, we define a threshold that will remove the shadows and then too small objects or other noises. So basically we will define a threshold or the size of the pixel that should appear as and it will be considered as an object, right? I don't want a flying housefly to be considered as an object there. Just an example. Now define the borders of the object, right? So we need to give a border or a box there, right? And basically a rectangular box around the object. And then we are going to calculate the time when object appears and exits the frame. I hope you guys are clear. Again, guys, I'm repeating the logic. What happens? You first save the initial image in a frame. What happens the moment you switch on the camera? The first image that will appear, that will be saved. That will be converted to a Gaussian blur image. Similarly, whatever frames that appear after that initial image will also be converted to Gaussian blur image. Now, the difference between the first frame and the subsequent frames will be calculated. Now, that difference will tell us whether there is an object in front of the camera or not. Because if there's a change from first frame, then there is definitely some object. But that object might be too small and I might not want it. For that, we will define a threshold. All right, so this should be the size of the object in order to consider it as an object or an emotion in front of the camera. Then we are going to define the borders around that object. We'll add a rectangular box. And then finally, we are going to calculate the time when object appears and exits the frame, right? We'll save that in a data frame. And after that, we are going to visualize the data frame. That's it. We are going to create a pandas data frame for that. Now, the question is how I'm going to execute it, right? So guys, this is pretty much from what we did last time as well. So what we have here is we are going to create a video capture object. Then we are converting the frame color to grayscale. Then we are converting the grayscale image to Gaussian blur image. And this if statement will basically store my first frame or my first image. The moment I switch on the camera, whatever image comes first, it will be stored in this particular first frame variable. Right? So the statement says that if first frame is none, when there is nothing in the first frame, it will enter the loop. The first image that will appear will be stored in the first frame. And after that, continue means it will come out of the loop, right? Let's see what we are going to do next. After that, what we are going to do is we are going to calculate the difference. Since I've told you earlier as well, we are going to calculate the difference between a first frame and the subsequent frames which I have stored in gray, right? So this will calculate the difference. After that, I have defined a threshold. Now it provides a threshold value such that it will convert the difference value with less than 30 to black. If the difference is greater than 30, it will convert those pixels to white. So basically, whatever object is there in front of the screen, it will convert that to white, right? Whatever the difference is. So that's why I've given the color as well. And this is basically the difference value that I've defined a threshold here. Similarly, I've defined one more threshold, right? You can see it over here as well, thresh delta that I'm using here. After that, what I'm doing is I'm defining the contours, or you can say the borders. So basically the borders around that object which appears. Now I'm adding one more threshold, guys. This will remove noises and shadows, or even a housefly, which I don't want to detect, right? So basically it will keep only that part white which has area greater than 1000 pixels. So if my object has area smaller than 1000 pixels, it won't be detected because I don't want to detect it, right? So you can change it the way you want. You can keep it 5000, you can keep it 10,000, you can keep it 200. That totally depends on you, right? And this is basically to create a rectangular box around the object in the frame. So I hope you guys are clear with it. And finally, we are just displaying all the things. And yeah, you can see it over here as well. And you know what it is. Basically, frame will change after every 1 millisecond. This will basically close the window, and this will close all the windows. Now what we need to do is we need to calculate the time for which the object was in front of the camera. For that, we will create a pandas data frame, right? So pandas.data frame is what we are going to use here. It will have two columns, start and end, basically when object appears in front of the camera and when it went off. And we are going to tweak a couple of things. We are going to define this variable called status. Status at the beginning of the recording is 0, and as the object is not visible, right? So if there is no movement, then it will be 0 because there is no object that is there in front of the screen, right? But it will change the status when the object is being detected. The status will become 1, right? Similarly, we were going to append the status, list of status for every frame. For every frame, we are going to append it. So this basically tells us the second last status list value, all right? These two conditional statements will basically record date time in a list when change occurs. Let me tell you how. So if my status underscore list, the last value of this list is actually equal to 1, which means there is an object. But my second last value says that there was no object before in the previous frame. That means there is an object which has appeared, right? So that basically the time at which the object has appeared will be stored here. Again, which will be stored here. After that, if you notice the second conditional statement, which says that my last frame does not have anything. I mean, there's no object in front of it, in front of the camera, but in my second last frame, there was an object. That means the object went off, right? So it will note that time as well when the object was not there in front of the screen. That's simple, guys. So this will basically create a pandas data frame that will have two columns, start and end, which will tell us when the object appeared in front of the camera and when the object went off from the camera. Right? So this is how it is. And then what we are going to do is we are going to use this for loop in which we are storing the time values in a data frame, right? I think you guys are aware of pandas. If you aren't aware of pandas, I'll leave a link in the description box below, which is nothing but a detailed tutorial about pandas and data analysis using it. So go through it if you are not aware of pandas. It's a very important library. I think every Pythonist should know about it. And then we are going to store it in a times.csv file. So it will be a CSV file. Right, so time end time is equals to I plus 1. Ignore index. So we don't have any index values here, right? We don't want to display the index, so there is no index value here. This for loop is pretty self-explanatory. So let me just go ahead and execute this first, and then I'll tell you how we have visualized it. So here is our motion detector, guys. I've explained to you the code in detail, and if you want the code, you can go ahead and mention your email ID, and we will reply you back. We'll basically provide you with the code. So if you're looking to execute it on your own, go ahead and mention that, right? So what I'll do is I'll first, won't come in front of the camera. I'll go away because it has to first capture the first frame. Then only it can identify the difference between the subsequent frames, right? So guys, I'll execute it now. And what will happen, it'll first capture the first image which is there in front of the camera, and any movement that will happen, it will capture that, right? So the first frame will be stored. Then the difference between the first frame and the subsequent frame will be calculated in order to determine if there is an object in front of the camera or not. Let me go ahead and execute this. So guys, you see a plain background. There's nothing, right? So this will be saved, the first frame. And then let us see what will happen if I bring in my hand. So there's a rectangular box around my hand, you can see, right? So it is basically capturing the motion around the camera. And all of these things are saved in my pandas data frame. right? So you can notice my hand is coming and then it is going off. So all of the time at which the hand appears in front of the camera and the time at which it went off will be stored in my pandas data frame because I have two columns, start and end, right? So if I just minimize this, let me show you the Gaussian blur image as well, right? So yeah, in that Gaussian blur image, I have defined that, to keep the object white if it is greater than 1000 pixels, right? So this is what comes up, right? Yes, this is Gaussian blur image. This is Gaussian blur, yeah. And this is a gray frame, which you can see over here. Let me press Q, it'll close all the windows. Now let me show you this times.csv file. So, yep, this is how it looks. Now let me go back to my slides again. Now basically what we are doing is we are going to plot it on the browser using the Bouquet library. Now guys, to explain Bouquet, it'll take a lot of time, right? I've just written the code here to show you how the graph will look like. I'll be coming up with a separate tutorial on Bouquet if you guys want. So if you really want a tutorial on Bouquet, which is nothing but a library that helps us to visualize the data on the browser, you can go ahead and mention that in the comment section that we want a tutorial on Bouquet as well, right? For now, I'll just go and open my PyCharm and I'll execute the code there. So this is my code that will help us to visualize the graph, right? So it is basically using the motion detector, which I have here, right? From this file, it will take df, the data frame which we have created. So let me just go ahead and run this. Right, so again, I'm just going to put my hand a couple of times and I'm going to put my other hand as well. Yes. So yes, I think it's a good enough size of the data frame and it should appear in the browser. The moment I press Q, you'll see that there'll be a graph that will appear on our screen. And here we go, guys. So this is the graph that I was talking about, end time, start time. So let me just increase the size for you guys. So yeah, this is how the graph will look like. Start time, end time. So we have everything here. So guys, so I hope you have understood this and it was an interesting session for you.
Top 5 frameworks in Python. So without wasting any more time, let's look at the agenda for this session. So first of all, I'll be starting with what exactly are frameworks in Python. Moving further, we will discuss why we are using frameworks, and then I will list out the top 5 frameworks that we have in Python, namely Django, Web2Py, Flask, Bottle, and CherryPy. I hope you guys are clear with the agenda. So let's quickly try to understand what are frameworks in Python. Python is a general purpose programming language. It is one of the most popular programming language nowadays. We can use it for so many applications, including web development. Now, a framework is a collection of modules or packages which helps in writing web applications, or it helps in web development. Now, we don't have to worry about the low-level details such as protocol, sockets, or thread management when we are working with a framework. Frameworks make the developer's life easier by giving them a structure for app development. They automate the implementation of common solutions, which gives the flexibility to the developer to focus only on the application logic instead of the routine processes. They provide common patterns for faster, reliable, scalable, and easily maintainable web applications. Now let's take a look at a few operations that are used to run web applications using frameworks. So I have listed down all the operations here. So first of all, we will talk about URL routing. So URL routing is the mechanism of mapping the URL directly to the code that creates the web page. The next one is the input form handling and validation. Coming on to the next operation is output formats with templating engine. Now you must be wondering what a templating engine is. A template engine allows developers to generate a desired content types, for example HTML, XML, or JSON. We also have the data connection configuration and persistent data manipulation through an ORM. ORM is also known as Object Relational Mapper. Now you must be wondering what is the function of an ORM. An Object Relational Mapper or an ORM is a code library that automates the transfer of data stored in a relational database table into the objects that are most commonly used in an application code. We also have the web security against cross-site request forgery, also known as CSRF, SQL injection, cross-site scripting, and other common malicious attacks as well. The last but not the least is the session storage and retrieval. So these are only a few operations we can perform using the frameworks in Python. Now let's try to look at a few advantages of Python frameworks. First of all, Python frameworks are open source, which means you don't have to spend any money while working on a Python framework. The next one is it has a very good documentation. All the frameworks in Python have a very good documentation, which means you can learn easily the functionalities and the key features of any framework using the good documentation that it has. The next one is the security, where it provides security against the malicious attacks, and then there is integration and efficiency as well. So these are the advantages of using a Python framework for web development. Also, there are a few limitations when we are working on a Python framework, which is it is open source, so the code is going to be public. So that is one issue here. Also, there are a few limitations when we are using a framework, because the difference between a library and a framework is it adds to a few rules and regulations when it comes to a framework. Now let's try to understand why we are using a framework. Now we know that frameworks make it easier to reuse the code for common HTTP operations and to structure projects so other developers with the knowledge of the framework can easily build and quickly maintain the application. So these are the advantages, which is why we are using a Python framework. That is easier implementation, we have the maintenance, and the readability is pretty good, and then there is code reusability as well. So these are the reasons why we are using Python framework instead of a library, right? So now that we have understood what are frameworks and why we are using them in Python, and also we have discussed the key features and advantages of Python frameworks, now let's try to look at the top 5 frameworks that we have in Python. So first of all, let me talk about Django, guys. Django is a free, open source and a full stack Python framework which includes all the necessary features by default. It follows the DRY principle, which says don't repeat yourselves. Also, Django uses ORM to map objects to the database tables. Some of the exemplary features of Django are authentication, URL routing, template engine, and the ORM. Also, there is database schema migrations as well. Now, the main databases that Django works with are PostgreSQL, MySQL, SQLite, and Oracle. Also, it follows the MVC-MVT architecture. So let's try to understand what is an MVC-MVT architecture. The model view template, or MVT, is slightly different from MVC, which is the model view controller. In fact, the main difference between the two is that Django takes care of the controller part itself. The controller part is basically the software code that controls the interactions between the model and the view, leaving us with the template. Now, the template is a HTML file mixed with the Django template language. Now, looking at the diagram, we can understand that the developer provides the model, the view, and the template, and then just maps it to a URL, and Django does the magic to serve it to the user. So this is the MVC-MVT architecture, guys, and this is all about Django. Now let's try to understand the next framework that we have, which is actually Web2Py. Web2Py is a scalable, open source, and a full stack Python framework. However, you should know that it does not support Python 3. Now, what is so great about Web2Py, right? It comes with its own web-based IDE, and among other things includes a separate code editor, a debugger, and one-click deployment as well. Now, looking at the other valuable Web2Py features, it includes no requirement for installation and configuration. It has the ability to run on different platforms. It has the ability to read multiple protocols. It also provides us with data security that prevents such vulnerabilities like cross-site scripting, injection flaws, and malicious file execution. It also has an error tracking system through error logging and ticketing systems. Also, it has the ability for role-based access control. And last but not the least, it has a backward compatibility that ensures user-oriented advancement without the need to lose the ties with earlier versions. So this is all about Web2Py, guys. These are all the features that we have in Web2Py framework. Now let's talk about the next framework that we have, which is Flask framework. So talking about Flask, Flask is a micro framework, guys. Now the difference between the full stack framework and a micro framework is the full stack framework does the heavy lifting for the application that we are making. But the micro framework is small and very easy to use. Also, when we are using the micro framework, the URL routing is going to be RESTful for many of the occasions. So this is the basic difference between a full stack and a micro framework, guys. Now let's try to look at the features of the Flask framework. So I've already told you it is a micro framework. It is lightweight and it has a modular design which makes it easily adaptable to developers' needs. It also includes a number of useful out-of-the-box features which include a built-in development server and a fast debugger. It also has an integrated support for unit testing and the RESTful request dispatching. One more thing guys, Flask supports the Jinja 2 templating. Now you must be wondering what is a Jinja 2 templating, right? So Jinja 2 templating is nothing but a modern day templating language made after the Django's template language. Coming on to the next features, we have a Flask. It has secure cookie support, that is the client side sessions. Then we have WSGI compliance as well, which is the web server gateway interface. Now you must be wondering what is WSGI guys. It actually implements the web server side of the WSGI interface for running the Python applications that we are making. Now Flask is also Unicode based and also has the ability to plug in any ORM. Last but not the least, we have the HTTP request handling as well. So these are all the key features of Flask framework guys. Now that we are done with Flask, now let's move on to the next framework that we have, which is Bottle. Talking about Bottle, Bottle is also a micro framework guys. Originally it was meant for building APIs. Bottle implements everything in a single source file. It has no dependencies apart from the Python standard library. Now its default features include routing, templating, utilities, and a basic abstraction over the WSGI standard. Bottle is a perfect solution for prototyping, learning the organization of web frameworks, and building simple personal apps. So these are the features of Bottle framework, which is also a micro framework guys, just like Flask. So now that we are done with the key features of Bottle, let's take a look at the next framework that we have, which is CherryPy. CherryPy is an open source minimalist web framework. It makes building Python web applications no different than building any other object-oriented program. It allows you to use any type of technology for templating, data access, and so on. However, it's still able to handle sessions, statics, cookies, file uploads, and everything else that a web framework typically can. Now let's try to take a look at some default features of CherryPy. It has an HTTP compliant WSGI thread pooled web server. It has the simplicity of running multiple HTTP servers at once. It also has a powerful configuration system, a flexible plugin system. It also has out-of-the-box tools for caching, encoding, sessions, authentication, static content, etc. Now CherryPy also has a built-in support for profiling, coverage, and testing. And last but not the least, it also has the ability to run on different platforms. So this is all about CherryPy guys. Now that we are done with the top 5 frameworks and we have discussed the key features of all these frameworks, let me take you to PyCharm guys, where I have a sample project that I made on Django and Flask. So this is actually where my project is saved guys. So I'll go to my project, and this manage.py file is actually the file which helps with the management of the site, and we can start a web server without installing anything else. So I'll copy this path guys, and I'll go to the project that I made over here. And if you want to know how you can make a project or install Django on your system and then make a web app, you can simply go to the Edureka YouTube channel, where we have the detailed tutorial about Django, in which we have a detailed tutorial about Django web development, and where you can actually learn to build a simple app from scratch. So what I'll do is I'll just write the path that I have copied. So now that I'm in my directory where I want to run my server, I'll just write python.manage.py to run my server. I'll just write run server. Now you have to pay a little attention to these files that you get while creating your project in Django. So these files are there. So settings.py file actually has the configuration of your website, and url.py have the list of patterns that will be used by the URL solver. And then you have the database, the time zones, and everything else that you can actually edit in your settings.py file. So I'm not going to go line by line explaining everything. So I'll just explain you that I have one more directory polls over here, which is actually my app. And in this I have migrations and the template. Inside the template I have the HTML file where I have actually written the code of my survey form that I have made, that I will show you guys. So when I run this server, what is going to happen is I'll get address. Wait, let it run. So I'm getting this address guys. So when I go on this address and write polls, that is the name of my app, I will get this survey form that I have made and stored inside the template that I had made. So this is actually a very basic survey form that you can make from using the Django app. So let me show you guys what the same thing you can do using Flask. So I have also made a project using Flask as well. So in this we have the main file, main.py, when you install Flask, you can simply import it, and there is no, I'll show you guys in the project interpreter. So inside in project interpreter, you can just add Flask over here. If you don't have installed it in your system, you will find it over here. You can install the package and you are good to go. So now that I have told you about the main.py, then we have a render template in which we are going to store the HTML file, the template that we have. Inside this, I have also written the same code for the survey form. And to run this server, we are just going to run this main file, and you will get an address, see over here. And when you go over here and type the name of your app, that is profile, you'll get the same survey form that I had got. So this is a sample project, guys, that you can make for practice. Although it is a very basic thing that you can do, you can connect it to your database, and there are so many things that you can do while using these projects. So this is only a very basic project that I have done using this.
Let's move on and see why Python is used for web development. Guys, Python allows you to build web applications dynamically. It's a very stable language. It also grants you ease to build multi-protocol network applications. The fact of Python being flexible, easy to use, and its quick processing are just a few reasons to mention for its worth in web development. Now that I've explained about the features of Python, let's take a walk through some of the libraries that Python provides for web development. Guys, Python provides a number of libraries for web development. Some of the important ones are CherryPy, Django, Web2Py, Pyramid, TurboGears, and Flask. Among these, in today's session, I'll be using the Django framework. So now y'all might be wondering why Django and why not any other library. Django is truly the best Python library for web development. It's written purely in Python and it's fast. You can create websites within a matter of few hours. It's fully loaded with all the required tools to create websites, and it's very secure. Be it YouTube, your Dropbox, Google, or Instagram. All these internet giants rely on Django. So with this, I think I've given you enough for why I've chosen Django over the other libraries. So as you can see over here, web project has been created within the current directory. So after this, I'll just open up the terminal. And over here, I'll use the command pip install Django. It's going to take a while to install Django, guys. So when you're installing Django, along with Django, the SQL parse database and the pytz module also gets installed. SQL parse is actually a non-validating SQL parser for Python. It provides support for parsing, splitting, and formatting SQL statements. Now this is actually compatible with the versions of Python from 2.7. The pytz module is actually a third-party module that brings the Olsen TZ database into Python. TZ actually stands for time zone, guys. This library allows accurate and cross-platform time zone calculations using Python 2.4 or higher. It also solves the issue of ambiguous times. Okay, so once Django has been installed, it will throw a message saying successfully installed Django with its version and the version of the pytz module and the SQL parse. Now to cross-check the installation of Django, go to your command prompt and use the command python -m Django --version. Now when you use this command, it should return the version of Django that's been installed. So I hope everyone's getting the same. Okay, so now let's close this. I hope everyone's clear with this. For any doubts, guys, please do let me know in the chat box because my team is always here to help you. So now to create a Django project, within this project, I'll use the command django-admin start project, and I'll give a name to my project. Let me give the name as demo project. Okay, so now a demo project has been created within the web project directory. Let me open this directory, and here it shows the web project that's been created. Let me just go to the presentation mode and show you all. I'll go to view and I'll select the files that I want and the terminal. As you can see over here, within the demo project directory, there's another directory with the same name as my project, and there is a file created by Django called as the manage.py file. The manage.py file is actually a command line utility that lets you interact with the Django project. Don't worry guys, we'll be using this many a times, so you'll get familiar with this. Now let me just open this directory and see what's present within it. The first file that's created within this directory is the init.py. Now the init.py is actually an empty directory which is considered to be a package. After that, there is something called as the settings.py. This actually consists of all the settings that are necessary for the current project. After that, it's urls.py. urls.py consists of all the URL declarations for this project. And finally, the wsgi.py file, where WSGI stands for Web Server Gateway Interface. Now this is actually a calling convention, guys, for web servers to forward requests to web applications or other servers. So I hope everyone's clear until here. If you have any doubts, do let me know in the chat box. Okay, so now to check if I'm able to connect from my project to the web server, I'll just get into my project using the cd command. And after this, I'll use python manage.py run server. Like I told you, the manage.py file will help me connect to the server. So this will return an IP address. So when you click on that address, you will see a screen with a rocket which is ready to take off. So congratulations guys, your rocket is ready to move on, which means you're all set to create your own websites. So I know that after this, everyone would be excited to create their own websites. To do so, I'll just get back to my PyCharm and show you guys what exactly you must do to create your own websites. Okay, so to create my website, all I'm going to do is create an app within my demo project. I'll just return the control to my terminal using Ctrl-C, and over here, I'll create a new app within my project. Please make a note guys that one project can have n number of apps, which means you can include any number of apps within your project. To create an app, I'll use the same command, which is python manage.py, and instead of run server, I'll use the start app command and I'll give a name to my app. Let me just give the name as demo app. So now an app has been created within my project. Let me just open this up to show you all what's present within this demo app. So just like how Django had created files for us within our project, when we created a new app, Django has created the necessary files for us. So this is what Django does. It writes all the necessary code, and all you have to do is write your website specific codes and just modify the files that are present and add your own files as per your choice. The first file that I'm going to open over here is views.py. And as you can see over here, Django has already imported render for me. Now I want to use the HTTP response function. So I'll use from django.http import HTTP response. Please be careful with your spellings, guys. Now within this file, I'll create a new function using the def keyword, and I'll give the name of the function as hi. To this function, I'll pass one parameter, which is request. Within this function, I'll just write one return statement using the HTTP response function. I actually want this function to return a message saying that this is the homepage of my website. I'll just put it as a string and I'll use the h1 tag for this. This is my homepage. And I'll close the h1 tag /h1. So as you can see over here, PyCharm has highlighted this line because I'm using the HTTP response function. The first line of my code is not highlighted because I'm not using the render function anywhere. As of now, I'll not be using the render function. However, I'll be showing you all how to use this later on. Okay, now I've created views for my project, but I will not be able to connect this file to the urls.py which is present in the demo app. To connect views.py to this urls.py, I'll have to create another urls.py within the demo app directory, and connect that urls.py to the urls.py which is present in the demo project. Don't get confused, guys. I'll be doing it over here and the video will be available after this. In case you have any doubts, you can go through it again. So I'll just create a new file within this app. It's going to be a Python file. I'll give the name as urls.py and I'll say OK. This urls.py is actually very similar to the urls.py which is present in the demo project. So I'll open the urls.py present in the demo project directory and I'll copy the from statement which is from django.urls import path and the URL pattern list. I'll just copy this and I'll go to urls.py present in my app and I'll paste it over here. Now over here, since I want to map the views.py into this urls.py, what I'm going to do is use from dot, which means from the current directory, import views. And within the URLs pattern, I do not want this admin path, so I'll just remove this and I'll leave the name as blank because I want this to be mapped to my home page. And over here, I'll use views.hide, which is the name of my function. And I'll give a name to this path. You can give any name of your choice. Let me just give the name as homepage, home-page. Okay, so after this, what I have to do is map this urls.py to the urls.py which is present in the demo app. So I'll open the urls.py present in the demo app. And over here, I'll create a new path and I'll give an empty string because I want it to be mapped to my homepage like I already told y'all. Sorry guys, I'll have to import the include function also. So from django.urls, I'll import the include function. And over here, I'm going to use the include function. I'll map the urls.py present in my demo app. And I'll close this. So after this, let me just go to my terminal and use python manage.py run server. I've just made a name mistake. This is demo app. Okay, so as you can see over here, it has returned the IP address again. I'll click on this IP address. Congratulations guys. Instead of that rocket which we were seeing previously, which was the default page, my website is displaying whatever I want it to display. So this was the message I wanted to display on my home page, and it shows that this is my home page. So now I'll get back to my PyCharm and I'll see how I can modify this page to create a website. I'll return the control back to my terminal using Ctrl+C. So to write HTML code within this project, all you have to do is create a new directory within your app directory. And that will be the templates directory. Now these will be the templates that are specific to this project. And instead of looking elsewhere, Django will look into this directory for the necessary templates. Within the templates directory, I'll create a new directory with the same name as my app. Don't get confused with this, guys. This is actually the Django convention which helps you write project-specific code. So within this demo app, I want to write the HTML code. So I'll create a new HTML file to write all the HTML code that I want. I'll just give the name as hi.html and I'll say OK. So as you can see over here, Django has already written the minimum HTML code for me. I'll just change the title to Edureka, guys. You can give any title of your choice. And within the body, I'll just write hi. And after this, I'll open the apps.py file. I'll copy the name of this class. And then go to settings.py, present in my demo project. And over here, I'll look for installed apps. Remember that whenever you create new apps, you'll have to add it over here. Then within a string, give the name of the app, which is demo app. Please be very careful with the spellings because if you make any mistakes, it's going to throw a lot of errors and you'll not be able to understand why it's throwing such errors. And for beginners, it sometimes gets very confusing to debug these errors. So just be careful over there. So let me get back to this. Name of my app, which is demo app, dot apps, dot the name of the class that we've copied from there. I'll just paste it over here. and I'll specify a comma after this. Now from here, I'll go back to my views.py file, and instead of this HTTP response, I'll be using the render function. So I'll just remove this. I'll return render, and I'll specify the request function. And then within a string, I'll specify the HTML file which is present in the demo app. So demo app / hi.html, which is the name of my file. Guys, please write the same name which you have given to your file. I'll run my server again after this. So python manage.py run server. Let's go back to our server and see what happens. So as you can see over here, guys, the title has changed from the default address to Edureka, and my homepage now shows a message saying hi. So I hope everyone's clear with everything until now. Now all I'm going to do is go back to my HTML file and do some modifications to create my own website. So now to create my own website, I'm just going to modify this HTML page. Guys, if you're done till here, you've been successful in creating a website. Now all you have to do after this is specify your project specific HTML code. Let me just show you a few basic things that you can do using HTML over here. So I hope everyone knows some basics of HTML. Let me just change the message from hi to welcome to Edureka. Okay, I'll just specify the second line of my page to be some h2 tag and a new message saying that this is my website. Let me save this and rerun my server. I'll just go back to my server and I'll reload the page. So as you can see over here, the h1 tag says welcome to Edureka and the second h2 tag says this is my website. So this is how you can write your own HTML code to your program, guys. So now let me create some list over here. To create a list, I can either specify it to be an ordered list or an unordered list. For ordered list, I'll have to use OL tag, and for unordered list, I'll have to use the UL tag. Over here, I'll be using the unordered list, and within this list, I'll specify the list elements. First element is Python, and the second element I'll give as Java or something. Okay, let me save this, go back to my server and reload this page. So as you can see over here, guys, it has created an unordered list over here. So now let me show you all how to create a table over here. So to create a table for your website, you can use the table tag and specify whatever style you want for your table. In my case, I'll just give the width to be 30% and I'll close this. So within the table, you can have the TR, the TH and the TD tags. The TR tag is actually for the table rows, TH is for table headings and TD is for the table columns. I'll just write a TR tag over here, and within this TR tag, I'll specify the TH tags. Let me just give the heading as Python, and I'll give another heading as Java. So after this, I'll create another row using the TR tag. And within this, I'll specify the columns. So for that, I'll use the TD tag. And I'll just specify which IDE you can use for Python and Java. So for Python, you can use PyCharm. Let me just copy this. And for Java, you can use Eclipse. So I'll change the name from PyCharm to Eclipse over here. And I'll save this. So as you can see over here, a table has been created. But guys, my table over here does not have any borders. To add borders to my table, I'll go back to my HTML page. And over here, within head, I'm going to use the style tag. And within this tag, I'll specify what border I want for my table. Let me save this and reload my page. So as you can see over here, guys, I included the style tag and specified what kind of border I want So the same way on my server over here, a table has been created with a specified style. To know more about HTML and learn how to create beautiful websites, you can just go to the Bootstrap website. And from here, you can take any code that you want for your website. So I'll just show you what happens when you use this. So let me just use the style from the Bootstrap, and it should be present within the head. So I'll just paste it over here. Let me save this. I'll go back to my server and I'll reload this page. As you can see over here, guys, using the small bit of code that was present on the Bootstrap website, my website looks so much more better than what it was looking before this. You can use this Bootstrap website to create your own beautiful websites.
Web scraping using Python. Now without wasting any more time, let me quickly tell you what all we are going to cover in this session. So these are topics that I'll be covering in this session. So I'll start the session by first discussing the need. What is the need of web scraping, or why do people actually scrape a website? And then we'll understand what exactly is web scraping. Now once we get an idea of scraping, we'll then understand the different libraries which are used to scrape a website, and towards the end we'll be doing a demo where I'll be scraping a website from the scratch. So in this demo, I'll be fetching some details from Flipkart. So I hope you guys are clear with the agenda. Now let me begin with the very first topic, that is the need of scraping, or why do people actually scrape a website. So scraping is basically extracting data from various websites. Now there are many ways to collect data online, but let's say I just want to collect data for comparison. So here let me take an example of MySmartPrice, which is known for best price comparison. So what they do, they collect data directly from merchants. Now the larger stores generally provide the feeds which are listed on their stores. But what about the smaller stores? Now one way of doing it is to either copy the prices from different websites and then paste it to your local system, which will in turn be a very tedious job and it will consume a lot of time as well. So what you can do, you can simply scrape the prices from different websites. Now apart from these, there are many use cases, or you can say real life examples where people do scraping. So here first is your e-commerce portals. Now here what you can do, you can build your own website and then scrape products from retailer, or you can say manufacturing websites. So basically you can scrape prices, ratings, images, or any other specifications as well. Then you have market research. So here scraping can help you in providing important information to identify, to analyze the market, to analyze the need, its size, and the competition of market as well. Now it can be any kind of industry. It can be your travel areas where you can scrape reviews, or you can scrape products, or any places, hotels, restaurant, or it can be anything. Then you have social media. So here people scrape business profiles from social networks and track their online presence and reputation, and hence the list goes on. So people generally use web scraping to build the best marketing strategies, monitor them, and hence upgrade their business. So in a way, web scraping provides them a way to get information, whether it can be a website prices, it can be images, it can be data, for any analyzing purpose as well. So also you do scraping because many websites do not provide an API, unlike Facebook, Twitter and all. But in many cases you will find that web scraping is the only alternative to get data out of them. So we have discussed the various real life use cases which uses web scraping. But here the question is it actually legal? Well, maybe. Scraping is fine till you are not causing any considerable damage to the target website and you are doing it responsibly. So website is legal as long as there is no attempt to change the article or blog or anything. You should not try to override the restricted access of the website or play around with the security mechanism. Now let me tell you the companies who have faced problems while web scraping. So you all must have heard about LinkedIn. So in 2014, there was a case where they sued a group of dependents in California. Now this case was based on Digital Millennium Copyright Act, where they used a series of bots and fake profiles to scrape the data from other member profiles. So that is why you should always know the difference and respect the fine line between collecting information versus stealing it. So now let's understand what exactly is web scraping. Now as I've already explained you the need, it will be very easy for you to understand this concept. So web scraping is a method where you pull data from different web pages, extract the useful information, and then store the same data to your local storage. Now this local storage can be in any form. It can be in XML form, it can be CSV, or it can be any database as well. So web scraping is a technique where you automate the procedure within a fraction of seconds instead of manually copying the data from websites. Now we know scraping is when you extract any information. Now if you want to extract through a browser or a website or a web page, so that process is known as a web scraping. So let us see the basic steps which are involved while scraping. So the very first step is document load. Now in our case we are doing web scraping, so we have to load the entire document, which is your HTML page. Next is your parsing. So parsing is basically where you interpret your document to make your searching possible. So in HTML there is your DOM by which you interpret all the HTML code. Next is your extraction. So here you simply extract anything like the name, like the price, or any specification of the product. And the last is your transformation. So here it basically converts the data into useful formats. Like for example, you can change the type here. Now if you have a date string and you want the output as date, so you can transform it in any form. So these are the steps which are involved to do simple scraping. Now let us see what are the different packages that are used for web scraping. Although I would recommend Python because a lot of people use it for web scraping. Well, the good part about Python is that it has libraries for everything. Now this is why it is the go-to language for many developers. Now as you can see here, there are a lot of libraries which are used for web scraping, such as Pattern, Scrapy, Mechanize, Beautiful Soup, and Request. So I have only used scraping. I have only used Python for scraping because what I like about Python is that it makes a string manipulation very easy. So string manipulation basically is the key where you parse any information from a page. Along with this, it is also compatible with various databases such as your NoSQL databases like MongoDB, and MongoDB is what we mostly prefer to use for data storage in web scraping. Now as you can see, there are different Python packages. Now these are not enough. We also have some other Python libraries such as XPath, you have PDF, you have Miner, and many more. But here if you see, Beautiful Soup and Request are the most popular libraries in this lot, and later in the demo we'll be implementing them as well. So Beautiful Soup is a Python library which is used for pulling data out of your HTML and XML files. Now it provides you simple, in fact very simple ways of navigating, searching, and modifying the HTML and many more things like that. Next is your Request. So Request is a library which is widely used for sending and receiving information over HTTP. Well, that's all for the theory part. So now let me move on to a demo part where I'll be scraping a website from the scratch. Excuse me. So here we'll be scraping Flipkart. Now let's see what all we can scrape from it. So we all know Flipkart is an e-commerce company. So what I'll do first, I'll simply search a product on Flipkart. Let's say an iPhone. So here as you can see, the list of all the iPhones will be displayed. Now what I do, I have to fetch the name of the iPhone, what are the configurations, what are the ratings, and what is the price of the iPhone. So fetching all these details, I need to first view the HTML page. Now how will I do it? I have to simply right click it and go to the inspect. So this will basically open up my HTML code. Now this is my HTML code. So to understand this HTML, let me open my PyCharm and let's understand each component one by one. So this is my PyCharm community, guys, and as you can see, this is the code for scraping Flipkart. Well, it is not that big code because Python makes it very easy. It has small syntaxes and it is very much similar to your English language as well. So what I have done in the beginning, I have simply imported two libraries which are Beautiful Soup and Request. So these libraries I have already discussed. So how you can import them? You can simply go to File, then go to your Settings, open your project interpreter, and here all your packages will be present. Now here as you can see, we have Beautiful Soup 4. So we just click on that and just click OK. So these packages will be imported automatically. Now I have named my beautiful soup as soup and request as you request, because I don't want to use beautiful soup and request again and again. Next, also I have used URL lib, which is a package. Now if you're using Python 2, you have a different package. You will be having URL lib 2. Since I am using Python 3, so this will work for me. And then I have a function which is URL open. So this function will basically import all the dependencies. Next, what I've done, I've simply specified the URL which I have to scrape. So let me just copy this URL and let me show you what does this display. Or in fact, if you don't want to copy it, just simply type in flipkart.com. You can search the product. Now in my case, it's iPhone. So as you can see, there is a list of iPhones that are displayed. So here we have all the necessary details of it. We have the title, we have the ratings, we have the reviews, we have the price as well. So this is all the Flipkart page. Now let me go back to PyCharm and let's understand the code. So here what I have done, I have my uRequest, which will basically opens up the connection, and this will grab the web page or the Flipkart page in our case, and then it will directly load it. And then what I have done, I have simply saved it to a variable which is uClient. After that, what I have done, I have passed the same variable to the read function. So this read function will dump all your data which is gathered and then store the same in the variable which is page_html. And then I have closed the connection. Then what next I have to do? I have to parse my HTML because it's a large HTML file. So let me show you the HTML. Now to see HTML, you just have to right click, go on inspect. So here on the right hand side you see your HTML code. Now if you move your cursor, you will see the left side, the pointer will be changing. So here if you want to see which part it is showing, you have this title, then if you go down you have the reviews and the ratings, and then if you'll go down, you have the content, or you can say the description, and after that you have the price. So what I have to do, I have to first search for the main class in which all these features are present. So if I go up, so this is my main class, or you can say the main div class, which covers all the element. It has title also, it has price also, it has ratings, reviews and everything. So I'll just copy this class. I'll go back to my PyCharm. So here I have written this, pasted this, the same div class which is over here. So here I have page soup, which will help me to pass my HTML, and then I've used a function which is find all. So here it will find all the div tag which is a class. Now in some cases it may be ID also. So here we have div tag, which is a class, and the name of the div tag, and then I have stored it into containers. So next what I'll be doing, I'll be printing the length of these containers, which will basically tell me how many products that I have on this web page. So I'll comment the whole code for now. So here as we see, there are 24 products on the very first page of Flipkart. So let me show you again. So here as you can see, there are many products. Now using this length function, I have calculated that there are 24 products which are displayed on the very first page of Flipkart site. So this was for the one div class, or you say just one container, but let's say I have to fetch details of each product which is present on the web page. So what I have to do, I have to traverse the DOM elements. So first of all, I will first see the containers, or you can see the HTML code for the very first index. So here I'll be writing print soup.prettify containers and the first index. So prettify is a function which is used to beautify your HTML, or basically it will bring your HTML in a structured, or you can say an organized format. So let me just run this whole HTML. So here my HTML, so this is my basically HTML. Now what I'll do, I'll copy the whole HTML and I'll place it somewhere else. Let's say I'll place it in my notepad, so that we can see it simultaneously. Now let us try to read this HTML a bit. Now here first we'll figure out what things we need to scrape from here. So here the first thing that it is visible that we need a title of this. We need the title of the phone, which is Apple iPhone SE space gray, and it is 32 GB. Now this title is present inside a div tag, inside another div class, and then it has an image tag. Then let's see what else we can scrape from here. So here we have 4.5 rating, so this is the rating, so we can scrape this as well. And then moving on, we have the price as well. So these are 3 things that we can scrape. We have many more things, but for now we'll just be scraping these 3 things. So let me go back to my PyCharm and let's see what is the first thing that we'll be going to scrape. So here what I have done, I need a loop for traversing these elements. So for that I have stored the elements of containers in a variable called as container. So this containers is my main div class which has all the elements present. So now what I'll be doing, I'll be first printing the title, or you can say the product name. So for that, let me open my HTML. So here, as you can see, in this container I have a div class, and inside that div we have another div, and inside that div we have an image tag which has a title alt, and this is basically the attribute of it. So attributes are always written in square brackets. So here, as you can see, I have print the container, and inside container there is div, and inside div we have image, and then we have a attribute which is alt. So let me just print this and let me see what does it display. So here we have the first name, or you can say the first phone, or you can say the first title of the phone. So this is my Apple iPhone SE space C that we have already seen in the HTML. Next, what I have to do, I'll scrape some other thing. Let me just comment this thing. So next I'll be scraping price. So let's see where this price is present. So here is my price. Now I have to see that in which div class this price is present. So in this div class which has the title this, so I'll just copy this and I'll go back to my code and I'll paste it over here. So this is the exact same div class which I'm talking, this. Now inside this I have container which find all the div which is a class, and then the name of the div class. Now here if you see, I have print price 0.text. Now why text? Because as you can see here, I have React ID, I have data React ID, then I have React text, then I have a rupee symbol, and we have many more tags, but this price is not enclosing any of the tags. So for that, this becomes my text. Now similarly, I have 21,000 as text, and I have 26,000, and all these things will become as text. So let me go back, and here I have print price 0, which is the first element, and then the text. So let me just print it for you. So as you can see, all the text has been displayed. So it says 21,000, which has some 19% off, and then it tells me the EMI option which starts from this price. So this is how I have fetched my price. Now what I have to do, I'll be printing ratings as well. So it will be the same procedure. So first I'll just comment the price. And for ratings, let me again go back to my HTML and let's see where is my rating. So this is my rating. Now again I have to see which class it is present in. So this is present in this class. So I'll again copy this class. I'll go to my PyCharm. I'll paste this, and then I'll say rate container which find all the div tag which is a class, and then the name of the class. Here also I have done the text, because if you go ahead and see HTML, you will see a lot of things. You have 4.5, then you have stars and all these things. So it will be very easy if you write text. So if I go ahead and run this program, so as you can see 4.5 star 3 this rating and this reviews have been printed. Next I have all the details like title, price, ratings. So let me just print them once again for you. So we have your title, we have price, and then we have ratings. So let me just print it together once more. So as you can see, I have the title, I have the price, and I have the ratings. So now what I have to do, this is showing in my terminal, but what if I want to show this in my file? So now I'll be creating a file. So I'll just again comment this, and here I'll be creating a file. So here I have created a file which is named as products.csv, and then using the open function I have instantiated a mode that is write and then stored the same in F. So this F is a normal convention of Fwriter. Then what I have done, I have created some headers to it. So because CSV do have headers, so I have added manually headings to it. So I have written product name, or you can say title, then the pricing, and then the ratings, and then I have simply write it. So I have these three things for one containers. Now I have to do the same for all the containers, or you can say all the div classes which is present on the web page. So for that I need a for loop. So what I'll do next, I'll create a loop. Now here it will say for container in containers. So containers is the main class where all your element is present, or your features are present. So here I want the same things. I need the product name, I need the price, and I need the rating. So here I'll just simply copy the same things which I have already showed you. So here for printing the title, I have written container.div.image and alt. So I have copied it here, and then I have saved it into a variable which is product name. Similarly for price. Similarly for price, I'll be copying this thing and this, and I'll be saving it to a variable which is price. And similarly for rating. So here if you see, I have added one more function, that is strip. So strip basically eliminates all your unnecessary commas or unnecessary spaces which are present on the website, because every time the spacing is not present. So in this case your extra spacing was there, so I have written this strip function. So let me now print all of these, and let's see whether my loops work or not. So as you can see, I have the title, price, and rating for all the products. So this is my first product name, then I have the price for the same, and then I have the rating. Next I have the second product name, I have the price, and then I have the rating. So similarly we have 24 products, ratings, and price for the same. Next, what you can do, let's say I don't want the entire price, or I don't just need the discount or EMI options that it provides. So what I can do, I can simply pass my string. So let me just again show you. So if you see here, I just don't need the whole price. I just need 44,999, but I don't need how much discount it has, how much EMI exchange it has, and everything like that. So for that you need to pass your string. So here if you see I have passed my string. I'll just remove the comments. So here I have first split my price. So for that I have used a function split, which will basically split my prices, and then I have again used the same function for the rupee symbol. So here as you can see, I have this rupee symbol, and in spite of this rupee symbol I want to add RS. So here I have added rupees RS, and then I've added the same variable. Next I have again split it with the E. Now why E? Because there are some features where it does not provide any discount, it just provides your EMI option. So here for that just to look a bit clean, I have again split it with respect to E, and then the final price, or you can say the split price, is been saved in a variable which is final price. Similarly, I've done it for rating. So if you see the ratings as well, I have 4.5, I have ratings, and then this much reviews, but I just need 4.5. So again I have split the string, and then I have stored the final rating in the variable which is final underscore rating. Now what I have to do, I have to concatenate all these three features. So I'll be concatenating the product name, my price, and the rating. So I'll be concatenating it with the comma operator. Now if you see here, now this I'll be storing in CSV as well. So you should keep in mind there should be no extra commas, because every time it finds a comma, it will create a new column for it. So if you look at it closely, you have product name is this, which has a comma as well. So rose gold comma 32 GB. Now for that, if you want to eliminate this comma, what you have to do, you have to write replace function, which will basically replace your comma with a pipeline. And for final price and for rating, it is fine for me. So I will simply print these things, and let's see what it says. So this is my concatenated string. Since I have not removed the previous one, so let me just remove the previous one so that it will not confuse you. So let me just comment these, and I just want to show the final version, which is the concatenated string. So as you can see, I have the title of the phone, which is this, and then I have the pricing, and then I have the rating. Similarly, for all the 24 products, I have the same. Next, what I have to do, I have to put the same in my file also. So I'll use the function write, and I'll display the same. I'll just copy the same print statement over here, and then I'll close my file also. So we have already seen the output over here. Now let's see what this file display. So where this file will be created. So wherever your project is, you will directly go to that folder, and the file will be saved automatically. So it's in my D drive, it's then into Ayushi, and then in the web scraping I have my products.csv. So let me go and click it. So here, as you can see, I have the product name, I have the pricing, and then I have the ratings. So this is what my CSV file looks like. Now let me go back again to code. So as you have seen, we have fetched all the details from the Flipkart website, and these details are automatically fetched and then stored in a CSV file, which is named as products.csv. This was the code that we have just discussed. So here we have scraped the prices, the title, and the ratings of Flipkart. So this was all for the day. Thank you guys for attending this. I hope you guys like it. And now if you guys have any doubts, you can simply ping it over the chat window, and we'll be happy to help you with the same. Well, thank you everyone.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!